counterintuitive. But like, if I stack up the evidence on both sides, and one side is saying, "Hey, this horizon's 11 miles away when it should be 1 mile away," and then you stack up the evidence on the other side, that admittedly good bit of evidence doesn't stack up for me. So yeah, I think it's quite possible the horizon moves depending on a bit of wibbly refraction, same as the road appears to wibble on a hot day.
Okay, but you also simultaneously say the radius of the Earth could actually be larger than it is? Than the heliocentric?
No, I didn't say that. I didn't say that. I think it was just mistaken from what I was saying, which was the attempt to make a logical syllogism failed to recognize the fact that it doesn't disprove radius. It disproves if we take it as on its face, which I don't, right? Because I think it's based on it's if P is false, so then Q is also ridiculous. Doesn't matter. If P is wrong, then Q is relevant. But if P was right, then the resultant argument should be maybe the radius is bigger, and also maybe there's no radius. But it doesn't make sense to go, therefore there is no radius based on that logical syllogism. It's not a logical syllogism. It's how do you say it? Like, not bunk logic.
I've heard people say that though. Therefore, the radius is not 3959. It would have to be 40,000 or something ridiculous.
Well, it's still within that logical statement. It's not accounting for all factors. And I don't think we're living on a globe, but I'm just saying that it's a very limited argument, no matter what, the modest tolerance.
Yeah, and that's all I mean. Like, it's presented by some people, like the people that whoever the other person was saying. Some people say therefore the radius is wrong. They're at least sticking to the finding of the logical syllogism and going, okay, so if we've proven the radius is wrong, then what does that mean? And take further steps after that. That to me is totally valid. But the whole, shitty Word document that gets posted around, therefore it's not a ball, is how it ends. Just wrong.
You have to realize that,
the people repost that without going, oh, hang on, this is logically bunk, is the point I was making.
Yeah, with the modus tollens that was done, you could easily reverse and say the same thing of flat Earth. If the Earth is flat and no radius, I should be able to essentially see forever. And I can't see forever, therefore not flat.
Yeah, what my roboting friend is saying is which Roland My Boulder has actually made, just to let you know, Moyok, you're coming in very, very roboty. Roland My Boulder has actually made it. He's just got a picture of the white swan, and he makes, in fact, one I would argue is a more robust, though still not necessarily completely sound, contra claim, which is if the Earth is flat and light travels in straight lines, then no object could be obscured, or if water is flat, I think it is.
You had to add in the light.
I forget what it is. I forget what it is, but like essentially, if water's flat, then no object could be obscured by water by going a further distance. Therefore, the Earth is not flat, or something like that. Like it's still not 100% correct, because upward refraction does occur. Things can be obscured from the bottom up. I do think imitating Earth curve where it doesn't exist. It's a more effective modus tollens because it is a contrapositive claim, and it is testing the claim of flat and saying therefore not flat, where the original one is just sort of getting it wrong.
Yeah, I agree. The modus tollens cannot be used to like 100% disprove, but it could be used to raise questions and lead into further investigation.
Yeah, I think that's very true. I think it's a starting question for many people. And admittedly, when I was first shown it by flat earthers, I was like, let me see this. And then I was like finding those oil rigs on Google Earth, and like I must admit, I did have a moment of being like, hang on, what's going on here?
So you were flat earth for a moment.
Yeah, like I did have a brief fleeting moment where I was like, what's going on here? Like, of course, the dissonance kicks in and you're like, it can't be, it won't be. What about all the other things? I'm like wanting to make it not the case. But yeah, for a moment there, I was like, oh wow, because
But
what I
again, I
expected
mean,
to find was just that people had like picked the wrong rigs or measured the distance incorrectly or done something else wrong. And then when I looked at it, it was like, what's going on? And it wasn't until another glober in the room spoke up and was like, it's atmospheric refraction, that I was like, oh. And, you know, and admittedly, probably accepted that as an answer.
This is
really
kind of, it's like,
quickly.
it seems like that's your style, writing. That's your,
What's my style?
hello? Can you hear me?
yeah, we can hear you.
Yeah, I just hear sound in the background as well. But go on, what's my style?
Cricket.
Yep, me
Are
too.
you saying something, Gio?
We're never going to find out what your style is, man.
Yeah.
Can I ask you guys a question though about?
Evidently.
I think.
Would you like to ask another one?
Well, I mean, I just wanted to go back to my original question.
Yeah, go on. Sorry, it was a joke. When you say, can I ask a question? You are asking a question, so I like to say evidently.
Okay. So how do people go like? Okay, so I think a lot of people who still believe that they're living on a spherical globe, spherical world, will say, well, potentially it is, and I think it's in defense of all these crazy measurements that have been taken. Right? Not crazy, but astounding measurements, and remarkable measurements, and so they say, well, potentially, and I'm not saying I believe this, but I'm better being like potentially, maybe, and then they say, well, maybe our world is 2 or 3 or way bigger, basically like 2 or 10 times bigger than what they tell us it is, right? And that would, and then, like, what, like, why could that not be the case? I guess I could have just said it like that. Could that not just be the case?
Absolutely.
It throws every single thing off.
That's the next thing.
It throws every single thing off of the entire Earth. It throws off the daily cycle, throws off
I
the
really
seasons,
have nothing else
throws
to
off outer
add
space.
to that point, other than just like I've never really heard that broken down properly.
Could you hear me?
Do you have Gio muted? It started speaking. He was answering you, and then you came in.
Oh,
I'm
I'm
not sure if you
sorry.
got him.
No, I don't have him. I don't have him muted, but I'll listen.
Gio was saying it throws everything else out. Like it sort of it throws out your sort of your space travel. If your radius is wrong, then how do they get?
He was
things?
somehow accidentally muted. I wouldn't normally do that on purpose. I love Gio. Sorry, Gio. I did have you accidentally muted. I must have clicked it.
Yeah, no worries.
Go for it, Gio.
No, I was just saying that, yeah, I mean, if you change the radius of the Earth, it throws pretty much everything off of the entire model. Throws off gravity and all the gravity calculations, throws off the daily cycle of the Earth, the seasons.
Well, for one thing, brother, it would throw off the day and night.
So run with me on this.
You wouldn't have 12 hours
on this one, then, Gio. So Gio, let's run through this one, because this is a conversation I started having with myself in my helmet again today, and wanted to say, you already believe all of those things are wrong or out, correct? Like you already think that they're wrong about gravity, that they're wrong about the way the day-night cycle works, that kind of stuff?
You're asking me that?
Yes.
No, I wouldn't agree to that. I think those things. No, I'm not sure what you're referring to, but I mean, gravity is not a mass attracting mass clinging things to a ball, but the effect that we could call gravity is very real. And yeah, I don't know. I guess like you said things that I guess all I can say is those things you said I wouldn't say. So I guess go from there.
Yeah. So I've formed the question poorly then. What I mean is not that you think that you agree with gravity. What I mean is you already think, I think that you already think that they are either wrong, the vast majority of people, the scientists, NASA, the average glober, anybody except flat earthers, are either wrong or lying about gravity. They're either wrong or lying about the shape of the Earth. They're either wrong or lying about the way the sort of eclipses. Any of the stuff that would be thrown. Here's the point I'm making. It seems like what you're saying is, well, this would throw, if the radius were wrong, it would throw everything else out. It would throw everything else out about the globe model, but you've already thrown that stuff out. So you could still have your global conspiracy to hide things. You could still have your global conspiracy, hiding the true radius of the Earth, to hide more land and stuff like that. So there's nothing in itself of any of the measurements taken that could fit with a big Earth that would be thrown out by that, because they tell you it's 3959, but it could in fact be 300,059, whatever. And there's more land, but the rest of it still fits.
No, it doesn't. It wouldn't fit
You know
at
what
all.
I mean? Why wouldn't it fit?
I think I hear what you're saying, but no, my understanding is it wouldn't fit at all. If you made the radius, let's just say you made it 8,000. I mean, you said 300, but let's just say you made it 8,000 from 4. Well, then the Earth would have to spin, quote unquote, at a completely different rate. So that 1,000 miles an hour sun wouldn't be that anymore, but we observe it as 1,000 miles an hour. So for it to do a whole day cycle, if it was a larger radius, it's not actually possible. Like they had to reverse engineer.
How do we know it's?
They had to reverse engineer the radius from something real. I think our optics, the way that optics work, so they have to use that 3959. They can't use a different size.
I heard you say that last night about the reverse engineering, but couldn't it just be that you've got to calculate it one way, whether or not you believe in spherical Earth or not so spherical Earth, you're going to come up with some kind of number, right? Like, I don't know.
I think what Gio is saying is if I'm to guess, Gio, correct me here, is the equator on the globe model is 3959 times 2 pi r. Like that's the r number. So 2 times pi times 3959 gives you the length of the equator. And I think what Gio is saying is we know that the ground position of the sun at equinox moves across the Earth at 1,000 miles an hour. If the equator, if the Earth were bigger, then the equator would be longer, than that speed would be faster. Is that correct, Gio?
That was one point I was making. Yeah, that's with the day and night cycle. Yeah, if the radius was, let's say, 8,000 miles,
I think that's a valid point.
Yeah, it would.
How did you confirm the speed of the sun or the length of the equator?
That was my first thought, because even if it was the double the radius or whatever you guys like, or whatever you're talking about, then I was to say like that speed couldn't also be doubled.
Well, just going off a basic thing with the sun, if you chase the sun with an airplane going like 600-700 miles an hour, you can kind of chase it a bit to some degree. So it's definitely not going 4,000 miles an hour, the sun, You can fly 700 and kind of chase it around,
Okay, that I kind of see what you're saying. That's a reasonable argument.
A time boundary. What's a time boundary? You know the thing. Like my clocks went back. What do you call that?
So you're saying this has already been figured the shit out of already?
No. As in like I'm driving west, so my clock went back an hour as I crossed that time zone. That's it. The word I was looking for is time zone.
Guys, you can fly an airplane at 600 miles an hour and keep up with the sun if you're at, I'm going to guesstimate, but at 60 degrees above or below the equator. 60, 70 degrees.
So would you say then, it sounds like what you're saying, that's a really good point. I'm glad you raised that, Moyak. I'm sorry to jump in on top of you. Would you say then, Gio, if we... Say again, sorry?
Oh, I just said I'm driving. I can't talk a lot.
Okay. Would you say then, if I've confirmed the ground speed of the sun was slower the further south you get, would that work then, Gio, for you as evidence that the Earth is getting converging to a south pole, basically. If the ground speed of the sun is one of the reasons, okay.
Yeah, exactly. If you're then because I mean, to make the radius larger, you'd have to speed the sun way up, like way beyond 1,000. You know, like for example, if you sped it up to, or if you made the radius twice as large, and you'd have to speed the sun twice as much, and so on. So it would be a large difference. But yeah, if you're talking also about the speed of the sun in relation to the Tropic of Cancer, the equator, the Tropic of Capricorn, yes, on like an AE map, the sun would have to move a faster ground speed at the Tropic of Capricorn than it would at the Tropic of Cancer. So it's something we haven't tested yet. I've never seen it tested ever. And we talked about, one way to do it where we could mark the subsolar point on the Earth as it tracks upon the Earth, and then time it, and then actually see how much Earth it's traversing, therefore, its speed. So yeah, it's a test that actually is not really it's not too hard to do, but yeah, I think we need to do that test to verify that. But I mean, the difference between, it'll be interesting to see what it is. Like the difference between 1,000 and 1,040, like what are we talking? Like what's the actual, is it up to 1,200 or something, but it's not going to be, 5,000 miles an hour or 10,000 or anything.
Okay. I understand what you're saying. How, and like I'm innocent question here. How is it measured actually? Like the speed, like it goes across the sky. That's what we're measuring, right?
There's many ways to measure it. One of the easiest ones available to all of us now that you could use to do this without much, just sitting at your computer, is go, what are the sunrise sunset times? Because they're very, very accurate, because fishermen and all sorts of lay people, pilots and mariners, and I've got sunrise and sunset on my watch. I've got a fancy new GPS watch because sunset matters to me at the moment because I'm overlanding and I don't like riding my motorbike at nighttime. So just check sunrise and sunset times.
Yeah, I do. Just naturally.
Yeah, but you can put that on an AE map and have the sunrise and sunsets times match as well. So that doesn't necessarily prove anything about this.
So that's only step one. It's going, does sunrise and sunset match, and then how far apart are these places? Right, because the distance between Sydney and Perth is known. It's a known distance. So if you say Sydney and Perth are relatively far south, they're one country, but you could also compare it to other places. Is the sun getting from Sydney to Perth to Punta Arenas in Chile? Because you will know that the sun is dead overhead in between those times, so you're using that as your subsolar point. And without having done it, I can fairly strongly guarantee that you will find that distance is shorter, but the time taken is still, as it should be to get around in 24 hours. Like we know it's 24 hours. That's not in contention.
Oh yeah, I mean that's all based on their model though, their latitude and longitude, meaning like how the dirt, if you will, like the actual soil of the Earth actually is laid out in that sense. And so yeah, I mean they're going off of their particular system that they've already kind of. So I don't think that's a way that you could be able to test the speed of the sun. Like you'd have to actually do it yourself ultimately.
Mm-hmm. So then let me rewind a bit, Gio. It sounded like what you were saying made you confident that at least the equators should match was by matching the distance and the speed of the subsolar point. I guess then what that means is you do think that the equator that distance is correct. The only thing in contention is that from the equator, the distances going north should be getting linearly smaller, and the distances south should be getting linearly longer. Is that right?
Yeah, I think so. Although I don't know what you mean by, you just mean further, I mean like longer distance that the sun travels?
Yeah, like when I say linear, I guess I probably mean like trigonometry. Like you're drawing flat, straight triangles.
Yeah, and a faster actual speed. See, what I was saying about testing the ground speed with the subsolar point, I was saying like actually do it, like instead of going off some globe map and kind of being like, oh, well, yeah, the sunset and this latitude and longitude. I was saying actually like do it, like go out there and actually mark on the, on the soil, and so on, like on the actual Earth, to verify that. And yeah, I mean, if that was done and it showed the same speed in the Tropic of Cancer as it did at the Tropic of Capricorn, then yeah, the AE map does not fit that.
Do you think we can reasonably measure?
It'd fit a ball though, right?
It would fit a globe, or it could fit other type flat Earth type ideas, but yeah, it definitely wouldn't fit an AE map.
Can I put forth a couple of thought experiments in this?
Test it.
So I got you. Go ahead, man. I'll go for you.
I just wondered, do you think that you can reasonably measure like 60 to 100 miles relatively accurately? Or the distance between like two cities in a straight line? Gio?
I guess my thought is like yes and no. I guess it just depends on what kind of accuracy you're talking. It depends on the landscape too, because if you were in like Colorado with huge mountains, that'd be very different than in a very level, flat area. So I wouldn't really...
Level, flat area. The best place to test it would probably be on Australia. Because there's plenty of roads that go pretty much due east-west, I think.
Can I ask a question really quick?
I got something to toss out there. But I'll tell you, you ask your question and then I'll go.
But yeah, I mean, you can measure something like, 50, 100 miles. Yeah, Moyak. I mean, like I said, it just depends on the landscape and your equipment. And also your ability to traverse the land freely, because if you're driving around on roads, that's not really the same as actually getting the distance.
Well, using like the Tropic of Cancer on an AE map, wouldn't it be almost a doubling of speed between Tropic of Cancer and Capricorn? Or Capricorn and, Cancer to Capricorn would be almost a doubling of speed. So you can reach that over 100 miles with an accuracy of, let's say, 50%. And I'd still get a meaningful answer.
I think you roboted out there a little bit, so I think I missed part of that.
I got it. I understand what you're getting at it. I got that's actually what I was going to bring up. Was on a flat surface, if you're trying to track the sun above the southern tropics at like 22 or 23 degrees, something like that, you can take that 23 degrees south plus the 90 degrees north, comes up with 113 degrees times 69 miles, gives you the and then multiply that by 2, and then multiply that by, to get the diameter, then multiply that by pi to get the circumference. On a flat surface, the southern tropic would have a circumference of like 48,000 miles, which produces a ground speed of the sun at 2,000 miles an hour. And it would be cool it would be interesting to track, but the rhetorical part here, or theoretical part, I guess rhetorical is better, is that once the sun's over the southern tropic, it must travel faster than it would over the equator. And the number itself isn't relevant to the conclusion that the day should be shorter because the sun's moving faster, right?
Well, no, but there's more land in the south. And another factor is that it could also change altitude if it went higher. Right. But yeah, there's a lot more land to cover.
Well, that's right. So more land doesn't have anything to do with one individual's day and night cycle on the land. Right? Like all he needs to see is the sun. Place on the land. One spot on the land, right? Because he just sees the sun come up and then go down, right? And so what I'm getting at is on the equator, if the sun were over the equator, the guy would get a 12-hour day if it's going 1,000 miles an hour. If a guy's in the southern tropic and the sun's directly above him and moving double the speed, it gives him a 6-hour day. But again, the number is not relevant because the fact is when the sun's over the southern tropic, like in Australia, the longest days are 16 hours. So you end up with the sun that's moving faster, yet produces a longer day when each individual is going to see the sun for less time as opposed to more time.
Yeah, well, like I said, the altitude could change as well. which would alter all that in terms of the field of view and how the field of view and how it rises and sets. But I mean, yeah, I mean, technically they claim that there's the 24-hour sun in Antarctica as well. So it's way longer than 16 hours if you go to that level.
Yeah, the further south you get during the southern summer, like same as in the north, the further south you get, in exactly proportion to your latitude, the longer your days get in your summer, until you get south far enough that you get within the Arctic Circle, which definitionally is where you will sometimes get a 24-hour sun. Isn't it? Isn't that what the Arctic Circle is? Beyond this point, the sun's at sea level will not set if surrounded by sea, I guess. Like, yeah, if you're next to a big...
By the way, that calculation... sorry, I didn't mean to interrupt the end there. I don't think your calculation, Negator, is very close, because the Antarctic ice wall, quote unquote, as it were, like that Antarctic rim, I just posted an image, would be like 50,000 miles. And there is like Captain Cook and those guys that claim that they were getting, 50, 60,000 mile that they were calculating. So I don't know where you got that being twice as much at the Tropic of Cancer, Tropic of Capricorn, but that wouldn't be correct. My general understanding from the math I've seen, and I'm just going to round it, is that at the Tropic of Cancer, the sun goes like 700 to 800 miles. And then at the Tropic of Capricorn, it's maybe, 12, 1300.
It would have to be, or it's measured at?
What's that?
Or something else entirely? Do you mean for the FE to be correct, that's what it is, or somebody's clocked it and said it's 1200?
Well, I'm just saying, if you do the math of the 24,000, almost 25 at the equator, and then the 12-hour day, and then if you shrink that, 23.5 to 23.4 degrees north and south.
So I actually just did the math. Whoever made that graphic, the rim would be...
That up to the rim would be, and then we didn't hear another word.
Sorry, the rim...
Well, it's hard to say what the rim is, because you're cutting out, Negator. But it in terms of the idea of the rim, that would depend on what degree and how far you're out. I mean. Okay,
I'm sorry. That's a stupid push to talk about on the WhatsApp. Not WhatsApp, the Discord app. It would be the rim. The circumference of the rim should be 78,000 miles, 49.
Oof. At what? Where are you getting that from, though? At what distance? What latitude? Or where are you coming up with that? I mean, Captain Cook, there's several reports of those original, some of those sailors getting, like I said, 50 to 60,000 miles. But that doesn't mean that that's exactly what it is, but that's what they were getting.
So, hang on. Captain Cook clocked like 69,000 miles, but that included his journey from Europe and around to the Horn of Africa, and then around it. That wasn't him going around just Antarctica. And the 79 comes from the same math that produces the 24,000 mile equator, right? Like you've got 90 degrees from the North Pole to the equator times 69 miles per degree. It gives you a value of the radius, which you multiply by 2 to get the diameter, which you multiply by 3 point whatever to get that 24,000 mile number. So you simply you add another 90 degrees worth of Earth and continue.
Yeah, I mean, I guess for this, though, it's not really relevant, right? We're talking about the Tropic of Capricorn, because the sun's not going beyond there anyways. So, yeah.
Can I ask a really,
what length would that have to be, and what would that do to the ground speed of the sun? Also trying to figure out what this would mean for the equator, because I'm crossing the equator in like 4 or 5 days.
Before we get into that, can I ask a really basic question? Like, it might be a trigonometry thing. Oh. Don't you need, I mean, this is super basic. Don't you need to have, the distance of an object that you're trying to measure to, figure it? Don't you have to, triangulate it in that way? You have to at least know how far away it is before you can make any kind of serious measurements about speed or anything like that?
So trig just requires that you have, at barest minimum, one angle and one side, or two sides, or da-da-da-da-da. Like, but one angle and one side would be enough to make a triangle. So, like, let's say we're making a triangle between me, the top of the building, and the base of the building. Now, if I can measure the distance between me and the base of the building, then I know the angle to the building, I can know how tall the building is. So you don't need to know
I'm with you.
In fact, you can solve
I understand. Yeah, I get it. Okay, that makes sense. Yeah, okay.
But you're right in thinking, don't you need to know a number, but that number you can take from an easier place.
You can determine it with by other means. Yeah, okay.
Yeah.
Thank you for that. I appreciate that.
That's cool.
On a side note, whoever made that graphic GeoLint, to get the circumference of the edge, all they did was multiply the circumference of the equator by 2. Which
it looks like it. They're just putting like a general kind of doubling, but you originally were saying it was 48,000 at the Tropic of Capricorn, which would be doubling the speed of the sun. But yeah, it's definitely not that. It's like 30 something thousand miles, and it would raise the speed of the sun probably. I've done the math in the past. I'd have to pull up the paperwork because I do have it saved somewhere, but it's like 200 and something mile an hour difference.
Oh,
what is the? Do you know the number?
This heavily. This is not correct.
Geo, do you know the number of the Tropic of Cancer? The proposed number? Since I'm driving, I can't look it up. So you say it's 30,000 for Capricorn, and what is it for Cancer?
I can do that real quick. What's Cancer? 20? They're what? 23 degrees up above and below the equator, right?
Right.
Okay, 1 second.
Yeah, I mean, I hesitate to put any number on it because that's still going off of their claims, because that's all dependent on how far it is from the North Pole and their latitude and longitude lines. So, but you could still calculate it. You can calculate it for the equator being 24,901. But I'm just saying, like, to assume that their degrees actually are 90 from the center and all that, it starts to get into assumption world. So it's kind of tricky to calculate it.
I thought it was 1.78 times the Capricorn was 1.78 times bigger than Cancer.
Yeah,
but that's just
sounds.
Number
Yeah, so it would be like a 35 each way, basically, like half of that between the equator and the tropics.
Yeah, I'm not sure.
Hang on, maybe I did screw something up. Wait a second.
I am now below sea level 50 feet. 60 feet. 70 feet below sea level. And now I'm coming back up.
Circumference is 2 pi r, right? Diameter times pi?
Moyak, are you discording while scuba diving again?
Didn't realize he was a serial scuba discorder.
Scuba discorder.
By the way, you're all welcome for me provoking Tim into a debate, and well done, Tim, for taking the bait and having a cordial conversation.
He did say words at the start.
Geo's always cordial. What are you talking about?
He engaged. I'm talking about Tim. Geo's always cordial. But I just remember we were like all sitting here in silence, and I kept like trying to do things, and Tim was like, "You're gonna have to do better bait than that." So I brought out the big guns and pointed out why Black Swan modus tolerance is false, and that got it going.
Yeah, no worries.
Hey, I lost GPS signal and I'm underwater in a tunnel, but I still have cell phone service.
Proof.
Weird. Okay, I haven't quite come out the tunnel yet, but I have GPS service again, and I'm on the same cell site.
You have to admit, Riding, that if to do the subsolar point test of tracking the position of the subsolar point of the sun as it tracks upon the Earth, at the GP as it continually moves, and actually tracking the distance and the time that it makes, that would be very revealing. You would agree, right?
Like, absolutely.
And you would agree that if it's dramatically, noticeably, measurably larger at the Tropic of Cancer, I guess what you would maybe say oblate spheroid, but that wouldn't really cover it,
Oblate, no, oblateness, like oblateness is only meant to be like
a tiny
most negligible amount of difference. The oblateness is so small that celestial navigation assumes that the Earth is perfectly spherical and can still get you to within a nautical mile. So obviously the oblateness doesn't do much. So there would be no, if you found that the ground speed of the sun, like two different persons midday, was measurably too far apart, that would, it'd blow the globe model out of the water. And it would be easy to test. Like, I'm just getting up the map for you of how far I've gone so far, and can't get the Tropic of Cancer to show up on this, so I'll just draw it on.
Yeah, and like I said, if it was,
I think is that you can also reasonably track. You can reasonably track zenith angle of the sun at any location on Earth.
I think that's what we're both saying the same thing.
But you have to track it, and you have to mark it on the Earth, and you have to measure the distance and track the time, and you have to get the right zenith angle directly, right at the apex. So it is a bit of a project, but I mean, it's not excessive to do, and it is fairly easy to do considering some of the complications of other things we've talked about.
So
to be fair, I think you're making it more difficult than it necessarily needs to be, because, which I think is what Moyok was about to say. You can, like, solar noon is easy to tell through other methods. So what you need to really be doing is just confirming the distances, right? Because nobody's going to be able to lie to you and tell you that sunrise is an hour wrong. Otherwise, every truck driver and fisherman and sailor and pilot and everybody would go, the fucking things are wrong. The sun was up at 6 o'clock and they said it was going to be up at 6:20. It'd only be right for some people at a time. So the real thing you need to do is confirm the Tropic of Capricorn distance.
So on a side note, I discovered the discrepancy between what you were saying and what I was saying, Gio, and we're both right in a sense. I don't know if you guys want me to expound on that.
Go on.
So what he said was correct, that if he uses the equator circumference of 24,000 miles and does the math backwards to produce a radius value, which then he can turn into degrees and then add in the extra 23 degrees to the other tropic, it'll produce a value that's like 31,000 miles. The problem here is, well, not the problem, but what I'm using to produce the tropic distance and the edge distance, well, both tropics and the edge, is the known value of 1 degree equals 69 miles. On a flat map, 1 degree does not equal 69 miles because it's flat. It's not on a curved surface, right? On this map,
the whole 1 degree for 69 miles is a much better place to go. Sorry, it was just an interjection, not an interruption. Go for it.
No, yeah. So that's when you take the Earth and you smash it into a flat surface and you disregard the 1 degree per 69 miles, and you start with 24,000 miles at the equator on that flat map you presented, then 1 degree becomes noticeably shorter. It has to, because 24,000 miles at the equator produces a diameter of like 8,000 miles. Anywho, it throws the math off because it requires that 1 degree not be 69 miles going north to south.
I mean, the one degree to 69 miles has to be out, like either stars and anything you can measure with the 1 degree per 69 miles, which is things even terrestrially, has to be out everywhere on a flat thing, because you cannot get a linear distance in a triangle. That's why we've got trigonometry. You wouldn't have the field of trigonometry if it was just this side equals this distance, therefore that angle equals that.
Not sure.
Yeah, sorry, it's very poorly explained. What I'm saying is the 1 degree per 69 miles wouldn't just be out in the south. The 1 degree per 69 miles would be out everywhere if the Earth were flat. It just wouldn't be a thing. Nobody would say it.
Correct. What conclusion are we drawing here? Yeah, it doesn't work, but are we throwing out whether we can measure that in reality?
Yeah, it does work. It does work. It's a measurement of the optical sphere that you're visually viewing. It does work. It's the declination angle of the object in the sky, which is declining within your sphere of view, of vision. And when you do celestial navigation, you're creating the declination angle and the elevation angle and the horizontal level line from your feet to the GP. So that does work with the 1 degree per 69 miles. It's not. Yeah, what you guys are doing is taking the optical sphere and turning it into a physical sphere that you're standing on, and then and then putting the stars so far away that those lines are more or less parallel. So it like reverses the entire structure of it to where you guys then claim, or the globe Earth is going to then claim that the Earth is the sphere. But if you view it as actual straight lines within a celestial sphere, it works the same way. So they just inverted it for the globe.
I don't think we're arguing one way or the other. We're just trying to make the math make sense in the context of whether it's presented from a flat Earth or a globe Earth.
But I think Jerry's point is that there could be an optical dome or effect that presents the stars as if we're on a globe, even though we're not.
Well, I mean, we still have the issue. Well, the optical thing, it's not deep enough to explain why something shifts 1 degree every 69 miles you move on Earth.
Well, I mean, that is crazy. It is a slightly different topic, though. I mean, we could go into that one, but I guess originally we were talking about the speed of the sun and all that, but because that is a whole separate thing. That I was just saying that the 1 degree per 69 miles, if you're bringing that up, that doesn't only work on a sphere. That's all. But it's a whole different point. It's a whole separate point to discuss.
No, what I'm saying is if we, like when you said the southern tropic would be 31,000 miles, that would be based upon each degree being less than 69 miles.
I would go away from the degrees, minutes, and seconds thing, because Geo has a little bit of a problem with those. They could be conforming to this other model. So what I would think is, as a preliminary thing, Geo, you could go out there, and look at you could look at the solar noon between you and your buddy at a similar latitude, and see what the speed of the sun is at solar noon at your latitude, and just using known distances between cities at whatever increment you want. I'd say probably about 60 to 100 miles would be best. So with a person, and you could do that. You could even do that without a friend. You could do that with a calculator. Just look at the sunrise time look where solar noon is, and you can do a preliminary test of just looking in multiple locations and seeing what the answer is.
Yeah,
then you can validate with your friend that solar noon or that the solar observation in that tool match reality.
Yeah, I just wouldn't want to assume the map of the globe for that. I wouldn't want to use those coordinates to start with. I'm talking about doing it like in a sense from scratch, like actually marking the subsolar point and tracking it rather than just going off of distance given by this latitude and longitude coordinate system that the globe gives, because that just isn't actually doing the same test that I'm talking about,
Right, I'm putting it up in your neck of the woods, so this way you don't have to wait for somebody else to do it, or you don't have to get together $10,000 to go and drive down to the equator. You can go and do this now if you know the two distances in your local neck of the woods and find out what solar noon time is for both of those locations. And you can start a preliminary test. See if it's worth your money to go to equator.
Yeah, I mean, it is a fairly significant difference. If the sun is doing like 800 miles per hour, I think it's 200 and some change from what I remember when I did the math, like 200 and some change mile per hour difference between, let's say, 1,000 at the equator, 780, 790, something like that at the Tropic of Cancer, and then something like 1230 or so at the Tropic of Capricorn. So it is a significant enough difference that should be able to gather that data.
I agree with those numbers too, by the way, Gio, now that I looked at all the math. If we start with the 24,000 mile equator is where we draw our numbers from.
Yeah, it's based off that, yeah.
I still think it's pretty easy to corroborate that at that tropic daytime is still longer than what it would be at the equator as opposed to 20% shorter, or however you want.
Well, it doesn't really change the amount of day. Like I think about it like, let's say like the hands of a clock, that are traversing the face of the clock. So if you were to, let's say the hour hand and it's moving along, well, on the outer edge of the hour hand, like where it's, running over the numbers of the clock, on the outer edge, the ground speed, if you want to call it that, of the outer tip of the hour hand is really cooking across the face of the clock compared to the inner part of the hand, which is really close in. But if you were to put a sun on that and then imagine, that's like your AE map and the sun's on it, it's still going to be passing over the Earth. Like, let's say the sun is like a local hotspot kind of heat lamp type thing. It's still going to be cruising upon the Earth in a way that would still light up a region for a viewer as it comes in and out of vision, in and out of their view, field of view. It's still going to pass over in that one rotational cycle. It's like a difference between a rotational speed versus the ground speed.
Couldn't you, if you took that thought experiment and turned it into a person with a flashlight, say driving by your house, pointing a flashlight at your house, if he were going faster and you looked out your window, you'd see the flashlight for less time. Like if you looked at your watch and counted how long it took for him to drive past you, it would necessitate a shorter amount of time if he sped his car up.
Right, and I hear you on that as well. Now, this is where the possible altitude change or there could even be like an electrostatic effect, the way that the sun works. That gets into a whole other thing because, if we're talking about the sun being like a physical rock or whatever, some kind of physical sphere in the sky, then that's kind of one setup. But there's other ways that perhaps the sun could even illuminate the blue sky and the ether and all that, in terms of its breadth and its like magnetic field, how it spreads upon the Earth, I guess is what I'm saying, due to that. So there is that potential. But then there's the other thing of the altitude, because what you just said right there, I hear you. Yeah, like if you're in your house, somebody's got a flashlight, they're doing a drive-by flashlighting. And yeah, if they're going 40 miles an hour versus 20 miles an hour, it is going to be dramatically different. But if you put that car further away, that would buffer that. You know, it would change that. So if the sun goes a higher altitude in the south, then that would be another factor, and how it's actually lighting up the environment at that different altitude. If that's a factor as well. So that's one thing.
I think that's why we're using the zenith angle, because that eliminates all of those little problems. We don't care about the distance anymore, because zenith is going to be the highest point. It's a fixed relationship to you at that point. So everybody look at zenith at the same time. Right. Yeah. On a latitude, longitude.
I'm not entirely sure I grasp that point. I'll think about it. But I do want to say...
Essentially, you can test anywhere on a line of longitude. You'll get the same solar noon. So you can test anywhere on Earth. You don't have to relegate this to ground speed measurements. You could do the ground speed of the solar noon, which you can identify all the way up to the North Pole and South Pole.
Right.
Now you're not relegated to waiting for the one day a year and it not being cloudy that day and the sun going directly overhead to say that I got the ground speed.
Well, you wouldn't have to be at the one day of the year. You could just, anytime that the sun is at the Tropic of Capricorn or near it, or anytime it's even near the Tropic of Cancer, you could just measure the subsolar point as it tracks upon the Earth. It's actually not, we've talked about ways of doing it. It's not too hard. There's a way you can build a little like shadow box, basically. Like you can even build it with cardboard and stuff. You can build a little sun viewing, what's a good word for it? Like a little sun viewing, like a sun tracking device, whatever you would want to call it. But basically you can create it to where you have like a box, you have holes in the box to where the only time the sun will make a shadow on the inside of it is when it's directly overhead. So you could just take that and then use that at the different sites. So, you could even do this over a couple of days. Like you wouldn't have to even do it all at one moment, but because it's going to be, relatively close to the Tropic of Capricorn within, it's not going to move that much within that amount of day. But yeah, you could just take that little box thing and then find the actual subsolar points by lining it up distance wise and lining the shadow up. And then once you get one, put a stake in the ground, mark it, and then, continue doing that, mark. And then eventually you'll have the distance. And then once you have them all marked, as the sun's coming around, you can time them. So if you had like 10 of these or 20 of them, little stations, marked, then you have, time them with the individual people at the stakes or, and then actually just mark that time. And then that'll show it.
Yeah, I did this with, I liked my method, which was I made up a square of wood. I put in a couple of hunks of PVC and I tied strings in an X fashion across it. And then I aligned the thing so that the cross of the little pieces of string actually lined up on a point on the board. So you could actually track the sun and that X as it moved across the board.
Nice.
Same essential thing.
Yeah, almost like a sundial. That's cool.
Yeah. But the point I'm trying to make, though, is that, we don't need it to go overhead. We just need which is, really critical to being able to at more than one location and not being able to have your test destroyed by a one day a year observation. Solar noon happens every day at your house, no matter what latitude you're at. So if you can reliably track the solar noon distance between you and another location, you should be able to get a speed.
Yeah, you just look directly south.
Yeah. It's a fixed location that everybody can uniformly find.
Yeah, I mean, if you guys, if there were measurements of this that were very well done, it would more or less single-handedly either debunk the globe or debunk the AE map.
preliminary test, I mean, you do agree that the sun trackers typically do give pretty good answers, right? That they do tell you when noon is. There's not really a whole lot of question. Solar noon is. They are very reliable. Sunrise, sunset times, and pretty accurate. So, I mean, couldn't you just, as a preliminary test, go and look at Perth to, east side of Australia, west side of Australia, and then you want in North America, east side of North America, west side of North America, looking at solar noon times. Then, well, that's for a preliminary test. Now, if you wanted to validate that, I guess you could do smaller subs tests in your area. Like you could look, you and a friend lives 100 miles away, just to validate that distances are correct and that it works on the small scale. So you could go up to like 45 degrees and 45 degrees with Australia, right? Australia and America. That should be more than double the speed.
I was just trying to think, like, would time zones alter that?
Not
like
really.
It would to some degree because the way they all overlap, and then you're.
Not solar noon. Solar noon is not a time thing per se. It's a physical observation thing. When solar noon is because you're looking due south at the sun or due north at the sun. That's why I chose to use my cross when I did it, the string, because I was able to tell when it was exactly due north. And high precision because I had it like a couple feet away, so the angles on it were just and it was a very thin string, so it was like just really precise how it ticked along. It was kind of fun to watch. But I left it out in the weather and the board warped and died.
Yeah, I mean, the only way that I think it would be valid to be done would be to do it from scratch, meaning don't go off any globe coordinates or globe maps or GPS or any of that stuff. To actually go off the dirt, like the sky and the dirt, like the actual ground and the actual sky, the actual position of the sun over that said ground, and then measure the distance yourself and time it yourself.
Right, but do you agree that I could do that from any latitude? Yes, any latitude. Using the solar moon method. Is there any way that the sun could have a different solar noon at a given longitude? Longitude. God, I hate these terms.
I think that because that requires accepting like known distances, maybe he doesn't want to do it like that. I don't know.
Well, that starts to accept the globe coordinates and the globe distances, yeah.
Well, you don't have to accept the globe distances. You go and measure it, and the globe coordinates, I'm really only concerned with north and south and the generic term that the Capricorn, or that latitudes do increase as you go south. That the circumference should increase as you go south. You don't need exact numbers. You just need to have, the acceptance that north is north and that latitudes get bigger and bigger with concentric rings. I have driven more than 1 degree this morning.
One degree of what, Mark? 1 degree of what? When you gauge that 1 degree, do you gauge it as you drive along the Earth, or do you gauge it via a sort of a reference in the sky? Yeah.
What I would do to prove it would be I can look at the stars and stuff, and I can see that they're 1 degree different than my wife observes them at the house. I'm almost due north.
Okay, very good. Now, what's to say? So, just to develop an alternative point of view, the Earth is flat. Whatever's happening in the sky, the contour is along that surface or whatever. So you're actually gauging distance along the barrier of the sky, if you want, as opposed to the curve of the ground. Have you considered that? Because you are referencing the sky.
I have
What's going on in the
considered that
sky.
ad nauseum with your hypothetical, and I can come up with no method of making it make rational sense.
Yes, but that's only because you incorporate within the spinning ball Earth model the distant stars. If you're looking for an alternative, which you are, I hope, you
No,
look at the
I mean, I
sky, you
can't
get
understand
this
the
1 degree.
geometry
One
of it.
second, please. You look at the sky, you get this 1 degree deviation, and you declare that applies along the Earth's surface. Okay, it might do, but what's the alternative?
I love your question that, what's the alternative? I don't know. Present one that works, and I will look at it.
But surely any way to find out a broach the truth is by questioning what you already know. So you present one yourself that might work.
No, it's not how it works. You don't just say that, hey, you have an idea, this works, come up with another idea. I know that fire burns me. Maybe fire doesn't burn me.
The idea is that the Earth is not curved. The Earth is actually flat, but the barrier itself is curved. So a basic sort of jump away from the spinning ball Earth, which is we have a barrier around the Earth. Are you with me so far? Barrier over the Earth's surface?
But you need to frame that out further. I mean, I understand what you're saying. You're saying, what if something happens that could make it look the way I see it? But now you've got to describe that something. You're telling me, hey, what if it's this? You go figure it out.
No, you're coming in. You're not in the true spirit of science and inquiry here. You're just dogmatically defending a model which you have no direct bearing or connection to any of its particular aspects. You don't know that the Earth is moving.
I'm looking
at it. You don't know that
trying
the Earth
to
is
verify.
moving.
We're not actually talking about these things. We're actually talking about the concepts of can we measure the ground speed of the sun and ground speed of solar noon? And they really are, it's irrelevant, your latitude and longitude, other than the generic, concept of things being, that latitudes are circular, going around a north-centered map.
Yeah.
Beyond that, I don't care about the degrees. It should be, the further south I go, the longer the distance, the faster the sun's, subsolar point should be and moving. And also solar noon should be moving.
It sort of depends on what you say.
So as I travel from the most north latitudes to the most south latitudes, I should see a 2, 3, 4, 5, 6 times change in the solar noon point.
Don't you have to make a count for magnetic deviation, declination? The further south you go, the more you have to take into account this declination from the north standard. But also, when you say that something doesn't work, so you have no particular model to work on. You're just saying if all the component parts are as you view them in the heliocentric model, it wouldn't work like this. I don't get that, man.
Nope.
I don't get that.
Not even the heliocentric model. This is just a geometric model. This is asking if, with the presuppositions that I said, which are that there is a map and it's north-centered, and as we move further out from the north, we have concentric rings that make up the latitudes. And then finally, it has the assumption that the sun is a real, or is in a place over that map. Don't care about distances, except for the distances where I take my measurements. And those I can make, by pacing, with tape measure, with cars, with whatever method you want.
Okay, so I've just tuned in. Moyak, is that how you pronounce your name?
Moyak, yep.
Moyak, yeah. Hi, I'm a globe earther. I'm here to, listen and learn, and I'm not a troll. I'm not here to patronise or, be one of those dicks. 100% not.
Don't worry, but I'm a globe earther, and I'm
I'm a troll.
Right, because I was just gonna absolutely contradict what you said, but yeah, okay, right, okay, I understand. Yeah. Can I ask any flat earthers what, on the flat Earth model, is there a north and south?
I think most flat earthers cotton to some semblance of a north-centered plane with a circling sun above it.
Yeah, because on the flat Earth model, like the North, but what we would call the North Pole is in the middle, isn't it?
Right.
And then Antarctica is on the outer circle.
Correct.
Sort of thing. Yeah. So like on the flat Earth model, would a flat earther say north and south, and I mean east and west makes sense, I suppose, but
ring magnets are a type of magnet where they have north is in the center, and then the outer ring is the southern part of that of the magnetic of the speaker. It's called a ring magnet. Speakers work this way, like speakers for listening to music and all that actually have a ring magnet designed to them. So yeah, in that kind of idea, the North Pole being the north, and then everything's moving away from the north, everything from the north emanating outward would be moving out to that southern ring in terms of that idea of like a ring magnet.
Well, it's kind of not true though. The ring magnet actually north is on the top and south is on the bottom, or flip it over, north is on the bottom, south.
Yeah,
whatever.
and it's interesting to use the term magnet because the whole point of magnetism is because of that. In the globe Earth theory or model, that it has an iron core, and birds. Like birds fly and stuff with because of that magnetism, so I don't know. So, like on a flat Earth model, yeah, like where does the magnet pull you? What's the central? Well, basically gravity, isn't it? That's what we're talking about.
Well, magnetically, there's the attraction to the north, so. But that's all that happens. We only have that to the north. There's nothing that necessarily attracts south. So south is just everything away from the north, 180 degree, opposite.
Okay, so what are your thoughts on, how birds migrate, like pigeons, have this magnetic thing? It's fantastic,
Right. Yeah, they have like a magnetic.
You know what I mean? I can't explain it, but
Yeah, birds. My understanding of it is that birds actually have like a piece of like a magnetic piece of like tissue that is in their brain. It's like in their head, and it somehow connects with the magnetic field for when they fly south and when they migrate.
Yeah. So to me, that wouldn't work on a flat Earth model. Like, why would there be an attraction to the center, like the north? A
lot of the ancient cosmologies and so on talk about that there's a massive magnetic mountain at the north. Like in the Vedic traditions, they called it Mount Meru, perhaps made of lodestone or some kind of magnetic material. So if there's a massive magnetic mountain there, that would certainly make sense why our compasses point there.
Okay. Right. Okay. Yeah. Thanks for explaining. What is anybody's thoughts on the ISS? The International Space Station. Like, I love. I have the app on my phone, and I love, every now and then when it's flying over, going out and watching it. Do you guys believe that is there and it's happening? I'm sorry. Yeah, I've killed the conversation. I'm sorry. Yeah, like I said, I didn't come into like troll or bombard. I'm here to listen, so I'll shut up now and I'll let you crack on.
What was your question there again, bud? No one answered. What was your question you left at the end?
I don't think there were many active flat earthers to start with, just Geo, and then like 5 of us. And
I missed this question at the end. I'm an active flat earther.
He was asking about the ISS.
Yeah.
I think you were asking if we think it's up there, or if it's an actual space station, or.
Well, yeah. Do you think it's up there? Because I mean, there's a lot of evidence to say that it is, but if it is, and if astronauts are there, as a flat earther, you know, do you have a particular idea of, you know, it's going around like the sun does? You can't see my hand actions now, but you know, is it just like all the other satellites? You know, it's up there, but still in the same. Is the right word the fermentation?
Fermentation, the firmament, yeah, firmament.
Firmament. Thank you. Sorry. Yes, it's like still in like the firmament. It's in like the dome or whatever, you know. So do you believe? So number one question: do you believe that it is there? And if you do, what are your thoughts about it? And if you don't, what are your thoughts about that as well?
Oh, that's why I asked you to repeat the question, because no one was jumping in. But if no one is jumping in, I will say that no, it's not. It's not a reality. That's a movie show we're privy to. I do think it's very possible that there is some advanced technology that is way above there, above the atmosphere, coasting or surfing the ether. In terms of what people might film on the ground, I'm thinking it's some sort of reflection. You know, the way they can project stars from the ground. So if there's some sort of a barrier up there that's reflecting something, it would be quite easy to reflect from the ground or from a plane, even as it's traveling along, some sort of reflection that gives the impression of solidity. That's my impression.
Yeah. Okay, yeah.
Yeah, like there is like a little light thing that we see that you can see from the ground. Yeah, whether that is some kind of projection or whether it's some kind of a military craft or something. But a whole nother inquiry, though, even beyond just what we see, is whether, you know, that actually is a station up there with, you know, humans floating around up there.
Gio, do you think there's a possibility they got into the waters beyond? So when they made it to the moon, for instance, they broke into the waters beyond. I mentioned this, and apparently there's no information about it as well, but I learned it on a conspiracy forum back maybe 10 years ago. But it was on the same day that man went to the moon, it was a top secret mission to reach the furthest depths of the ocean, or something like that. You know, at that point. So it's 1969, like the exact same day. So I'm thinking it's all sort of code for us. And we know the astronauts train in water, astronautical, if there's waters beyond. Do you think it's possible that they breached the barrier and there's possibly something swirling around outside of it? I'm just asking, like, you know, because obviously all the fakery is quite clearly fakery and too obviously fakery as well. So is there a story beyond it? That's my question.
Well, if I could take that, if nobody else wants to, but you know, I think the reason I'm not aggressively coming in with my globe Earth opinion is because, you know, I can see the points that you all make. And a lot of them are reasonable points, and with the moon landings and all that, you know, it is hard to believe. It is, but that there were a lot of people who are much cleverer than all of us, you know, who made that, and they admit themselves, you know, they sent like Neil Armstrong and Buzz and Phil Collins. Oh, not Phil Collins. You know who I mean. The other one. You know, they said that they sent them, you know, basically like a tinfoil can. And there's more technology in the phone that I hold in my hand now, talking to you, than there was in that rocket. It's incredible that it happened. And I totally understand why people think that it didn't. But equally, I know that there are reflectors on the moon that we bounce lasers off and things like that are just, to me, that is proof that we have been there. Also, that whole argument of, the Russians, the Chinese, and, well, basically every other country that would have a reason to dispute it, didn't dispute it. They agreed that it did happen.
How do you know? How do you know there's reflectors on Jamie? How do you know?
Oh, hey, mate. I recognise that voice.
Mm-hmm. Probably do.
Well, I know
that's a pretty strong statement. I know there is reflectors on the moon.
Yeah, it is a strong statement. Mm-hmm. But I do know because I have. Oh, yeah. Oh, okay. Yeah. You're going to get me on a technicality, I know.
Not a technicality at all.
But,
like you either know or you don't know.
Yeah. Well, I feel like I do know.
Okay, then. Well, then
I've seen the
do
experiments.
you know?
Well, because I've seen the experiments, and you can point the laser at the moon and go and then measure how far away it is because of how long the light takes from the laser to get there, and there's these little things on the moon, reflectors.
Can I add something here? It sounds like you've read and heard or seen a story, you're repeating it to us, but in actuality, the people that would actually fire the laser wouldn't even actually know if there's reflectors on the moon. I mean, just to make it short, there could be it could be controlled by a computer program, and the person actually pushing the button to fire the laser and gets a return signal wouldn't even know if there's reflectors on the moon. So how could you know? But how could I know? I don't think we can.
Yeah, I mean, you're absolutely right in what you're in the first bit that you said. Same as Banso Bandit, who I've spoken to before. Love him, great guy. I'm taking faith, in what I've heard, and this is a great conversation, isn't it? Is that right or wrong? I don't know.
We've all done that, right?
Yeah,
and continue to do so on some things.
Yeah, I mean, obviously, I'm not a scientist. None of us are. None of us are. Well, excuse me, maybe somebody is in here. I'm not sure, but I'm certainly not a scientist. And yes, I do take with faith what I hear from reliable sources or something. But I do question it and stuff. But I'm not clever enough to remember exactly what those reflector things are and how exactly they were put there and what the reason is. But all I know is when I hear the people who know what they're talking about explain it, I'm like, oh yeah, of course, right, yeah, makes sense. And to me, those people make more sense than that, with the greatest respect, than flat earthers.
My stomach is hurting.
They're more clever, they're more smart, intelligent, educated. We get it, yeah, you know that.
Oh yeah,
no. My stomach is hurting listening to you saying that you're not intelligent and people are smarter than you, and you're believing their story and taking it on faith because they have a degree or whatever. That makes my stomach hurt.
And I disagree with you too, Jamie. Like you say, you're not a scientist. I'd actually say that we are all scientists.
Yes. Right. Okay. Yeah. Great response. Actually. Yeah. Yeah, and that's where I do have a massive respect. Well, I have respect for everybody. You know, who am I to judge or decide? You know, I don't know anything. But yeah, I have
respect for Jeffrey Dahmer.
Well, I have a respect for all of you who question this, because that is science. That is exactly what science is to question and go, yeah, I'm not going to accept what's in front of me. You know, let's look. However, science, a scientist will also accept the results of any experiment, right? They won't try and make the experiment fit for their cause or for their opinion, right? So, like, when I've seen, I know it's a controversial thing, but that Netflix documentary Behind the Curve, when they put the GPS thing on the ground to see if the Earth rotated 15 degrees every hour, and it did, you know, they re-experimented, tried it again, put it in a capsule and all this kind of thing.
They weren't seeing if the Earth would rotate 15 degrees per hour. You're very naive, man. Don't take that out of disrespect. What I'm hearing is a very naive stance on. They were just seeing what it would detect. It did. They're telling us, and we have to take that on faith because I wasn't there. But they're telling us it did detect a 15-degree drift. But now they're trying to figure out what it was, because now when they take it up at altitude, it doesn't get a 15-degree drift. So now they're thinking that it's more of picking up what they call a ether drift, not the Earth rotating, but the sky rotating.
The sky, yeah.
Yeah. So
but it was on the floor. The GPS thing was on the floor.
What does that matter? Yeah, of course, that wouldn't make a difference. If the floor is turning and the sky is still, and the floor is turning 15 degrees, or if the floor is stationary and the sky is drifting 15 degrees, then it would detect the same. But once you take it up to altitude and you're above and it changes, then you have to start saying, I'm still on the floor, but for some reason it changed the drift. So I have to figure out why, because if the floor is constantly moving at 15 degrees, it wouldn't matter what altitude you take it at. And there's just so many factors that go into that.
And that was conveniently cut out of the documentary on Netflix.
Exactly. That's why I'm saying you're a little naive.
I'll accept that. I am naive, and you know what? I am a sucker, and
no, you just were born into a world where they've already given you everything. That when you say that you trust people who know what they're talking about, well, how do you know that they know what they're talking about? I could talk to kids all day long. They know what they're talking about when it comes to Santa Claus, but do they really know what they're talking about? I mean, that's the problem here.
I agree. In that, that's the conflict, isn't it? Of who to trust and what, and that's it is where I have respect for all of you, is that you are questioning it, and rightly so. I sit here and accept it, kind of thing.
No respect for yourself. Okay.
No, but what is the difference between me listening to those people, scientists and whatever, Brian Cox or Einstein or Stephen Hawkins, whatever, to you listening to, I don't know, Mark Sargent or somebody like what's the difference?
About 3 years.
The thing is,
about a couple of years.
Yeah,
I would say.
Real quick, guys.
The
thing is, you could. All right, go ahead.
No, you go ahead. Sorry, big pardon.
The thing is, you can say I know something, right? Now, do you actually know, or do you think you know? Right? Those are two different things, because, like Fuzzy said, there's a little kid out there. He knows Santa Claus. He knows. He thinks he knows. Does he know, or does he think he knows that Santa Claus came to his house last night? To him, he knows.
The tooth fairy came to our house last night.
But that's what I'm saying. Also, I accept that. Yeah, you're right. I don't know. I haven't done the
Globers run around like we know every time these.
Yeah. But you don't know either.
And that's the point.
Every time these Globers run around like we know.
Yeah.
I have to go in depth to explain to them. You think you know, actually no.
To answer your question,
I see what you're saying now. Yeah.
You said, what's the difference between, right? We were in your shoes. All of us were in your shoes at one point in time. I was in your shoes for 35 years. I thought I knew everything about the globe, the space, all the quasars, all of it, right? And then I just went to go to prove that the radius is correct. How do I prove that the globe is correct? Well, let me just follow the evidence and just show them. We've had thousands of years to prove it, so let me just find the proof. Still looking.
Yeah. Okay. I mean, to comment on what Jeremy said there. Yeah, absolutely. I hate the patronising attitude of globe earthers and that sort of looking down the nose and we're better than you. We understand. We're clever. We're evolved. Yeah, that's wrong. Yeah, because I know no more than you do, of course.
All the Globers say, like, "Oh my gosh, we have thousands of years of science. You're denying all the science?" And I was like, "All right, show me the science that proves the globe." Well, you would just deny it even if I showed it to you. You just don't even understand the science, so you just don't even. You just like, show it to me. You just don't understand, bro. Show it to me. Can't do it. No proof of the globe exists definitively. It only exists in our minds because we were taught about the globe at the same time we were taught about the Tooth Fairy and Santa Claus.
Yeah, but Santa Claus lived at the North Pole.
Yeah,
so
of
he was,
the globe that they just
top.
told you about. They told you Earth is a globe, it's a ball, and Santa Claus lives on the top of the ball.
Yeah. And flew around the Earth in one night to deliver all the presents, even to the.
Santa Claus. Santa Claus used to be depicted in all kinds of colors: green, blue, red, all different colors. And Coca-Cola made this massive. Marketing campaign. And always depicts him in red.
Made him red, didn't they?
Made it red and white. That's shocking. From Coca-Cola?
They always depict him as red, yeah.
Yeah, he was green, wasn't he, before Coca-Cola got hold
Green,
of it?
blue. He was any different color you wanted, really. I mean, it was like a buffet of colors for Santa.
And he comes down the chimney. Red is the fiery color, Jeremy. So it's why I was going to ask you, what do you think there's any particular reason for choosing these particular colors to transform this man? I will just tell you myself, while he comes down fire pits, he's like an angry god in a sense, Santa, because if you're not good, then he won't be pleased. He'll leave a piece of coal in your hanging stocking or something like that. So yeah, what do you think red invokes then is the question.
Was there a question there, or I don't know?
Yeah, what do you think red invokes? I asked you 2 times, man.
Coca-Cola.
Whole family. You think that's all there is to it?
I think that's why he's red right now, is because of Coca-Cola, yes.
Redshift.
It's really that simple.
That's what you're saying. It's just a branding. Okay. You're not saying there's anything more to it than that. Okay.
I think it might be. I think he has a point. I think he has a point, to be fair, because
I have a point.
My dad was a vicar, right, for the Church of England, and during certain festivals, the clerical, like the clothes and whatnot, would change. So I think like Easter was purple, Pentecost was like green, but I don't know. But yeah, the colours changed. What they wore, what the vicar wore.
Colours affect your mood, yeah. Colours affect everything, Jeremy. That's why I thought you were sort of capable of answering beyond that, but obviously you're not. It's just a marketing ploy from a soft drinks company who took over a famous image or icon. Okay, fair enough. You're stuck there.
Yeah. So yeah, so at Easter, the vicar was like sponsored by Dr. Pepper, and you know, come Christmas and that, you know, yeah, it was tango. And sorry, yeah, I'm just being silly now.
Yeah, green is for spring. The green is the color of the heart as well. Red is the belly. Blue is the mind. So yeah, all of these colors they're like words. They invoke certain emotions within us. This is a whole psychological thing itself. So yeah, they've definitely commandeered the symbol and associated these colors specifically. Remember, if you don't do good, Santa will punish you. He won't give you any material rewards. Like the angry God. If you strip Santa and God naked and put them in the same room, you'd have a difficulty telling who is who.
Jamie, this is the part, right? The same evidence, the same standard of evidence that exists for Santa is the same standard of evidence that exists for the globe. You're taught that this is the way it is, and without question, okay, well, that's how it is. And then they show you certain pieces of evidence that happen to fit that story and ignore everything else. They're like, well, look at the cookies, look at the half drinking milk, look at the paw prints. The reindeer must have eaten the carrot. That's the only thing that makes sense last night. Why else would there be reindeer? I mean, it must be true. By that standard of evidence, Santa Claus is real. By that standard of evidence, the globe is what it is because it looks like it from the ground, and that's what we've already been told to believe. And therefore, that standard of evidence fits our worldview as we were taught by a child.
But hang on, there's also more to it, bud. In this reality, as flat earthers, something's going on at the North Center. And if we talk about eternal presence, and we're here caught under the chains of time, there's more to the story, I think. So to throw it out just on its literal basis alone is fair enough, but to see deeper to a symbolic and a definitely appropriate level of encoding that applies to all of us. I think that's
there's definitely more to it. I was just trying to break down that like when you go to try to prove the globe to be correct, you run into the same problems that you do when you try to prove Santa to be real. Like it's all just circumstantial based on an idea.
Again, I think there's more to it. I think flat Earth is a psyop because we haven't defined what Earth is. If you just say draw a picture of it, flat Earth.
Oh no, I know.
You're going to draw a disc or a one-dimensional surface. So yeah, I do think there are aspects of the Earth that move, aspects of the Earth that are globular. But yeah, we just haven't defined the term.
Obviously, my point is that what we were told the world is as children, compared to what it actually is and what we can prove it to be, is not. We don't know what it is. You're right. It's more complicated than that, but we don't know. So anytime people say we do know, hold on there, is my point. It's just, obviously it's more complicated. But he's kind of new to this whole thing, so I'm trying to break it down for him.
He's not new. I remember him from a few years ago, and I'm most interested by your dad is a vicar. Did you talk to him about flat Earth, and what did he have to say? The Bible, for the most part, if you go seeking it, will definitely lead you to thinking that we're on a stationary surface that is flat and enclosed. But have you mentioned that to your vicar dad, if he's still around? Vicar is a priest, by the way, or just in general for the American viewer. It's a priest or a pastor or something like that.
Well, yeah. So a priest, I think, is like Catholic, but yeah. So my dad, vicar. No, I never spoke to him about flat Earth or anything like that. He died in 2008, so it was
okay.
It was like, I think, a while before this whole flat Earth phenomenon kind of thing happened. But we did talk about science. Because I did question him on, science exists. How can God exist? And his belief, quite honestly, was that God and science could go hand in hand. My dad did believe in evolution. He wasn't a creationist. I think his view. Well, I know that his view was. That the Bible readings of Adam and Eve and Noah's Ark and things like that were more like stories to live by and to you know, to tell a
Noah's Ark
parable.
is the story to live by, okay, or to die by.
Yeah,
maybe.
no, so not a thing that actually happened, but you know, a thing of, you know.
Well, I mean, isn't that a bit disingenuous then? I mean, if he is there in this very pivotal position for years, influencing people, influencing congregations, and he doesn't believe in half the stuff he is lecturing.
No, he did. No, he did believe in it. But no. Well, I can't speak for him. I can't speak for him. I can't.
Well, you can speak for him.
Okay, right. So somebody's gonna fucking laugh and be a dickhead. But
no, I think there's just a breaking up on the line or something.
But no, I think there's a difference between, you know, being disingenuous and interpreting scripture in one way or another. You know.
Did you think the story of Jesus was okay, I'm going to he walks, Mike.
How great to have a sensible.
Did you think that the story of Jesus was a story symbolic to
Hold on, Fuzzy. No.
Fuzzy,
Yeah, Fuzzy, your mic's all fucked up, buddy.
Yeah, he's okay. He's gone on mute.
I thought we were getting fucking infected with the diseases of evil.
Anyway, I'm sorry that your dad is not around. I think these are the most interesting of times. And I guess what you're trying to say is he was a religious man. He probably took the story of Jesus literally, or the New Testament especially. But he also had trust and faith in science, or the giants of science, the mind of man. And he sort of tried to blend the two. I think that's maybe the message you're trying to get across.
Yeah, I think. Again, like I said, you know, I can't speak for him. And, you know, it was 2008. I was 21 when he died. So, you know, I was quite young. And so I hadn't had... So, like, I wish he was here now to have this sort of conversation with. You know, it'd be brilliant. You know, at 21, I had better things on my mind, or so I thought, you know, going out, getting drunk, and, you know, I wasn't talking about God and science, you know. But
he must have died young, bud. He must have died young, so...
Yeah, he was 54. Yeah.
That's very young, isn't it? That's very young, especially for a priest.
Yeah. Especially for a priest.
Yeah, well, they tend to live long. Like the royalty, the priests tend to live long, and I was going to say prosperous lives, but long.
Yeah,
long
it was too much communion wine, I reckon. Yeah.
Well, have you called? So here's the point. I do remember you from talking a few years ago. I know you've been on these forums, maybe tipping in and out for a few years. But have you had any cause to question the basic deliverance of the truth of our reality as given to us by science yourself? Because every one of us here definitely have, and there's not one of us who'd be able to ever go back to a spinning ball Earth as given, or a heliocentric or a greater Big Bang model as given, literally. No, it's impossible, I say. But have you had any cause to question things deeply yourself?
Yeah. Oh, sorry. Sorry, Jeremy, go ahead.
That was for you, but I want to respond to that after you.
Yeah, okay, thank you. Yeah, of course I do. It's interesting to hear that question kind of the other way, because usually the question is, have you ever, you know, lacked faith in God? And of course I have. But you're asking, have I ever lacked faith in science?
Yes, and man.
And, yeah, interesting. Yeah, of course I have. It's a constant battle, you know, between what I see and what I know myself to what I'm told, and to then what people like you pose a question of. Yeah, I constantly debate. It's the reason I'm here. I wouldn't be here talking to you guys if I wasn't questioning my belief in science or God or anything. I wouldn't be here. I wouldn't be here.
All the answers, all the questions you asked.
Hold on, Pete. I want to respond to what you said, Pete, please. Can I, Pete? Is that, are we all allowed to talk, or good looking?
Shut up, Jeremy,
what
with your
you
smart
said
ass
was,
talk. Off you go, please.
what you said was just false. I would go back to the globe in 5 minutes flat if someone had some definitive proof of curvature. I'd be a glober in 5 minutes. 5 minutes.
Yes, but so would all of us, man. But there is none, you see. That's the point. As far as what we know, we've come to know now, it's almost impossible for any flat earther to go back. It would take some extra. My brother always says it to me. He said, "What would you do if you got a place in the rocket and they brought you up to space and you saw the Earth moving?" I said, "For fuck's sake, what am I going to do but accept it, of course. But what would you do?" I asked him. "If you went up in the rocket and you couldn't get up in the rocket, you couldn't see shit." But you know what I mean? Absolutely, Jeremy. Of course we'd go back if there was something definitive, but there is nothing. And we know in our hearts at this point that the globe, spinning ball Earth, cannot be true, literally.
No, but
it just cannot be.
I mean, to a certain point, I have to say that, you know, there has been like what more is needed than has been given. But then equally, I'm like, well, yeah, okay, well, I don't know, I've not been up there to see it. But yeah, okay, yeah.
Definitive evidence of curvature. Even if you did go up there to see it, because I've went through this rocket scenario in my head multiple times. How would you know you're moving as opposed to the Earth moving? You know what I mean? How would you know it's a ball and it's not the way refraction in a circle of light works as you get up over it? How do you know there's not cameras in the windows and you're not actually even looking outside? You're looking at a really good screen that's full. You know what I mean? Like, there's so many ways that you could be tricked. Our eyes get tricked. They're not perfect. You know, when you look at something, you can have a 2D thing appear 3D. You know, your eyes get fooled. Also, by the way, this Earth stopping the Earth rotating thing with the where the light hit, this shit ain't over.
Sorry, say that again. Stuff in the Earth, what?
We were just running through a hypothetical where if you stop the Earth from rotating, would the sun stop instantly, or would it keep moving through the sky for 8 minutes?
Well, what's the theory? Are you on a flat Earth model there, or?
No, you're on the whole globe model, the whole heliocentric model. You stop the Earth rotating.
So if the
does the sun freeze, or does the sun keep moving for 8 minutes?
Well, no, if the Earth randomly just stopped rotating, that wouldn't affect the sun at all.
Or, yeah.
It has to, so the photons can catch up.
I've got a cool picture.
Jeremy, when I think of that, I think of like a water gun or like a hose, you know, where you're kind of like. So imagine if like somebody were standing in the yard and they're slowly, like they're standing up, but then they're slowly kind of spinning in place, you know, like a globe Earth. And then you'd have like a hose and you're blasting them with the hose. And you'd have to kind of imagine the 8 minutes, you know, the water coming from the hose and hitting them. And then if the guy stops spinning, yeah, it seems like the position of the hose that's hitting them would just stay frozen in the sky because now they're not moving. Like
you would think it would hit. You'd think it would hit the whole same spot, but look, put yourself as a photon, right? You're a photon. You just left the surface of the Earth, of the sun. You're on your way. Then now we stop the Earth rotating. That photon's going to see the Earth rotate for 8 more minutes. That photon's not going to see the Earth stop rotating instantly. It's going to take 8 minutes.
You're mixing up two questions.
What's up?
You're mixing up two questions, right? So
we're talking about the Earth. The Earth stopping.
The Earth stopping spinning has no effect on the sun, right? There is that theory that because it takes light like 8 minutes to come from the sun, if the sun suddenly disappeared or exploded or whatever, we wouldn't know about it for 8 minutes.
Yeah, I'm not mixing that up. I didn't say anything about that.
Yeah. No, but you were saying like, oh, if the Earth stops spinning, then we wouldn't know for 8 minutes.
No, he's saying if the Earth stops spinning, what would it look like on Earth? What would the position of the sun do if you're standing on Earth right when it stops rotating? I think that's what he's.
Would it keep going for 8 more minutes? Would the sun keep moving through the sky for 8 minutes, or would it freeze instantly? Because right now they say we see the sun where it was 8. I know you think so, right? You'd think it would freeze, but pretend you're a photon and you're leaving the surface of the sun.
But you're working
there's a whole
on a flat
stream
Earth model there.
What's
right?
I think I can help you with this, Jeremy. I think I can.
I don't know. Nobody will ever let me get through the scenario though, and you guys don't hear it from another. You got to look at it from another point of view.
Go for it.
So there's a stream of photons. Picture a string of photons hitting the Earth, right, from the sun. You stop the sun. You stop the Earth from rotating. The photon that's 1 millimeter above the surface of the Earth, that's pretty much going to hit right where it sees it, right?
Yeah.
Yeah. So then there's a photon in that line 4 minutes away. That's going to see the Earth rotate for 4 more minutes, right?
Yes.
Right.
Yeah.
Right.
So you could pause. You're on the 4 minute photon. You see where the Earth is. You go another minute. You pause. The Earth's moved. You go another minute. You pause. The Earth's moved under you. So is that photon going to hit where it sees it, or is Earth going to like magically go into reverse once the photon gets there?
So similar, yeah. It's not going to go in. It's not going to go in
Where
reverse.
is the sun for you in this?
It's not going to go in reverse. The photon's going to hit where it sees, right?
Yes, the photon's going to just land wherever it's going to land. The way you're describing it, is the Earth going to turn backwards? No.
Okay, so the Earth's not going to turn backwards. The photon's going to hit. The photon's going to hit where it sees, right?
Right. So
do you understand how?
I think I get your point about it. When you first asked the question, I was like, yeah, it is. The sun's going to be backwards in the sky. And then I had to think about it a bit longer. I was like, no, okay, I'm thinking about it wrong. So I think now, I don't know, but I think I would put it a different way, which is rather than slowing down the Earth, let's speed it up. So it spins once every 8 minutes. So it spins around at the same rate it takes the light to leave the sun and hit the Earth. You with me so far?
Yo, it's like heads don't even hear what I say. You skipped right over my shit, and now we're on to
I
some
agree
other
with your
new
shit.
analogy. Okay, so the sun's gonna okay, so you agree with me? The photons are gonna hit where they see. So the one that was 8 minutes away, that's gonna see the Earth rotate for 8 minutes, and that's gonna hit in a different spot. All these photons are gonna hit in different spots, right?
The reason everybody is having difficulty, myself included, or the reason I'm having difficulty, and I assume everybody else is having difficulty giving you a direct answer on this, is because you're linking a broken premise into your question. And we're trying to pick apart the broken premise, and it sounds to me like you keep going that
What's the broken premise?
The Earth, either the sun moves backwards in the sky, or the 8 minutes is false. What you need to have is the possibility that the sun doesn't move in the sky and the 8 minutes is true.
The sun's not moving. This is all in the heliocentric model. The sun's not moving, and the light is moving in a straight line. And the Earth and the light is moving in a straight line.
Right.
Now, you have this single stream of photons, a ray, if you will, of photons all coming towards the Earth. You agree they all can't hit in the same spot, right? Because they're going to hit where they see. So hold on.
Staying in this scenario.
Before you get to a new scenario, everyone does this every time.
No, I'm not getting to a new scenario. Jeremy. Let's chill and have a nice conversation because we can and you can and I know you can. So all I want to add, all I want to do is add to your scenario. We're just going to put exactly the same scenario. All we're going to add is that there is a north, south, east, west on the Earth as you look over it, right?
That doesn't matter.
Right? So you're looking
let
dead.
Jeremy finish.
Just whoever the third person is talking, maybe not.
Sorry, it's Jamie. Sorry, I'll shut up.
If you're looking straight down on the Earth, let's say the sun is always to the west of the Earth. Can we just do that just for this? So the photons are leaving the sun in a steady stream from the west, and they're hitting the Earth from the west. Yeah? Jeremy?
Why is there now west and east in this?
I want to add that so that we can make sense of it.
Yes, there are.
Yeah, just was cutting out. You were roboting, at least for me.
Me?
Not for you. Okay, hang on. Let me switch internet.
If we say, Jeremy, this pillar or band of photons is hitting the Earth now, and it's hitting at the degree zero of longitude, right? If that's what Eggshells is getting at. So let's say it's hitting the 0 degree longitude. Now suddenly you stop the Earth, and 8 minutes later, photons arrive from the sun to the stationary Earth. He's saying that, yes, the same band of photons will hit 0 degrees longitude.
No, he just agreed that the photons are going to hit where they see.
Okay, I'm back.
He actually agreed to the exact opposite of that, Pete.
Okay, well, let him clarify then.
Well, that's why I made the analogy.
What happens, Jeremy, is you fence people in to a position where you force them to give an answer that doesn't quite make sense to either you nor me. So I like, if you say, does the photon hit the Earth where it sees? To me, a photon doesn't see, but if a photon's hitting the Earth, it hits the Earth wherever it is. So that would make sense for one proposition or the other. Doesn't really make sense to me. So let's just stick with this thing. Same thing you're saying, but I just want you to keep the sun locked at the west of the Earth as you look on it, or just call it west, call it like anything. And
the world, man.
As the Earth turns, it's always getting bathed in an 8-minute long string of photons, but always from the same direction. It's almost as if we were standing out in a backyard and you started spraying me with a hose. As I turned around, I would always be getting hit by that hose directly from your direction, even though the photons or the water that left the hose that hit me as my front turned past you, for example, left the hose when my shoulder was towards you, it still hits me in the direct direction that you are coming from, that you are standing. So I see you and I see the water coming from you from the same direction, even though in time I was rotated differently when that water left the hose. But it doesn't matter to me when the water left the hose or when the photons left the sun. It matters when they hit the Earth, and they'll only ever hit the Earth in the direction that the sun is.
Gio, did you want to bring up a water gun example now, or?
I think that's a good explanation. I'm on board that. Yeah, I'm on board that.
No, I was just going to
Very kind of you to say so.
Yeah, no, I think I was going to actually just sort of compound on that and just say that, yeah, like if you are being sprayed with a hose, the minute you stop spinning, the rest of the water that is coming out of the hose for that quote unquote 8 minutes is still just traveling straight. And so if the Earth has stopped by then, it should all just focus on one area. Just like if you stop when you're being hit with a hose, if you're spinning, if you stop, let's say you stop, like Riding was saying, if the hose is hitting your right shoulder or something, then if you just freeze there, then all the rest of the quote unquote photons, in that analogy, and the water are just going to all hit your shoulder, which means the sun would just stay in that same position.
Right, yes. Yeah, so that's a logical experiment, isn't it, then? To squirt water on somebody on Earth as they
Okay, I've
spin.
heard your.
That's you know that's
an analogy,
everyone's.
and you're not actually saying anything when you speak. So.
I know, yeah.
So
I know you're
this
making
is
an
also,
analogy.
Jeremy.
Hold on, man.
I
Let
just
me
want to make this
respond to
clear.
all that.
I'm not. Yeah, I just want to make clear though, just before you say it, I'm not saying this is the answer. That's the way I conceive of it, but not an astrophysicist. Go for it. Sorry.
It's a rotisserie and a chicken argument.
I'm trying to get everyone to see it from a different point of view, right? This is what happens when you get wrapped up in this relativistic nonsense. You want to bring it to an analogy on Earth with a chicken and waterfalls or squirt guns or hoses in a yard. That's cool, but we're dealing with this relativistic shit with this 8-minute lag. So the photon leaving the sun, we all agree the photon's going to hit where it sees, right? If you could freeze time through this whole thing, you could let a photon travel 2 minutes, freeze time, pause it, unpause it. We all agree the photon's going to hit where it sees, right? Moyak, you agree to that?
So that's an interesting way to put it. I would say
no. You don't agree to that, Moyak. You think the photon's going to hit somewhere other than where it is?
I do see his point. I think he's wrong, but I do see what he's saying.
I'd like to rephrase it a little bit.
It's actually a really good question that has. Yeah, it's a great question.
If the Earth was just spinning, then I would expect it to hit the left side, not moving in orbit. If it was spinning and you were squirting the hose or the photons at the left side of the globe, it would hit the left side of the globe. But if it was rotating, it would hit at a different point on the left side of the globe than the sun saw, the photon saw when it started its trip.
No, we all agree.
Yeah. That's where I was starting with, which was if you go with your analogy, Jeremy, where the photon sees. If we said, let's say the photon, because it's magical, can see with zero lag, but it travels at the speed of light. So it takes 8 minutes to get to Earth, but it knows the position of Earth before it leaves. It will not land where it sees. As it leaves the sun, it will see the Earth rotated back, and as it reaches the Earth will turn into it, and it will land where the Earth will be 8 minutes from when it left, if that makes any sense at all. But here's another way to conceive of it. Yeah. But what that doesn't mean, so what you're right about that, and it's a really good question because it is a counterintuitive answer, I think. But what that doesn't mean is that the sun moves in the sky. What that means is if I turn in the garden as somebody sprays me with the hose, I'm getting hit as I rotate with water that left the hose when I was in a different position. But I will always be hit by that water from the hose in the direction of the person holding the hose.
You've got to get this, Jeremy. That is so clear.
Right, I get it.
No, it's a good question, Moyak. It's a good question.
Am I ever going to be able to respond? I've heard all your points. Yes, this makes sense for a hose on Earth or a rotisserie chicken under a waterfall. We're not dealing with shit like that. We're dealing with this relative. Hold on, man. Just hold on. I'm not going to be long. I don't talk for long.
No, just
we're not dealing with this. We're not dealing with.
Talk.
Go on.
You're roboting, Moyak.
A little bit. I think I've worked out what it is, Jeremy. Your audio drops when other people speak.
That's a bullshit excuse. Come on, man. That dude's interrupting on purpose.
Easy, Ricker. We don't need.
How many times does Jeremy have to say, "I'm not going to be long. Just let me speak," and then he gets cut off immediately?
Look how Ricky is helping.
Let me go. I might be having mic issues. I don't know. All right, my headphones are fucked up.
Go for it, Jeremy.
Okay, you're a photon. What's that? You're a photon. You just left the surface of the sun. You stopped the Earth rotating. Okay, there's a whole stream, a straight line. The sun's not moving. This is the whole heliocentric model. There's a stream of photons. There was a photon 1 millimeter above the surface. That's going to hit at a longitude that it sees, right underneath it. So there's a photon 8 minutes away. It's going to see the Earth rotate for 8 more minutes. That photon just hit. Photon already hit. It hit at the prime meridian.
Good morning.
That photon hit at the prime meridian.
Sure.
The Earth is going to rotate. Somebody's hot micing. The Earth is going to rotate for 8 more minutes from the photon on the sun. Right? We got to wait 8 minutes now of rotation before that sun sees it. Like you picture, you're on the photon and you could freeze frame. You can go 4 minutes. You've seen the Earth turn 4 minutes worth of rotation for the Earth now, because just because you stop the Earth from rotating, it's still going to take you 8 minutes to see that it stopped rotating, right?
Yeah, but the photon that's just leaving the sun when the other one is hitting the Earth is looking 8 minutes back into the Earth's past. So when it comes 8 minutes duration, it will hit in exactly the same spot where the Earth, with the initial photon hit, stopped at that moment in time.
Yeah, like here's another way. Here's another way to put it, Jeremy. If what you were saying is right, this is what it would mean, and this is the analogy I was trying to say before. So just allow me to say it. And that is, if the Earth was rotating at once every 8 minutes, if you were right, what that would mean is at midnight, or sort of when the sun is due west, the Earth facing completely east, completely on the opposite side of the sun, would be bathed in light because it's being hit by photons that left at the time that was. Right? That's what that would mean. If the sun moved in the sky, dependent on this thing that you're talking about, it would mean that the actual side of light, if you sped up the Earth enough, could be completely wrong. And immediately you could see it, that would be wrong, right? If you've got a light bulb on one side of a ball, or somebody getting sprayed by a hose, that their dry side could be the opposite.
I hear your position. I understand your position. I understand the hose, the water analogy, the squirt gun, the chicken rotisserie under the waterfall. I understand it should hit the same spot.
Mm-hmm.
Can you hear my position? Do you understand my position?
I understand your position. Yeah, I understand your position.
Which one's it going to be? It can't be both.
Your one's wrong.
Is the light? I'm wrong, and the light's not going to hit where it sees.
If you mean the light's not going to hit where it sees, is it going to land directly on the Earth? As it if it drew a crosshair on the Earth as it left the sun, will it hit that spot on the Earth? No, it will not. It will hit whichever side of the Earth is facing towards it. So that crosshair will move forwards in time across the turning of the Earth and hit somewhere else. What that doesn't mean, though, is that the sun moves in the sky. What that means is the sun stays stationary. It's a really good question. I have to think about it for ages before.
You do realize you can't have the photon move across the surface. The photon's moving across the surface of the Earth, and the sun stays stationary in the sky. Those are two opposing views.
No, but that's not
what I'm saying is,
Jeremy, you're simultaneously
photon going from the sun
asking a question and presenting only one valid answer. Like either you want the answer and you don't have it, or you have the answer and we're having a debate. Which is it?
No, there's two different answers for this. Could be a paradox right here.
It's not. We agree. Misunderstanding it.
It is a paradox. It's a great question. I love it.
It is a good question. Yeah, on that I will absolutely give you.
Tell me where I misunderstand. Stream of photons. The Earth's rotating. There's a constant stream of photons from one spot on the sun to one spot on the Earth. You stop the Earth from rotating.
Right. Okay. So right.
Oh, okay.
So a photon doesn't leave the sun going, all right, off I go. I'm going to land on the Earth in North Yorkshire near Jamie. Boom. It doesn't. The sun is a stream of light and a stream of photons, and as the Earth rotates and moves around the sun, mind you, the sun rotates as well. The sun spins in a globe and heliocentric model. So the sun's rotating, the Earth's rotating, and everything's going round. The photons leaving the sun, yes, take 8 minutes to get to Earth, right? Where they land on Earth is almost irrelevant. It doesn't matter. The Earth spins, I'll probably get this wrong now, but is it east to west or west to east?
We know all these things.
The sun rises in the east. Yeah.
Okay, do we all agree
that is the issue? That actually is the issue.
We know these
things. Photon isn't going, what do I do when I get to Earth? It is.
No, the photon's not sentient. We know.
I don't think Jeremy's suggesting that. It's just Jeremy's asking a legit question because as viewed from the Earth, the sun will always stay in its same position. So Jeremy then reasons that therefore from the Earth the sun will move in its position if you stopped or started the rotation from one to the other. It's just that he's adding two together. He's going the turn of this should equal the turn of an equal and opposite turn of that. But what he doesn't realise, I think, I might be wrong about this, is he's doubling the turn. It should be 1 to 0, whereas he's getting 2. Both are turning.
The issue is here riding on eggshells. You're having difficulty.
I'm never gonna be able to say it. Pete's gonna try to reiterate it.
You've said it quite a few times.
All I hear is you talking.
So we all agree that photon's gonna hit.
So once again, hey Jeremy, you have control over this 24/7, right? And you can talk about things for days on end, and you must be heard. I wanted to say something to riding on eggshells. All right. Right, riding on eggshells. You're having difficulty with this intellectually wrapping your brain around it. Of course, there's an alternative point of view, which is for a flat earther that the sun is local and the light is instantaneous. There is no such delay. So I'd like to hear your thoughts on that after you wrap up with Jeremy.
Yeah, absolutely possible. I mean, intuitively, it makes more sense. It feels better. If you look at crepuscular rays, it feels like it fits more. It's just it doesn't to me stack up with other bits of evidence. So there's evidence on one side, evidence on another side. But to me, like a gut feeling, that would work better for me. Especially something that hot. I'm in Indonesia at the moment. I get absolutely baked each day in the sun if I'm not wearing sun cream, and the only thing showing is my nose and my cheeks. Wow, they get burned. To suggest that thing is 93 million miles away is mind-boggling. It's just come on, no, it's got to be closer.
Right, and this is why we're getting lost in all of these mental gymnastics with Jeremy's scenario, and it's not necessarily Jeremy's scenario. He's trying to hold you to the fire. But yes, if these things aren't real in the first place, you're just delving into thought exercise. You're like Einstein riding on a light wave, which is fundamentally what viewing things from a point of view of a photon is. Now, off you go, Jeremy. Thank you.
Oh, that's another interesting way to look at it. Go for it, Jeremy.
There's people. We have people on all the photons, right? We can pause time and see what happens in between and whenever we want. This is hypothetical, right? So I'm on a photon 8 minutes away. You're on a photon 4 minutes away. Geo's on a photon that's about to hit the Earth 1 inch. Okay? We stop the rotation of Earth. We stop the rotation of Earth right as we're all at those points.
Mm-hmm.
Geo's going to hit the Earth we're pretty much right where he sees it, right? You're going to travel for 4 more minutes. The Earth, you will see the Earth rotate under you for 4 more minutes. We can pause. We can pause when you're 3 minutes. We can pause when you're 2 minutes. We can pause when you're 1 minute. The Earth is going to rotate 4 more minutes under you, right?
Mm-hmm. Yep.
I want you to stop me when I'm wrong, because you keep saying I'm fundamentally wrong. People keep thinking I'm getting this wrong. Please stop me when I'm wrong.
Yeah, you're right.
No, I think the way you're describing it right now sounds really good. Yeah. So the photon, a minute in front of me.
Okay. Hold on, man.
Hit the Earth in a certain place. Yep. Go for it. Keep going.
So you're gonna hit where you see, right? The Earth. You're gonna hit where you see it, where you see, right?
The where you see isn't making it, go back to the way you were saying. You're in a string of a queue of protons, let's say. Photons. Sorry. The way, sorry, I don't know any of this shit. I'm not an astrophysicist. The one a minute in front of you hit at a piece of ground, and then that piece of ground turned a minute away from me.
Geo was on 1 inch from the ground. He hit. Now you're 4 minutes away. Okay, you're in that same. You're right under at 4 minutes. You're right under that same piece of land. You're going to see the land rotate for 4 more minutes, right?
Yes. Yes.
Yes.
Well, hold on.
And we not hold on.
You said interrupt you if you got something wrong.
Let him go.
Okay, what I get wrong? No, he's right. What I get wrong?
So you said for 4 more minutes, but you failed to realize that that photon was actually it's 4 more minutes in the past. All right, visually anyway.
It's not 4 minutes in the past. We're on the photon.
Yeah, you're on the photon. Yeah, but what the photon sees, there's 4 minutes in the past though. So it's gonna pretty much hit the same spot that the 1 minute one hits or whatever.
But what we're saying, I think, when he says what the photon sees, correct me if I'm wrong, Jeremy, you're not giving the speed of light to its sight. So the photon is quote unquote seeing in real time, but it is traveling at light speed. Is that the gist, Jeremy?
We can pause at every point along this line. Okay, so when you're on the photon, you're seeing as we see, right? You're a human on a photon.
Well, no, now it gets difficult because now you do what Arma's saying, which is you do not see other photons hit because they're traveling at light speed and you're traveling at light speed. So you see nothing. Arguably, you're seeing the part. Like I don't know.
Yeah.
That just gets in.
It breaks down. Laws of physics break down like
it's going to break my brain. I'm not going to be able to answer. I'm quite confident of my answer. Otherwise,
but I don't think Jeremy's saying that either, though. I think Jeremy's just saying that if we're riding a photon, but we're not like experiencing any time dilation, we're pretty much just placed where the photon is, at every instance, right? Then it would just be like what we see as humans, basically. But I guess
do that. But okay, yeah.
Yeah, but basically, So, but with this thing though, is that Jeremy is forgetting that the one that's 4 minutes away, that's also going to be seeing the Earth 4 minutes before it stopped rotating.
This is why it gets so much more difficult if you talk about what the photon sees, because the photon's now receiving photons that are bouncing the other direction. It's like, what? When did the light that gets the photon's eyes leave the sun to bounce off the Earth to get back to its eyes? Like, my brain.
I told you this is all mad. It's an exercise in thought. It's like Einstein riding on a light beam, and the added difficulty is if we attach sentience to that photon as it's traveling at the speed of light, all laws of physics break down for us. So this is an added difficulty.
Absolutely.
I mean, the easiest way to do this though was just to
Just admit the Earth doesn't move and the sun is near. That's brilliant. That's the easiest way to deal with all of this.
Well,
Get to the
what I was going to say
it is easier.
Well, that's the point, isn't it? That's the easy answer.
Yeah, it's something we can wrap our brains around. How about that?
Yeah,
that's
all right.
exactly it. These relativistic effects are very difficult, nigh on impossible to wrap our brains around. Except that, like, the idea of an 8 minutes long string of photons, I can, but I'm still quite possibly wrong. Like, I'm just giving you my gut reaction, Jeremy. Like, not my gut reaction. My gut reaction was first initially with you, then the sun should move.
Get sick all over the place.
But that doesn't have any bearing on whether it's true. Reality has no requirement to make sense to us.
But this is a mental sort of wrapping around a concept being presented to you. So that's a different matter. I think actually we forget about our gut, our second brain, and what we need to go with most. We're lost in the upper brain here. This is the whole point. We're lost in this fantasy world that we can't wrap our brains around, but yet you'll sell it to us as reality. Doesn't work, bud. Even if it was true, you'd never know if it was true because we can't wrap our brains around it. There's a good one.
That's true. I wouldn't, if somebody changed the speed of light or said it was instant, I wouldn't change anything in my normal reality.
Are you kidding? So if you found out that the Earth was flat and stationary, you were central in the universe, there was a creator, and there was a purpose and a higher power to your life, it wouldn't change anything?
No. That's not what I said. That would change lots. Right? I would immediately buy a boat or steal a boat and start sailing south. That's the first thing I do.
Would steal a boat? Why would you steal a boat and head south? What did you to hide from? You were a lawyer,
because I can't afford a boat that can go to the south, but I got to go to the south.
What do you want to do? Escape beyond the boundary? Go across the infinite plane?
Well, just the opposite direction from Polaris.
Why don't you go north, bud? Why don't you go north? That's where everyone can at least send
you go. We can both buy a boat. I'm heading south.
Off you go.
The biggest questions for me are in the south.
I'll tell you this though: if we all headed north, we'd all meet up, avoiding any accidents or anything. If we headed south, we would all head in absolutely opposing directions. The further south we went. So, how do you feel about that? Being totally alone and realizing that you made the wrong decision, but it was too late.
Even if I died, I would die knowing the truth, and that would be so exciting to me that it would be a life well spent.
But that's so interesting.
The goal wouldn't be to die. The goal would be to find some undeniable evidence, turn around, come back to humanity, and become famous for having proved the Earth is flat.
That's
So you
so
have to see
interesting,
it for
right?
yourself.
1 second. That's so interesting because you're already in what I call the southern hemisphere. I look at the hemisphere as the barrier that we're under, or which is highest at the equator, lowest north and south. But that sort of aspect, the way our brain is orientated that way. But you're there at the southern aspect, and you want to, if you found out the Earth was flat and all the things I said was true, you would buy a boat or steal a boat and head south. That's the first thing you would do, really? Really? You're already
Where the
south, so you head
penguins are.
further south into the depths
First
of the
thing,
Antarctic. Okay, that's mad.
first thing, I'd probably get back on this Discord and like make some apologies.
Oh yeah.
Eat some
Yeah,
humble, eat a couple of big serves of humble pie. But yeah, like
yeah.
among the first things I would do would be to beg, borrow, or steal a boat from somebody and sail south with with
Why
satellite
would
internet
you?
connection
Why
and
would
a
you on
sextant
Earth go
and
south? Why would you not go north?
barrels of
Something that
rum.
you're separated from all your life,
Oh,
and you've
what?
heard all of
Like,
the
what's your
fantasy
problem
or
with him
mystical
going
stories
south?
about
Why
Mount
would?
Meru
Wait,
and the way the gateway
Because
between
south
the
is a
north.
point. Okay, I can answer that. Because
But
south is a
why?
point
But
on
why?
either map. So if I sail to the north and find that indeed it is a point, I've done nothing. If I sail to the south, I either find it is a circumference, i.e., 60 something miles long, or it is a singular point that I can stand on. That's where I prove A
Listen,
or
bud,
B.
eggshell, stop bullshitting me. I already told you the scenario was that the truth about the flat Earth came out, and all of these different things were laid before us. So don't worry about that. The layout of the land was known, but why did you forget about that part? Why would you not head north? The
Oh,
boundaries
if the layout of
are
the
already
land was
delivered to the
known,
people, laid bare for the people, so you don't have to worry about that.
um,
I think you know
depends
too
if
much
you
about
mean that
North.
it's.
The man protests too little, I think.
No, that would be it would be mysterious, just not equally so. I guess it depends. If you're saying like it was laid bare, like I've reality is as it is today. I've grown up. I'm approaching my 40th birthday, being a Glober, and then suddenly it's revealed. Then yeah, I'm going south. If I'd grown up
Unless
the whole
you're
time
talking about
believing in a
1 second,
flat,
please.
probably
Unless you're
wouldn't sail
talking
anyway.
about inside knowledge that you know about things like Iron Mountain and the escape of the Nazis to bases beyond Antarctica. So maybe you have inside knowledge
Oh,
knowing that that's
jeez,
the way
bloody
to
hell.
go.
It's getting a bit
It's
further.
possible. That's very
Yeah,
possible. Maybe that's what the Falkland
yeah.
Wars were about.
If
Maybe
in
when they
doubt,
tell us that
bring the
Antarctica
Nazis
is a
into the argument.
Hey, bud, I was talking, Jamie, and you won't be able for what I'm saying because you're too new to any of the arguments here. But I'm saying that, yeah, maybe that's what the Falklands War was about, to protect this boundary and this entrance into what's beyond the southern peripheral. So maybe your decision is, your answer is well made,
Oh boy.
eggshells.
Hmm. Yeah, it's a fun one though to think what would I do if I found out. Like I mean, my other what would I do is like if the apocalypse happened like right this second, what would you do? Would you just like suddenly crack a bottle of whiskey and sit there waiting for the end? Would you pack a go bag and what would you pack in it? Where would you go? Who would you bring? Because there might be some people in your life where you're like, I really like them, but they're not very useful and they might slow me down.
So basically, you take yourself and your loved one, your nearest and dearest, and you go off alone. Okay.
I'd head to Australia. I mean, depends on the kind of apocalypse, but I've made this plan extensively. The go bag is multi-tool. Passport though they will probably be useless just because it's small. Firelighters, as much clean water as I can. Charcoal when and wherever I find it, so I can make more clean water. Um, good shoes, like a few different things like that. Then who would I bring is absolutely like loved ones, but like you're going to end up with a bit of a gang, right? And beyond my loved ones, that gang is only going to be competent people, like competent and fun to hang out with people. And then where do I go is for me probably Australia, because everybody who's played Risk or any of those games knows that a giant sea border is a pretty good place to be. And where do I head is straight away to a port somewhere where I get on a sailboat and follow the Southern Cross.
Southern Cross, a reflection of what's going on in the north, and maybe see this is a game of second guessing. When we come to flat Earth, Admiral Byrd, Dickie Byrd, Someone posted a picture of remember that interview he did about 1955 or something, talking about these vast swathes of land beyond Antarctica in the backdrop. The backdrop, never
Did he say
noticed it.
beyond? So
Yeah,
can I
beyond
just check with
Antarctica.
you? Did he say beyond Antarctica, or was
Yeah,
it
beyond.
ambiguous and he could have? But let me finish. Did he say beyond Antarctica, or did what he say was ambiguous enough that he could have actually been talking about Antarctica itself?
Yeah, that's fine. That's fine. You know what I mean. And his language sort of specified that. And of course, he's saying it on mainstream. The interesting point was that you mightn't have noticed if you look up the interview, there's a big azimuthal equidistant projection map at the back. Big dodo behind him, behind the bird. Admiral Byrd, Richard E. Byrd, Dick E. Byrd. If I tell you don't say Dick E. Byrd, that means don't say a word, keep it on the hush hush. But the point is that when we came to Flat Earth, we were given all of this then secret information. Everyone started talking about exploration, Dell, beyond the Imaginary Curve, everyone heading south. Infinite Plane talks about more lands beyond. And the north was almost forgotten. But then is it another layer? It wasn't forgotten by everyone, and lots of people put focus at the north, including myself. But is it again another reversal of fortune? And it ultimately is that the freedom awaits at the southern peripherals. I would actually take it, eggshells, that you have more inside information than I'm aware of, and your choice is made after due consideration. So yeah, I value your answer there.
Well, thank you. Kind of mindful we might have derailed off Jeremy's thing, but I'm also wondering if that's okay.
We'll get back to it.
Jeremy is dogged when he gets on topics like this, which I do very much admire about you, Jeremy, if you're still
here. Just while it's quiet, I'd like to apologise to Guest Me Dodo for cross talking earlier.
Well, that's very gentlemanly of you. I do enjoy people on both sides of this argument, which is why I tried to with my hose analogy, who, when they make an analogy or simile or whatever you want to call it, metaphor, pick a funny one, like a not violent one, but one that makes you giggle a bit, so that when people get stuck in that analogy for ages, they're like, this is really funny. Like, I certainly think a lot of the 24/7 love getting stuck in the, like, is your girlfriend cheating on you metaphor, which I do think is quite fun. I think the difficulty, I'm just responding to what Moyok said in the chat here, that like he had a lot of Jeremy had a lot of believers at Gems, but they all checked their logic and eventually all but Jeremy realized they were wrong, is from the perspective of a flat earther, in these rooms, us Globers should all be on point with the same message given to us by, some, authority or governing body. And therefore, if we give divergent answers or somebody says something is wrong or somebody explains something poorly or differently, that is evidence of doublespeak and dishonesty and inaccuracy and contradictions in the model. Whereas if you entertain while hearing their answers that maybe it's a bunch of lay people occasionally getting things wrong, explaining things poorly, more getting things wrong, then it makes sense that we're not all on the same page. But that we all end up on the same page. That's the bit that's more interesting. You can have one glober check another glober's logic or answer on something and say that's incorrect because of X, Y, Z, and have the former glober go, oh, actually, you're right. Yep, I've changed my mind. That's important. It's not just musing what could be. It's fitting with everything else that is said to be.
You know, in chat earlier, I was talking to those that I was talking to, and in my mind, like I just kind of like heard this little voice, like "Stop wasting your time," and it made me like I even said it in the chat, like there's a time when to pick fruit from a tree. You know, like you can go when it's like not ready to just easily get plucked, and you're like, it's like the hardest thing. Sometimes you're bending the shit out of the branch. It's just like bending with it, like it will not break from that branch. It's because it's not ready to be picked. And I feel like in a lot of these discussions, we're dealing with, if you're so in a strong position that what you've been told is the truth, and you've looked at all the insights and outsides and side sites and upsides and everything about it, and you keep your position because you're like, this makes complete sense to me, then there's no way you're gonna let go from that branch. It's gonna take time for you to hear these holes in the beliefs, these things that don't make sense. But then again, you just usually say, well, it does make sense because they have an answer for that. Look, it's this what it is. Even though it's a blind belief, it's a faith belief. You have to admit that, because nobody's measuring by hand these distances. We're just having to believe that this math is what it is, and that's it. It is a blind belief. It's a faith belief at this point, but backed up by what they say. Well, this guy over here, he signs the fuck out of it, and he knows what the truth is, and he used all these science methods. But then we learn later, that's not even considered science at this point. But then that's even arguable too. But all I'm saying is, like, when a person's ready to receive the truth and snap out of the that learning, if you will, what has been learned and what they once held to be true, that's when a light turns on, and just so easily the smallest explanation of the most complicated thing finally makes sense. And
I think that's absolutely true. I think it's like because the way you said that was also very adept, really nicely said. Because I think that is the way that both sides feel about the other side. Like,
absolutely,
because it's completely devoid of judgment about which side is right. Like one side gets told, "Hey, we've got scientists that told us X was right," and we go, and the other side goes, "They're not real scientists, so they weren't doing real science," or like, and yeah, for somebody who's like me, who's deeply ensconced in the globe, who thinks that who I don't want to say believes, but very strongly thinks that a lot of the tenets that the globe holds is true. Like even my dad, and I've mentioned that to other people. Like I mentioned it to you before, Apocryphon. Like he's navigated a fair amount of the globe, and he's confident. And I'm like, well, the only two ways he could be wrong is if he's lying or dumb. But there's got to be a point for somebody on either side to be ready to do it, but also an approach. Like I don't think you necessarily. It's just about, is the fruit ready? But it's like it's an animal. It's more like an animal. Is this sheep ready to be shorn? Maybe in that, like, it also takes a bit of a relationship. Like badgering somebody and calling them a globe-tard or a science denier. I mean that from either side. Like a sort of it's just not going to get there. It's like kicking a sheep and then going, "Hey, by the way, can I flip you on your back and shear you?" It'll kick it.
Yeah,
you're going to feel naked afterwards. I like this metaphor.
And if I could say, and I can't read his name, but Apocryphon, is that how you say it?
Bingo.
Yeah, exactly. Like what you said there of, letting go of that branch. Yeah, that's what I find really hard. Letting go of my beliefs. It's hard. And like I said before, I'm here to listen to the other side of the coin with an open mind, because I am on the fence. I really am.
Yeah.
But
are you?
But on the other side of that, when you say that, it's totally down to faith, it isn't proved, and it's the thing is, it is proved. It has been.
What is it that has you on the fence, though, Jamie? Like, are there flat Earth arguments you feel are valid, or are they globe Earth explanations you feel have holes in them? Like, what exactly has you on the fence? What has you thinking the Earth really could be flat?
Well, I'll tell you what has been on the fence is more. It's the idea of like a conspiracy, of like, am I being lied to? Is it this? Science-wise, I do.
I'm guessing if you're on the fence about this, can I just interject to guess you're like not on the fence about 9/11? Sorry, go.
Oh, right. Oh, jeez. Okay. Well, hold that thought. Bloody hell.
Yeah.
But no. What Apocryphon said, about science. They make up, the sun's 93 million miles away. They make this up. They haven't just made it up. They haven't. There's been tests done. There's been and whether you agree with it or not, or agree with the results or not, the tests have been done, which is why they believe that things are the way they are. The moon's out there and the Earth is here and it's a globe and this and that and the other, right? And if in a million years' time, right, if we burned all of the books, every book, fiction, non-fiction, science books, Bibles, whatever, burn it all. In 1,000 years' time, right, fiction will come back differently. The Bible, the Quran, the whatever, it will all come back differently. But science books will come back exactly the same, because all the same texts will be done, right?
Well, hold on. I want to say something on that, though, just real quick. For instance, there's a lot of weird evidence that we might actually be the dumbed down ones in our time, and that, let's say, those in the 1700s were actually they had a higher intellect and understanding of things. But something happened to where now, like, even if you look at our buildings and construction, like, there's things that were made back in the 1800s that they actually don't think they can recreate today. And we are more advanced. So to say that the science would come back different.
Could you give us an example of one of these things?
No, I'm saying the science would come back the same.
Hold on. I caught myself. To say that the science would come back the same, I would say it would only come back to what is allowed to come back. Like,
could you give us an example?
I think what he means. I think what he means, Apocryphon, is like if you say that that water is made up of hydrogen and oxygen. While you might give hydrogen and oxygen different names, you would still end up coming back to its H2O. Like, it wouldn't necessarily be H, it wouldn't necessarily be O, but it would still have to be that basic construction, because science is about discovering the structure of reality, and reality doesn't change. So if you wiped away culture, you might change the language, you might change the hats we wear, or the religions we believe in, but water's still going to be water.
Yeah, but at the same time,
Jamie?
What? I was gonna say at the same time, though, that there is a lot of stuff today that everybody in this Discord channel, as we speak right now, has been born into and told this is what it is. This, hands down, they have it in textbooks. It's almost like we can say it's written in stone for now, because things can change once we, you know, get better at it, you know, and we could, if we come up with a new theory or a new, you know, revelation in science.
Yeah, and that is a great point.
But
That is a great point.
so
Sorry, yeah,
so
carry on. Sorry.
but there's a lot of science, quote unquote, that now, you know, today compared to 40 years ago, we're thinking back like, well, wait, how are we calling it science if we can't run it through, you know, those steps of what we have learned what science even is to begin with? But now, because you can't run it through there, the common collective, the common collective,
No.
the common collective has now agreed that, well, we don't have to go through those steps. Like, we don't need a variable to know the deep space that reaches 25 trillion light years or whatever their numbers are. Like, they don't need anything what we would use in science. Like, they don't need that no more, because now it's just a consensus that when it comes to certain things in quote unquote science, they just agree, and that's it, and it is what it is.
No, I disagree. I disagree with that entirely. I think it is a constant search for, well, I suppose the truth, but it's science is exactly, science means not. I can't remember. I don't know if it's Latin or something, but the word science literally means knowledge or knowing, right? And
I don't like that one.
And science has always, you know, when it's got it wrong, has gone, oh yeah, shit, yeah, we got that wrong. You know, when it in the whatever 1700s, whatever it was, thought the Earth was flat, and Galileo goes and spots, you know, Jupiter through his telescope and says to the Catholic Church, no, we're not the center of the universe. The sun is the center of the solar system. He was, you know, marched out of town. He was ostracized. He was also.
Hey, can I jump in just real quick, Jamie?
Yeah, go ahead.
Just to bring it back to the point that's being made about science being open. So I was invited to write a scientific popular paper on my research on mirages, right? Purely scientific, had nothing to do with flat Earth. Okay, I was asked to put it up or to submit it for publication on a Georgia State University, right?
Wow. Okay. Yeah.
One of your side trolled that university so badly, calling me a flat earther and just lambasting my character, that apart from the science of what I proposed, my paper was taken down because I was slandered. Right? They didn't want this bad publication, bad publicity, all this kind of stuff. Right? So, not even like I'm just wondering if anyone from your side who knows Sean Hawkins, has anyone gone to him and said, like, why did you do that? Why were you such a dick? Like, so my point is like, I can't even get past you guys, right?
Yeah.
I can't even get past you guys with my content that's purely like, so when are you guys going to start dealing with the claims that I'm making? Because just like, I can't remember who was talking about if we did science over again for the past 200 years, okay, the science of superior mirages and looming would have to change, because within the very interpretation of looming, there's the curve of the Earth, right? So
right, okay.
It's not even approached from a neutral bias. It's already assuming something about the physical world and then interpreting the data through that.
Well, it's literally what I'm saying is that Galileo was ridiculed and so forth, and science is you know, a progression of learning, knowing, etc. Right? I don't know anything about mirages or.
I would argue.
Let me ask you this, Jamie, about you were talking about like the people doing science. Of the people who've done robust experiments on the side of flat Earth, which do you think have returned strong evidence for the flat Earth?
Right, repeat the question. Sorry.
So
who is your most respected
there's many,
researcher?
like, no, it doesn't have to be respected. I just mean like who's had good method to their test, has had
What's it
recorded
for
data
a flat
well,
Earth?
and has returned data that you feel convincingly shows flat Earth. Because like when I first got involved in the debate, people waved in my face these sort of documents and stuff going, this shows flat Earth, and then I started reading them.
Yeah, there is no.
So which do you
that's
feel?
the issue. There's not a single person who's been able to claim flat Earth, perform a logical and valid experiment, and then answer any questions.
That's not true.
All right,
They don't even
prove
need to
me
be able to
wrong.
answer any questions, but I mean, like something that is well designed, that is an
Yeah, it's
experiment
like you
that has
guys
a
are
like
whistling
A,
past me
B,
right
I'll
now.
answer
I'm
the
right
question
here.
that was posed to
I'm
me.
right here, guys. You're talking about me. You can just talk to me.
Well, I've asked you for this like I can't count the number of times, Travis, and you just keep asking me for cash. If you want to show your results and show your experiment, please do. Please
It's going
go
to
for it.
take. It's going to take a team of people and time. Okay.
Okay. So hang on, pause, Travis. You don't have results. What you have is a test you want to do, and you need time and cash to do it.
No.
What I'm
Right.
saying is not that. Okay, so let me just make it clear again
Yeah,
what
but
I'm
then,
asking, because
but then
maybe
they've
we're talking
already
past
got
one
the
another. I'm
answers,
saying
and there's
who
not of
has
them.
already done it? Who's got a test that shows some strong evidence that is in favour of flat Earth? Not who's got a test that they plan on doing if they get the money and people behind them. Who has already done that and has got a result that in
Yeah,
your
no
mind,
one, no
Jamie,
one,
is
no
good.
one.
Yeah,
Well,
and
It's kind of
there
important.
are right, and while there are fine tuning, while there are fine tunings to go along with my research, up to this point, my research is solid enough to make certain claims and hypotheses on.
Can we see your research?
If I could
You haven't.
respond
I've asked
to
you for it many times, Travis, and I've got the same answer. So I'm just going to exclude yours. I'm going to say accept Travis's for now, because it doesn't seem you're hearing me when I say has already done it. So instead of saying has already done it, you don't appear to be hearing. I'll just go to saying, aside from Travis, who claims he's done it, what are the best things you've heard of, Jamie, where you're like, hey, this is something to think about. You know,
Before Jamie, hold on, Jamie. Before you answer that, I've been trying to jump in real quick. Eggshells. By asking that question, I want to just before he answers, I want to say this: there have been numerous people that have gone out and done these distances and taken photos,
I've heard that.
and the fact
I've heard that, yeah.
Okay, the fact that you can see something that you shouldn't be seeing, and I can't stress that enough. You shouldn't be seeing it. The fact that you can see it, it destroys a ball curve geometric blah blah. Because but here's the problem though. From the rebuttal to that is that light bends around a curve and brings it up to view. That is Narnia speech. That is Narnia.
So hang on.
and
So
that's where Travis is talking about the mirage.
let's find the middle. Let's find the middle ground then. Yeah, many flat earthers go, I shouldn't be able to see this. If the ball was the size I was told it was, and refraction didn't exist, I shouldn't be able to see this thing. Now, it might be Narnia that refraction exists. I would say it's not, for a variety of reasons, including you can find texts today dating back hundreds and hundreds and hundreds of years describing this effect. But if you just put that aside and you just say there exists a retort to that evidence, there exists a retort that says light bends up to, I think it's like 1/10 of a degree. And if you say all of the evidence that exists for flat Earth, none of it's experimental and none of it controls for that variable. That's what experiments should do in my mind, and that is go, what is the current like thing that people say, like, what do we say causes cancer? And they go, but a confounding variable could be that they're driving cars with leaded petrol. So you go, okay, we can control for the people in our study who are driving cars that run on leaded petrol. None of these observations control for
the variable of refraction.
What flat earther are
And
you saying doesn't
worse,
believe in
worse,
refraction?
worse than
Yeah.
that
Look.
is the fact that just let me get this thought out and then I'm done. It's
Yeah,
very
let
quick
his
thing.
monologue
The
continue.
the most important thing is almost all of the flat Earth observations or measurements that have gone out and have set up rigorous controls and have tried to get it beyond refraction have come back with the opposite result.
That's not
Yeah,
true.
right.
That is
Whatever,
just
dude.
unfollowed,
Fe
man. That is
core,
unbelievable.
Such bullshit, man.
Jeranism, Bob
Oh my
Nodell.
That
god.
is so wrong, dude.
Oh my god.
So I've
You're
given
This guy's
you're
fucking
I've
misleading the
destroying your
audience.
world.
You are
okay,
misleading the
easy guys,
audience.
easy guys.
No,
Are
it's
you
not easy
recording
when
this
you're openly deceiving.
for a
Don't
show
tell
or
me to be
something?
easy when you just said so many things that were untrue in one monologue that I'm almost throwing up. So you're either deceiving on purpose.
I'm sorry about that.
Or you're either deceiving on purpose, which gets me upset. So don't tell me to calm down. Or you're
Yeah,
just
stop being a wet blanket,
willfully
dude.
ignorant on the subject.
Respect each
So let me.
other, everybody.
Yeah,
No, you
I
don't need
really
to.
don't
I'm
want to
gonna
hear
try.
you
I'm gonna
anymore.
try.
There's really
We
no
don't need you to
rebuttal.
keep going.
Don't
You
really
don't,
need you to keep going on your monologue.
yeah.
Is this the behavior of people who are right? That's what I'd ask you. But Jamie, here, the three examples I gave you are F.E. Core, Jeranism, and Bob Nodell. And by their own testimony, you don't have to take my word for it. Go and find out what they say about their test. And
Yeah,
all
go
of them
talk to them.
change the results. Let me finish it. Let me finish this. Change the results of their tests after they did it. They set the parameters for their tests, did their tests, and then changed the parameters post hoc, not just to say flat Earth, but even after they changed the parameters, the best they could come out with afterwards was inconclusive. So they had to redraw the rules they set themselves. Still, the best they could get out of those redrawn rules were, we can't tell.
So I'd be willing to bet my
it's
life
just,
you're
hold on,
talking about Jeranism when he did the test on Canal during that documentary, which you didn't. You're just going to stop there and not go to where he openly, on a live server, told everyone what happened and that the conclusion was inconclusive because they think something was in the way, obstructing it. But you're not going to mention that, are you?
yes.
Right,
No, that's
and he had
exactly what
an
I just
issue.
mentioned. I'm
He had an
happy to
issue
go
with
there.
his laser, right? So, Jaron had an issue where the collimator on his laser had melted, right? So he had an issue with the laser. They
No,
were
I think you're talking about FE Core.
with
Jeranism tried the one where he
really
shone a
went.
light through
Dude,
two
if you're gonna
holes.
talk over me,
And
I'm just gonna mute you. So,
And Jeranism has said
Jeranism
that
had an
bushes were in
issue
the way
with
on that one.
his
it's
laser.
not the one I'm talking about, though. I'm sorry for upsetting you, but that's not the one I'm talking about. I'm talking about the one from the documentary that Raki is talking about, which is he said, if I can shine my light through this hole and that hole, it should be able to see
Right.
the third hole flat, which
Which
wasn't
is
a laser, it was just a torch.
it's exactly the one I'm talking about. It was originally supposed to be with a laser, which they were unable to use because the collimator melted onto the laser because he had it on a little bit too long. So he had an issue with the laser. So they tried to, like you said, ad hoc, just try to do something with a flashlight, which wasn't the original idea. But since they had a bunch of people out there and they had set some stuff up, they tried to just use a flashlight in place of the laser. So yes,
Okay,
there was an
yes,
issue that took
yes,
place, and you don't know enough about it to be able to speak as if you know all the ins and the outs and the details. If you wanted to,
You
you could
absolutely,
figure out. You could
yeah,
talk to Jerry.
true. Yeah,
that's
So
absolutely
another
right.
thing
So can I just
you had
check? Can I
mentioned,
just check with?
another
Can I
thing
just
that you
jump
had
in and
mentioned,
check? Sorry,
Bob Nodell.
interject
So
to
can
check
you?
on that one before we get onto the second one. We can get on to the second one in a moment. The thing I wanted to check about that one is did you just describe exactly what I said, which is he set parameters for his experiment, then didn't get the results he wanted, and changed the parameters post hoc.
No, I did not
Is that
say
what
that.
happened?
I
Yes or
said
no?
that his
No, we don't
laser,
need this
he had
bullshit,
a
man.
hey,
Oh my god.
I got it, Travis.
Yes or no?
I
It's
said
a yes
Alright.
or no
he
question.
had a
You did do that or
failure
you
with
didn't do
one
that.
of his devices, so he didn't change the parameters of it at all whatsoever. They just tried to do what they were going to do with a laser with the flashlight because the laser malfunctioned. They had an issue. So everybody there, globe and flat, both sides agreed that what they were doing was inconclusive because they had this malfunction with the laser and they really couldn't get any results one way or the other. So not proving flat, not proving globe, right? So it
I
was
didn't say
a
I didn't say
consensus.
proof flat or globe. What I said was he set parameters for his experiment,
and then changed them post hoc. It sounds like you're describing that.
No, he didn't change them. He didn't change them post hoc just randomly to try to fit like a flat earth, like you're leading your audience, which I'm sure you're streaming this right now, leading your audience to believe that he just got a result and then changed some stuff post hoc to make it look like the earth was flat. That's not the case. He had a malfunction.
I didn't say that. I specifically said that was not the case. I mean, please listen to the words I'm saying. I'm not saying he changed it to make it look like it was flat earth.
We listened to him, and you're very deceptive.
Of course you don't want to listen to it because it absolutely destroys the best evidence you've got.
Whatever.
Okay, I understand why you don't want to listen to it. I'm just inviting you to do so anyway.
I already
As he
listened
smiles through his teeth.
Right.
Yeah, I mean, it is funny. It is funny that you go, we've got these experiments that show flat earth, and then the best
can't comprehend what I'm hearing when you talk.
It is funny.
So let me ask you
what was the second one you were going to go on to? You wanted to talk about a second example. Like FE Core is another good example. Their collimator broke, and they didn't hit their target, and they still haven't released their results. Like, what are we, 8 years later now?
No, I was going to talk to you about. You said Bob did an experiment. So what experiment did Bob do, and what parameters did Bob lay out prior to doing an experiment?
I mean, if we're going to get stuck on the word experiment, then I'll just call it a test. Bob did a test where he, I mean, it's slightly mistold in the Behind the Curve documentary, but at least the telling I heard of a recording of Bob about it was that 2 of the tests had been done before he got his hands on it, and then he did another test, but there was a series of tests done with a rented or bought, I'm not sure which, but a ring laser gyro, and all of the intent was to find, like to test, like if we find 15 degrees per hour or if we find 15 degrees per hour or 0. And it seems like he found 15 degrees per hour, except when he took it to different temperatures and heights, he still found a rotation. Of the rotation he found, if you looked at the high and the low, it still averaged around 15. He never found 0. It was always rotating in the correct direction. But again, changed the parameters later to call it ether.
It's not changing the parameters. I mean, the Sagnac effect has been around for a very long time and was used within many different tests, including Michelson, Morley, Michelson, Gale, all of which were dealing with the Earth's movement either around the sun or the rotation, trying to find that through the ether. So the ether has always been a parameter within using interferometry. So it's nothing new. So don't try to allude to the fact that we do pick up a drift of something across the Earth, but it's not the Earth's movement. You can't determine whether Earth's movement.
Is it your suggestion then? Is it your suggestion then he bought or borrowed a ring laser gyro to test whether the Earth was moving when he already knew that a mysterious field was going to show him something exactly that would look like the Earth's moving? What kind of a test is that? Like, a test should give you a yes-no result. What you're suggesting is we all already knew that there was this mysterious ether that was going to make it look to the gyro like it was turning, but he still used a gyro to tell whether it was turning. That doesn't make any sense whatsoever. You've gone from suggesting that Bob was mistaken.
So here's the deal.
I don't think the latter is true. I think the former is true.
You're suggesting that he purchased or borrowed a ring laser gyro to test whether the Earth was or was not moving. Do you know that for a fact? Did he give you some sort of hypothesis?
Oh my God! Oh, you guys are so clearly intellectually dishonest. You are unable to even address this guy.
You don't even know. You don't know Bob, and you can ask Bob what his hypothesis was when he first got his hands on the ring laser gyro, and why would he move elevations if he wasn't trying to test whether or not elevation had a difference in this drift that he's receiving, that he's metering.
Of course he would. Because he set out to test whether the Earth was stationary. When he didn't get the result he wanted,
how do you
he
know
started
that?
twiddling with variables in the hope that he could find a result that did.
Can you give me a citation that says that Bob set out to see if the Earth was stationary? Can you link that in the text chat, please?
No,
if you can't do that, then go ahead.
If I'm wrong about this, what you can put in the text chat, because somebody played me a very long clip that I listened to a long time back where he came back and defended his things and then presented the ether as the explanation. I don't have any citation I can show you. I'm on my mobile. I'm in Indonesia. You're not going to get that out of me. But it, to me, is another example. I can give you more if you would like. I can keep giving you examples of flat earthers setting up good tests, smart people, like a clever idea.
Keep it up, Harry. Man, you're batting 1,000. You're doing great, kid. Keep it up. Give us some more, buddy.
Yeah, he's just giving
it is
examples
going well. This is
that are completely convoluted from what actually took place. You're just misrepresenting stuff. So let me ask you something, Eggshells. What would be a test that you have done that proves that the Earth is a globe? Or could you give us something that would falsify the claim that the Earth is a globe? Something that we could do that could falsify the claim of the Earth being a globe?
You've done it.
Falsification is pretty good. Is there something that could prove a globe? No, I don't think that's possible. I don't think that would be scientific or rigorous. You can't show that something is the case because there are unknown unknowns. Can you reasonably reliably show that something is not the case? You can get better towards that. So, like, is there something I've done personally? Not really, no. Like, I haven't gone out and taken pictures of lighthouses, if that's what you mean. But, like, I have looked a lot at the South Celestial Pole. I have confirmed for myself that the Southern Cross does a tight circle in the sky, and I have sought quite hard to find answers for how we could have what appears to be a central point of rotation that can be seen from multiple parts on the Southern Hemisphere. That is,
we're talking about the surface, right?
Sure, yeah. Can we tell where we are on the surface by looking at the stars?
We can get a good idea because the stars tend to repeat their patterns above us, so we can translate that to the ground. But the patterns that the stars make in the sky don't necessarily give us a specific indication as to what we're standing on.
Do they not? How could they tell us reliably where we are if they don't know the shape of where we are? If the shape was, would you agree this then? Would you agree that, like, do you hold to something close to the AE map where the North Pole is the center and there's the southern ice wall?
Oh, don't start that again. Bloody hell.
I mean, we need to start somewhere. One of my problems with disproving flat Earth, which I'm not able to do, is because it tries as hard as it can in every flat Earther I talk to present itself as unfalsifiable because it doesn't want to do these tests. If I'm engaged in this kind of adversarial conversation, then people will refuse to tell me whether they believe in the AE map. If I ask them to spitball and we're having a nice conversation, most people go, yeah, probably something like the AE map, but we don't know the layout of continents and there could be more land. But you know where this is going, right? If you agree to the AE map, that I can disprove, which is why you won't want to agree to it. Or do you? Prove me wrong. Do you think it's probably the AE map?
No, I don't think it's the AE map. I think there's issues with the AE map. And like I said, do you have a specific map that you cling to?
I think
so. If there's issues with the AE map, if there's issues with the AE map, that's a globe projection. So, what aside from the globe, what map do you have since you can't use the AE map
to disprove flat Earth? Is that what you mean? What's your question?
Yeah.
I'm not following it.
Yeah, where's your map?
That's exactly what I was saying. I struggled to disprove flat Earth because, like all pseudosciences, like homeopathy or spirit healing or breatharianism.
Well, that's cool. That's cool to try to lump it in with that stuff and just about things that are completely contrary to what we're talking about.
Please let one another finish, man.
But if we're talking about maps,
let him finish.
Please let's let one another finish. If you're talking about, I think the reason I can't disprove the flat Earth is because the believers of it, particularly the proponents of it, try to make it unfalsifiable, and I recognize that symptom in other things that I consider to be pseudoscience. In fact, that's one of the hallmarks to me of pseudoscience, and that is it presents itself in a way that cannot be tested.
Yeah,
perfect. Because that's exactly what I just asked you. That's exactly what I just asked you. How can we falsify the globe? And you said that basically we couldn't, right? So it's pseudoscience to believe in the globe. You're totally just proving exactly what we talked about prior to maps.
No, I don't know if you switched your question. It sounds like to me like you have. Can you falsify the globe? Absolutely. Prove there's no South Pole. Show lines of latitude don't match up. Show the
What do you mean lines of latitude don't match
polar
up? Do we
point is wrong.
have physical lines of latitude that are drawn somewhere that we can see whether they do or don't match up? Or lines of latitude just
They have to be physically like. That's a weird standard to set. That they have to be drawn on the Earth. What do they have to be drawn with? Like, no, they're not drawn on the Earth. But can you test them? Yeah, absolutely, you can test them. If you want to find ways to test this, talk to IB Hunter, because IB Hunter has measured the Earth, has done so physically. He's built things that map the sea floor. He's used gyro compasses, and he's used like all sorts of really cool machinery, GPSs, like undersea vehicles, and he has tested it. Have I? No. But like, yeah, I think there are many ways to test it. You just find any 4 distances don't match up.
Any 4 distances don't match up. What do you mean by that?
So get 4 cities where you're confident that the distances between them are correct. So like if you live in America, go, do I think that they are right about the linear distance between LA and New York? And then
well,
LA
we'd have
and
to measure that.
Florida.
Right.
Right, okay. Are you talking
and you can measure
the
them.
crow flies kind of thing?
Yeah, as the crow flies. And if you believe them because you test them with road times and maps and flight times and whatever else, and then all you need to do is go, hey, look, these don't match with spherical excess. Like you should be flying longer to get around the curve, essentially. There'd be millions of ways to falsify the globe. Here's one I give to people regularly. I will buy anybody a shiny new car. Shiny new car, I guarantee you. I've said it in the chat multiple times. Take this to the bank. I'll buy you a shiny new car, Mustang or anything you want, if you show me Polaris more than 5 degrees below the equator. I don't think it's visible more than 2 degrees below the equator with extreme refraction at the right point in its orbit, in its motion. But I want to make it 5 just in case there's some shit I don't get. But at sea level, if you fly me Polaris below the equator, you falsify the globe, I'll buy you a car. So there's many ways to falsify the globe.
Hey, how come? Hey, Larry, or no, not Larry. Eggshells. How come you can see the Southern Cross from Florida?
You should be able to see the Southern Cross from north of the equator because it's not bang on the southern. Can you see Sigma Octantis from Florida?
Hold on, Southern.
That's
okay. Why are you giving me giving me a red herring?
Because
I'm talking about the Southern Cross.
Okay, why you
the
can
Southern
see the
Cross
Southern
is
Cross
above
from
the
north of
horizon.
the... Exactly.
It's not actually
it's
the
not
southern point, is what he was fixing to say.
Exactly. Thank you,
okay, but how?
Yeah, it's not bang on the southern point.
Okay. How much difference is it from Polaris to the Southern Cross? Are they 2 degrees difference, 5 degrees difference?
No.
How much?
Miles.
From what I found,
miles.
the Southern
like
Cross.
You're talking like 10 degrees or more, I would say. Go for it, Armour.
Oh, I was gonna say, wait, if I got it right though, let me just double check. From what I'm getting though, it's saying it's what is it, -60 degrees? What is it, latitude? I guess for the GP, I guess for the Southern Cross, if we're gonna use yeah. So, I mean, the sky you get a full 180 degrees. So as long as you're as long as that's within 180 degrees of your wait, is it from your latitude?
No, it's up down, isn't it? Not the left, right.
My bad. 90. I think it's. Wait, hold on. Yeah, my bad. I'm having a brain fart right now. Give me a second.
The point is, Florida is much farther away from the equator.
Florida.
That's my point.
I would need to do the maths on that too. But if what you're saying is based on the right ascension and declination
eggshells.
of Southern Cross is,
you're trying to divert. You're doing the same thing Bryant does. Well, I'm gonna have to look into it. I'm gonna have. Can you send me a paper? Remember the guy that Whitsitt debated? He had like 10 things that he had to go look up.
Okay, I figured it out.
What do you want me to? I don't understand this. Hang on. Are you complaining that I don't already know exactly the right ascension and declination of all 5 stars of the Southern Cross? Is that your issue right now?
What I'm
Somebody
saying
brought up the Southern Cross when I was in the middle of talking about Polaris, and you're upset with me
because I'm unable to continue the conversation because I don't already know their latitude and longitude in space.
Yeah,
It's just
because he's
weird,
not a
man. Like,
human.
think about that
you're the
logically,
one
and
who
just
brought
go,
up
you
the
wouldn't
Southern
hold a flat
Cross.
earther to that standard. It's a dumb standard. Don't hold people to it.
You were the one that brought up the Southern Cross and how
Dumb
you
standard.
can see
Well,
it.
yeah,
No, somebody else did.
This guy just
Well,
put a nail in your
We're
fucking coffin.
talking about this kind
yeah.
of shit.
Well, anyway, to answer your question, you should be able to because Florida's latitude is 27 degrees north, and the Southern Cross's GP's latitude is roughly 60. So that is within 90 degrees, right? And so that you should be able to see it. Yeah.
Yeah,
Just let me make it simpler for you to get the shiny new car. Get any star outside of the 2 degrees for refraction, outside of where you should see it, and I'll give you a
Eggshell.
shiny new
Sorry,
car.
can the
So you see
shiny
Sigma Octantis from
Yeah,
anywhere in the
test
northern
that?
hemisphere. You just don't.
You're proposing something that's not going to be possible, dude. Like, what are you? Like,
Exactly.
what?
Can the
That's
shiny
why
new
I'm offering
car
a
be the
shiny new.
Tesla
You think I've got this
This is
money
stupid.
flying
that
around, Travis?
Elon's
No,
put up in
I'm
space?
that confident in the
Why
globe
can't?
that I'm willing to stake a shiny new car on it.
Yeah,
Well,
I
if
don't need a shiny new car. I just need a team of people and some time to do my experiments. So why don't you just do that?
You can
Look, if I hold
exchange
on,
the car for
If
cash.
hold
the
on,
experiments that you'll deny anyway?
if I fail, I'll pay you back.
No one's gonna lend you
I'm not
money,
giving you
dude.
money in
Every bank in the
advance to do
world would
something I
fucking
consider
laugh you out.
inconclusive.
Every bank in the
think
world would laugh you
I'm
out.
just talking to
I've
Harry.
never been. I've never been able to understand your test such to understand whether it would be conclusive either way. But I'm confident enough in my understanding of like celestial navigation and the positions of the stars and that of the globe that I'm staking a shiny new car because I absolutely will pay out.
Hey, but here's the thing though.
He's
Here's the thing
asking
though,
you to
right?
borrow
Eggshells.
some money so he could conduct his experiment.
Eggshells. Here's the
Harry.
problem though.
Why would I
You
pay him
have
to conduct an experiment that I think is bunk and won't work and will just cost me money to find out nothing about the Earth? Like, why don't you
eggshells.
just
Get
give
your
me
money
cash?
Eggshells.
You
You're
won't give me
asking
my money back. If you don't have the money to do it now, you won't have the money to give me back.
Harry.
No flat earther has money.
Harry, you're asking something though that is literally would be an impossible thing to do because
Exactly.
if I look at a building in downtown LA, no matter what the weather conditions are, if I drove far enough away from the skyscrapers, no matter what the fuck the sky is doing, I will not see them anymore at all because they're going to be so far beyond the vanishing point that it doesn't matter refraction, looming, a fucking mirage, whatever. If I'm in San Diego, I cannot see the skyscrapers in downtown Los Angeles. You're just too far away from it. And the thing
Yeah,
is that
this point isn't about how far they are away. It's just that I was asked by somebody, I don't know their name, what would disprove it? What would what are the ways to falsify the globe? And I was giving a long string of them, including one I'm willing to bet a shiny new car on. You're right. I think it is impossible.
Again,
but the challenge we have is
it's an absurd bet.
Right. So
like
hold on, guys. Let me get in for a second because I was the one that I was the one he originally asked. Hold on, Travis. So he originally asked me.
Guys, I have to go for now. I'll be back. Love talking to you all.
Bye,
And
Jamie.
I'll be back.
Yeah,
Lovely
take
chat.
care, Jamie.
Take care. Peace
So,
and love.
writing, you initially
Be-
said to me,
Be nice to each other.
you
Yeah, we'll
initially
try.
said to me,
We'll try. Good call.
yeah, you initially said to me something about falsifiability, right? Falsifying the globe, this, that, or the other. So
Yeah.
you brought up the stars as if you'll give a shiny new car if you can see this star from this distance, right? So perspective doesn't allow for us to see things forever, meaning as you get further away from something, it will eventually go down, 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 and eventually vanish from your perspective. So regardless of whether the surface of the earth is curved or flat, these ideas of perspective are still in play. And we've known for ages what the stars do and the distances in which we can see specific stars. So my question to you is, how does that necessarily prove the surface that you're standing on?
So it doesn't prove it. To go back to what I said, I don't think that you can prove things. I think you can disprove things. When you say things go down in view, yes, but what I think they do is they follow right-angle triangles. Laws of perspective is just right-angle triangles, things that shrink away from. I think, Travis, you taught me this, or maybe it was Rakia. Somebody taught me this rule of.
It's not just right-angle triangles.
Well,
that's what perspective is defined as. You're saying something other than perspective. You're saying something other than perspective, because perspective is a mathematically based, 100% accurate or defined method of measuring things.
So,
for instance, I would say it's not 100% accurate. There's refraction and stuff like that. But like, if a car is X amount smaller to me at this, like X size at this distance to me, I can use trigonometry to figure out how big it will be if I'm 5 times further from it.
But Harry, I cannot see a plane that's 30,000 miles up in the air when it's so many miles away from me. Even though you would think like, well, you should be able to fucking see it because it's only 30,000 miles. If I could see a star that's 1 trillion miles, I should be able to see a plane that's 30,000 miles. But what you're
30,000 feet.
I'm sorry. Yeah. I apologize. 30,000.
It would be maths.
Hold on. That's fallacious
I haven't
thinking.
done the
First
maths.
off,
I don't know the maths off the top of my head, but I think that the size of that plane would be like all I would need to draw is a triangle, of which the apex is my eyeball.
But what are you drawing a triangle to? You can't see it.
Yeah, let me explain it. Which is the further it gets from me, it's like a triangle. The apex is my eye, arguably the back of my eyeball. And the base of the triangle is the plane from wingtip to wingtip. That distance wingtip to wingtip, due to the laws of perspective, is always just going to be a triangle, and trigonometry will describe it.
You can't.
When flat earthers talk, so flat earthers, while you might be right about laws of perspective behaving differently or something like that, you're not able to put it in terms of, like, if you want to say how big is a plane going to appear, what is the angular size of a plane going to be at 30,000 feet, you want me to search it up now, it's on my phone, but I'll do it. And I can do it and come back to you with a number. It is going to be 2 arc minutes or like 1 arc second. I don't know where it's going to be.
No, Harry, hold on. Get out of imagination. See, this is the problem. You're stuck in, we can take calculations of the things we cannot see. This is a problem with a lot of your guys' arguments. You're living in
we're saying
imagination.
things we can see. We can see an airplane.
I'm saying here's what they'll look like.
Okay.
We can see an airplane at 30,000 feet. We take out our Q 9000. We take into account all the field of view settings on it, and I can now measure that airplane.
No. That's not the argument. Shut up. That's not the argument, bro. Shut up. The argument was a plane over Texas. I can't see from California because even though it's so high, I cannot see it because fuck it. Put a plane in Las Vegas. I can't see a plane that's over Las Vegas. Or better yet,
so I'm going to do it. I'm going to do it right. I'm going to do it right now.
Listen to me. I can't see a plane that's 30,000 feet in the sky in San Diego from Los Angeles.
What's the distance?
I'm going to do it right now. I'm going to put this in my that top end. C is my eyeball, and that plane is 30,000 feet from. Oh, we're going to do metric because fucking.
Okay.
It doesn't make any sense.
You're missing the point.
30,000 feet is 10,000.
This is science, by the way, guys. Everybody listening, this is our science today. This is science right here. Everybody listening, this is science. Math is science. Congratulations.
2 meters.
And what's a plane wingtip to wingtip? Let's make it big. Let's make it a big plane, 100 meters.
Plane width.
Yeah, this is
commercial airplane, right? Commercial airplane. So commercial.
Yeah. So it's going to be half a degree in my height, in my eye. So I should still be able to see that. That would be on close to the edge of our optical limit, because our optical limit of ability to resolve things, I think, is meant to be 2 arc minutes. Isn't that correct?
Even still, and they still go on. It's amazing.
Hold on. Wait, how big was the plane? You said it was half a degree.
I put it 100. I put it 10,000 meters from me, and 100 meters wingtip to wingtip.
Hold on, let me just double
Have you
check.
ever done this
Hold
stuff in reality? Like, it's great to draw
This is
things out.
reality. Like, okay, so
Draw it all out in orthogonal
here's the
view,
thing.
orthographic
If
view,
you
and then
want,
try to equate that to reality. But the problem
I've
is,
measured
there's
things. I've
many
done this
things that
just
go
from
on
perspective.
within reality that don't
okay.
perfectly match everything that you want to draw on paper, especially when you go to a side-on view of things and you just try to do all your little maths.
It sounds like you just don't
not
want
the way
this
it
to
works
match
in
up because you
reality.
know it doesn't match your reality. That's what it sounds like. It
No,
sounds
no,
like you've
no, no,
gone
no.
from
It
saying we
doesn't.
can prove. Let me
This is
finish. Let me
fucking
finish though.
retarded, dude. I
It
can't
sounds like
stand.
you've gone from.
No,
It sounds
I
like
don't
you've
care what
gone
you
from
think. It
saying
sounds like I've gone
we
from,
can
and
test this stuff to now we can't.
yeah, we can.
Perspective is to me.
You're not testing it
No,
right
no, no,
now.
no, no,
Perspective
You're
is
no,
just
just
no.
drawing on
triangles.
paper,
Harry,
buddy.
Harry. No, that's bullshit. I didn't say you can't mathematically add it up. I said you can't physically see it. Two different things, bro. Oh, I could
Right.
get a 1 degree
It's
and I got
obscured.
5 degrees here, and if I add this and carry the 1, shut the fuck up.
Wait,
That's
you're
not what
saying?
I'm talking about.
Hold
Easy,
on, but what is your? Hold on,
Easy. We're friends. Remember, we're friends.
yeah,
Yeah,
but
you're pissing me off right now because you're saying,
Okay,
okay,
let's stop being pissed.
So
hold on,
you,
hold on,
so
hold on,
dude,
hold on,
take
you're
ownership of you
saying
being pissed. I get that I had a part in it, but you're the one doing the pissed. And if we
my
chill out, we'll both be happy.
argument was that you can't see it at the I personally can't see it from where I stand in LA and I look over San Diego or towards the direction of San Diego. I can't see flights that have taken off the ground from San Diego, even though they're 30,000 feet in the sky.
Right, but do you understand what that means for me though?
Okay,
like
but what
there
I'm
is a simple answer to that.
Oh,
If you,
God.
I mean, I thought you meant a plane 30,000 feet overhead. I think I can see a plane 30,000 feet overhead, although it's
Of course, you
at
can see a
spec.
plane 30,000 feet up in the sky. That is retarded. I said when it's in the
Easy, man. Easy, chill.
Okay,
Like,
you're
if
right.
what you're saying, if what you're saying is if I'm in LA and a plane takes off in San Fran, yeah, I mean, I don't know what the distance is between those, but to me, yeah, one should be around the curve. Now, I get that you say that could be a factor of perspective, but the point I'm making is I can put numbers on my perspective. It doesn't mean the numbers are right, but it means we can interrogate the numbers. Like the moment I say these numbers, you can hear Armour getting his hot little sexy little typing fingers and typing those sexy little hot little numbers into his calculator because he can test them and he can turn around and say, hey, your numbers are wrong. My sexy little fingers found out that they are the numbers X.
Get a room.
He can test them. He can what I mean is he can falsify what I'm saying.
Okay,
That's
but
the
here's what
point
I'm
I'm
saying.
making about flat Earth. It doesn't make itself falsifiable.
But Harry, the plane in the distance, in the sky, not being able to see it, is why I was saying your show me Polaris from this distance away. It's just, it gets something in the sky, no matter how high, when you get far enough away from it, you will not be able to see it.
Okay.
Like literally.
Let's do it. Let's do another way then. Geo's got this idea for a test in the southern hemisphere, which is you get to the Tropic of Capricorn, right? Which is the lowest point on the southernmost point on the Earth, over which the sun will be dead overhead. For Sydney, it's never dead overhead because we're south of the Tropic of Capricorn. So his idea is trace the subsolar point there. So you can know, even though you don't know the distance from it, you know if something's dead overhead or not because you can measure that. And what you know is on the equator, the sun, the GP of the sun, the point at which it's directly overhead, moves across the Earth at around about 1,000 miles an hour. Right? That's the rotational speed that it's going around the Earth. What it moves at the Tropic of Cancer is less than that. What his test idea is to go, if we go to the Tropic of Capricorn, it should be on the AE map faster. What it should be on the globe is slower. It should in fact equal the Tropic of Cancer. So now you don't have to know where the thing is or how far it is or anything like that. It's just something you can see. But you're going, at what point is it dead overhead? And I can use tools like a sextant, or you could use a plumb. You could use a bunch of ways to test that. And go, when is it dead overhead? Click my stopwatch, and then get somebody else a couple of hours around across the plane around the Earth to click their stopwatch. Then compare your stopwatches and go, how fast is the sun traveling. My point is, this is yet another way that I can test the globe, or I can test the AE map, which is why when I asked our chat before, does he hold to the AE map, he didn't want to say yes, because the AE map presents itself in a way that can be tested and hence can be falsified, which is why every time you test it, it is falsified. Whereas every time you
I
test
didn't
the
hold
globe,
to it because no maps are accurate, regardless. So I don't hold to any specific map. No, I don't, and
okay,
I
can I check?
certainly am not going to be
I'm not.
strawman into the AE map is the only map that could be a flat Earth model or anything like that. So don't try
Okay,
to strawman.
can I test? Can I test? Sorry, what's your name? It doesn't show up on my mobile, so I don't
Sounds like
Discord in my
napalm.
chat. Something sounds
Napalm.
It sounds like
Napalm. G'day,
napalm,
Napalm.
Harry.
So Napalm, do you think that some maps are more accurate than others? If we throw it, if I agree with you on the premise that none of them are 100% correct, do you think that some maps are more accurate than others?
Sure, I would say a local map of your city or town is fairly accurate.
Okay.
I'd like to ask a question, just prompt on this, Eggshells. Just a quick question. Do you hold to the general model that the North is in the center of a plane or in the center of a path that the sun takes above the surface of the Earth? In other words, does the sun circle around on a flat plane above that surface with the North being in the center?
Good question. Well asked. Really clean question, that one.
Are you asking me or are you asking Eggshells?
Yeah, I'm asking Napalm.
I don't think that's the case. He's asking you.
Yeah, I mean, I don't know for sure. I mean, it seems as though yes, the North seems to be central to what we know for the most part. Everything in the northern hemisphere, as far as the AE map is concerned, seems to be fairly accurate for the most part. I do feel like there's probably some discrepancies the closer you get to that north central point, and obviously some discrepancies further in the south. But
so would you agree then?
I don't know for sure if there is a movement of the sun directly around the central point, whether it deviates coming further north and further south. That could just be an optical thing to us, and not necessarily a specific physical movement of the sun closer to the north and further to the south. So I don't know for sure.
So would you agree, Napalm, that your answer there, I couldn't falsify? There's no test I could run on the answer you gave. Oh no, I guess there is. Actually, here's the test I would run on the answer you gave. Would you agree, therefore, that latitudes, as we go further south, would have to be longer?
What do you mean?
Latitudes are sort of lines parallel to the path of the sun, or lines emanating out, if you want, from the North Pole. Would you
What do you
agree
mean
that
would have to be longer? Are you talking about drawing them out specifically on a map? I don't know. Sure.
No. So I mean, they don't have to be drawn, right? Like mine, like I just mean lines of latitude exist. We can.
Lines of
I
latitude
would struggle
exist. They exist in models, brother. They aren't in reality. I can't go out and
So this is what I mean.
physically
This is what
see
I mean.
a line of latitude.
You will refuse to make this falsifiable. And the reason I think you're doing that is because I think somewhere inside you know that the moment you stick to any particular answer, I will be able to disprove it. So you don't want to stick to an answer. That's why I think that the flat Earth is false.
Harry, what about this?
Well,
What
thank you
about
for the psychoanalyzing, but you're incorrect.
Harry, what about when they've made maps? They made maps in the past, and they showed it as like a picture from space, and America was like extremely large compared to even Africa, or Africa's way smaller than like Greenland, or the same size even though we know that like if you did take the measurements of what people travel across it, it's way larger than what they made it to be on this photographic map from space. So when they've made those errors, how does any baller just be like? Because remember, they said this is a picture from space, and then when you realize like somebody like fucked up and made a picture that doesn't represent even the measurements here on the ground, let alone from space, then how does that not like raise a red flag on any of guys' minds and say, well, wait, maybe they are?
I don't know what the bit. I don't know what the bit you're referring to is, but I certainly know that there have been disputes in the past. It's in fact my understanding is Australia learnt from disputes in America because America drew up its state borders along lines of latitude and longitude as well. And my understanding is actually the lines of longitude it's very hard to know where you're at in time, and there is actually some dodginess there. So Australia, when it drew up its borders, used celestial navigation, or not even navigation, but like used observations of the star to set its state borders so that we didn't have the same issues. Because yeah, you're right. Like maps have changed in the past. Like there's also countries that, totally separate thing, I know, but countries that set its map by a river and then the river changes its course. But to me, the model changing, like the map changing, is only to me an issue if the map changes from like so wildly that it makes me think that the person who made the previous one was lying. But if somebody goes, oh, state border's here, and then they move it like 2 miles and they go, oh, this is actually based on an incorrect calculation we did before, and it gets like closer and closer, and like, for example, the changes somebody makes to a model become smaller and smaller. Like we started off with a rough idea of the radius of the Earth, and then we get down and down and down till any changes that are made nowadays are probably in the centimeters, I'm guessing.
All right, Harry, check it out.
That to me lends credence to those changes.
Okay, Harry, check it out. See, the picture I posted at 21 minutes after the hour, that's from NASA. That is their blue marble picture. And look how large America. Where's the rest of the world at on this ball? How can it even fit on this ball?
I don't know. I don't know where the image comes from, but I'm sure. I mean, I think things should look.
You need the link from NASA.
Come on, man.
No, I'm not doubting it, but I mean, things should look bigger if they're on that side of the globe. That's a major problem with all of the like Mercator or all of the other projection maps. It's really difficult to show stuff on a globe. Like, for example, let's put it this way: if I was down on the ground, if the Earth was a globe, and I was down on the ground looking at the ground in wherever that is, Florida, Mexico, somewhere, everything I see from 180 degrees will all be America. Like by America, I mean like North America, including Mexico. As I go up, the Earth will start to disappear away from me, but still America will dominate my view. It will have more of my perspective. Again, if you want to test this, it's what I said before. It's triangles.
Mm-hmm.
Just do
because
this
it's so
triangles,
big.
and as you zoom out, you can do this with maths, is what I'm saying. You can find out.
You're saying that because it's so big. How we see it from the ground.
No, I'm not saying because it's so big. I'm saying because the closer your perspective is, the more of your view it will take up. So it's more about not the Earth's so big, but where your eyeball's at.
I got you.
Arma could show you this in 20 seconds on a thing.
Can I ask you a quick question about being on the ground and seeing Earth curve? I think when I stand in certain spots along, especially along parallel objects, it looks like it's curving to me. Like I have video and pictures of this. Is that Earth curve?
I don't know. I mean, I'm sure you can get things that would resemble Earth curve that could well be sort of lensing effects, and like my 360 camera can make it look like I'm on a planet the size of like a large.
No, I'm talking about with my eyeballs, not with a wide angle lens. But I guess our eyeballs, our lenses are wide angle lenses in some aspect. But I guess I'll rephrase the question. Do you think I'm seeing Earth curve, or do you think I'm seeing perspective optical effect when standing on the ground and viewing?
I would struggle if it were my eyes and my brain. I would struggle to perceive Earth curve, I think, when I'm at sea level. Like I've been on a bunch of ferries lately, and I get to look out at the ocean, and I don't perceive it as curved. But do I see it as curved? Is a different question.
Is it small enough to see the Earth curve from the ground, or is it too big to see Earth curve from the ground?
Mathematics is difficult, I think, because it's like, let's say I could see 180 degrees view if I turn my head. The question is, in that, should I see Earth curve? Mathematically, yes. I mean, mathematically, if I got a 1 millimeter wide chunk, there's curve in there. It's just so infinitesimally small it would have a bunch of zeros in front of the decimal point for degree. Do I perceive it? Like, do I look at that and go, "Oh, tiny little ball"? No. I think.
I think due to perspective,
obviously the
right?
Earth is.
Hang on, you answered
Yeah.
it. I'm fine with your answer, but as a 6-foot man viewing out to the horizon appears to rise up, however far, but it's 3 miles away, let's say, and then after that it should be appearing to curve down due to Earth curve, but we don't see that. We see the distant horizon continuing to rise up. I find that strange.
What I would definitely agree is the Earth is it could well be flat, but if it is a ball, it is evidently a ball big enough that yourselves, half the people in this room, and people throughout history have looked out and perceived it and thought it to be flat. So obviously, it is like by your very existence, it is not something so obviously curved that everybody could see it.
Yeah, that's a fair answer. I kind of go against Soundly where he says he's seeing Earth curve with his 20/20 vision. I think even if it is a ball, you wouldn't be able to see it. You're just seeing perspective and optical illusions basically created by your eyesight and the atmosphere you're looking through or the medium you're looking through. It wouldn't be Earth curve, but he chooses to call it Earth curve, but that's weird. But if it was a flat plane, the water being horizontal, like looking over a large lake that you can measure horizontally, and it doesn't have waves and things that can kind of misguide your brain from what you're seeing. The distant water appears to rise up and merge with the sky due to perspective. So that gives it even a different look. It doesn't, you're not appearing that you're 6 foot above the water. It appears that the water is at your line of sight, which is we all know is not true. It's just because of I call it an optical illusion, even perspective, because the water actually isn't at your eyesight. It's just that illusion is being created. Right, exactly. You're always 6 foot above the horizontal plane that's created by the water. If it's curving away, it's even worse. So from your feet, if it's curving away from every point, then you should not only be 6 foot above right at your feet, but you should be 6 foot plus X, right? X square, actually, in every direction. And that's not what we see, brother. And that's not what we measure.
Well, I'm not sure that's not what we see because, like, going back to the point that that Apocryphon raised before, if you're seeing out to, let's say, the horizon's at 3 miles out, if what you're seeing out there is, like, essentially the question would be, how big would a 6 foot person look at 3 miles out? And I would
No, we're seeing the horizon, right?
But the point is, how big would a 6 foot person look? The reason I'm asking that question is you're talking about eyes at 6 foot, feet at 0 foot. How big is that at 3 miles out? And the law of perspective, Armour could crunch it in a second in the calculator, and you would go very, very small. It would be very difficult to perceive that kind of difference at 3 miles.
Yeah, but it's the horizontal line that our eyes create, or that we can create with our eyes, is 6 foot above the water should never appear to rise up to that point or towards that point. It does due to perspective, the way our eyeballs are shaped and the way the angles come into the back of our lens and all that, and our brain interprets that. That is the optical illusion being created with that short distance. Now imagine something beyond that distance. It might be in its original position, so it's going to appear lower beyond that point, which is going to create some obstruction, correct?
Can you say the last bit again in a different way? What's going to create an obstruction?
Well, we have a 6 foot observer looking over water. The water appears at 3 miles to be at or near its its horizontal line of sight, and that's a point, right, that you're looking at, and it looks like where the water meets the sky, right? And it appears to ramp up or rise up towards your line of sight. Well, beyond that point, if an object is taller than 6 foot, that object is going to appear in the background to be lower because your perspective, is due to your height above. If you're 6 foot or 10 foot or 20 foot, the perspective is going to go to that distance. Anything beyond that distance is going to appear lower, therefore be obstructed.
On that last point, no, I don't agree. Like barring refractive effects, there could be refractive effects that sort of that bend water in the foreground up. Like I certainly think that there are refractive effects that can make it.
No, not in the foreground.
The Earth look more curved than I think it is, but I don't think that they're like the perspective, the law of perspective, which obviously ignores refraction because it's just used for pictures and stuff, but it's still mathematical. Doesn't ever create a situation where something is obscured when it's not. All it does is shrink things at a trigonometric rate.
I didn't say the law of perspective did that. I said the law of perspective creates a point where at a certain distance due to your viewer height creates that point, right? I think they call it the vanishing point. And anything beyond that, that's larger and taller than your viewer height, your horizon, your horizontal line of sight, is going to appear in the background and is going to appear lower due to that optical illusion of the foreground, due to perspective.
So this is a thing I've heard a lot, but I can't ever wrap my head. Like, are there any things that other examples or sort of
I can give you a way to show it to yourself.
Yes.
I can give you a way right now in your room.
Sorry. Just let me finish. Like numbers I could put to it to be like, for example, like how do I know where this point's going to be? How much of an object is going to be hidden, and what mechanism hides the bottom but not the top?
Oh yeah, I'm sure you could do a spreadsheet on that easily because we know the vanishing point due to the distance of if you take out refraction, of course, and perspective is taking out refraction. They do it in the numbers of perspective is done in basically a vacuum. But if you do it that way, I'm sure you could figure it out. But I can give you a way in real world right now in your room. Just put your hand out, your left hand out in front of you, and put the top of your fingernails at your eye level, and move it closer to you, like halfway maybe. Like extend your arm all the way, and then move that left arm closer about halfway to your eyes where it's still at your line of sight. Take your other finger, put it at your line of sight, and move it past that fingernail tip. And at some point, you won't be able to see your right hand finger because of you're going a further distance away from that vanishing point. And that's obstruction.
To me, the only way I could hide one finger behind another thing, again, let's stick with sort of inner vacuum laws of perspective. The only way I could do that in my mind is if it actually was obscured. If I drew dead lines of sight from one to the other.
The angle gets so small, the resolution can't be made out, so it appears to be obstructed bottom up. It's not, right? You and I can agree that it's not obstructed bottom up, but because of that 0.02 or whatever, once that angle gets below that, you can't resolve the information of your finger or whatever object is beyond that point. So it appears to be obstructed bottom up because you're just losing that information. It's not actually obstructed.
But how does the 0.02 happen and the appearance of bottom up obstruction happen when in cases when I can still resolve the top of the object? So like the 0.02 is meant to be the minimum angular size something can be that we can see. It doesn't to me explain why half of it, like a mountain, for example, that's sort of
I can explain.
Taking up a degree of my view. Why is the bottom subject?
Because it's at a different angle. It's at a less acute angle. You'll be looking up at the top of the mountain, but the base of the mountain is reaching that acute angle where it gets below that resolving point. So the bottom of it is unresolvable. So it appears to be obstructed, but it's not. It's just not being able to be resolved. It's merging in, blending in, if you will, with the medium that you're looking through because of that angle and the way our eyes work.
Hey, yo, Eggs, have you ever done that with that, like a, oh, what up, brother? Have you ever done that thing with the coin on the table?
That's an aperture issue, though.
Yeah, I've seen the thing with the coin on the table. I haven't done it myself.
Dude, do it if you do it. If you do it
with armor
yourself,
on it.
if you do it yourself, it's kind of it's interesting, especially if you have, let's say, like if you have like a flat table and you have like, let's say, if you have your girl or something like that, hold a coin and just let her scrape it all the way away from you. You know what I mean? You're on one side looking at it like what you perceive to be level. You know what I mean, from the beginning. If you pull the coin away from you, you'll notice like the bottom of the table will like appear to obstruct all the way up as the coin goes further down the table, and it looks, you know,
it's not actually obstructing.
But that's
it's so cool. It's just a cool little thing to do because it kind of makes the point for it makes the
Well,
point.
he's saying it's aperture. Yeah, of course. It's the way our eyes work. It's the way lenses work, and it's due to distance. The coin and the table are merging together. They're blending together where the resolution can't be made out. Your brain can't interpret the information because it can't resolve it.
No, that's
yeah.
When I say aperture,
Exactly
when I say aperture, I'm not talking about you're talking about like you're still talking about like angular resolution. But the aperture example, right? The thing is, the reason why that penny or that coin, whatever, is actually able to disappear is because the table, all right, is actually technically blocking it. It's just that when you have the aperture, you know, large enough, it will take in some of the light from above the table. But if the aperture is small enough, then it won't. All right, and that's when the coin is hidden.
You can take that out of the equation. You just have to make the table really, really long. The camera lens doesn't have to be halfway above and halfway below. Certain camera lenses take in light from the top when you zoom out and from the middle when you're not. That's not what we're talking about. We're talking about the angle.
I've got a
I was
table
almost
here.
done. I was almost done.
Sorry.
What we're talking about here is when the angle gets so small that the two objects, the one on the ground and the one above it, are merging together where your brain can interpret the information and it looks like it's obstructed, but it's not.
Yeah, well, that's.
Is it similar to this? And maybe not. And tell me to shut up. But like I've done like amateur theatre and stuff, right? And if you go to the theatre and watch a play or a musical or whatever, the stage in the theatre is sloped, like it's like on an angle.
Yeah, I'm with you.
Yeah.
Hello, Andrew here as well. I'm with you.
Yeah. So yeah, because if you were sat in the audience and the stage was just, you know, like a tabletop, then like you'd lose half your actor because you would see the stage and then the top of his legs and the rest of his body. Or so the stage is sloped.
Slopes. Of course, a hill obstructs stuff. Of course, slopes obstruct stuff. We're talking about how light is perceived, how information is not resolved once the angle gets so acute. Not that a physical object like a hill or a slope is in the way. Of course, that obstructs things. You're not receiving that information either, but you're not receiving this information for different reasons.
Yeah, but I mentioned
Could
the stage thing
without
because
attempt.
I'm interested in the coin on the tabletop thing.
Yeah. I was going to go into that just quickly. So you can actually eliminate whether it's like quote unquote physical direct obstruction or let's call it ocular obstruction or whatever, by just zooming in. If you can zoom in and see the whole coin again, then it wasn't actually being obstructed.
Exactly. You zoom in, you can see the bottom.
That I think will also fix what Arma's saying, which is aperture is when the area catching light is really big. So it's catching stuff that's from above the level of the table to below the level of the table. It's like a cat with really like dilated pupils. But my understanding, Arma's going to correct me on this probably, is that when you zoom in, you naturally narrow that anyway. Because to me, I can like would you agree with this, Rakia? The thing I'm talking about, I can draw and map and show mathematically, and the thing you're talking about, you're not able to.
I think it might be.
What are you talking about? I have video proving this, and this is very well documented in perspective. This is not something I'm making up or just dreamed up. I'm just using the current science to hang on. I'm just using the current science to tell myself and to teach myself and others how something on a flat plane can be obstructed, and this is without atmospheric conditions. So once you throw in atmospheric conditions over
I'm not saying you're lying.
yeah,
Sorry to
of
jump in.
course you can because
I'm not
it's
saying
documented. This isn't me.
I'm not saying you're lying, but to me, like filming something, when what we are debating is the optics, is like, well, obviously, if you're debating optics, using optics isn't gonna square it. Whereas, like, if you use maths, you can go, okay, do the numbers, match
This is
the
all
optics,
mapped
and
out.
now I've got to.
Hey, real quick.
This is all been mapped out already. When the angular resolution gets too small, you can't resolve the image. This is all current map.
We're talking about resolving half the image, though.
Hey, yo,
guys, we gotta let each other finish because we can't moan about being cut off. We're cutting other people off. No, it was everyone. I'm not even going to any specific person, but we can't moan about being cut off if we're doing it ourselves. So,
it hasn't been bad.
Yeah, it's pretty bad then.
Go on, Issa.
Well, I was just thinking, like, you're over here like asking for the mathematics of what we can clearly demonstrate on, let's say, like a table with a coin. So I mean, just like regardless of like the mathematics or whatever it is, like we have like let's say we have a microcosm for how potentially maybe the sun is setting. You know what I mean? Like, whereas, you know what I mean? So it's just an interesting, like, regardless of how the aperture actually does what it does or whatever, like, we still have like a microcosm as an example that's very easy to relate to reality. You know what I mean? Like,
My challenge with the table one is, like, the table is going, can I reproduce this effect? But I've never seen anybody do so in a way that's able to confirm for me the lens is bang in front of the table and the table isn't warped.
right, but that's
both like to me. It's like if we talk about like, hey,
you
trust
already
your
said you
senses,
didn't
which you're
do
big
it.
on, right?
Right,
But
you'd have to do
you're
it
saying
yourself.
but like you're big on your trust your senses. To me, like if I want to know if a pool cue's bent before I play pool, I look straight down it. And if I can see like the butt of the cue, the middle of the cue, and the tip of the cue all line up, and I turn them, and never is a hump in the middle of the cue obscuring the tip of the cue, I got a straight cue. I'm gonna play with this puppy. So I trust my senses to tell me if something is obscure. The foreground is obscuring the background, and I go, if the foreground's obscuring the background, you'd smash me to pieces. I might be better at picking a straight cue, but the way you said that made me think it wouldn't do me much good.
Yeah, you can look down at all you want. I'll roll it on a flat surface, and I'll outgun you like 10
Well,
out of
but here,
10 out of
this
10.
is the thing. Eggs, now check this out. Eggs, check this out. So to confirm that you've got a straight cue, you look down the eye of the end of it, and you have a look for yourself. Now, regarding the coin on the table, you can do that for yourself too, but you haven't. You're looking for somebody else's video. Well, I'm just saying, like,
I just posted. Check the chat.
Oh no! Hold on. I'm not talking about somebody else's video of it. I'm talking about you doing it.
No.
And what I mean
check
is
the chat. I just took that photo. I'm in this room right now.
Oh, awesome! And forgive me if I didn't check the chat.
It wasn't a coin though. It's my battery pack. But
fair
yeah,
enough.
the battery I'm using to charge my phone while we do this. But to me, like if something's obscured in the foreground, there could be bending of light. Like you could be talking about refraction that's pulling the foreground up, which is a lot of what Travis's works on. But if something in the foreground obscures the background, whether it comes from left, right, top, or bottom, then there's something in the way.
Well, do you think that's naive it's a naive conclusion knowing that there's like this mysterious light action happening?
Not when I trust my senses. If you ask me to trust my senses, then my senses tell me something's obscuring that thing. Same as if somebody poked their head around the corner of a door, I wouldn't go, hey, maybe they're already in my room.
Good at finding a pool cue either.
It's a false dilemma, Harry.
No, but I wanted to ask Eggshells, are you Australian?
Yes, yeah, good guess.
Yeah, okay. I just because I love that analogy. Like only in Australia would bring it down to like a pool cube, like playing pool.
He heard it from us.
Yeah.
No, listen, Harry, that's a false dilemma because you can clearly see in an extreme example that a mirage can obstruct something that is obviously behind it. So your initial.
But I've said that multiple times. I don't know if
I
you just
know.
got back to
Please
the
let me
conversation, but
finish,
I agree.
please.
Sorry,
I'll try not to be too long. Your initial trusting of your senses for an inferior mirage might lead you to think that there's something out there, really, and you try to walk out there and you never get there. You're like, well, I thought there was water, but there's not. So there is an aspect in which you have to then reassess what you're seeing. Okay, so now you have a refraction.
100% agree.
Right, exactly. So go with me on this, or please follow me on this. Now you have a refraction phenomenon that doesn't have a mirage. And yet you are looking at something that apparently is one thing when you can clearly demonstrate that if this refraction weren't here, that observation would look entirely different.
Say it for me again, how you just said it. You need to go beyond your sense. How did you say that? The first thing where I agreed with it, I really liked it, and then it slipped out of my head. Sometimes you need to go beyond your senses, or something. What was the wording you used?
Whereas you would have initially trusted your senses, upon further investigation, you would have to reevaluate what you thought you saw. Okay, so in the instance of an inferior mirage, there is obstruction.
Yeah, I think there's probably many cases. Sorry to jump in. I think I agree now. Yeah, I think there's many cases that probably globers present to you of being like, look, this thing is being obstructed bottom up, where it could well be the case that that light is being bent upwards. And I agree with you. Sometimes, like my initial impression, like I need to investigate further because my initial senses are unable to go, because for me, it, like my meat world reality, like let's pull it back from talking about things miles away on the horizon. If I'm trying to chuck a ball at someone's head and their head's obscured by a door frame, I can reliably assume that their head is behind the door frame. But should we sometimes question or doubt that sense with more information? Sure, yeah, I think you might be right on that.
All right, so let me just piggyback real quick, and again, I don't want to talk too long. That image that you posted once of that sailboat in the distance on the lake, do you remember you did it like within the past couple of weeks? So it's a beautiful blue lake, and then in the distance, you can see the sail, but no hull.
Yep.
Okay?
Yes.
Okay, great.
Yeah.
Now, in different conditions, you'd be able to see that entire boat, is my prediction. Okay.
Oh, so let me try and find it again. Well, yeah, keep going. Sorry,
I made a cutout of it yesterday, making an explanation of something. But the reason why I'm saying what I'm saying is because on the Chesapeake Bay, during filming in the course of a morning, I had a catamaran mast completely visible and no hull. Couldn't see the catamaran. Within 2 hours, the catamaran was visible, and it hadn't moved. But the conditions of the day had changed. So, again, I'm seeing something that I initially would have thought, oh, there's curvature because I can't see the hull. And I'd go on my merry way. And then 2 hours later, Mother Nature goes, bing, and is like, where'd Travis go? Where'd Travis go? He didn't see my magic trick. You know what I mean? So the fact that you're giving us credit in one instance with the inferior mirage, I'm asking you to give us the same credit now with this added information that I've been saying for a couple of years, that even without a mirage, the refraction creates obstruction.
So yeah, I think you're probably right on that. The only difference for me is I think from the conversations we've had, if I'm understanding correctly, is what I think your position is, that's always what's happening when things are structured like from the bottom up. And my position is, I think that's only sometimes what's happening when things are obstructed from the bottom up. So I don't think that what you're talking about is impossible. Indeed, I think it does happen. And again, something else that, exactly as you say, my senses say that thing's obstructed, but they might be wrong. I might need to investigate further.
Right.
It's just, I think the only difference in our positions is I think that sometimes it actually is obstructed, but I can't tell the difference between them.
Right. But see, in this instance, you're begging for another explanation when you don't need one, right? So when you then say,
the other way around.
Hold on. When you say, Travis, I'll give you 9 out of 10, but that 10th one is definitely curvature. That would then, because if I've proven my case for 9, right? If I show you 9 different things with all of the variables covered and experiments and tests and notes, and you go, look, 9 out of 10, Travis, that's awesome. But that 10th one is definitely curvature. That would then fall on you to bear that burden to prove that claim.
No, it wouldn't, because my position on it is, unlike it was originally, is now, I don't think whether, like, looking at things, particularly over water, is a very good way of determining the shape of the Earth. I think Al-Biruni and the people who invoke
it's got nothing to do with, right, it's got nothing to do, look, this discussion of refraction, from my perspective, has nothing to do with the shape of the Earth. I'm sorry?
I said he almost got to finish.
Yeah, I was still kind of speaking there, Travis. What I'm saying is, like, I'm not out to disprove what you're saying or like prove that you're wrong or anything like that. All I'm saying is, I now hold a position of like it's just a bad way to determine things.
Okay,
I wouldn't use it to determine things. I'm doubtful of people who say, "Hey, doubt your senses. It's not what it looks like it is. It might be something different." But I've got my ear open to you. I'm happy to listen to that. The only reason I invoked it as like trust your senses is because Issa and I talk a lot, and Issa is almost done. And Issa is big on I don't like these fucking people telling me I shouldn't listen or shouldn't trust my own senses. That's all. That's the
okay,
only reason I invoked it.
Right. It depends on what the claim is. Okay, it depends on what the claim is. My claim has nothing to do with the shape of the Earth. My claim has to do with visibility. Okay, the fact that it has application to the shape of the Earth is a reality because there's a claim that the Earth is shaped the way it is.
To be fair,
And
though. Oh, sorry, go on.
Go ahead, Issa.
I was just saying, to be fair, I was kind of making the point that, like, I was kind of poo-pooing your point, if you will, talking to Eggs. And Eggs was saying how, with the same atmosphere ideas that you're showing, to him prove obstruction. If I'm not mistaken, Eggs.
No, I wasn't saying they prove obstruction. I was saying like that's to me what they look like, and if I were to just trust my senses, that's what I'd go with. But yeah, I like the whole reason I brought. I don't know when during the conversation, Travis, I was deliberately invoking what you were saying to say I think Travis is probably onto something. That things can be obscured bottom up, and my senses might not be good for this. But it was more sort of
but
playing with what you say about I trust my senses.
Yes, sir. And I was saying, like, in the sense of like trusting your senses, you think your senses would lead you to think that is obstruction.
Yeah, my senses would. Yeah.
And my point is that now your senses couldn't also incorporate the notion that the light may be doing magical shit over there. Like, you know what I mean? Like regarding what Travis is talking about.
But hang on. Are you getting into the same territory,
you don't think your senses
because you're saying
would,
it doesn't feel like we're. But you would say the same, right? It doesn't feel like I'm moving. But could your senses be interpreting that wrong?
I mean, I guess I'd have to give you that. Maybe I would say the same, but because you don't know. But in the same sense of, like, because you don't know what's actually happening. But the proposal is there. And it could be, one could be led to believe that there's like spooky light action at a distance over the horizon versus like obstruction. Especially
to me is why, like,
what's that?
No.
I was just going to say, I was going to bring it back to this because my real notion for any of this is the idea that we can make microcosms of these things. That's all. But you know what I mean? Like the idea that you could have a glass of coffee or a cup of coffee and it's flat and level across the top. Like that's a microcosm of applied science. You know what I mean?
Yeah. Like
So
for me, the thing is, and I don't mean this to poo-poo or throw out what you're saying, Travis, but like essentially when it comes to light at a distance horizontally, there is like particularly like exactly the horizon distance. There is one side claiming, yeah, the light's bending in such a way to make it look like the ball isn't the correct radius, like the light's bending up to make it look planar. And on the other side, they're saying, oh no, the light's bending down to make it look ballish. And what that means for me is, unless I have an empirical way to split between them, which I probably could find, but honestly can't be bothered, I just will throw that argument out altogether and let's move on to other arguments where there is not parity and investigate those.
Well, and that's why the microcosm. Pardon me, Travis. Go on, brother. I was just bringing up the microcosm, but go on.
No, you're exactly right, and Beerman and I are starting to work on thinking through more of that microcosm. But Harry, what I'm trying to tell you is if you went back to that same lake where that sailboat was, you would have evidence that you're not looking over curvature, right? Because I took it to mean that when you posted that photo, that you apparently think that sailboat is blocked by the curve of the Earth.
No, I didn't. Like I posted it because I think I meant to put it in the chat a moment ago, but certainly on the day I tried to post it. Let me find it again. I'll just find it. But it's was far too close to be obstructed by Earth curve. I didn't at the time think it was Earth curve.
Great.
I thought it was funny.
Then what's obstructing it?
Right, great. So hold on.
Let me post it again.
Question, Rakia. Right,
find it,
good
and then
question.
It'll be funny.
So here's the point, though, is that your generic assessment right now that it's far too close doesn't take away from the fact that the obstruction is created by refraction. And this is what I have said for 3 years. A mirage.
How did you determine that?
Hold on. A mirage or refraction is mirage or refraction at any distance. So if you have obstruction created by refraction at too short of a distance for it to be curvature, then when you have that same refraction phenomena at a different distance, perhaps even farther, it's still refraction and not Earth curve.
Yeah, it should be proof that it's happening at a shorter distance, that of course it's happening at a longer distance, because the more distance, the more medium, the more chance you have to be affected. The light has to be affected. I just posted my shrimp boat. That's less than 4 miles. I would say it's actually 3 miles, but I give it 4 miles just to be safe, with a viewer height of about 8 to 10 foot. And that is what people call Earth curve. When I show this picture, they go, yeah, well, the great proof of the curve of the Earth. Well, no, unless you live on a basketball, that's not the Earth curve causing that. That's some type of, optical phenomena, or optical illusion is what I call it. The foreground is appearing to ramp up and obstruct something in the background is the best way I describe it. But it's based on atmospheric conditions and the way our eyes work and perceive things, the way it's reflected back, because I can go out to the same spot, and I have other times where I've gone out and you can see the entire shrimp boat. So, it's definitely not a physical Earth curve, right?
Well, I mean, I want to go back to the question we're trying to answer is it's definitely not an Earth curve. So I don't mean to skip by that question, but like I do think sometimes it might be. I'm not saying, like, I'm just not holding the position of like, yes, definitely this one or not that one. Because as I said before, like some of those things are mysterious.
Well, let's talk about a specific one, like you said.
So hang on, I'm posting. So Travis, what method did you use to determine the one I posted was refraction?
Repeated observations over 4 years.
How can I tell the difference between that and confirmation bias?
When you stay, like, let's say you had a week here at this location, and you saw this picture that you took, and you're like, wow, that's really interesting, and you knew that boat was there the whole week, or was going to be there the whole week, and you kept taking pictures of it. And in one of those pictures, the conditions were so different that you actually saw the entire boat. That's not confirmation bias. That's additional information. Oh,
it's impossible to determine to distinguish that from confirmation bias.
On this day, I could. No, it's just bare information. It's data.
Hey, Travis,
you can
you could
see
say
the
this.
boat. You can't see the boat.
Travis, you could say, well,
but what you're saying is, I can see the boat, I can't see the boat, and I'm picking the ones like here. Let me post the thing. Hopefully it'll work this time. I've been trying about 4 times.
Is the
But the boat,
Himawari confirmation bias? Is the Himawari confirmation bias?
Like to look at the Himawari and say this is proof of the spherical Earth. Yeah, sure it is. Like, why won't it let me? Have I lost image perms or something?
Yeah, I mean,
post that. Is that working? It's not on my.
It's.
But I'm trying to post the picture now. But you will see in a moment when I post it. It is not Earth curve. It is not refraction. It is not even a boat.
Did you take this picture?
Has it gone up in the chat?
I'm asking the one you're posting in chat. Did you take it yourself?
Yeah, I took it myself. And we were chugging. We were going out diving. So it's not on a lake. It's on just like east of Flores in Indonesia, heading west of Flores in Indonesia, heading west. I can even give you the GPS thing of it, and it's
No, I just like talking about pictures that you've taken yourself, because so many people post things that they have no clue about the picture and they're posting it as proof of something.
I just want to point out
I took it as a funny laugh to be like, is this Earth curve? And then we went past it, but for some reason I don't have image perms.
Hey, so Harry,
or something.
Harry, while you're figuring out,
it turns out to not even be a boat.
Harry, while you're figuring out your camera or your photos, but still talking, not letting people talk while you look, I just want to throw out something. You keep saying, and he even asked you, like, you give me 9 out of 10, but you go, but this one, it's because of Earth curve. That's only giving you like you're holding on to it being a ball, because 1 out of a million pictures, you just need one to make you say it's because of a ball. There's no other reason why other than a ball. Even though you have 999,999 other pictures that look like you're on a ball, but it's not. It has nothing to do with the shape of the Earth. But as long as you hold on to that one, it allows you to say, yeah, but it's because of the ball. But all these others that the flat earthers are talking about, that's refraction, that's illuminating, these mirages.
It just sounds for all the world like you're responding to what Travis said about me, like I said it about myself. What I've said about myself when it comes to these pictures is I don't take either as evidence of either because there's noise in the image. If you look at the images, they've just managed to make it into the chat. My first view is the first image, and then as we get closer to it, it starts to look like a sunken sail ship. And then as we get closer, it just happens to be like, I don't know if they've done it on purpose to make it look like a sunken sail ship, but it's like 2 posts in the ground in a mangrove with something like like a park bench or something. I don't even know what it is anymore. It's not a boat.
I think it's safe to say that when you're taking pictures in an environment that is going to distort the optics, whether it be the heat, the wind, the sky itself, the mist, the whatever it is, maybe even your own eyes, maybe grandpa could see farther than you, or less than you. But what I'm saying is that when you're dealing with pictures of these optical things that are, like, looks like the boat's floating, then looks like the boat's behind the dip, those things do not prove curvature Earth at all.
You're saying the same thing I did.
But here's
yeah,
the
you're
thing,
agreeing
though.
with me. You sound like you're aggressively agreeing. I'm agreeing.
But hold on, though.
It does not prove the globe.
But Harry, hold on though. The only difference is I'm saying because it's not curved, you're never going to have that answer. You're saying, well, there's only one picture I need
from that
it's curved.
No, that you're not listening. If you're saying that, you're still not listening. You're not listening. I said the opposite.
Are you an atheist?
I've said, let me finish. Come on. I said the opposite of that. I've said if there is an answer for why things might obstruct bottom up, and there's refraction explaining why the thing might appear flatter, I throw all of this out. It's not proof of flat. It's not proof of globe. It's bad data. I throw the lot out. What you're describing, though, sounds very similar to what Travis was saying, where Travis, I don't know, unless I misunderstood you, Travis, you were saying you put this in your paper as evidence of upward refraction, where, as I've posted in the chat, and you can see it 3 minutes past the hour, it's not a boat. It is a bench and 2 posts or something. I don't even know what it is.
Yeah.
Right? But once we got up to it, because we were chugging west past it, once we got up to it, I was like, oh, the whole thing is just like, it's not the thing I thought it was. So I agree with you. It's bad data for everything. But the point you're making
are you an atheist,
it just rests on the wrong side, Apocryphon, where you were saying to use this as data for either for a globe model or a flat model is bad. That's what it sounded like Travis was just doing. He was using this for evidence of upward refraction. And I said, how did you determine it was upward refraction? And his method was, he's got a lot of experience of looking at it. Well, he looked at this and he got it wrong. But he still used his evidence.
No. That's not what that means.
I was gonna say.
Sounds like what it means.
I was gonna say. Let me respond
I'm an
to him.
atheist, though, by the way.
Let me respond to Harry, and then you could ask him after. Just real quick, just because I don't want to get off this.
Travis does need to get in. That was a pretty hard shot at Travis, so he needs to get in after too.
Yeah. So Harry, if you are agreeing that these, the pictures that are being taken can prove that it's not a ball, but it's not good to use because it is.
That's not what I'm saying.
No. Hold on. Let me restate that. I'm gonna say these pictures that we take, they prove that it's not a ball, right? With the seeing 19 miles out, seeing 56 miles out, seeing 217 miles out. If you're taking photographs that disprove a ball, but it's having to do with optics, because if we see 59 miles away, the ball side says, oh, that's refraction. It's the light bends and is bending it back up because it curves up, blah 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 blah. But I'm saying though is that these photos that ballers use to represent the curve are getting destroyed left and right because, like Travis said, on certain conditions, you can see the thing that's supposed to be behind the curve. Just real quick though, Dicelo, go ahead and ask.
But I was
just wondering, Harry,
about Travis. So
Travis, or do you believe in God at all? Oh, you're just going to ignore my question?
No. I've been trying to respond to it, but also another conversation's been happening. I don't think there's a God. I think it's very unlikely there's a God. It's entirely possible, but to my mind, the probability I would say is quite low.
I just want to say also, the pictures we've been taking, they don't prove it's not a ball. Like, I don't know where you would even get that from, but just because you can see the thing, more of the thing or less of the thing, it doesn't prove that it's a ball or not a ball. Either way you want to go with it.
Yeah. Let me explain. Let me be hyper specific then. It proves that it's not a 25,000 mile circumference ball. It could be a bigger ball.
It absolutely does not.
No, it doesn't.
Does not prove that at all.
It doesn't. What it proves.
You're saying it doesn't. Okay. Hold on. You're saying that if I can see 200 miles away, even though I should only be able to see an X amount of miles away, and there should be 2,000 feet of drop, you're saying that doesn't prove it? That's ridiculous. That's stupid.
That absolutely does not prove it. Let me explain something. Things are going up and down. Like we're not seeing in a straight line all the time because there's static objects we're looking at. Sometimes they're lower, sometimes they're higher. So anything you look at doesn't prove anything one way or the other.
Right now, you sound like a baller. This is the point. 2,000 feet behind the drop.
Hey, you're muted, Jeremy.
Apocryphon,
You're muted.
Wait, he's muted.
You can't. Apocryphon, you can't disagree with Jeremy and agree with Travis. Travis is talking about the bending of light. He's just describing, unless I'm strawmanning Travis here, in which case please correct me, but Travis is talking about the bending of light. He's just describing it as a phenomena that causes upward refraction that makes things appear to be. So if your issue is with light bending to explain phenomena we see in photos, then Travis relies on the same thing too. Both sides rely on the same thing, which is why I say I don't trust either.
No. What I'm saying is that if you're lifting something up 2,000 feet on the other side of a water wall, and it should be 2,000 feet in the eye level, right? The horizontal eye level of overlooking a ball, because it's dipping beyond your eye level. It's dipping behind that ball, and it's 2,000 feet drop. Now you're gonna lift it up into my eyes. That is Narnia right there. We're in La La Land.
But what you're describing, I could just add the same incredulity. So let me just play it back to you. I don't mean to be like making fun of you when I do this. I just want you to realize that it sounds the same both ways. What Travis is talking about is thousands of liters of water heaving up in front of an object and dipping in a distant object like a boat down in our view, so it appears to be obstructed. Like all I need to do is just state what's happening. I'm incredulous about it, and it starts to sound ridiculous.
No,
anyway,
yeah,
Travis, you need to speak. You've been trying to get in for a while.
Well, yeah, when you say I don't say that there's thousands of liters of water keeping up. That's not what I say. That's ridiculous,
no,
boy.
Sorry. I'm not saying that you say that. No, I'm not saying that you say it. I'm saying when Apocryphon, you're saying, oh, but it's got to lift this up and do this. You're just describing what's happening with incredulity so that I can describe what Travis is talking about. I'm not saying that, Travis, you say this. Travis, you don't. You say that light is bending. The things are exactly where they are, but the light on its path to our eyes bends such that it makes the water in front of an object appear to be higher than it is in reality, such that it makes the object appear to be obscured behind it. That's my best steel man of what you're saying, Travis.
That was a better way of saying it.
But hold on though.
Yeah, all I meant with what I said before was I was replaying the counterpoint to what Apocryphon was saying, which is if we see mountains 2,000 miles away, they're going to be lifted up so far, and it's like, well, okay, so many liters of water. It's not what Travis is saying. It's just.
No, you're taking one actual optical illusion that does happen, and then you're combining it with this Narnia La La Land, and you're saying this is how it works. This is how I can see around a ball. I can see around a hill because light's bending over it and bringing it up into my view. This is ridiculous.
Can I just check that with
Narnia.
Travis?
Hold on, let me respond real quick, Kool-Aid. It's not Narnia La La Land. We know things are moving up and down in our vision for a fact. That's not La La Narnia Land. That's actually happens.
Look,
things are to move up and down in our vision.
Things move. Hold on.
Require things to be bending up and down. It's just which way they're bending in which circumstances.
In your view, things that are going up and down that are an effect of the air and everything. Whatever. Because of the conditions for the weather that day, things that are going up and down have to do with the conditions that you're seeing. I get what you're saying, but once they go beyond the vanishing point, it doesn't matter the conditions at that point when it's beyond how far you can see it. Now I'm back to seeing a plane in San Diego from Los Angeles. What I'm saying is
you're just asserting your belief again.
When it's not
say the
belief.
same
It's
thing the other
factual.
way around.
It's factual. When you take an object far enough, when you take an object far enough that you can no longer see it at all, no matter what the weather's like, it's just so far beyond. It's just I can't see New York from here.
Yeah,
Wake up.
If you were on that object, what would you see? You wouldn't see the end of the horizon. You would see another horizon, wouldn't you? I would disappear. If you were on that object.
You're right. It works both ways. That's a two-way street. I don't know what you're talking about.
The best way I've heard refraction described is it's not bending things or moving things or perfectly to your eye. It presents the view you see of the horizon as if you were higher, as if you move vertically from where you are 10, 20, 30 floors up.
Okay.
So
let me ask you this.
Yeah, but that's not uniform.
Okay,
Not
Yeah,
let me
whether it's
let me
happening
ask
is
you
a
this then.
separate issue.
Let me,
I've got no idea on
not
whether it's
all
happening.
the time. That's not true all the time.
Yes, yeah, absolutely true. Because sometimes it can bend it the other way.
it
Yeah,
is
yeah.
true.
okay,
But
It is
okay,
what
true.
I mean is the refraction that Apocryphon's talking about to
okay,
explain seeing mountains too far away is that's all it requires. Just
okay,
bending
okay.
light
So
such
Yeah,
that it
let me ask you
appears as
this.
if
yeah.
you're
The
looking
higher
further.
you are, yeah,
So let me
yeah.
ask you this. So let me ask you this. If I'm seeing a boat that looks like it's floating in the sky, okay, because of this weird optical illusion going on, are you saying that the person in the boat is looking down at me, like if he's floating up in the sky? Are you? Is that what you're stating right now? Because that's what you're
No,
saying
I don't know.
indirectly.
no,
I
it
don't know.
isn't. It isn't what it says.
I don't. I just keep saying I don't know much about refraction. Travis would be a good person to ask about this. I don't know what
Yeah,
any
No,
person
she's
has
not a
said.
good person
I
to
just
ask
keep
about
throwing it
this.
out as bad data.
Shut up, Jeremy.
Listen to me. Do you understand? Hold on, Travis. 1 second.
but I've
I
never
was
seen
joking.
that. I've
I
never
was
seen
joking, but hold on.
a boat flying in the sky. I've never seen that.
Is my
Have
mic
you?
Yeah,
cutting out?
plenty of
Does
pictures like
happen.
that.
No.
Seen photos. Never seen it
So
myself.
you got to before you can even go down this road, you have to understand that things are being projected higher and lower than their actual position. All right. If you want to make some claim about this, debunks the notion that it's a 3959 radius ball we're on, you'd have to show that what you're looking at is in an actual position. You can't
Yeah.
do
Okay.
that.
Yeah.
All
Fair
all
enough.
you can do is look at
But
something.
I have.
All
But
you
I
can do
have.
is look at
But
something.
I
Hold on 1
have
second.
watched a boat
Hold on, man.
disappear
Let
behind the
him
No,
finish
horizon.
first.
I haven't watched a boat float up in the
I don't
sky.
know. What's your name? Hold on a second,
Jamie.
man. Yeah,
Sorry.
you just wait. I'm almost done.
Jeremy.
Hold on. I'm not going to be much
I'm
longer.
sorry.
I promise. So, fuck, I forgot where I was.
The proving
Well,
3959 with the refraction
Yeah,
up and
if you
down.
want to prove that it's not, if you want to prove that it's not a ball 3959, you have to prove that what you're looking at is the actual position of the object. I don't know how the fuck you would even go about
Yeah,
doing
but
that.
you
If
have
you
to
could do
prove
that,
that a
Jamie,
boat
hold on one
flies in the
second, man.
sky.
Jamie, dude, he only got like 3 words in that time. Let him finish.
So if you want to prove it's not a ball 3959, you have to show it's the actual position. And as far as things blocking things geometrically, we have 2 pictures, right, of static objects, water and from where the guy was standing with the theodolite. One of the pictures, the horizon is below level, and another picture, the horizon is above level. So when the horizon was below level, if you were to go take a box and geometrically place it at level on the crosshairs, you would then see the water above the crosshairs, above the box, even though it was geometrically blocking it. Unless you think the water actually is above level, in that case, welcome to concave Earth.
Yeah, so I posted
Okay.
a picture. I posted a picture 60 minutes after the hour. Just let me know this. Is the guy looking over the edge of that boat staring down 100 yards below him or like 50 yards below him? Do you think he sees water that far down from him?
No, I don't know, but no, I think that what he sees is water disappearing out in front of him. Like the point you're arguing against Apocryphon, if it's against me, is I'm saying given that the boats can appear to float in the sky, looking at the horizon is a bad method of determining anything that requires me knowing its position. Same thing that
My
Jeremy's saying.
argument.
If shit's moving, don't use it to measure shit.
Well, here's my argument though. I think that for the most part, when they're saying this is the horizon, they are wrong. That is not the horizon. That's my argument. My
Yeah,
argument is
we've got the same argument.
yeah, but here's the thing. Here's the
You, me, and
problem.
Jeremy are agreed.
But here's the problem though. On the geometry of the ball sphere math, whatever calculation, then that there should be a certain distance where that horizon it should start to drop, and then you shouldn't see beyond that.
Dude, you're not dealing with strictly geometry here. I thought that's what we've been talking about this whole time. If it was strictly geometry, we wouldn't even be here. It's not strictly geometry. You also have this added effect of where the positions of objects are in the distance. I don't know why heads don't understand.
Okay. Look it. If the geometry is that,
understand it's not just geometry. Do you understand
if the
that?
geometry, if the geometry was that the horizon should be at, let's say, 5 miles. Okay, let's just give it that for the height and distance, 5 miles. Okay, no matter what the sky is doing, it's not going to be pulling up something from behind a wall of water.
Okay.
What it will
listen
do.
to me.
Okay.
Oh, hold on, you're wrong. Just let me stop you there because I can show you an instance where we have the water on a lake. It's underneath the level line by a lot. Then, and a few hours later, or whenever sometime later, they have the water above level, over the level line of
That's
the
refraction.
theodolite.
That's
Okay,
refraction.
so if we were to take a box, hold on, man. If you were to take a box, put it 50 feet in front of you, 10 feet in front of you, whatever, and put it right at level to where you couldn't see the water, and then you waited until the water was above level, you would now geometrically have something being lifted up over an object where you could see it.
So
you understand
you're
that
saying,
this can happen.
So you're saying that because you can see over a box that is 10 feet in front of you, because of the water behind it, remember the water's level to where you're standing, and you're setting up that box in a false position because now that water's still level no matter what time of day it
Why
is.
is the
That
box
water's
in a
still
false
level.
position?
I'd
Why is
like
the
to go
box in a
next,
false
please.
position? What does
Because
that
you're
even
putting
mean?
it at your eye level to block out something that is recorded at a certain time of day, but at a different time of the day you would be able to see it. But that's stupid. That's honestly,
Yeah,
that's
that's
dumbass argument.
showing that the water can be lifted up over something that should be geometrically blocking it. Your whole argument is debunked on this.
No, oh my god, no! Because the beginning part of it is that it was flat to begin with. That's what you're missing. You stated that like
Okay,
if
it's
you were
flat.
confident in that. But if the water was flat
It's
to
flat. That
begin
means it
with,
should be at the level. It's flat. That means it should be at the level line, right? So if I put a box at level to where I can't see the water, I should never be able to see the water because geometrically that could never happen. However, it would happen because there's this optical effect that lifts the water up above level. Your whole argument is not a good argument, dude.
just
I'm
like
telling
that,
you.
picture I posted. Look at that boat, how high it is. But it's not high. It's just you're marking your level horizon at the wrong spot of the water to begin with, because the horizon is way beyond that. In reality, you just
Okay,
don't
is the
see that.
horizon higher than level? Is the horizon higher than level?
Of course not. It's a level. That's the whole point of it.
Okay, so we have a picture of the horizon, the water, over level. Above level. If we're to block something geometrically, like a box or a soda can or whatever you want to put in front of you to block it geometrically, when the water goes above level, we now have that thing that you said couldn't happen and debunk the radius of the Earth, which is not true.
Hold on. You're saying
Yeah.
you're saying that the
Can,
boat was
can
above
somebody
level. How
mute?
did the
Can
boat get
somebody
above?
mute Jeremy?
How was the
Somebody mute
boat
Jeremy.
above level? How was the boat above level? How do you get that? Was it floating?
The water is above level. The water is above level.
Let me try something with Jeremy.
I don't think that's
no boat in my scenario.
That doesn't make sense actually. The water was above level because of refraction?
Sure, yeah. The water was above level because of refraction, or we're on a concave Earth.
Or it's still level, it's just being refracted and it's looking like
It's being
an image.
refracted up above. It's being
But it's
refracted
still
up
level
above
though.
that. Okay, yeah, sure. It's
The
being
water's still
refracted up above. It's being refracted up above that box we put in front of us, 20 feet in front of us to block it. Remember the thing you said couldn't happen geometrically? Because we're not just dealing with geometry here. We're dealing with an optical.
Problem, right. The problem, hold on, just real quick, and then we should get to SE.
It's a good description.
Okay, shush. We should get to SE after this, but real quick. What Jeremy is saying is right now at this point merely a thought experiment. It hasn't been done. It makes sense, Jeremy. I think we all understand what you're saying. Right. It has not been done.
Wait,
so let's hear from
a thought experiment. We have the picture. Hold on. We have the pictures of the horizon. Hold on, man. Jamie, hold on 1 second. We have the pictures of the water below level and above level. Now, yes, putting the box in front of it is a thought experiment. However, if you can't envision us putting a box after we take the first picture of the water being below level and then just waiting and seeing that, yes, we could now see the water because it's above level, If you can't go that far in your mind, I don't know what to tell you, bro.
That's a fair call. I think that's a fair call.
Let me try something with Jeremy, if I may. I posted a picture, 18 past the hour, Jeremy. B-Ball's famous picture. Everybody seen this before?
Okay, I don't even have to look. I know what it is. He's looking at a tall building on the horizon,
Where is
right?
it? Where is it
And
posted?
14 stories are blocked by the water.
All right.
Okay,
Well, I
now
wouldn't say that. I wouldn't say they're being blocked by the water.
Okay, what would you say?
Where is it posted?
There's some optical
18
effect
past the
happening.
hour.
I would just say that there's some optical effect happening in between B-Ball and that building that's making it look like that.
So what's blocking the 14 floors, 14 stories?
An optical perspective view of the water.
Because B-Ball says that it's the water, guys, right? Let's get this. It's the Earth curve.
I'm not saying that what they say. I'm not saying what they say is correct. I'm saying what we say about, well, you shouldn't be able to see the water because it should be geometrically blocked by the. No, that's not true.
The horizon he's 8 foot above the water. The horizon is however far away, 8 miles, let's say. And it appears that the water is ramping up towards his eye level. Anything beyond that point appears lower, and it appears to be obstructed. It's not obstructed. It's just an optical illusion.
So you agree with that, Jeremy?
I agree with what Rocky had just said. Absolutely, 100%.
Okay. So now, so because you said something different before, let's take Mount Canada.
Absolutely not. I've never said anything different than that. I always say it's optical drop. It's apparent optical drop. I've said that for years now.
All right. Okay. So let's go to Mount Canada, that observation, right? You said before that there's no way to prove, not the ball, but if we see that far, right, we see Mount Canada, but their model says that we shouldn't be able to see that, right?
Yeah.
So what are you saying is happening there?
Well, I'm saying if you want to prove...
Our model doesn't say that you can't see Mount Canada, just to jump in. Our model says if you ignored refraction, you couldn't see Mount Canada.
Yeah, 160 miles refraction up. Is that what your model says?
The model says there is refraction.
Right.
How much? Let's start with that.
Yeah. How much should, in your model, how much of Mount Canada should be hidden?
With or without refraction?
All of it, right? Every single bit of it?
With or without refraction?
Right. So you're saying that Mount Canada gets risen 160 miles in the air in order for you to see it, correct?
I mean, miles doesn't make sense to me. It's an angular measurement.
It sure as hell doesn't. So Jeremy, do you agree with that? Is that
why
what
aren't
you
you
think
answering
going
the
on
with
there?
or without refraction? Well, Jeremy's going to get you on the with or without refraction. He's going to ask the same question.
No, don't speak for Jeremy. You spoke for yourself. You say it's refraction.
I get it.
It's refraction.
No. I asked a question. I asked a question with or without refraction, and you wouldn't
it's
answer
always
it.
with refraction. You just keep asking the same question and mumbling through his, wanting to get to Jeremy, what Jeremy thinks. We understand what you think. Refraction is bringing it up and over the ball 160 miles up. Yeah, we're saying that's ridiculous. We're asking now Jeremy's.
Yeah, what do you think?
You can't even worry.
Say 5 miles at most.
You can't even be worried about the
He's still mumbling on purpose, Jeremy. Jesus, man. These trolls are ridiculous.
You guys hear me? My mic might be messed
No,
up.
we
My
hear
mic
you, Jeremy.
Sorry
We hear
about
the
that.
other
That was my
guy
fault.
mumbling through you again.
Yeah, Jeremy, I don't know why
I
don't know why you're nice to these trolls, but you are completely getting dicked right now.
I know, they're dicking me. They're dicking me hard. Listen, you can't worry about just geometry. You can't worry about just geometry at that point, because even if the Earth was flat, the scenario where we have the water above level, we know things are moving up and down. If you wanted to say that debunked the 3959 globe radius, you'd have to show that when you look at Canada, actual position of it. You can't do that.
No, what are you talking about, bro? You're not
I'm
even
talking
willing
about
to
you
admit
say
on
we
there.
see.
Let me finish. You're the
All
one
right.
that always sees things from their model, right? Like the pump and the drop. We won't get into that now. You can't go in their model and say that in their model it says that you cannot see further than 3 miles the horizon, right? Now this thing is supposed to be 160 miles below the curve, the physical curve. And you're telling me now that that's not a problem in their model? Really, Jeremy?
Geometrically, yes, you shouldn't be able to see it past 3 miles from a 6-foot observer on a beach or whatever. However, there's not just geometry going on here. There's atmospheric effects, perspective, like there's a lot of stuff happening in between you and that thing. So it's not just geometry.
Yeah, but he's saying 160 miles up, it can't be refraction in atmosphere.
Yeah, exactly.
So can I then ask, if we're saying just geometry, why don't we then just say geometry when it comes to
Who
why
just
things
said
get...
We're not saying just
Hang on. Rakia, I thought you just got
not
very upset that I mumbled
SC is telling you not
lightly
just
in the background of Jeremy speaking. Now you're having a little tantrum. Control yourself, man.
Eggshells. I've been listening to you all day. Your game is not going to work, bro. That is not what I said. We didn't see just the Earth.
Guys,
hey, Eggshell?
big old turgid member.
It's not going to work,
Let me
bro.
finish it, and then you can have a go.
Relax, guys.
Simmer down.
Go ahead, Eggshell.
Yeah, let me finish. Thank you, man. If what you're saying, like Jeremy's just saying it's not just geometry. If you're saying it is just geometry, then what goes out the window is your whole explanation for how things can be obstructed bottom up.
Again, we did not say just geometry for the third time, Eggshell. Your game is not going to work, bro.
I apologize.
Hold on, just let him finish, guys. Just let him finish.
Finish. Say it again, and I'm going to say the same thing after you finish. Go ahead, Eggshell.
All right, you can go when he's done, please.
You've got two choices, and that is light is completely straight, and you can draw a perspective drawing, and things shrink away from us at a linear rate. You can draw with trigonometry, and nothing gets obstructed unless it actually is obstructed, in which case nothing ever goes over a curve. Or Jeremy is right, and there are other factors at play. You can't have it both ways.
Okay, are you
We're
done?
not trying to take it both ways. Troll.
We're not doing it both ways. For the third time, Eggshells, your game is not going to play. I don't know, you're recording or something, it's not going to work. We didn't say both ways. According to your model, Kanagu should be 160 miles or so behind the Earth curve. Nothing you say or do will ever change that. Do you understand?
According to your misunderstanding of our model.
No, that is your model.
I'll blow your mind. I'll blow your mind right now about our model. The globe Earth, the center of it, at the equator, it spins faster than it does at the poles. Get your head round that.
We're not talking about spinning.
That's Narnia. That's Narnia now.
Yeah.
All right. Now we're in Narnia La La Land.
Now we're in La La Land.
It's true.
We're talking about something obscuring because it's going behind 160 miles down drop of water. That's what we're talking about here.
Right. So either, like, our model doesn't say that. Our model has had people talking about refraction and atmospheric and terrestrial refraction since well before all of us were born. So it doesn't.
Yeah, that's what your model says. Refraction.
Let me finish. Come on.
Yeah, go ahead. Sorry.
What Jeremy's saying is right. If you just go in geometry, then sure, Kanagu should be hidden. But if you just go in geometry, nothing should get hidden bottom up, which throws out all of the work Travis is doing. And every time a ship goes over the horizon, your model is destroyed.
You're intentionally lying. It's not. We are
one.
not saying obstruction only. I repeat for the fourth time. Don't lie and repeat it again, Eggshells. We are not saying only due to the curve. We're saying both things. Do you understand, Eggshells?
Yes, yeah, that's what I'm saying. I'm saying you're saying both things. I'm saying you're invoking refraction and bendy light when it suits you,
Is
And
this
when it
guy
doesn't suit you,
unbelievable?
you're referring back to.
You hear him?
Still
Guys, I
speaking,
hope
still
everybody
speaking,
hears the
still
sophistry
speaking. I
here, huh?
swear I was like mid-sentence. But
Yeah, but
when
you're
I'm
saying the
mid-sentence,
same
for
thing
everybody
over
else
and over
listening,
again, which is a
for
straw
everybody
man.
else listening, you can tell when the dissonance gets high because that's when Rakia and SE jump in.
No, when you
I'm saying
start
something, it
repeating
doesn't bother
yourself
them.
is when it gets high.
See? Here we
When
go.
are we
Here
going
we
to
go.
stop letting these fucking gaslighting trolls
Over and over
this
again.
channel,
Let
man?
him get
Listen
it.
at him.
This
I'm
is
going to bed
fucking
He's
soon.
ridiculous.
laughing. He's laughing because he knows what he's doing. He knows he's trying to wind us up
Yes,
with his
I'm upsetting
bullshit.
That's
you.
right, and
And
it's
he's
not
no,
gonna
you're not
work.
upsetting us.
By pointing,
You are
I got
by
not
pointing out
upsetting
how
us.
busted
Don't
your
get
model
the
is.
All right.
It's a discussion. There's no one
You hold
gaslighting
on,
anyone.
Jamie. Hold on, man.
No, we're having a discussion. Yeah.
Hold on,
I agree with you.
eggshells. Eggshells. Guys, one at a time, or this isn't going to work. Let eggshells finish. I know you don't like what he's saying, whatever. We got to let him finish. And then you guys can go right next. That's all.
I'm next after him.
Yeah. So
Go ahead,
I don't need
sweetheart.
to repeat the point. I don't need to repeat the point that Jeremy's made. It's either geometric or there's other factors at play. But the point I'm making about the dissonance is that people, same for me, I will only jump in when somebody's upsetting me so much with what they're saying I can't control myself anymore.
Right, are you done, sir?
Yep.
Okay, now listen up. I know who you are. I know your game. I've been listening for a couple of hours. You're playing your game. You're laughing. It's not going to work, sunshine. Those days are over. I just want to let you know that, okay? Mwah.
Okay. So geometric, or are there other factors at play? Is Jeremy right, or is it just geometric?
They're both factors
So
at play.
I think the problem
in order
is the
for your
amount.
fantasy, listen up. In order for your fantasy ball to work, right? This is what has to happen. A mountain has to go up, like a hovercraft has to go up 160 miles for your fantasy to work. That does not happen in reality. Eggy?
Okay. Well, I mean, I don't know. Okay, in
your
order to say
fantasy to
that,
work-
though, hold on. In order to say that doesn't happen in reality, you'd have to show the actual position of it, or why it's off its actual position. Like, you can't make any claims on this one way or the other
Yeah,
because
exactly.
no one has that. Because no one has the actual position of anything.
And to add
Sure,
to
we
that,
have
as
the actual
incredulous
position.
as you are,
Excuse me, Jeremy. Of course, we have the actual position. In their physical globe, the actual position is around the hump of water, Jeremy. 60 miles below. That's the actual position, Jeremy. So we have the actual position, yes.
Yeah, well, we also have
as incredulous as you
fraction.
are about a mountain bending up, your model requires water to bend up.
No, it doesn't. Not at all.
Well, I think it's
First of all, we don't have a model. It's your model in question. Your model
That's even
curves
worse.
at
You
3
don't
miles.
have a model.
And continues to curve. So in order for that fantasy to occur, that mountain has to rise 160 miles. You guys have to show this happening, not us.
SE, I want to point out something.
Wait, hold on, 160 miles.
Yeah,
we
he
have
makes up
shown
numbers.
Give or take. I'm not sure the exact number, but a lot of
We
miles.
might have done drop and not hit. It doesn't matter. The point is, you can't make any absolute claims about this because you don't know how much it is or isn't. We know shit's refracting. Now it's just all about we need to quantify it, and I don't know how you would quantify it other than knowing its actual position from your field of view.
We do know the exact position, Jeremy, because according to their sphere, we know that we're here and there's a big drop of water. It has to be there according to their geometrical Earth.
Yes, and
there's no way around
their
that.
model,
Jeremy.
they think. Yes, in their model, they think they know the actual position, and they say it's rising up. We think we know the actual position. It would be horizontal, and in our case, I mean, it's still looming.
Okay, but so why if it's a flat Earth then? Never mind saying the tops of mountains or the tops of buildings across a lake and Seattle and all that stuff, right? Why at my home now? I'm in North Yorkshire. Why can I not look across the fields and see the Eiffel Tower? Or
let me put it this way. This
the
might
West
clear it
Coast
up.
of
Hold on.
England and look across and see the Empire State Building.
My shit's gonna blow this out of the water. Let's say you're in a plane,
You
right?
gotta be retarded to ask that question, by the way. I mean, that's ridiculous.
Hold on.
Well, yeah.
Hold on.
Well, yeah.
Let's say you're in a plane.
No, he doesn't. If it's just geometric, no, he doesn't.
Real quick, SE. You're in a plane, right? All right, you're in a plane. You're looking out through the side of the window. You can see you got a window seat. There's some kid behind you kicking your seat. All right, but you look out, see the sun setting. Sun setting. You can look out, you see the sun setting.
Yeah.
So the sun, so we see the sun level, right? Right above the ground in the horizon. It's half cut off.
Right. Okay. Yeah.
Not you, man. Not you.
I hear you, bro.
Oh, sorry.
You're with me. So how high does the sun have to be? You're talking about 160 miles. How high does the sun have to be, refracted down for this to happen?
Jeremy,
more than
we're
160
talking about
miles, probably.
Jeremy,
No.
we're
And
talking
the same
about
angular
the sun
size
now,
it was
bro.
during the day. No, it doesn't have to be 160 miles refracted down because your foreground is at a certain point and the sun is beyond the foreground. It's in the background and it's above you and it's going away. So it's appearing to get lower. And when it reaches that point where it's below the foreground, the vanishing point of where your altitude dictates the distance, then it's going to appear to be obstructed bottom up.
Yeah, I'm just talking about what we see. Just what we see. I'm not talking about why it's happening or what's actually happening. Just what we see. When you're in a plane, you're miles up in the sky. Then you look down, see that the sun is at where the horizon is, at ground level. You can see that, right?
Sometimes, yeah. Sometimes the sun just goes far enough away where it blinks out.
Okay, but we know the sun can't actually be there. There needs to be some it's making the sun appear hundreds or thousands of miles high in the sky to now it appears way down to where it's touching the ground. So this 160 mile Canigoo, this 160 mile Canigoo thing is less worse than the sun.
Yeah, and I would just want to add to that. If you were standing on a mountain and you were seeing the sunset into the ocean, and it was just geometry, as you guys keep claiming, what you are geometrically seeing is the easy now.
Did you say just geometry again?
Yeah, he said just
You're having a very good sentence, bro. I swear to you.
Listen to me, guys.
None of you. You're gonna have to lose this sentence if you don't take it back, or we're gonna have to mute all of us.
I gotta mute all you guys.
Yeah, mute us all, Jeremy, because if he's gonna
There's no way this guy's gonna
gonna
finish
mute
his
you
sentence
all.
and
Might as
then
well
take
mute
it back.
me. Go ahead and mute me, buddy. Keep going with the mute button.
Want to go ahead and get in there too, guys?
What
Mute
you-
Elijah.
That was
You're all muted.
That was really good.
Fuck out of here.
If
The
it was
real mod has
just,
stepped in.
thank you.
If you're the real mod, kick Harry the fuck out.
Why
If you're the
Harry,
real
you have
mod.
been
for? Oh
kicked.
my
You've
gosh.
been dismissed. Goodbye.
Everyone stop talking for a second, please. Holy hell, guys. I
They
don't even
did
know how I'm
stop
going to unmute
talking
you.
when
I'm on
I
a
came
cell phone.
through.
Yo, what are you doing?
I already calmed the room down, Jeremy. Stop crying.
I have like 18 people muted right now. Guys, come on, please. He's going to keep saying the same nutcase shit over and over again. Let's not spiral out of control. All right, now I got to log into my fucking computer, unmute us all. All right, I know he keeps saying the wrong thing, what we're not saying. All right, there's nothing I can do about that. We can't let this devolve into chaos, though. Please, guys. All right, I'm going to unmute everyone in like 10 seconds.
It's a conspiracy. You're shutting us up.
Utter chaos. Anyway.
Eggshells. What were you saying?
Hold on, he's muted. I have to log into my computer because it's too hard to do on a cell phone. I can't even see who I don't even know who I just muted just now. Everyone's going to get unmuted. You guys can't do that. Come on, guys. You know you can't do that.
Yeah, you guys gotta stop doing that shit. You guys are crazy. See, I can talk shit right now because I'm not muted.
Armbar, you're about to get muted.
I'm glad I'm unmuted now, so I can say it. We're gonna keep.
So
doing it
before
until
I say what I
mod
was
takes-
going to say,
let's not him laugh.
what I was going to say, I just want to refer back to the other thing I said earlier, which is about how dissonance causes people to erupt and interrupt and not let people finish because the thought that they're expressing causes so much Yeah, like that. Good example.
Yeah,
Thank you,
like
Rakia.
this. Lie, and you can mute me again because if you're gonna lie about me, and then come back and laugh
Let me
about
finish
it,
your thought,
then I'm
man.
gonna disrupt. No, it's
I got
not you're
free reign,
lying.
bitches.
Lying
Don't
about
prove my
me.
point. You don't
Yeah,
need. You just don't
don't
need to prove
lie
my
then.
point.
Hey,
Your point
Rakia.
doesn't have to
Hey,
include a
Finish, and
lie.
then I'm
Rakia sounds
wrong.
like Joe from Family Guy.
Rakia,
Oh,
let him
Hey,
finish.
Finn.
oh.
So
Hey, who else is talking right now?
Rocky has a few
anyway.
breadcrumbs.
So the point I was just making, I won't use the word geometry because it's triggering people, but the point you're making is if the 160 miles matters, what you're talking about is dead straight lines of sight. So if there are dead straight lines of sight and you are up on a mountain and you watch a sunset into the sea, what you are seeing is the sun below your view. So if you drew a straight line out from where you are objectively above the surface of the water. If the water doesn't curve and the sun is going into it, the sun is below your position. So if we can trust lines of sight to be dead straight such that Canada is 160 miles up or something, I'm quite confident that maths is wrong, but let's run with it, then you've got a massive problem with sunsets, as Jeremy stated.
Okay, now you're done? All right. Go ahead, Rakia.
Yeah, I'm done.
If someone's going to be allowed to lie like that on purpose, knowingly,
Can you stop
then
being a wet
that's
fucking blanket and just complaining
yeah.
every
And if
chance you get the
people
goddamn
are going
floor?
to interrupt, you took me off of mute so I could talk, and now they're laughing again. Wet blanket, right?
I know.
Of course, it's
Smooth or
funny.
flat here,
He's
son.
trolling again, right? It's the same trolls
It's
every
funny.
day.
Bias is, Jeremy. I don't know what's going on here.
No, it's the same trolls, the same characters. We've been trying to make this point for years. We've gotten close over the last couple of weeks, but the trolls are still allowed to do this for some reason. And when people
And you're the one destroying this room.
yeah,
We were having a
disrupting
really
me
lovely
again.
conversation.
No, bullshit. Bullshit. You're blaming me, but your lies about me and others destroyed this conversation. Not me. No one. And I mean no one was being disruptive while you weren't lying. It's only when you did insert the lie over and over again when it explained that it was a lie and for you to stop doing it, but you did it again to troll as you're interrupting me again. As you're interrupting me. As you're interrupting me.
I got it, Rakia. Hold on.
Yeah,
I got it.
I
Rakia.
understand.
Hold on 1 second.
I understand.
Go
That's when we
ahead.
got disruptive. That's when 5 or 6 people got aggravated and started talking on purpose to disrupt the lie. The lie is what caused it.
You guys
Not the
realize
people.
this is all gold.
Can I jump in
Eggshells
just real
for
quick,
you guys.
briefly?
Eggshells, you're
Hold
so
on.
lucky,
Forget
you
what
bastard. You evil bastard.
Every
Forget what
time
address.
Mike Tyson
Forget what
got
HL.
under the groin, everybody was like, "Oh, come on!" And then when he bit the ears, Jeremy came in and said, "Come on, fam, you can't do that. You're disqualified." That's when.
Yeah, when you act
Mic
like
check.
lunatics, they
Listen,
just
hold
say,
on,
"Hey,
Issa.
those are a bunch
I know.
of lunatics." Too. Remember that.
I know. Hold on, Issa. Forget these guys. Address what I said. If we see the sun at the ground level, the sun's really, hundreds or thousands of miles above us. How does that not make it worse than the Canagoo thing for us if the Earth is flat?
I think Rakia already explained.
Anyone want to address that point?
I already have.
Don't know. I think I was just trying to talk. Could you not hear me?
See this bias going on? What the hell?
Try again, Travis. You were breaking up for me, but you said my name. Then you broke up.
Yeah, I said to Jeremy, I said, Rakia already answered this. If you don't understand Rakia's answer, I don't know how to help you.
No, Rakia tried to explain what was happening. All right, we're not worried about what's actually happening. We're just worried about what we see. I rebutted that. You hear me rebut it?
It is what I see. I don't understand what you're asking now, because that is what I see. I see the sun above me, right? If I'm in an airplane, I'm at an altitude where my horizon is going to be dictated by my altitude and the distance that I see. That point that the sky and ground meet at around my eye level, if something goes beyond that, that's higher than me, like the sun, and it goes beyond that point, it's going to appear lower and be obstructed bottom up.
Okay,
I don't know how else to
Okay, listen. There's things happening that are making things appear in different positions. That's fine. I don't care what the cause of them is, what the names of the effects are. It doesn't matter. All we know is there's effects that are making things not appear in their correct positions. So we look out, we see Canagoo in this spot, impossible on the globe. We see the sun touching the horizon, right at the horizon. That's not possible on a flat Earth. And I think the sun thing is way worse, unless the sun's less than 160 miles up. Thing's way worse. The sun's way worse than Canagoo for us.
So, Jeremy, tell me,
I have
what
a
effect do
response.
you?
I don't have a question. I have a response. So you did go first. What'll it be? A question or a response?
I don't understand what you're saying.
Who are you talking to?
Yeah, who are you talking to,
You.
Elijah?
I'm saying I did interrupt you. You decide if I can interrupt or if you want to ask your question.
Oh, okay.
Go ahead, Elijah. Go ahead.
Thank you. So we already know the Earth is measurably not a sphere. We know that. We don't need the sun to determine that. Since that's the case, this conversation about what the sun appears to do with Canagoo, how is that worse for a flat Earth when it's geometrically a plane, horizontal
All
in
right, I know.
orientation?
I'll tell you how. Because these guys are making the argument that on a ball, Canagoo's lifted up 160 miles. That's impossible. However, on the flat Earth, we have the sun not in its position above us, however many hundreds or thousands of miles you want to give to us. We have it at the ground. We see it at the ground level. So we're just going off what we see.
How does that correspond in your head, Jeremy? I'm trying to understand this, bro.
Because we see
Remember
Canagoo, right?
my argument about what was I saying? Damn, I just had it. Using one sense to validate things is damn near probably impossible. Not damn near, probably impossible if you haven't experienced that thing already. Right? This is what we're doing. Using one sense, looking to determine facts. That's just dumb. But
I agree. Hold on, I agree with you. Let me
I'm
just
not
interrupt,
done.
please.
I'm not done. I'm not done. But since the Earth doesn't measure to be a sphere, and we know that just because the clouds look like they touch over there doesn't look like that for everybody, because that's just perspective. What does it matter
let me respond.
what the sun is doing?
Let me respond. I agree. We shouldn't judge anything based on one sense. You can't come to any absolute conclusions off this one sense by just looking at something. I agree. They're trying to come to this absolute conclusion that Earth can't be a ball because Canagoo's loomed up 160 miles. I don't know if you came in late, but this whole sun thing is in response to their shit that they were bringing up. Like, you're trying to argue with me over nothing. I agree with you. Do you get it? Do you get it, SE, or what? Do you get it?
Oh, sorry, I missed that, bro.
You cut out at the end there, man.
Say it again, Jeremy. I want to hear it.
SE, we see the sun at the horizon, right? We know that's not the case because the sun has to be hundreds, if not thousands, of miles above us. So when we see the sun at the ground level, hundreds or thousands of miles beneath where it should be, and we see Canagoo hundred something miles above where it should be on the globe, what's the difference?
I'll tell you the difference if I don't get interrupted.
Okay, go ahead.
Okay. The difference is that on the Earth, we know Canagoo is a solid object. There's a mountain. We know where it should be. According to the globe, we know it should be around a sphere of water, which is ridiculous, but we'll leave that out. And the sun now is a whole different thing, something we don't know, and something that it's like, how can you make references about that, Jeremy?
It's irrelevant, though. Because you could make the argument about Kenegu then. How come at ground level we don't see Kenegu?
No. Well, here's the thing.
Because it's too far away,
The
bro.
reason that the
That's
argument,
why.
the reason that the argument against Kenegu stands, it's because it's against a claim, a geometric claim that's made by the globe.
Okay.
The reason that the whole,
I think we all get that.
The reason that the whole sun thing doesn't stand as a juxtaposition is because it's actually a straw man. Because I think we're all trying to tell you, Jeremy, that none of us can tell you why what we're seeing is happening. But you're saying it disproves a flat Earth in full straw man fashion.
But then don't.
I'm not saying it disproves flat Earth. Hold on, man. I'm not saying it disproves flat Earth.
It doesn't work on a flat Earth. It's the same thing.
No, I'm telling you, we have
It's
the same
a problem for a flat Earth. It's the same thing. It's not a problem if you don't straw man Earth.
We have the same problem with the sun on flat Earth because the sun's supposed to be hundreds or thousands of miles above us, yet we see it on the horizon. Here you're saying Kenegu is a problem for them because it's supposed to be 160 miles lower.
You don't
it's the
hear
same
us.
thing.
You don't hear us. No, we're not making geometric. We're not making geometric claims about the horizon. They make geometric claims, and we can see how that's busted. That's the only reason we talk about it at all. Not to say, it's a matter. Listen closely. The horizon is not an actual object. We all know that. It has to do with things that we don't fully understand. The sun is also a thing we don't fully understand because it's not actually an object that disappears like a baseball would as it moves throughout the sky, but we still say, well, prospectively, it still drops because of our. But we don't know, and we're not saying we do. How the fuck can you say it's a problem when you have to qualify it as being a problem? Like, it's not a problem unless you actually knew that the sun was below us, because that's what the connotation is. That we see it, it's below our eye level, therefore it's a problem. No, it's not.
It's just
You're
a problem
saying
if you're ignoring refraction. I think that's what Jeremy's saying.
Hold on.
We both need refraction.
I'm just telling you that this is just going off where we see stuff, right? We see Kenegu in this one spot. You're like, yo, it geometrically can't be there. All right, fine. We look at the sun in this one spot, and for us, for flat Earth, the sun can't geometrically possibly actually be there because it's thousands of miles above our head.
it's not geometrically anywhere we try to pinpoint it. That's always the case, and we already know that.
So it's not geometrically where you claim it to be. So what you're saying is there is this object, and I see it in a particular place, but it is not in that place.
You can't measure
just the same thing the other side's
it in that place. That's what I'm saying. Everybody knows that. You can't triangulate the sun's position. Everybody knows that. That's what I'm saying, not what you're trying to change what I said into.
Wait, but guys,
everybody understands that you can't.
All Jeremy's trying to point out to you is you're not being consistent with your logic.
Well, here's the thing.
You've got no way to pick between them. You're picking one and not the other.
It has nothing to do with my logic because there's no argument on the side of the sun. There's no argument. There's no parallel between, hey, actually, we live on a sphere where geometrically things are blocked by the ground is curving away from you, so the angle at which the ground is curved is too far, you can't see it because it's a ball. Everybody knows that. I'm not making claims about the sky at all. Though I see the sun above me, though I know it's above me, what else can I say? So because it appears below my eye level, all of a sudden I have a problem with understanding that it's above me? Right. No, we're on Earth. Yeah, exactly. We're on.
It's not.
What, Jeremy?
There's no problem with understanding it's still above you when you see it at the ground level. We're just going off what we see. We see the sun at ground level. All right. It's supposed to be way up above us. It's hundreds of miles off its actual position, right?
No.
Do we see the sun? Do we see the sun? No, we don't. We don't see
Jeremy,
the sun hundreds of miles off its
No,
actual position.
no, it's not hundreds of miles. That like you
Jeremy.
said that. How the no? There's a premise in there. What the fuck? How are you talking about miles and where it should be and where it isn't, and it's off by this many miles? Who the fuck are you to like? What are you to? Who the fuck are you to tell me that I can't accept that premise to then say, yeah, that's right. You're right. It can't be hundreds of thousands of feet or hundreds of feet below my. No, I'm not. No.
What was it Armor was trying to say?
Is the sun? Hold on. Let me just try to get this through. Let me just try to get this through. Is the sun? The sun is supposed to be above your head. I don't care what number you want to put on it. 5 miles, 10 miles, 3,000 miles, whatever. We know that it's above our head. When you see it, you're seeing it at ground level when it's setting at the horizon. You're up in a plane. It's way beneath you.
No.
All right. However, X amount of miles it is beneath you now. Yes.
No.
Yes, you see it beneath you.
No, here's why.
Here's why.
Jeremy, you're not right, okay? And here's why. When you look across the lake and you see people, you are not seeing them as 2 inches tall. You're seeing them as far away. Anyone who describes it as, I see those people as being 2 inches tall, that person's an idiot. Because they're not taking into account perspective and how the human vision works.
Okay, we're not talking about the
them as 2 inches tall.
objects. We're not talking about the angular size of objects. We're just talking about where we see them.
I understand that. It's an analogy.
Where we see them.
You do not see the sun at ground level. Just like you don't see people as 2 inches tall.
You can see the sun at ground level as it's setting. It'll be half cut off. There's the ground. There's the ground.
What elevation is ground level, Jeremy? What
Zero.
elevation is ground level? Exactly.
Zero.
That's the claim you're making, and you're saying
not at
that's
zero.
the problem.
You never see the
But
sun.
that's what you're saying, Jeremy. That's what you're saying. You're saying it appears at ground level. So then don't force me to make a conclusion. Your conclusion is that it can't be at this metric. We see it at ground level.
I never said that. I never said that.
You did say that.
I never said that. I don't think it's actually at that level. I never said that shit, bro. Stop strawmanning.
You said it can't. You said it can't be hundreds of thousands of miles below, or it can't be above me and then hundreds of thousands of miles below me. You did say that. You did fucking say that.
I actually believe that it can do that. All I'm saying is
you did. You fucking did say that. So now my point. So my point being,
I didn't say that. I've been agreeing with Rakia the whole time. I never said that. Straw man.
He didn't just say that.
Clip. Go find the clip.
Well, he said it was hundreds of thousands of miles above us, and then at the horizon, it's at ground level. I don't know what he can clarify that.
So that's what I'm saying. If I said that backwards, that's
I'll clarify right now. Stop mumbling. We see the sun at ground level as it's setting if we're in a plane, right? Does everyone agree to that?
So we see it at zero.
We don't.
That's what you want us to agree to?
You're in a plane. Picture you're in a plane. You're looking out the window. You can see the sunset over the ocean. Over the ocean, the sea level 0.
I've never seen the sun anywhere other than in the sky, and the sky's not ground level. So,
you've never seen a sunset?
I've never seen the sun anywhere other than in the sky, and the sky is not ground level. So no matter what it is you think you're seeing, it can't be at ground level because the sun's always in the sky.
I agree.
Oh,
I agree.
Hold on.
I agree.
Hold on. That's silly, actually. Hold on. I've seen. Okay, maybe I haven't. But
bro.
No, hear me out. Hear me out. All right. So we have the sunset, right? And we have, let's say, for example, a boat passing in front of that, right? So what, is he gonna make the claim out that the boat is also in the sky? I mean, they're both literally like in the same, like position. That's fucking silly. Come on, man.
No, the boat would be in the water.
Look in the chat.
But the sun isn't in the water, though?
No, the sun's in the sky where I see it.
No, visually, it's in the water, just like the boat.
I've never seen the sun in the water. Maybe you have. All I was
Okay,
doing
guys,
was
look in the
responding to Jeremy.
chat.
I have personally never seen the sun at ground level or in the water.
So you've
Maybe
never
you
seen a
have.
sunset?
I have.
Then okay.
Okay, guys, look in the chat. Look in the chat. Just relax and look in the chat.
Hey,
You don't
I want to go
know
back in this.
what you don't know what the fuck the sun is. You have not seen what I'm looking at filtered by the clouds. You can probably use a better filter. You haven't seen it from up high hit the horizon and go from bottom to top. You've never seen that. So I don't care about this.
No one's ever
we
seen
see it at ground level. I don't care about that because
No one's ever
ultimately
seen
it's
a
not
sunset
going
on a
under the
plane.
horizon. So who cares?
You sure about
Seen
that?
a sunset on a plane before, I guess. No one's ever seen a sunset on a plane.
I have to. Yeah, me too.
And
I'm not saying it's going under the horizon. I'm saying it looks
it
like
doesn't even
looks
set
like.
the way
It
they
looks
claim.
like
It
it's
doesn't
touching
even
the
set the
horizon.
way.
It looks like it's touching the horizon when the sun's setting. There's ground or the water, and then there's the sun.
There's glare. There's glare.
There's nothing in between them. That's what you see.
There's glare.
You can get a solar
see
filter
glare.
on it.
Exactly, and you'll never see what the
and you
fuck
can
you're
see the
explaining.
sun.
No, you can't.
The sun and the ground. There's no space in between them. Yes, you can.
Cite it. Get footage. Get footage from a plane. Do it now with a solar filter. Let's see
Are you
it.
serious,
Because I'm
man?
telling you
This
that's not. Let's
this
see it.
ain't a good
I'm
look,
dead
guys.
serious. I'm
my
dead
gosh.
serious.
Look, bro, this is the kind of
I'm
shit
dead
that has me
serious.
questioning
Let's
our own
see
side.
it.
This is the kind of shit that has me
before you
questioning our own
question
side.
me and talk
Just so
before
you
you
know.
question me and talk shit.
Come on, guys.
Before
We
you
got two mods arguing. Come on, we got two
Heading to
mods
the
arguing.
office now.
Thank you. Be
Okay.
respectful to the honorary monk. Listen, you don't have to poison the well and do that when I'm saying, fine, let's see it. Every time niggas want to say, fine, let's see it, people want to say, oh, niggas is crazy. No, let's see it. And then I'll concede.
Sunset solar
That's
filter.
simple.
All right. We'll
For anyone who has seen a sunset on a plane, there's no question that the sun sets, it's touching the ground. This kind of goofy shit right here is shit that's got me questioning my own side.
I'll go against you because when you're usually when you're up in the plane at especially at like 30,000 feet, you're not seeing the ground. You're seeing the upper cloud level where the sun appears to set. That's your horizon point. It's not the ground. So like when Doofus shows his high altitude picture of the white haze in the distance, that's not the ground. That's the top of clouds. Goofy.
Why are you saying
that's still below eye level.
Because Jeremy is goofy.
Oh. Let's not ignore the fact that Harry was psychoanalyzing our interaction with the dissonance. When Jeremy was trying to talk, Harry was subverting Jeremy by whispering and talking quietly over him. So don't psychoanalyze us, you sociopath.
Is that Geo?
Guys, I think we're losing Jeremy to the ball.
Yeah, you guys are all crazy. Jeremy's
fucking other day. Come on, he literally said things disappear below the geometric horizon. And then
we got into an intervention.
And then he wants people to accept statements like that. Like you don't even know the words you're using.
Now we get the second shift of trolls coming in. Is this Doofus or Nidhug?
All right.
Anyway. I've seen sunsets from planes a lot, and usually they're different than when you see them on the ground because you can't see forever. Even like you're still seeing the horizon point because you're higher. It's a further distance, but because you can't see forever, that point is more hazy and all that. Therefore the sunsets are a little different. And setting bottom up are usually not the case. So it would be and I guarantee this is the case, that it looks more like a setting moon. Like it just kind of
vaporizes into that band of atmosphere. The one that Dave calls it. Doesn't.
Vaporizes.
It fades out, but the glare you see the glare longer, but it does fade out more than it would at ground level most of the time. But even at ground level, I have a video at sea level in the south with the humid air, it fading out. And then David Weiss has many of them in cooler weather at altitude with a drone that they fade out. And that is what if you could see further, if the atmosphere didn't play a part and you weren't low to the ground all the time and your foreground was diminished by how far you see at that altitude, then you would see the sunset more of a fade out than a bottom up obstruction more.
Yeah, because there are 93 million miles between the two also. Why don't we see the moon rise and moon set like perfectly as exactly as we see the sun one?
We kind of do. I can sit in my back room
Hold on,
and I can watch the moon.
When is the 93 million mile position? When there's an eclipse, when you can't see between them, or when they're in your left to right view, or when they're above or below each other? Which
one question at a time then.
Equals 93 million miles in your space distances of degrees. Can we get a chart for that?
All right, so let's say forget the plane. You're standing on the ground, looking at the sunset at the horizon. Okay. The sun, it's halfway set. You can see half the sun. All right, it looks like the sun's touching the ground. Can we all agree on that?
Yes.
What about when you zoom in? What about when you zoom in and it doesn't appear that way after because here's the thing.
Yes,
we're talking about
it.
No, I didn't say no. What I said, no, I didn't say no.
Agree, good.
Listen. No, I don't agree. No, I don't. So listen to what I'm actually saying. So, okay, we have this effect that you're saying is touching the ground, right? And then someone
I said it looks like it's touching the ground.
Didn't I just say that?
No, you said it's touching the ground.
It looks like it's touching the ground until you zoom in and see, it was just an optical illusion.
Yeah, without a solar filter. Without a solar filter.
So then I guess when it goes further and you see this effect again, this is effectively the same argument as boats go over the curve. No, it doesn't. Look, we zoomed in, and then they say, well, just wait a while. It's the same thing.
You're wrong.
Yeah, I agree with you, Elijah. That was well said. I agree.
Are you serious? Come on, you guys gonna cherry pick a video like that? Like literally, if you put a solar filter in front of this, all right, this doesn't happen, or you can zoom in, all right.
It happens to a point, Arma. The distance gets greater when you use a solar filter because you don't have as much glare, but it's distance dependent. So you can't see forever. So distance is a factor when you're dealing with this. So at a certain distance, you're gonna reach your optical, whatever lens you're using. You're gonna. Don't know
interrupt.
Me right in the middle of what I'm saying.
Yeah.
Because I don't think you've gone out and done this as much as I have or Travis. So we're not using other people's videos and saying we're cherry picking. I have hundreds of videos of this. So don't say no right in the middle of my statement. I've seen it. I've done it myself.
Real quick, I've seen it
too.
I've seen it too, Rocky. Real quick though, have you ever seen a sunset where you couldn't zoom in and see space in between the Earth and the sun?
Yes, I've seen it where it appears to be touching.
Okay, so we
zoom in
now
and it's above. Yeah.
We now have a flat earther that we see the sun at sunset. You can see it, see the ground, and then the sun directly above it. Okay, is there any more fucking questions, or can we move on?
No, I think
hang on, Jeremy. Hang on, let me rebuttal that. If
he has a secret argument. Maybe let him just do it.
If you wait longer, if you wait 30 more minutes, the sun is going to go further away from you, and that gap is going to close. It's not touching the Earth ever. It just appears to be because the angle is changing as it goes away from you.
I'm not saying it's touching the Earth. I understand it's not actually touching the Earth, guys. Get up, please. Come on.
I was just saying it for the audience. I mean, you're so touchy on the subject for some reason.
Well, you guys are getting me hot right now. I don't know why.
Jeremy, you're right. You're 100%
just hold on.
right.
I don't need you to tell me I'm right. I'm trying to get through to these
can
guys.
I say one thing? Can I say one thing? I've been trying.
No.
All right.
Yeah, we heard you trying clipping Isa and everyone else. We heard you.
Can you stop
Everyone
sucking
get
dick,
it out
bro?
of their system. Everyone get it out of your system. I'll wait. Okay, I'll wait. Guys, go ahead.
I understand why people are
Everybody
arguing
quit
against
sucking the
Jeremy.
bros'
Be here all
If
day.
you
I can wait.
if you witness a sunset, which we all have, right, and it appears that it's touching, if you increase your elevation, you can continue to chase the sun, quote unquote, and continue to watch it. So
Yeah,
I don't
because you
understand
change
what
your
the issue
angle.
is. It's changing your angle by elevation, not by zooming in.
It's
So if
nothing to
you
do
zoom
with
in,
I'm now bored and I'm now curious.
thing.
Like, yes, that's true. Apparently we can't give caveats as to what we know. Like, obviously he's gonna say, yeah, that's obviously because it's a globe. For some reason we know it's the angle. I want to know what Jeremy's I want to know where this ends. Really do that.
That's what I'm
Now
saying.
curious.
You want to address me or this guy?
I would
Keep
rather,
responding to this guy. Keep responding to this guy if you want to have a conversation with him. Otherwise, let him make his point and let's move on. Are you done, Smooth?
Yeah, bud.
Jeremy, I think you should write an essay for us because we need to see this in writing. I think that everybody is not hearing what's supposed to be being said. This has been going on for so long. Nothing is getting clarified. Nothing.
Because everyone's making it difficult. All right? Just everyone relax. You're standing on the ground. You see that.
Come on, man. You're here
You're
too.
standing on the ground. The difficult part is people keep talking. You're doing right now.
I didn't mean to cut you off, man. I didn't mean to.
Just stop talking, please. You're standing on the ground. You're watching a sunset. The sun's half cut off by the horizon. It's not actually touching the horizon. We just see it appear to be touching the ground. That's where we see it. Okay? We all good so far because this was a huge contention a minute ago. Good, guys?
Go on. It appears. Yes, go on, Jeremy.
Okay, it appears to be touching the ground. Fine. We know that it's not actually touching the ground. It needs to be X number of distance in the sky, miles, whatever. However high in the sky you think it is, if you think it's less than 160 miles, whatever. This is the same thing Canagoo, because Canagoo's up 160 miles. This thing's down. Maybe it's only 50 miles. Maybe it's thousands of miles. I don't know.
Okay, can I say something on that? Are you done or did you clip?
The whole point.
Okay, but
Canagoo's
look, Jeremy,
up
it's not
160
down though.
miles, Jeremy.
Hold on, Elijah. it appears
SC's been
that way,
saying that
but
all
it's
morning.
not
I
down,
ran
though,
with
Jeremy.
SC's number, Eli. He's been saying that all morning, so I just ran with SC's numbers. If it's not right,
Okay, but Jeremy, it's not actually down, right? We're all agreeing on that, right? It just appears to be going down. Is that what you're trying to say?
yeah, just like the mountain appears to be where it is.
Yeah, but this is different, bro. This is different because the Mount Canagoo, the sun is behind. Otherwise, you wouldn't see it. But because of that exact orientation, shall we say, right, at that particular time of the year, we're seeing like the shadow, the what you might call it, the not the shadow. You know what I'm saying? You're not. It's because of the sun. You're seeing that. Otherwise, you wouldn't be able to see it. It's too far away.
It's backlit by the sun.
Yes, backlit. Yes, thank you.
Okay,
Do
can
you
I
understand the
ask a
difference here,
question
bro?
to SC?
He's never seen the sun at the ground plane. Like, I don't know why. I don't even know why y'all letting him have that.
Forget the plane.
gotta
We're just
ask SC
standing on the
for-
ground. You're on a boat or a mountain. You're looking at the sunset. Forget the plane.
Okay, so
Okay, so you're on the mountain. So what?
yeah, never mind.
Standing on the ground, you see the sunset. We see where the sun is.
Okay,
It appears.
you know what you see
the sun appears
over the water. over the water?
The sun.
You're on a mountain over and looking over the water. Yes or no?
Be on the beach. You're on a beach. No,
Okay,
you're on a
so
beach.
okay,
Watching
so
the
we're on the
sunset.
beach. Okay, all right.
Watching the sunset, you can see that the sun appears to be touching the ground. It's not actually touching the ground. I'm not saying that. It appears to be touching the ground. We know that it's not actually touching the ground. It needs to be hundreds of miles above us, right? I mean, I don't want to put a number on it, and I never have, but obviously it needs to be way
Just
above
say
that.
X. Just say X. X miles.
Well, you can say that. I can just qualify it without numbers by saying I know that this effect is optical because I can just open up the aperture of my camera. But continue with your
Can't always
argument.
do that.
Yeah,
I've seen
when
that
it's
done
of
before.
course when it's too far. Of course, when it's too far, just like boats, when it gets too far, but we still can create the effect or see the effect literally with the sun when it's not too far. See the same effect, and then open up the camera, and then poof, it's just an effect. And then that effect is
doubting that.
recreated when more distance because you can't see forever, and every optical equipment is going to have a limit just like our eye. When it gets too far, guess what? The effect that we said, oh, is just an effect of the angle of, the optics. Now all of a sudden, because it's too far, we're like what's the argument?
You got to try to be more. All right. I'm not saying it's not just an effect. I'm saying yes. It's just an effect. We're seeing it in this spot. It's just an effect. I agree. It's like you're trying to argue with me when we agree every time. I don't know why.
No, you keep adding units and shit, and I'm like, why? Like, why do I have? Because you keep saying right, like I'm supposed to go right, and I can't. That's what's annoying.
Okay, can I jump in just real quick? Hold on, just real quick.
It's supposed to be way over your head, right? Travis, the sun's supposed to be way above our head, right?
And
okay, and it's not. But when we see it here at the horizon during sunset, it's not. It doesn't appear to be way over our head anymore. It appears to be touching the ground.
And
okay, wait.
Okay, that's
no numbers necessary. Great. I wouldn't have said
numbers,
shit
fine.
if that's all you said. And
we don't need numbers. And that's
okay.
the whole point,
And finish.
is that,
Continue. That's not
hey,
all you were gonna say.
The whole point is we're seeing the sun in this one spot. We know it's not really in that spot. It's supposed to be way above our head. And the Globers say, oh, we're looking at Canagoo. It's not supposed to be here. It's supposed to be in this other spot.
Mm-hmm.
You can't say, oh, this doesn't work for the globe because it's not in the spot that it's supposed to be in geometrically.
Yeah. Jeremy,
it's not about the globe. It's about it's not about the sun. It's about seeing the silhouette of the mountain.
Well, they're replacing perspective with Earth curve.
Argument. Well, yeah.
Things appear lower in the distance because of perspective. They're using Earth curve in the place of it because you're spinning backwards, with Earth curve, and rotation in Earth curve is being put in place of perspective. They don't even mention perspective. How can they not mention perspective when?
I know their story, dude. I know their story. Go ahead, Travis.
Nah, I'm breaking up. I don't think I'll come through.
Seeing Canagoo is a geometric issue. Seeing the sun appear to touch the ground is not a flat Earth issue.
Okay, I'll tell you what is a flat Earth. Fine, you want it? We can't use the sun for some weird reason. Fine. How about Mount Rainier?
I'm just the argument, Jeremy. Not using the sun. It's the argument. Not using the
Elijah,
sun.
stop interrupting Jeremy.
Yeah, can you shut the fuck up for a second? Like every time you
Gonna
speak,
use the sun.
you get in
Fine.
there.
We're not gonna use the sun. Fine. You guys don't like the sun. I understand why. We'll use
like
Mount
gaslighting.
Rainier.
We'll use Mount Rainier. Listen, I said, okay, so we appear to
Dude,
see.
he can't even fucking finish. Shut the fuck up.
Yes, he can. No,
Hey,
because he's
Smooth,
gonna say,
back
okay,
off.
let's use a different. He's gonna say, okay, let's use a different example twice now, because we was in the plane, now we're on the ground. Now we're like, okay, fine. No, Jeremy, your argument was what was it actually? Because you're saying, okay, we agree, it appears to touch the ground. I'm like, okay, but weren't you saying that was a problem for flat Earth? And you're like, okay, let's look at it from this. No, your argument is a losing argument. It has nothing to do with the sun.
The sun can't geometrically touch the ground, right? Because we know it's way up in the sky.
Okay. Now what?
Okay.
That's the same thing we're saying with you're saying the other thing with Canago. Geometrically, it's not supposed to be here. Tell me how it's different.
Okay, like I said, because the mountain that we see that we don't normally see because there's too much air and atmosphere in the way, the mountain that we see is supposed to be on a curved part of the earth that's curved at an angle that you cannot see. That is not the same as the sun appears to touch the ground. They're not equivalent.
Can I just ask a quick question? I just want to know, Elijah. So why can't I say refraction? Why can't refraction bring up the mountain? Like, can you address that? I want to hear your answer on this so we can seriously
How is it angularly going to bring up the mountain like that? It's like how does it unfold a curved piece of land so that you see it as if it wasn't?
I mean, there's examples of this. I mean, have you seen the what was it, the sugar water one where they have a curve and there was buildings behind that and they brought that up over the curve? I mean, it's not impossible. It's refraction.
We don't live in sugar water.
That's besides the point, though. The whole point is to prove whether or not refraction can do this thing. All right. I mean, we can worry about the strength of it later. All right.
I mean, you can show it happening in the air. Remember the box, Elijah?
That didn't happen. That wasn't real.
Out 20 feet. Because you go out 20 feet, Travis. If you can't wrap your head around the fact that we could have put a box there, that's obnoxious. Come on. Seriously, dude. You guys
I already
me
told
sometimes.
you.
I'm not joking.
I already told you. I understand your explanation. Show me. Stop talking. Show me.
See, you can
it's
just
the same thing I said, and then he said, "Let's get out the plane."
You don't think you could put? I could have put a box there, and we would have seen the water.
Oh my God! I understand. I understand what you're saying. Stop talking about it and show us.
Well, Elijah doesn't, because he said he said
Travis doesn't think so either. Travis doesn't think. Travis thinks that somehow if we put the box there, we still wouldn't be able to see the water, even if we put the box at level and the water's above level. I know you want to bloody mute right now. I know.
Let me tell you what's wrong with being an apologist for the ballers. Maybe I'm gaslighting you too right now. Whatever. At least I can admit it. Yo, fam, we're talking about, okay, if the box is a mile away from you and then somehow sugar water makes it look like now all of a sudden it's behind 10 miles worth of other shit, then that would be like, okay, I don't see that. So this idea about Canagoo is like, is like going to try to be applied to the whole refraction argument, and then what the fuck does it have to do with the fact that geometrically there is no obstruction ever, which is why we see
this is a geometric argument,
which is a secondary thing. The fact that we can see Canagoo is elucidating the fact that there is no geometric horizon. So this box that's supposed to be 1 mile away is supposed to appear behind things that are 5 and 6 miles away that are actually there. The box is over there instead, behind that. No.
Can I answer to that?
So if it doesn't apply to that, then why are you applying it to Canagoo?
Well, you're asking how we can unfold. I don't recall your words, but for something that is behind a curve to be lifted up, all you need is just light to bend downwards. If light bends down, this is what happens. There's demonstrations of that. In principle, it makes obvious sense why that would happen, and what that requires, the conditions that we need for that to happen, is just that the atmosphere is actually denser in the bottom, because as we can test ourselves, light bends towards the denser medium.
Yeah, this is
And
gonna work. That'll work.
Guess how the profile of the atmosphere is. It's denser in the bottom. So you have all the ingredients that you need, and you have it working in principle. So you can't argue that shouldn't happen. Like, all the things that need for that to happen are there. In our argument, this shouldn't happen.
Jeremy, let me see that video. That video you talking about?
Yeah. I'd like to address the point where he says it's denser at the ground level. Over a flat plane, that would introduce that you're looking through a denser medium over distance, and that would introduce also bottom-up obstruction. Because at that angle where you're looking through the more dense atmosphere, you wouldn't get all the information as you would at a different angle looking at the top of an object where you're not looking, you're above the surface, looking above the surface, so not as dense.
Makes sense.
Yeah, but now you're just talking about things fading out. I was explicitly explaining how they could be lifted up.
Right. I just used your argument of being more dense at the ground level. Light bending would cause bottom-up obstruction without light bending over a flat plane. So you don't
There
need.
wouldn't be obstruction. There would just be things fading away because the medium is too thick for it to see through it. It has nothing to do with what I was saying.
Resolution. So you wouldn't be able to resolve the information lower to the ground. So it would be what we call obstruction. So I know you like to mix words, but your brain couldn't resolve the information because it's looking through a more dense atmosphere lower to the ground. So less information is reaching your eyes and your brain as it is if you're looking at a higher angle up into less dense air, and you're getting more information. So your brain is able to interpret, look, that's a building. It's not as blurry as when you're looking lower down, and then as you're looking where the ground and the sky appear to merge, that information is being distorted so bad your brain can't even make it out. So you can't even tell it's the bottom of the building or the water, and that looks like bottom up obstruction. Thank you very much. I'll be here all week.
It's completely besides the point, because I was responding to the question of how.
You can hand wave it if you want.
Well, yeah, I'm explaining why this is behind the point, because Elijah was asking how could the air refraction make things rise above the curvature, and whether or not it will be obstructed because of the atmosphere is too thick to see through, which I never claim. Being denser is like a 0.1 difference in pressure is quite a significant difference for refraction at long distances. So
show us that. Show us that.
Yeah, I'd like to see that.
We can go through the math of it, but regardless,
no, I don't want. No.
That's not even the point. That's not even the point.
I don't want the math. No. I don't want the 0.01 math. I want you to show me what the 0.10 looks like in a reality photograph. Show me the value you think you have.
I know you want to talk about something else. That's not what I'm talking to. That's not what I'm talking about.
No, okay, hold on. You just named a
I just
value.
made a claim that isn't relevant to my point. I was just responding to a side claim that Rakia made. Yes, I made a claim which is a side point from Rakia, which is not related to what I was arguing to Elijah. And I don't want to branch this conversation off a different subject. So I don't care about your response to that, because that's not even my point, and that's not even related to Elijah's
Why did you say it?
This is the topic. This is the topic.
Because I thought that
you
could
just
be
don't want to talk about it because I'm using your own.
I was trying to answer to Travis. Like, I have to. If someone asks me a question, I can't answer if you speak over me.
You've already answered. You said you don't want to address him because it's not on topic, and I'm answering you. It is on topic. I just used your own logic as far as the layer of the density being closer to the ground, being more dense, to show you and the audience. It's not all about you. Showing the audience how if it's more dense at the surface, you're not going to get that information. So if you're looking over a flat plane and more dense atmosphere, you're going to get less information, which is going to cause distortion and not be able to resolve that information. It's going to look like bottom-up obstruction. Thank you very much. I don't care what you're doing. I don't care what you're doing.
If you want to have a different, Okay, so if you want to
I
have a
don't
different
want to have a
conversation.
conversation with you, sir.
Just not
I
being
just used
trigger
your
happy.
point.
Jeez, man.
Okay, so
Yeah, but
I was
geez,
trying to
man, he
respond.
keeps saying stuff that we're not
Okay.
even talking about.
So I was responding
Okay.
to Elijah, and then you want to bring a separate point, and you don't care if it's a separate point, but you don't want me to respond to you. That doesn't make any sense for you to be in this conversation.
You said you didn't want to respond because it's not on topic. I said I used your point to Elijah or whoever to explain to the audience how it creates bottom-up obstruction due to the density. If you
But
don't
my
want to talk
question
about
wasn't
that,
about
I'm
that.
fine. I didn't say
Okay,
it
yeah.
was. Jesus, bro.
So why are you
This is
responding to me?
trollish.
Rock,
I wasn't
Okay, so
responding to you.
you're
okay,
I
just
was
so
wrong.
shut up
using
then. Let
your... Yeah,
me
you
see if
shut up because
Elijah
you
has a
don't want to be on
response.
topic.
Let them talk. You were wrong, Rocky. It's okay.
Oh,
Just
shut
wallow
up,
in your
Nate
Listen
Hug.
to
emotions.
that
Go on mute.
troll.
Shut up, Nate
Go
Hug.
on mute.
Hey, yo, don't call
Uh,
names. Listen, don't call names, please. And stop interrupting, guys. Let everyone finish, please.
we don't need we don't need a troll correcting our interpretation of another troll.
A troll, please.
All
Come
right.
on,
So
Travis.
regardless on what can or cannot cause bottom-up obstruction, what I said is a mechanism for you to have something being loomed up at a distance. It doesn't matter if you say, well, then you also wouldn't be able to see things from bottom up because of X, Y, and Z. But that doesn't matter. I was asking to the question, how could it make things being loomed up? And the side point doesn't address that.
I don't understand what you just said. What you just said
No,
made
but
no sense to me.
loomed up is okay.
Yeah, I'm not surprised with that.
There's nothing wrong. There's nothing wrong with looming, but all the citations when talking about looming is with respect to the horizon. So we're talking about objects looming or not. That's why I believe the example of buildings looming up and down was brought up. What the fuck does that have to do with the horizon? Nothing. Okay, Jeremy was talking about the sun. What does that have to do with the sun, Jeremy? Make your point. I'm not shutting you down. I want to hear it. What the hell is the point?
My point was that if the sun appears at ground level and it's supposed to be way above our head, it's the same thing as saying like Canigoo, we see Canigoo in this spot and it's supposed to be in a different spot. There's nothing different.
Yeah,
You're just
I don't
talking
agree.
about apparent
okay.
positions to actual positions.
Oh, okay. We don't agree. I don't know how you want to.
Yeah, I don't agree with that, Jeremy.
So I don't know how. There's nothing to argue.
That's fine. I mean, things are getting raised and lowered in the distance.
You're not
That's
making
not
an
a.
actual
Oh, all right.
claim.
Okay.
Go ahead.
Go ahead. Oh, wait. Not my
You're not
mic
making
fucked
a
up.
claim. You're not making an argument, right? You're just saying the only thing you are saying is we can't really use this argument because if they use this argument, that's equally bad. And we keep trying to explain why that's wrong, but you're not listening, and you think we're not listening. So I don't know.
And you don't have to even use this. Is it bad because of the sun?
It's not an argument. What you're saying is we can't use an argument. That's what you're saying.
No, I'm telling you that this is not strictly a geometric argument, right? So to say that it's supposed to be geometrically blocked by the horizon.
Right, we did the box.
There's not a geometric argument because it's not only geometry at this point. Things are being shifted up and down in your vision of sight. We know this.
Right. There would be no issue in this discussion if there were no claim for the globe. If there were no claim for the globe, we would have targets in the distance that we can see in one way one day, and that same target either completely different in another day or completely gone in another day. In all three
That's
instances.
what we see. That's what we see.
I know. In all three instances, which one is the control?
You don't have one. You don't have a control. You don't have a baseline. You don't have an actual position.
That's fine.
You need an actual position to have for your control. It needs to be the actual position, not some random average of when it was
I agree. Okay, now listen. Now, if we can travel to that object, whether it's a mountain or an island that's over the water, right? Know the distance. So we know that it's there. We go back to where we make the observation from. I can see that object. 2 months later, I go out. I can't see the object. It's not foggy. It's not cloudy. So the only thing I'm saying right now is every single time, it's always refraction. Always, every single time.
I mean, I don't think every single time. You probably get lucky once in a while, but
no, every single time you see
refraction,
it. Yeah. No, refraction can be anything from a slight fuzziness to a complex mirage. But the target is always there.
Okay, George has the water below level and above level. I'm guessing at one of those points was the actual position of the water, because it obviously went from above level to below level. So at one of those points, I'm guessing the water was actually at that point. Its actual position. That's just a guess.
Okay, but it's not just the water's position that changes. Everything in that image is not the same as the other image. Not just the position of the water. You can't just also focus on that one little.
No. And as far as Elijah said, with respect to the horizon, yeah, they did used to say that, and some papers say that, but we know the horizon's moving too. We have the water above level and below level, so we know that's moving also, because that's just another object in the distance. Why would that? Why would another object in the distance not be? Why would another object? Why would another object in the distance, just because it's on the ground and we call it the horizon? Why can't that be?
Wait.
The only thing that what you said invalidates is the claim that things are obstructed due to the horizon. That's all you did. Is validate our position.
I know, dude. I know. I'm on your side. You guys are coming at me like
Jeremy,
I'm a Glover and shit, man.
Listen, I noticed. Can you hear me?
Yeah, we hear you. We hear you.
Okay, listen. All right, Jeremy, go back and look at that picture, those two pictures of George's. Look at that tower. That tower in the top image, as far as I remember, is magnified larger than the other one. If you want proof of magnification, George gave it to you.
Yeah, let's see it. Hold on. You think George did it for us?
Yeah, what image is this?
I posted it a little while ago. That's an image I snapshot from George after begging him a year to post it, because I got this I got this years ago, and they all called me a liar. But when George did it, he was whatever.
Where is it?
Oh, my bad. You
wouldn't robot. He would never post it. And
you're roboting a little bit.
Where is it, though? I don't see the picture.
Which one is he talking about? I don't see it.
So that is Travis. Good catch. Good catch, Travis. That is a good proof of the atmosphere magnifying things. We can see it right there. Look at that tower. It's taller.
We have more
and wider.
Wait, can I see it? I don't see it. Where is it?
I swear, Jeremy, if you use this as one of your arguments after I've argued this for years, I'm going to come over there and reach out and pull your hair out.
Y'all hear me?
Yeah.
So the y'all remember that other magnification video about that weird spot where they're driving up through the trees, and it looks like this building all of a sudden just gets smaller and smaller?
Yeah, it's actually huge.
That's not magnification, though. I know what you guys are talking about. I literally did a 3D model of that. But can I see this other image that George supposed? It's not. I literally compared to two sizes. Literally, it gets bigger as you get closer to it. But can someone real fast show me George's picture though of this magnification? Like anyone? I don't see this.
So you're saying things can appear smaller but not appear bigger? Is that what you're arguing for?
It's look. I'll show you, but it's like a weird.
No. I'm saying is what
sort
you're
of an
saying.
optical illusion, but
we know the optical illusion is confirming that things can appear smaller. But,
no, but
are you
the thing
saying
is, it's not actually smaller though. It's if you angular size wise.
Actually, it appears like that. Yes, I know it appears. It's not actually. That's what we argued about this whole time. That it's not actual. It just appears. We all get that. The converse, though, does it appear that things are bigger?
Yes.
The converse. Okay. Okay. Thank you.
He
Okay.
didn't
Oh,
agree
so
to
this is
that.
the image I
I'm
see.
stating
Okay.
that because he just wants to breeze past.
All right, that's interesting. I mean, Let me see.
Yeah.
Yeah, think about that one for a little bit.
Sometimes slowing down
is
a good idea. You don't always have to rush into things.
Is there zoom on this thing, scope, or whatever the fuck you want to call it? Like, is there a zoom on this? Like, what is this?
It's a theodolite. I don't think they have zoom. They have one setting.
Okay. And then he didn't move his position at all, right?
No,
No,
he's anchored.
Rocky,
He's
you're-
anchored into the ground.
Okay.
Rocky, we can't hear
Does
you.
anyone
I
have
can't
a
really.
video of
Unfortunately, I can't really confirm this for myself. I just have to take your word for
Yeah, he
it.
said
But it
was
would
the
be
same
nice.
focal length, same pose. Yeah. Can you hear me on that?
You're very bottom.
You were breaking up.
The mount to the theodolite, it's anchor. It's like cemented into the ground. Or they're all static positions. Tower and his theodolite, whatever he's using. That I just measured it left to right, and it's definitely bigger and smaller left to right. And it's obviously, I didn't even have to measure the up and down. That's obviously magnified in that axis.
But hold on,
So it's being
hold on. Actually, no. I just noticed something in this image though. So notice in the bottom image though, right? The circle, that black circle, or I guess lack of a black circle, because technically it's the black is on the outside, right? That's smaller compared to the image up above where it's bigger. So I feel like he's actually scaling the image though. He's actually physically scaling the image. How come the circle is smaller in the bottom?
Oh, you know what? He probably didn't have his camera the same distance from the theodolite.
Yeah, what kind of inconsistent shit is that?
I know this.
Yeah, right. Welcome to the globe. Right.
No, you can adjust that. You can see where the what do you call
Crosshair?
the X thing is? What do you call that?
Crosshair.
The crosshair. You see at the bottom underneath the line where the shoreline juts out. You see where it is at the bottom one, how far away it is from the y-axis, and then on the top one, how far away it is from the y-axis.
Yes.
That in itself shows you the difference. So even though one's zoomed in and one's not, I understand your
I mean, it shows that
pointing out,
it's.
but the scale, when you actually look past that and you look at the scale itself, the position is different.
Position's different. That's fair enough, but I don't think the scale is different though.
No, if the position is different, the scale is different.
No,
This thing
he's
is a
set
fixed
up.
position. This thing is a
Set
fixed
up on the
position.
same
No,
post
if
every
it's being
day
brought up
on
vertically,
Bedrock.
if it's being brought up, then it doesn't have to scale. It's just being brought up. It doesn't have to be.
That's
not
exactly what
scale.
we're talking about, though.
Well,
Can someone translate for him? Because this is.
Then why did they say
odd.
scale for? Then that's not scale. Don't use the word incorrectly. That's fucking stupid.
Wait, ask who?
Don't be simple.
You mean don't be simple? That's the scale. Scale. You don't. Scale's not one axis. That's not how it works.
The image is
scale something,
bigger.
it gets bigger.
The image is bigger. Whatever it is, whatever
The
they're
image is
looking
bigger
at.
because he made it bigger. Look at the circle.
No, the image of the item, the object, is bigger in one than in the other.
Yeah, it's bigger than one because look at the circle. Literally,
It's
look at
got
the circle.
nothing
And the
to
bottom
do
one,
with
the circle is smaller.
That's why I pointed out the X. The X doesn't change. The crosshairs don't
Yes, it
change.
does.
Look
Yes, it
within.
does.
Look within.
It has an optical zoom. It can change. I know what you're talking about. The Theodolites have zoom.
Whether it has zoom or not, though, it's that circle thing is still weird, though. I mean, like, what's going on with that?
Questioning this whole. I'm questioning this whole picture now. Check. Can you guys hear me?
Yeah, check, Jeremy. Troll lover.
Come to you, Jeremy.
Troll lover. Do you feed the trolls, Jeremy?
Oh my God, he feeds them. He pets them.
Don't interrupt the
Yeah,
troll.
how many bridges do you have on your estate, Jeremy?
I don't know. I'm questioning this whole picture now because of what Arma just said.
No, his point doesn't make sense. Look within the circle. Don't look from outside the
Yeah,
circle.
that's fine, but I'm trying to figure out why that circle is different. What is causing that circle? Why is it smaller in one? What's that about?
Camera.
It doesn't
The
matter
camera's
whether it's
further away.
small or not. It's
Circle
hard to
is the
take a
same
picture.
on a theodolite.
It's
Rocky
hard
was
to
trying
take a
answer you.
picture.
Tell him
unless-
again, Rocky. You got Fundy muted.
Whoever said that theodolite has focal length, that's ridiculous. You put a camera up to the eyepiece of the theodolite, and you can take a picture of where your crosshairs are, the image that's within there. Nothing else changes. If you move the camera closer and further, you're going to get that optical, that distance of the roundness being bigger and smaller, but it doesn't change where the crosshair is.
Exactly.
I don't know.
That's
'cause
basically what I
Doofus,
was
I don't know
saying.
because Doofus was making an argument the other
That's
day.
Yeah,
patently false.
Remember
right.
the main
Doofus,
surveyor?
really? Doofus, really?
That is
Remember when
patently
the
false, by the way. The crosshair is part of the apparatus of the theodolite, not what the image behind it that it's looking at.
Yes,
You
I
can
know.
zoom in. You can zoom in
it's
on the
a
picture
it's
behind
a
it, and the
fixed point.
crosshair will stay in the same position.
And
Okay,
that's what I said,
Rakia.
that the crosshairs don't move. And you cannot adjust. You don't focus the theodolite.
Yes, you. First off,
Rakia,
you're
remember
using
when
a camera, and the
No,
camera has
DP
no focus.
there's no focal length
remember
on
when
it.
DP was
32 times in 24.
remember when
These guys
DP
are
was
always
doing
going to
his
look for holes in examples. Why do we waste that time?
remember when
What?
DP was giving his thing and we brought up the main surveyor and we said, look, he doesn't even know how to use his tools. He's got two tools right next to each other at the same height, and his crosshairs didn't match up. They're like one was at a different level than the other one.
You have one
Doofus said
upside down also.
Yeah, Doofus said that this was due to the angle or how far away the camera was from the theodolite screen. He acted like that could change the position in the theodolite of the crosshairs.
It can.
It can, he said. If you zoom in and out with a camera, I said this the other day, and y'all fault me. Remember, Jeremy? I said if you pick an object and put it in the center of your lens and zoom in and out full, that you would have to move your camera to keep the object in the center.
No,
Now
we're not talking about zooming in with the theodolite or whatever. We're talking about the angle and how far away you are from the camera to the theodolite, which you're looking at in the optics of the theodolite. They're saying that can change. They're saying that can change where the crosshairs are and all that shit.
Yeah, just like when you take a globe and you guys say like, oh no, you can see all of Africa in one, and then the other one you can't. It's because the focal length is different.
Okay, go ahead and do it then. Put a crosshair on a number. Let's pick 10. Set your story pole up. See where your crosshair hits it when you're looking through it, and take a camera and change the focal length and see if that crosshair moves. I'll take it not moving for 1,000, Junior.
Hold on.
Right,
To be
yeah,
fair,
you
though,
have to recreate your example before you.
hold
can
on.
use it as a
To be
rebuttal.
fair, focal length isn't really the issue. It's literally your distance to the object that's going to change that that warping and whatnot. But I guess in this example that's fine though, because in this example focal length could make the thing appear bigger because at that point you're more zoomed in and whatnot. But I don't know. I just wanted to point that out. The whole.
Do y'all want to know the guy George that took these pictures? Do you want to know his explanation of this? I don't mind saying word for word. He said because he took the one that he claims to be more refracted, where the crosshairs are above, where the horizon is above the crosshair. He said he took that in the afternoon, and it was heavily refracted. So that was his reasonings for that happening. So y'all can argue about it all you want.
Just
but
because
that's
his reason was just afternoon? Did I hear that
Yep,
right?
yep. And then
Yeah,
he said
more
it was heavily refracted
conditions in the
because
afternoon.
I mean, that's just an unfinished conclusion, but okay.
Well, he said there's more refraction in his area in the afternoon because of the conditions of the day. So he got that that crosshair. Yeah. So what he's saying though is backing us up that conditions of the day affect the position of distant objects. Thank you very much.
Oh yeah, we've already. This is an established an idea that we already know about. I don't understand why it's so difficult for the rest of them.
Okay, but how can you say that and then go to Canada? How can you say that, Rocky, and then go to Canada and be like, look, this shouldn't happen? We know that things are changing in the distance.
Well, we're talking about like a little over a couple of feet here, not 160 miles or whatever he's claiming it is. I mean, there's limits too. Like, you can't just make it wrap around a ball and say it's refraction because of the conditions of the day. I understand you have to have a baseline, and that's tough to do. I agree with you on that. But it's within reason too. You know what I'm saying? You can't just say it's underneath you. Like Rumpus and them saying if you have a big enough telescope in good conditions, you can see the back of your hat. I mean, you have
Yeah,
to
they've
be
said
within
that, haven't they?
reason, right?
That's
Yeah,
fucking
yeah,
stupid. Yeah.
yeah. You have to take it in context and be within reason. You can't be a psychopath in a padded room saying whatever you want to say on the internet.
Yeah, the seeing your own
I'm
ass
sure we
thing
could.
is
I'm
fucking
sure we could even
ridiculous. But
quantify the scale and at which point it would be unacceptable. If that
how
makes
do you
sense.
know when it would be unacceptable? How do you know when there's an unacceptable amount of refraction going on?
Well,
What's the limit?
I can tell you, I can't quantify the limit. And like Travis says, he would need some money to start to research that. But you can't say it's looming up however many feet, 60, 80, 100, a mile or whatever, and it's not blurry. I mean, when refraction occurs, you're getting distortion of light, the bending of light and distortion. The more it has to curve, the more it has to do this, that, and the other, the more distorted it's going to be.
That's true. The silhouette for Canagoo is pretty crisp,
Pretty
right? Can we bring
freaking clear and crisp.
Can we
That
bring a
looks like
picture of
reality.
that up? Yeah,
That's
let's
the
bring a
word
picture
I
of that
was
up.
looking for before.
Yeah, you're not
Silhouette.
smart enough.
Can
You're
a
not
your
smart
words.
enough
silhouette,
to remember.
Use
guys?
your words, Essie. We could have avoided this whole thing.
Thank
Big
you,
dumb
damn it. Thank you,
Cajun
Jeremy. Now hold on. Let me
Canadian,
just say
French
this.
Canadians shouldn't be allowed to speak here.
That's
Yeah.
right. Now, check this out. Now, that's the word I was looking for when I was giving you the description. Silhouette. Now, can a silhouette refract, ladies and gentlemen? Next question.
Bring a picture. Of course it can. Bring a picture of let's
What do
get
you
a
mean,
picture
of course it
Canagoo.
can?
Can a silhouette of something? It's just the thing.
It's a
The silhouette
backlit.
is the thing.
Think about this now. This is new
Yeah, but it's
stuff coming in.
But the
What is a
silhouette is the mountain. If I have the silhouette of the Marlboro Man on a horse, look at it, you see a silhouette. That's the guy on the horse.
That's the question. Can a silhouette refract?
I think it depends on the silhouette and the conditions with which it was created.
Why can't a
Sure.
silhouette refract?
I'm asking.
The guy
I'm
on
asking.
I think so. Yeah,
I'm thinking.
I think so.
Okay.
I don't see why not.
I think some
Depends on the
can, some
angle.
can't would be my answer, but I'd have to
Wait,
think more.
wouldn't a silhouette be the lack of light? Isn't that the whole thing? Is that it's blocking the light?
Exactly.
So how would a
Exactly.
lack of light refract? Not
Thank
light
you, Bob.
doesn't
That's
refract,
actually a
does
good
it?
point. That's a good point. I'll
That's
give you
my
that.
whole point. Yeah.
But the lack of light is caused by obstruction, and then there's still light, right? You only know that there's a lack of light because there's light.
Okay, armbar. Can a silhouette
So
refract?
Maybe not.
I don't. Yeah, I mean that's actually a good point. I mean, now that you
This would
mention it,
have
I
to
don't
be
think it
tested.
really could. I don't think it can.
Boy, that's not good
That's
news
the
for you, bro.
difference here, Jeremy. That's the difference, I
News
think.
for you, armbar. If a silhouette can't refract, or you got your radius wrong, bro.
It's game
Like
over.
whatever light wasn't blocked by the object could still refract, but like the part where the object is blocking the silhouette itself, how would it refract? It's blocking the light, and the light is the thing that refracts.
This is
not
what
good,
we should be
armbar.
pondering now.
I mean,
Both
the only
sides.
thing I can the only thing I can think of is because I mean, like I'm thinking about this now, right? So, because it would still be refracting light the light that isn't in that area, and so I imagine now, like I'm overlaying this image. I'm kind of thinking of it. I'm thinking of it like a projector. You know how you like project something on a wall? Like there's like the light part and there's the dark part. The dark part isn't actually any light. That's the wall, right? So I'm thinking about that. And if refraction is kind of like that, then that's tough.
It depends how you receive.
Then
the
you can't have a refracted silhouette in Earth, and you got the radius of Earth. Congratulations, welcome to.
Well, here's the thing, though.
Flat
Hold
Earth.
on.
Here's the
It
thing,
does
though.
depend on how you receive the silhouette, surely.
Yeah, because I imagine though, like if you are going to receive the other light that isn't the silhouette, then would you have double light in that area? Because you have the original light that was already kind of coming from that direction, and now you have this, refracted image also where there's the silhouette and then there's the light around that silhouette, obviously. So you'd be receiving that light as well. But that doesn't make any sense though, because I feel like when you're looking at these, refracted images, you're not getting like a really like bright. Like I it's probably not making sense to you guys, but like I'm thinking about it right now, and I'm like, I might have to look into this. I don't. It might be able to refract a silhouette.
Yeah, it has to, bro. There's no way you can say a silhouette can't refract and still think Earth's radius is 3959.
I think I may have found an Achilles heel here.
No, that's a good argument, but I do think though, because I'm looking at this, there's also an argument that can be made. I'm like, okay, but it's about forming it though. I don't know if I can form it properly though, because it's kind of like the whole projector argument thing.
Think
Bro,
about how
can a
you're
silhouette
receiving the
refract?
silhouette.
Yes or no?
Because but think about it, right? Let's say you're receiving a silhouette. Okay, like the picture that Dan the Waterman posted. So that one is you have object in front of light, blocking light, therefore silhouette. But you have the other stuff. You have other type of silhouettes where the light is behind you, or behind, or in between you and the object, and then it's casting a silhouette on another surface. And then between you and that, so those are kind of two options. There's probably some more. Between you and that observation, there is going to be conditions. Those conditions could refract what you're observing. Not directly necessarily the silhouette, but your perception of the silhouette could be refracted. Does that make
Listen,
sense? Is there any holes
It
with
makes
that?
sense. No, it
Okay,
makes sense. I'm sorry I called some of you guys goofy, or you were saying goofy shit or whatever, but you were saying goofy shit to me, okay? But I'm sorry.
I guess you're talking to the Globers. I don't know.
No, I was talking to my own guys. Travis, you're still goofy.
Let's see.
You gotta stop hanging around with ballers, Jeremy.
Bro, I've
Telling
been
you.
in here for like 3 weeks. I did go into Gems for like a half hour yesterday to pitch him that
That
stop
affected you.
rotating thing.
That affected you.
Listen, can
Yeah,
a
you gotta do a
silhouette
detox.
refract?
This is
I
the
think-
question, bro. This is the question.
I do think there is potential, though. I'm gonna real fast show you what I mean. Let me real fast pull up an image of like a horizon or something and kind of show you what I'm. Yeah, I'm gonna present this real fast. Let me see. Not right now, though. Give me like
There's
5
no
minutes. though.
light. There's no
No,
light. How could
I get
no
that.
light refract?
No, I get that, but let me real fast present. Like, you'll see what I'm talking about once I present it. Like, okay, that like I might have like a decent argument that you might like. So give me a second.
No light refract.
Jeremy, when you say there's no light, when you look at a shadow, you're seeing the light.
No, that's incorrect.
And the demarcation between the light and the dark. Otherwise, a shadow without any demarcation between light and dark is just dark or just light.
Yeah. So can a shadow refract?
Yes, because the light around it refracts.
Well, let me real
The
fast.
light-
You know what?
the light
That
changes
would be the
position
shadow
with the
refracting.
shadow.
Then that would be the light around it refracting.
Right.
So the shadow cannot refract, obviously.
Right. No, absolutely. But a shadow is nothing but. There's no essence to a shadow. You can't do anything to a shadow. A shadow
Okay.
is
Specifically the
is
lack of light.
So you can't refract it then. You cannot
So you
refract
can't.
it.
So a silhouette can't be refracted. You're saying?
I think it still can
Said
because
a shadow
He
can't
just said it, yeah.
refract, and then goes, "Oh no, a shadow can't refract. The light around it refracts. So a shadow refracts? No. Well, you just said it can. Well, yeah.
I think you guys need to stop jumping and start thinking. The question was a good question, and there's too many different examples of how a silhouette's going to be formed to just definitively say yes or no.
You know we have years, right? This is the first 5 minutes of this conversation, so be
Everyone
patient.
needs to start.
No, I
over-talking
get it.
and
I'm
go.
just saying, like, just in and of itself, how they're formed. They're formed in so many different circumstances that you can't. I don't think it would be wise to definitively say yes or no.
It's not really different.
It's obviously going to vary with the conditions.
It's not really different
formed? All
circumstances. You
silhouettes
form a
are.
silhouette. Go ahead, Moyad.
As it's to say, all silhouettes are formed at the demarcation of light. So if you refract the light, the shadow moves.
And you're saying you can refract a silhouette. All right.
Of course. Why not? Why not? Do you disagree with the statement that
I don't know.
the shadow is the demarcation between light and dark?
I don't know, bro. I don't know. The silhouette is.
Answer. I like that.
Yeah, I don't know if you can or can't refract a silhouette. I know that a silhouette is all the blackness, right? It's all dark. There's no light coming from it, so I don't know
Well, actually,
what there is to refract with
so
that.
Dan posted another example, a couple of examples of Statue of Liberty, that disgusting thing that it is. But that watching that from a distance would be the same as the other picture you were discussing with the theodolite, right? The only difference is in the picture with the theodolite, you can fully see the object, whereas in the one with the statue, you're seeing the silhouette of the object. So depending on the conditions between you and, in this case, the Statue of Liberty, the object would be either magnified or the opposite, right? So wouldn't that indicate that yes, you can, in this instance, refract it? I know I'm using words to paint pictures, but did that make sense?
Nah, I'm not sure.
Listen, scientifically, can you refract a silhouette?
Scientific. It's not a scientific question. Is
It's
it?
a difficult question to answer because what are you talking about? The silhouette, the shadow itself is nothing.
So that's definitely not going to be refracted because there's nothing to refract, right?
So you will reflect
remember,
light,
the only
which will
reason
make
you
the silhouette move.
Sorry, go ahead.
Yeah, you will reflect the light, which will make the silhouette move, or your perception of where the silhouette is.
Right. So you're saying it can be refracted? Okay.
Yeah, but then you also have to say that if it was doing that, then the crispness of the silhouette would also be compromised, right?
Yes, that's true. That's very
Not
true.
if it was uniform refraction. Like if I took
when does
just
that
as
happen?
an example, if I was to take a lens,
If you disagree with
if I
Sorry,
was to take a lens, if I was to take a lens and refract that light so that it comes in front of something, and now that silhouette will think that the light is coming from wherever that lens is refracting that light. So it'll still be crisp. It'll still be sharp.
Yeah, I guess this argument boils down to whether or not we're getting light from any other, I guess, angle. Because if we can get light from another angle, like then obviously that silhouette won't mean much because obviously we're getting light, hitting our eye where that silhouette would be. But with that being said, if light is being bent in such a way where only the light from that refraction, that the area where it's being refracted and whatnot, if that's the only light that we're getting, then we would get a refracted silhouette, because at that point
I have a better
we're not
way
getting
of
light. What?
Sorry to interrupt.
Can I-
Are you
can I
finished?
step in?
It's
Go
real
on.
quick. I think I have a better way to phrase this. What would be refracted is our resolution of the silhouette. I think if you state it that way, there shouldn't be any arguments, and then you account for all the different variations. What do you think of that?
I'm not sure what you mean by resolution. You mean like the actual detail?
Yeah, as in, okay, either us or the camera. We resolve the image, right?
Okay. Well, I mean,
So
I wasn't.
our resolution, in that sense, our resolution of the image can be refracted.
Oh, okay. We're past the
not
point
the
of whether
image,
or not
sorry,
this. Yeah. Okay.
the
So,
silhouette.
we're past the point of whether the silhouette can be refracted. We're just talking about the crispness now. Okay. So fair enough. All right.
I think I'm just talking about the phrasing, because it's the phrasing that was maybe a bit off.
Well, here's evidence though, real fast, of a silhouette being refracted. I know you guys are gonna hate this.
I hate to cut you off, Armor, but there was a statement that was made before, and as we get further and further away, I don't feel like I can address it. So there was a statement that was made specifically with regards to if light is coming in from different angles, then it affects the crispness of the silhouette, right? That was a statement you made. Correct me if I'm wrong.
Wait, who?
Armor, you.
No, I was saying if light was coming from different angles, then the silhouette wouldn't really be not so much crisp, but maybe it would be like a faded silhouette because there would be light from another source coming, occupying that space. Kind of like the moon example that I've given you guys, where the moon appears transparent because the dark part of the moon, right, doesn't have any light coming from it, but the sky, the blue sky, that has the blue light coming from it, right? So obviously the blue light. Yeah, so that's what I was kind of going on about. So I feel like you would still get the silhouette. It's just a matter of will that silhouette be as dark as it should be? For me, that was the whole thing,
But that wasn't it. So the initial idea was that the silhouette is crisp, and that the idea that if there's lots of refraction happening, then it would be a bit blurrier, which is what I think Travis's point was, and I think is a very good point to make. One thing I would say with regards to silhouettes and having light coming from different angles, this is very easy to observe within the context of a sports ground where you've got maybe 4 sets of floodlights in each of the corners. And what you'll often see at night is a player will be standing in the middle and he'll have 4 shadows. But they'll all be kind of, depending on which of the 4 floodlights he's standing nearest to and all the rest, they'll kind of be different shades of darkness and whatnot. But the crispness of one silhouette isn't affected by the other floodlights. The only thing that is affected is the shade of the shadow, if that makes sense, not the actual shape itself.
Yeah.
Okay.
Okay.
Yeah, and I also posted.
Let's not confuse a shadow with a silhouette, huh?
Fair enough. But
Right?
I real fast
Very
also
difficult.
I also posted a video though. I know you guys are gonna hate this, but I posted a video of the sugar water. In that video, he does refract like a little city skyline, whatever, and that's for the most part dark. So in a way, that is refracting a silhouette. So I mean, I should have figured that. I mean, it is, darkness can be brought up in a sense, but it's less so that it's the darkness is being brought up and just everything else, like all the other light is being brought up. And obviously, when you look in that direction, there just happens to be no light in that direction because all the other light is refracting, in such a manner.
But I want to make one thing clear. We do understand the difference between a shadow and a silhouette, right?
Yeah.
Why don't you define it for us, Montreal, so we can?
Well, before he does that, I just want to say, SE, that your question about the whole refraction of the refracting silhouettes, whatever. I will admit that was pretty good though. Like for a second, I was like, "Ooh, that's that." You know what I'm saying? Like that kind of got me thinking for a second. That was really good.
Thanks.
You speak fast, bud. You speak fast, but I'm not sure if you say very much.
Yeah. Wait, what?
Sorry. How you doing?
Saver? What? Okay. Anyway.
So the difference between
shadow that your silhouette is just in a shadow that you're observing from within the shadow.
I guess
well,
it is
look,
in a sense a shadow.
technically a shadow, right, is what you see on the ground or on the water. Light that bounces, like the absence of light behind the thing, but like reflected on another body, right? That's a shadow, right? Now a silhouette is like the mountain when you see it from afar, but you don't see the actual shadow on the ground. Am I correct in that?
It's an
You're
outline.
in the shadow.
The silhouette is an outline. Yeah, the
problem
shadow contains the body of the source itself.
Yeah.
The shadow is where you are. I'm sorry, a silhouette is when you are in the shadow. So you don't see the shadow per se. All you see is the absence of light at the object.
I guess that's another way to say it. Yeah. Yeah.
No, that's not right.
But you know what I mean, though. It's not really that. You actually see a
back
shadow,
to the original,
right?
Maybe.
But a silhouette is what Pete said. It's like the outline.
Yeah.
Like, yeah.
Did we get them to concede that those images were either magnified or whatever the opposite of magnified is?
A baller to concede. You're kidding.
I mean, I need to make sure that that wasn't like digitally scaled, or I don't know, maybe the camera was brought up to. I don't know. I need to figure that out because that circle thing is throwing me off.
Now he's a conspiracy theorist.
What?
Now you're a conspiracy theorist.
I'm not a conspiracy theorist. The circle's obviously a different size, not shape. It's obviously
you're like on the skeptic online. You're only skeptical towards skeptical people.
No, if someone else would have showed me this and they said, okay, I would have. No, hold on, I'm skeptic.
So I tried to find any literature if silhouettes refract, and I couldn't find any. Anybody have any luck?
Well, let me show you.
Discussed it at length, but
yeah,
does anyone have the video of that thing in Canada where they drive to the building and that building across the lake just zooms in? Just gets
let me show you that real fast. Okay, I'm sorry for hogging this convo, but
you can't. Hey, SC Montreal, you can't have a silhouette of a shadow. You can have a silhouette of a mountain in the backdrop, and all you can see is the dividing line, the ridges, whatever, of the mountain as they stick out against the back sky, whatever, if it's darkening. But you can't have I don't think you can have once you're in the middle of a shadow, a silhouette of a shadow. I don't think you can do that.
That's not the question. Of a silhouette? The question is, can a silhouette refract? That is the question.
Here you go.
And I think I fixed it by stating
I wouldn't.
the resolution of a
that's not it. I don't think
could be refracted.
Can a silhouette refract, Pete?
Hold on,
that is the question.
No, because a silhouette. Think of it again. A mountain at the end
isn't a thing. In and of itself, a silhouette isn't a thing. So that's why I rephrased the statement.
Let's try that.
Think about Rainier. Actually, here's
the resolution of a silhouette can be refracted. I think
okay, one second. If we think about Mount Rainier, you know that picture that the bowlers often show, and you have the shadow of the mountain, and then you have the mountain itself, and you have the sun in the backdrop. What would you consider to be the silhouette there? Just to, we're all on the same page. If someone said there's a silhouette in that image, what would you say the silhouette is?
The silhouette
the outline of the mountain, not the shadow.
Yes.
If you're on the cloud, you would see the silhouette.
So we're on the same page, Pete.
Yeah, you're actually just
Okay,
seeing
cool.
the shadow when you're to talk
The
about the
question
silhouette
is
and the
your
shadow
page
doesn't make
silhouetted
any
or not?
sense. You're just seeing the shadow because it's much elongated, stretched version of the mountain as well, with lots of different features blocked or blocked off. Yeah, okay, excellent.
Yeah, so that part, not the shadow part. From afar, when you see that silhouette, right? The backdrop,
Yeah.
the sun is in the back, and you're seeing that silhouette. Can that refract?
Yeah. Yeah, it can distort. It's like you know the crane from the what do you call it, the Black Swan. So if that was sort of, if the conditions were a little different, the light was a little lower, you'd get the silhouette of that as presented on the image, and you'd say, well, look, that's distorted. That's a distorted sort of
That's
silhouette
not the
of
same, though,
thing
bro.
itself.
That's not
Yeah.
the same. It's not in the back. That's not the same.
Yeah, Pete. I don't know if you've met Armour before, but Pete's Armour's actually he's the bookie's favourite to become the next flat earther from the Globe Earthers.
Really?
Yeah,
He
you
just
put like
has to put the
$20
pieces together.
for Flurf.
He's gonna switch with Jeremy, bro. He's gonna. Jeremy's gonna become a baller. He's gonna become a flat earther.
What would
He's
it
trying to
take
put
Arma to
the flat
switch on?
puzzle
If
around a sphere.
If a stumping argument.
Hold
was
on,
offered to
Pete.
Arma,
I don't know.
would he-
Hold on. I don't know if you got this brick guy muted or he's got you muted or something. What's going on?
It's all right.
Oh,
I give a fuck. You don't give a fuck?
No,
I find it easy to mute everyone, Jeremy. Then you don't have to listen to anyone's shit.
I muted about 10 people at once earlier.
Yeah.
Okay, well, we just came in at the same time, but I was going to say about Arma, what Crypto said there. I wonder what would it take to get you to switch over Arma? Would it be a cogent argument, or if someone gave you a one-to-one debate and you couldn't answer their considerations, would you switch to being a flat earther then, or stationary earther?
It would have to be like really logical arguments that I can't, bunk, that I can't debunk. I would say if you guys could do like three in a row or something like that, like three that I just could not, then I'd probably be like skeptical. Like I'd be like, okay, I'm like, but that hasn't happened though, you know what I'm saying? But if you can get like three where I'm just like, okay, I'm like super stumped, like, you know what I'm saying? Like super duper, stumped.
You'll make it. Don't worry.
You get stumped all the time though.
What now?
I hear you stumped all the time, and then you find some illogical kind of worm way out of it.
What illogical? What want to hear this? What are my illogical illogical arguments?
Well, no, I was just saying I hear it all the time. I can point them out next time if you want.
Yeah, point them out next time because I don't see any.
Would you appreciate, Arma, that every single aspect of your model that you cling to and you defend every day is problematic?
I don't know about that.
Arguments galore to be found within every single specific what do you call it, aspect of your model. Would you agree with that?
I don't think this is problematic.
You don't think that's problematic? Probabilities sort of amount as well exponentially. So it's one thing to have one aspect of your argument, your greater model that you swear by, you devote much amount of your time to defending. It's one aspect. It's one thing to have one problem with one aspect, but if there's problem with each and every aspect which build and construct the model, then again probabilities mount. You can't just keep insisting that every aspect is debatable away. Individually they are, but when you add them all together, yes, it becomes exponentially impossible to justify.
I can say the same about flat Earth. Anyway, let's continue the debate now. Do you guys want to like?
You could say about the same about flat Earth. Okay, why you fobbing me off there with that answer? But do you want to get back to your shift that you're on? Okay.
Well, no,
I
wanted to say,
I have a question for you.
I did just say to Armour about 2 minutes ago I would point out any logical fallacies he makes. That was a tu quoque fallacy, Armour. And the reason that's illogical is
first off, you just get you.
Didn't finish.
Okay, fine, and then I'll tell you the fallacy you made.
Stop interrupting, Arma. Stop interrupting him.
Yeah, the reason that what you said doesn't matter is because Pete's beliefs have no bearing on the validity of yours.
Okay. Yeah, you didn't say you'd point out fallacies. You said you'd point out me like being stumped and then coming up with an illogical like solution or some shit.
You have to
If you
argue
just
the
made
point for every single aspect of your model that none of us can relate to via personal experience. No one on earth can. So this is the point, and I'm not saying that it's not justifiable argument by argument, but when it mounts together, probabilities exponentiate. So yes, by the time you have and your 100th argument to support your model, and there's problems throughout the whole 100 listings, well then you have to say that the model is not true on probabilities alone, mathematically wise.
Okay, but also let's go back to the other guy. I don't really think it's a fallacy because if I was to accept right that the globe model has inconsistencies, right? I also see inconsistencies in the flat Earth model. So now, which one do I choose or
So what's the
whatever?
flat
You know what I'm
Earth model
saying?
that you
Like
follow most closely?
at that point,
That's a false choice.
a
Right?
false choice.
But back to your first. Yeah, of course it is. Back to your. It could be confident. For
Fair.
instance,
I guess
it
I
could
could
be-
choose. I could be in between. I guess I could be a skeptic just in
man,
general.
I didn't. I went to interrupt you and then I stopped myself. Right.
I'm
And
trying
now
to
here you
add.
are.
I'm not interrupting you. Go on.
You are, bud,
Okay.
and you actually say nothing as well.
You need to
so stop
breathe.
interrupting.
When other people speak, breathe.
The point I was making is still valid, right? He's talking about inconsistencies in your model. You might actually contend those inconsistencies, not a problem. But you do not just ignore them, or let's just say a valid rebuttal for the inconsistencies in your model isn't that his model has inconsistencies.
But it wasn't.
That's
I literally.
but that was your rebuttal.
No, my rebuttal was Hold on. My rebuttal was that I don't see any inconsistencies, and I said if anything, I see inconsistencies in the flat Earth model. All right. So first off, you're saying that I never saw inconsistencies. All right. I don't think there's any inconsistencies.
Would you agree that no one on
You're
earth has ever stood for?
hold on, I have to reply to that. You're now changing what you said. Initially,
Did I?
you said, yeah, because this is all recorded. You can go back to your.
What did I
He
say?
said you've got all of these inconsistencies, and you said, oh, but your flat Earth model's got inconsistencies too. Right, that was your rebuttal.
Okay, when I say two, I was talking from his point. Like I'm saying, if he's going to accept that the globe Earth has inconsistencies, then he has to also accept that the flat Earth has
Yeah,
inconsistencies
but
too.
you
All
have
right.
no flat Earth model in mind, Arma.
Doesn't matter. It's like you saying, oh, well, I'm a communist. And then someone goes, oh, well, I'm a capitalist. And then you say, oh, well, there's problems with capitalism, so I'll stick with communism. What?
Okay.
That doesn't make any sense.
Wait, say that again. What was your whole?
Well, okay, we
what's
got
your
the
argument?
point. Okay.
Well, hold on. I want to hear. I didn't hear it. I
Listen
didn't quite
with
hear.
your
What do you
ears,
say?
my
Hold on. What do you say? What do you say?
Paying
I want to hear.
attention then,
I
man.
think everyone in the room is bored with this point now. It's obviously objectively true.
Yeah, whatever. Anyway, so let's
Fine, it was
moving
a
on.
minor
All right,
point.
that was stupid. All right, so
Mute
here we
Now,
go.
yourself and
Arma,
breathe,
Arma,
man.
stop being so insistent. You're waiting for someone else to provide a flat Earth model to you that you can hold up against the globe Earth model that you are defending. Now, the problem is though, we're looking at reality, so you can't compare model with model. You have to compare model with reality. And can I ask you this one question? You said what inconsistencies in your model? Well, isn't one of the major inconsistencies that no one who has ever stepped forth on the surface of the Earth has ever experienced the Earth to move? Is that not one truism that we can all sort of experience and cling to by extrapolation that applies to
Okay,
all
but
of
it's
us?
not inconsistency though.
It is an inconsistency because you
No, it's
tell us
not.
that
You
it
have
is
to understand the
moving. That's an
context. It's not
inconsistency. It goes
inconsistent.
the mental thought, the modeling goes against the experience.
No, if you take into context, all right, that there's how physics works and whatnot. All right, if you understand
comes
how
later, bud.
momentum works and whatnot, rotation, the speed of the rotation
you
of the Earth is
devise all
spinning and
your
whatnot,
physics based on
then
the
you'd
initial
understand that
idea
it's
that
not
the Earth is
consistent. All right, if
moving.
you're gonna say if you're gonna say it's inconsistent, right, then you should at least apply all the rules, all right, within
Okay,
that model. All
you
right.
don't see your fault here. One
Can I
second, he
say
doesn't see his fault here, how he's lacking.
What is this
Because
armor hour? Can
if
we go back to fucking refraction? Come
Can
on.
you stop doing this, please? If the physics is built on the initial assumption that the Earth moves, which goes against our experience, well, what's the purpose of science? Surely that deals in empirical evidence gathered and collated and decoded or explained. So what's the problem here? What's your problem here, bud? Why are you so passionate?
I don't know why you're coming at me with this shit. What is this? This isn't armor hour. No one wants to hear this shit.
Yeah, he doesn't want to. He doesn't want to engage. Can I say something? He doesn't want to engage.
Go
Yeah,
ahead.
that's why this is not serious place anymore. And you tolerate him. Everyone, I go on mute now while you go back talking to this guy.
Thank you very much.
No, Eli's going to go ahead. Elijah.
Yeah, go ahead, Elijah.
So, here's the thing. Heliocentrists have what they call a concept of the cosmogony and the cosmology of this entire place, which includes heliocentrism and the Earth being a globe. Okay? That's the kind of model, if you can call it that, because it's really just a conceptual framework, I guess. And then when you talk about a flat Earth model, it's only talked about in practical instances. Flat Earth being you have a plane of reference, and this is how you are going to take in the data. So when NASA has over 500 mentions of flat Earth model and how valuable it is, that is a different thing. Something practically used versus a concept of how this place became and how everything works inside of our existence. Two different things. We don't have a claim to that. When we use a model, we use flat plane, which is the same model that you guys use as well. And that's literally the only claim we have. To say that some things don't work, yeah, well, you're thinking about a concept that none of us have said is actually a thing.
Okay.
He knows this well enough, though. He knows this fucking well enough. Every new day he comes in here, he knows it. Ask him what the sun is. What's the best answer you heard from a flat earther as to what the sun is?
Light
and
in the
explanation
sky.
as to why all of the skylights seem to rotate in unison pretty much over a daily, nightly basis. What's the best thing that you would go with in your own modeling of a flat earth, the way you can hold it up against your own spinning ball earth?
Huge tree.
If I was a flat earther, I would have.
Forget about that. From all the ideas you've heard, the one you went along with to test your own model against, what is it?
Oh, I don't know, some light in the sky that we can't explain. That would literally be it. I mean, because that's so easy to go with.
I'm telling you, this is not Earth Awakenings. This is Earth of fucking Sleepinings again.
I guess the name is Clicky, so maybe I just call him now.
Anyway, come on, back to refraction. Okay, so
you're defending a fucking impossible ball.
Yeah, I've never seen a flat Earth model that I agree with. I don't know what you're talking about. I mean, I don't think the Earth's a globe, but I've never seen a flat Earth model that I agree with, and I'm sure these people will say the same.
Yeah, that's because there's no flat Earth.
If she has the right dimensions, I could agree with her.
Wait, what was that?
Globe models everything just fine, so you sit and spin on that.
Yeah, maps are models. Yeah, maps are models, and all maps are flat Earth maps. So
All maps are projections too, and projections are by definition something three-dimensional projected onto a 2D surface. So again, you can say
yeah, thanks for playing Flat Earther guy.
My bad,
the other
Nidhogg.
guy that was saying that.
Hold on, man.
Yeah.
I cut off Nidhogg, so you could go no. So the flat Earth, if the globe models everything so perfectly, how come NASA's using flat Earth stationary models?
Yeah, they used those about 50 years ago because it was easier than putting it through a computer to calculate things.
Okay, so NASA can have flat Earth models, but we can't. Hold up. So NASA can have flat Earth models, but we can't. You literally just admitted. You literally just fucking admitted. Yeah.
So if
you guys just screech like monkeys when I get half a sentence out.
You heard him. It
So
was
are you-
easier to use flat Earth models than to use ball Earth models.
So what's the claim then?
Oh no,
So
he's
what's the
saying the
claim then?
same.
Hold on. So what's the claim? The claim is
No.
that these flat Earth maps are actually accurate from NASA. I mean, because you would have to assume so. Otherwise, what the fuck are they using this flat map for? Are you saying it's accurate?
Well,
Because
I
if so, then we can hold
already-
you guys to that model now, that map.
No one says there's
my answer already.
Arma, you're so
Like,
passionate. Calm the fuck
You
down.
just have to apply what the guy just said. So 50 years ago it was easier to apply these. Yeah. Practically for what we could do here on Earth, but to explain how things work on a macro level in this place that we've never experienced, yeah, they probably ante up. And you would probably, for things that we don't experience but say happens on a galactic scale, like, yeah, you probably need something else. But for everything that we can verify and know is true and methods that we can use to practically do things here on Earth, Those are the kinds of models that NASA uses, flat Earth models. Now, that's because the model is just an orientation of a stationary plane. The end. That's the model. The end. It's
hang
not a
on.
model of how this works. It's not a model to explain how that works.
Okay.
So it's not the same thing.
Elijah,
Yes.
remember that man went to the moon as well. So if they treated back in the day, 50 years ago or beyond, the Earth to be a stationary, flat Earth surface and everything, they had to go beyond that, but they didn't go beyond that because the technology doesn't allow. But yet they made it to the moon and back 7 times without much difficulty.
This is what happens when you only let me say half a sentence before you start squawking like you know what I'm talking
Yeah,
about.
go on, Nudhug.
Technology has gotten better, but back 50 years ago, you know, computing power required entire server rooms to cool down. So computations that did take into account curvature weren't necessary for a lot of the calculations that they did. Hence, assuming flat and stationary for some of their calculations. Doesn't mean the Earth is flat and stationary, but for the calculations they were doing, rather than wasting a lot of time and computing resources,
Now,
they
1
just
second.
assumed it was flat
Hold
and
on,
stationary. And if you actually read the documents, this would be very, very self-evident. But you guys don't. You just hear flat and stationary, and you go like wild
Hold on,
chickens.
Pete, please.
Okay, let me
Hold
respond
on,
briefly
Pete.
then.
Hold on, Pete, please. Wait,
When
wait,
they
wait.
went to the moon,
No,
Elijah.
wait. All I want to say is he said the same thing I said while telling us that I don't understand. That I
We
said the
don't use
same
a
exact
flat
thing
Earth
he said.
model. We
Now-
don't use a flat Earth model. That's what you
Okay,
said. We
let me-
don't do that. You're
Nudhug.
wrong, Elijah.
Okay, fair enough. There's a contentious point here, but fair enough. Now, when we went extraterrestrial, then we went to the moon, right? So now they will definitely have to take Earth's true nature because remember, you have lives, you have history at stake. Now, can we see the mathematical calculations, the trajectories of the moon rocket to the moon, incorporating this greater involved mathematics? Because surely the men's lives were worth it, right? So can we see it now? Can we see those calculations?
Yes. It's called rocket science.
Yeah, but funnily enough, all the trajectory information was lost, so we don't actually get to see the calculations. We don't get to see the minute by minute maneuvering according to all of the complicated mathematics.
You can go down to Cape Canaveral, not right now because there's a hurricane approaching, but you can go down to Cape Canaveral at any time and see rocket science in actuality working as they send rockets up into space.
So when planes are 50 years ago, when planes were traveling over the terrestrial plane or the globe, all they needed to do was just to take it in a local sense. They didn't need to think. They knew that the Earth was a spinning ball, but they only for local purposes. They just took it as a stationary plane, and then everything worked out okay. But here's the thing: monumental leap. We go to the moon. Now you can't just treat it like that, right? You have to know exactly the orbits, the speeds, the sizes. You have to take them all into account, absolutely intrinsically within the maths to be able to calculate the exact interjection points between all of the different. Yes, you know what I'm talking about. So where is the information, man? So funnily enough, they lost it. I'm telling you that. But you're telling me go to Cape Canaveral and look at them launching up a fucking rocket into the sky.
Yeah, that's because you're conflating different ideas. You're talking about what they quote unquote lost, which was just the tape backs of the launches from 50 years ago. They didn't lose how to do math. They didn't lose how to do calculations. They just
All
lost.
the trajectory information was lost. Telemetry, everything was lost. The
I'm
guidance.
glad you need to talk. I'm glad you need to talk over me in order to reiterate the point that I just said. Yeah, no, I understand that. But they didn't lose how to actually do these calculations. So I don't understand your point. Who cares? We also lost a lot of knowledge when the Library of Alexandria burned. That doesn't mean we still
well,
have.
listen, I know you're here for entertainment and you're mocking, but people care about these topics. If we're been fooled by people who are supposed to serve you and serve mankind, we need to know. Now, I'm just saying that I'll finish my point then, please. Nudhug. I'm just saying that when it was needed to take into account the true nature of the Earth, which was spinning ball Earth, let us see those calculations because they had to be intricate. Their new lives depended on it, and history itself depended on it. But are you not going to show me that? Can you not show me the intricate calculations that they followed according to the trajectory to the moon and back?
Yeah. Yes, you can. They have an entire science station set up at Cape Canaveral that you can go to as a visitor, and they'll show you exactly how they put rockets into space.
No one gives a fuck about your dumb rockets, dude. It's literally the dumbest thing ever. It's like, wow, look at this like phallic ritual. We're sending rockets into space. You guys, by your own admission, like this is the thing. You like just a second ago you said, yeah, we didn't lose the data on how to get to the moon or whatever.
Wow, you added so much. You know that?
And back in like what 70, 80 years at this point. So the story actually favors us. Like you guys are saying like, oh yeah, we have all the calculations and stuff, you know, to go to the moon. Okay, but you haven't been back in nearly 100 years.
But 54
That's
years.
pathetic. That's fucking pathetic. That's
100.
actually pathetic. And you're going to make every excuse in the book for these fucktards, dude.
What are you talking about? I'm pretty sure the Chinese sent a probe over to the moon like 4 years ago. You're just wrong.
Oh, the Chinese.
I understand. I understand
Chinese
that
space program.
I
Oh
understand
wow.
that your sentence being halfway through meant you needed to talk more. I understand you're butthurt because people can do things and you can't. But the evidence suggests that we can, and the evidence doesn't suggest that we can.
Yeah, no. Yeah, it actually doesn't. Again, that's to my point. The evidence actually suggests because you haven't been back in 80 fucking years. And who cares about what China does? Oh, wow. China sent a probe. Oh, and you think that the Chinese will actually give you fucking true information about what they're doing in space? You think that they're going to, you believe that? That's laughable, dude.
They don't
That's
have
hysterical.
to give us the information. We saw it happen with our own eyes and our own satellites. We don't need their permission.
Oh, you were
They
there?
didn't
So
need
you
to-
were there? You saw the lander on the moon with your own eyes? You were there? Or did you see it on TV?
What lander are you talking about, dude? You're just spouting nonsense. You have absolutely no clue what I'm talking about. You're just dribbling out things that you've heard in the past, thinking that they
Why are you
correlate with what
tolerated
I'm
here,
speaking.
shithead? Why are you tolerated here? You fucking waste of time. That's all you're doing here. This is desperate. 7 years later, Gio. 10 years fucking later for me, and he's coming back in with the same objections that we faced 10 years ago. What's going on?
Yeah, and you'll face them 20 years and 30 years and 40 years until you
Yeah, but
guys
where
wake
is your
up.
honesty? You won't say that you're here for truth and honesty and justice. You'll say you're here for entertainment, and you're telling all of us here, who's probably a lot of us, our lives have been turned upside down because of this. We found out everything that we've been told to be true is a lie, and you're just saying you're here for a laugh. Don't waste my fucking time, man.
Yes, I am here laughing at you, Pete, right now.
Yeah, that's no respect for your fellow man. But I forgot you're a heliocentrist, a prime member of the cult of
You don't have
Aristarchus
respect for
of
you,
Samos.
I don't
The
have
father of
respect for a man who
heliocentrism,
abandoned
the father
his
of
son
hell, the
because
father
he's
of the
mentally ill
lie.
and
Yes.
needed help. I have zero respect for you, Pete.
That's okay. That's okay. I never expected any respect from anybody, so that's okay.
I do agree
Almost
with
like you
Pete,
don't need to
though.
bring it
Like,
up.
how do we, like, this conversation should be like a school cafeteria. You know, there should be new people revolving into the conversation. Shouldn't be just us, shouldn't be just them. It should be revolving so much that we kind of don't have space because we're the old heads and we're irrelevant.
Well, then
Like,
someone should be bringing up a good argument.
but the reason that's not happening is because, like, has anybody focused on getting new people in here?
Too late for that, bud. It's too late for that, Elijah.
Yeah, it's too late because the flat Earth movement's dead.
Anyway, so that has in it, Geo, any
Yeah, get
moderators?
wrecked. No, I'm just kidding. I don't know.
Have you ever like, you know, did any campaigns to get newcomers to come in and have conversations over here?
No, people will find their own way over here, right? Their own intrigue and their own curiosity should bring them to a place like this. Like we all were brought here by our own sort of like curiosity and
No, we
things.
were
So it's like,
brought
yeah,
to flat Earth. We brought to flat Earth. I'm saying, is there a way for people to find this place? Like, is it being promoted? Like,
It's on fucking
let's
YouTube,
not
bud.
act like promotion isn't. But let's not act like promotion isn't important.
Yeah, you guys need
Like
advertisement.
what we know is we talk to each other every day. So it's obvious, it's evident that There aren't new people in here. I'm just saying.
Elijah,
Like,
you remember if Nathan Oakley?
I'm just talking about. Look. The reason I'm bringing this up is because I'm. Can we do something to get someone in here new today? Remember that idea about calling a family member? Like, is that a potentiality today? Like,
Okay. Let's do that a little bit later on. And I do encourage that as well, of course. The problem is, though, you remember Nathan Oakley's panel. If you speak out of turn, you're gone. In the 24/7 Discord, if you mention a few keywords, ether, you express skepticism in quantum mechanics or other things, Bible literalism you don't quite hold to, you're immediately shut down. So I wouldn't advise any new people to come. I really wouldn't. You are where you're at the minute, but you're just entering into the belly of a beast here. All conversation progress is almost shut down. It is facilitated, but it's still almost shut down. And I have to say, Elijah, you're on Nathan Oakley's today. If you're still on Nathan Oakley's, you have been doing something wrong. You have to be, because you're not talking about the real things. If you just want to encourage people to debate against ball earthers or nut hug till the cows come home, well, I'm not going to support you in that, because there's a greater truth to be had, and that's what we all as individuals should be working on and helping each other through. I'm done.
Are you done? All right.
Yes,
Yeah,
was
you
just
need to
done.
also
Thank
have
you.
new people on the other side. On the other side of it, not just people coming in saying, "Is the Earth flat?" We need the like a different type of like a better glober, if that makes any sense. Like an actual glober, actual. You know what I mean? An actual, not like a backyard lawnmower glober.
someone
Mark,
who
there needs to be
understands
some
the
declaration.
position. Someone
Yeah, go
who
on.
someone who understands the position, and then understands where we're pointing out a contradiction and goes, huh, okay. Not someone that morphs the conversation.
Yeah, and flat earthers that when we make an argument, they go, huh, because they understand it, but we don't get that a
Hey,
lot.
go send them to Gym Pandas, or go make a place for globe earthers to feel welcome. Since
Globe
I mean,
sorry. The
like,
globe doesn't have an argument, or else nobody would ever be here. There wouldn't be a FE society that's half fake. Also,
Right.
There wouldn't be a flat Earth before a globe. There wouldn't be a flat Earth after a globe. There wouldn't be a flat Earth movement of all different sorts of the fake kind and the real kind. There would be no flat Earth movement at all if we were on
Thank
a
you.
globe.
Thank you, Demark. And this is the whole point about getting to see this whole arena, a whole setting that we call life in a different sense. I've said it so many times that if you're a fucking flat earther and you don't realize that the nature of our reality, if it's not known completely by different powers in play, it's definitely known to a massive degree more than what we, even as we are now seasoned flat earthers, are appreciative of. If you come in consistently and argue with Myok or Arma here, I'm nearly finished, man. If you come in here consistently arguing with the same people over the same things, then their job is done, because they know better than you. And you're stuck arguing against them, the actors.
No, you guys are the actors, all right? What are you talking about?
Well, they claim
It
understanding
needs
and
to be a thing on our
coherent
computer
comprehension
that
of the
every time we
model.
introduce our debate forums, we drop a little blood to show we're genuine.
They claim understanding and comprehension, right, of a so-called model. But then when you say flat base, like a checkerboard, they're like, huh? And they're broke all of a sudden. Now they don't understand anything. Now they can't comprehend anything, and nothing works, but everything is on that flat base. There's nothing that's not a vertical thing on a flat base that we don't work with ever anywhere. But they keep saying that's impossible, which makes no sense. You can't show it's impossible. You can talk about it till you're blue in the face, but you can't show nothing. You can't show something being impossible over a flat plane, because you don't even understand it. You don't understand it. It doesn't end. It's not a pizza.
Imagine someone set you a challenge, Imagine someone set you a challenge to say that, like, you have to achieve this feat, and there's maybe a myriad different ways of doing it. So different models can be built to achieve it. Powerless flight, for instance, But yeah, what they're doing, they've built a model, and every other model has to be compared against their model as opposed to the task at hand. And this is their Achilles heel. And Arma here, you're dead right, Democ. They guffaw and fucking hum and haw around when they looking for a model to compare, and they have no flat Earth model. They have nothing in mind. They only bring their own sun into any flat Earth model, or all of their own models, sort of dictats into a flat Earth model that's presented. So that's why it's fucking hopeless. Fucking
Right.
hopeless.
They try to
Did you
conjoin
just
half the
say
stuff.
they got? Did you just say they got dick tats?
Dictats, they're dictations, right there. So the sun is a big ball. How does the ball work in flat Earth, Jeremy? You know what I mean? When they've already been told umpteen times that every single thing in a flat reality model is in opposition to every single thing in their model. And what supports us, Jeremy, we can at least demonstrate the principles of our thinking. They can't demonstrate shit.
What are you talking about?
Pete, you had me at dick tats.
I bet that rose up your cockles.
Anyway.
Hey, Jeremy, why do you think Jeff Bezos and his dick rocket? Why do you think SpaceX, you can't say SpaceX without saying SpaceX and a big dick rocket? Do you think it's all piss-taking us truthers, or do you think there's a greater sort of significance to it all? After all, our lives are about sex and death in a sense, aren't they?
It's kind of
Well, cars have changed
Arma, do you have?
100-fold. Rockets haven't changed at all.
Do you have a dick tat?
What?
No. Osiris is dick. You remember Osiris? So he was cut into 13 parts and his dick went missing. I think actually everything is inverted. So we have Father Earth and Mother Sky. Mother Sky, we are all developed in the womb and the waters break and then we are delivered. So I think everything is inverted, and I swear to you, my best way of looking at it is the two trees were on the surface of the stump of the tree this side. The tree is intact the other side as it's moving around. The root is sticking to, looking for purchase. It creates the barrier. It creates the skylights as it's turning around, and it creates the tides and conditions on Earth's surface, which we are made out of. Every living thing is made out of the detritus of the ashes of the giant tree of life. So yeah, just in a nutshell. But you know what I mean? To think in differing terms like that, going back to reality, well, how can you not go there? We know the spinning ball Earth is not so, heliocentrism is not so, Big Bangism is not so as literally delivered, but can it be decoded? I think so, because the lie is built on the truth. So take everything they gave us and flip it on its arse.
How come you can go the first try with a bottle rocket, but a bottle rocket never changes, and there's nothing hard about it? It's just an outside cone. You put a tip on it, and then you fill it with gas, and you light it. Like what became so complex about that exact framework or those steps that they can't ever do it again? It's kind of odd.
That's not how the rockets work. They are not just putting gas in something. A bottle rocket is a solid fuel rocket. In this iteration, actually, Artemis is using a partial solid fuel rocket system as well as a liquid fueled rocket system. So, I mean, what do you mean that they haven't changed this at all, or
my bottle
what?
rockets still work. What went wrong with yours? I like bottle
Okay,
rockets.
bottle
I sent them in
rocket.
a full thing for 3 years. 3 years, right? Dry, dusty bottle rockets. I'll keep relighting them and light them. They always work. How come your rocket worked the first time but never works again?
Hey, Mohawk, show me a bottle rocket in a
Works
bucket
all
in the
the time.
lab.
We're doing
Shut
it
the
all
fuck
every
up.
day. This is a different application.
Doing what? You guys always use the word it as if it means something. What does the word it mean? You're doing what every day? Failing?
We're sending rockets to space virtually every day.
When you say cancel the mission, you're taking them to
What the
space.
fuck
You
is
just
happening in
cancel
this
it.
chat?
Imagine
You
Moya
take
coming
That's
into
one
work every
that's
day,
one mission.
sitting
That's
down in
one
his
type
desk
of
in his
mission.
boat.
Can you show me any mission that you and I can put our cameras on and we get our own footage of it without somebody sending us 2 minutes of footage? Can we see it
No,
live?
I don't think that you're going to be allowed. They're not going to let some moron on the internet go and duct tape a camera to
to a
really
big
dumb.
bottle rocket dick that just goes up.
That would be a really dumb.
That's top secret, right?
That
Dick
would
in
be
the
a
air
really
is top secret.
that would be a really dumb idea. So they're not going to let you do that. However,
Why not?
my guess is
He's
that
not gonna let you down.
because it would be
That's your
dangerous.
warning.
Because it would be dangerous. One, you got to let somebody answer.
Says
When you
who?
ask a question, it's customary that you actually allow the person to answer. That way, that you can actually hear what they have to say, unless you really didn't want the question answered. You just want to hear yourself.
Gave your answer.
Well, the answer you said why not, and I had given you the answer. So apparently, you needed clarification because you have some kind of a difficulty
Did you see the
understanding.
towers coming down on the horizon on
I don't know
9/11?
what it means. You said it. We do it all the time. I don't even know what that is.
No,
So
I said we take rockets.
clarification.
Well, actually, that was answered. It said taking rockets to space.
Where have you done that at? Where have you seen that happen, start to finish at? Where have you done that? Where have you stood right next to it and watched to do that?
You know what? I have not seen. I've seen one from Wallops Island, but it wasn't real close. I saw that maybe 50 miles away. And it went off to the east, so it didn't fly over my head.
Don't you think with every little third grader and fifth grader having a camera, it would be smarter to put cameras on hot air balloons, high altitude balloons, and have them up there waiting, and then watch it go to space live? Plus, have cameras on it, watch itself go past the balloons you have. And
I don't know if it makes
everybody can do it publicly. I'm done.
I don't know if it makes your requirements for live. Pete, could you please just stop laughing? I mean, just mute yourself.
Okay, I'll turn
whatever.
on my volume.
Just
But
take your mic
just
down.
briefly, that was very okay. Happy go.
There is an image from the ISS of a rocket taking off from the ground to space. That's not an image; it's a video.
Jesus, here we go again.
And Pete, again, you're laughing.
From the ISS. You don't understand that he said, "Can we have kids?" Because he keeps trying to bring it back to something that we can be involved in, not something that, in a cult-like manner, we can praise those who can. That's been involved.
No.
Because we can't. I'm almost done.
Okay,
I'm almost done.
Sorry, go ahead.
As soon as Denmark said that, I thought, I wonder, it would be cool. We've seen the high altitude shots before. A lot of them got scrubbed off the internet. And I still have some. But the point is, it would have been cool.
So have you done
As
it?
a flat earther, I'm saying it would have been cool to have a rocket go up as a high altitude balloon that's up there has cameras that capture it. That would be cool.
That is cool, and that's something that you can set up if you desire, and that's a really wonderful experiment for you to do. But the fact is that we have images that come from alternative sources, including NASA, but not exclusively. There's
I don't
a
believe
image
them,
of a
though,
rocket taking
Maya.
off from an airplane, which is like 30,000 feet. So I mean, that's pretty good, isn't it? A third of the way up as high
I
as a
don't
balloon.
believe the images, though, Maya. The images are capable of being faked. And of course, there's plenty of reason to think that they might be faked with all the different cuts. So you have to, according to your scientific principles, express extreme doubt and skepticism to get on here. You can't just defend something that's impossible, and we've already ruled that as impossible long ago for the rest of us.
No,
So
we
when
don't.
you
We don't
say-
need
when
extreme
you say
skepticism.
rocket-
Like, you think that these private photo taken from the guy on the airplane was fake? I mean, I guess it could be, but sort of
Well, I
pointless.
guess video could be real too.
It wasn't
Yes, it
complete,
can.
though.
You keep hold on a second, Moyak. You keep saying photos, One Direction photos, God of photos. Believe NASA's photo. They're one shot, one still frame photo. Now we have cameras. Every little kid. I'm not done. Every little kid. Third grader, fifth grader. My 2-year-old grandson has a fucking tablet on his own. He watches every day. And you're telling us that NASA can't afford their own videos and tablets and YouTube live setups for all this stuff from the ground up live. That's what you're trying to tell me. You're also saying that a rocket was shot from an airplane horizontally. Where did it go? At what point horizontally can that rocket not see dirt and water underneath it? How many feet or how many seconds does it take for no dirt or water to be horizontally down below the rocket?
I'm not going to just listen to you babble for a while.
Oh,
Well,
you
no,
done?
hang on.
Okay,
Let's
good.
get places
Okay,
here.
so
He
if
asked you a
you're done
question.
babbling, there is tons and tons of footage of rockets going into space, low Earth orbit. I don't know why you're incapable of
True.
seeing these because they've been presented to you, but you deny them because you say they came from NASA. So obviously, I'm trying to find things that are
But
not
you
NASA.
believe them
So
because
I
you say
use
that
the
it came from
airplane
NASA.
video of a rocket taking off and going up, and you say that that's fake because it came from a private citizen on an airplane. I don't know how you're supposed to
said that was
overcome
fake.
your insane burden of proof when you're just changing the goalpost every time you speak.
No, I'm not changing anything. I'm asking you evidence. Keeps changing the goalpost for ass. I ask
All right,
any
take it easy,
object live that gets shot horizontally, at what point in a horizontal manner going straight forward, not a curve, straight, do you not see dirt and water is what I asked you. I didn't say space. I didn't say orbit. I didn't say any garbage. What you just came up with. I said what object, not a stick, not a selfie pole, not a rocket, not a hot air balloon, not a bullet, not a missile, nothing you have, no object can ever leave your supposed curved distant area horizontally and not see dirt. Pete, will you slow down? You just keep talking over everybody. Stop. So see horizontally, dirt and water looking down. Or as you go up every foot, you have a camera vertically at 33 degrees diagonally. Right? You have you're a vertical thing. You have a straight horizontal plane, and then off your plane out the bottom, you have a pole sticking 33 degrees at a diagonal tilt towards the horizon. And as you go up, you should see 1 degree, 2 degree, 3 degree, 4 degree, 5 degree more as you get closer and closer and closer to that. As you go up also. So you should see exponentially more degrees as you go forward and exponentially more as you go up on a ball. Now I don't know who told you how a ball worked, but for some reason you don't understand. Nobody comprehends all of a
All right,
sudden.
Demark, are you
That a
done
ball,
shouting with
I'm not
everyone? All I
done. A
said was
ball
right.
has an edge. Somewhere
Finish
on
up
a
your
ball,
point, bud.
when I
Stop
have a
shouting at
ball,
everyone.
I got a ball. Stop talking over me, dork. So I got a ball, right?
Call me dork,
You
dickhead.
show me any object that
dork.
you can't stick a selfie stick off of and show it not showing that object.
Yeah.
Show me any ball
You're just
that you cannot
monologuing
do
now.
this on.
You're just monologuing now.
Well,
I
I
gotta
got Pete
stop you.
talking over me the whole time. Now I got Jeremy talking over me. Thanks, guys.
Yeah, because you're monologuing. Well, I'm not talking over you. I'm modding you.
Thank you for not muting Pete the whole time, buddy.
I wasn't
I'm
talking over
modding you
you
because you're just
dickhead.
monologuing.
You should have been modding Pete over talking over me so I could get
I
done.
wasn't
Not
talking
monologue.
over you. You're
Don't
just
you
shouting
think?
at everyone, man. Stop doing it, Demark.
What are you even
Now, let the
talking
guy
about, Pete?
answer.
What are you bringing
Let the
right
guy
now?
answer and
Do
see
you
how
have evidence?
sufficient his answer is. How
I'm
it
asking for
satisfies you.
evidence.
Off
You
you
got
go.
some, Pete.
Stop
No?
talking.
You
Let
don't
the
got
guy
evidence?
answer
Well,
your consideration that you delivered in an angry
well,
tone.
you don't consider anybody. You talk over everybody for 5 hours
I didn't
straight.
talk, and all I said was
you
right,
get
and you
let to
started
do it,
shouting
and
at
it's
me.
okay for
Now
you,
shut
right?
the
That's
fuck
okay
up
because
and have
Pete
respect for your
gets to keep
grandchild.
talking
I
and
knew there was
talking and
children around
talking.
when you were
You
shouting
can't
like
even
that.
shut
I'm
up for
gonna
a whole
have to
second.
mute both you guys. I'm gonna have to mute both you guys if you don't stop.
You mute yourself. Just mute Pete and you'll be fine. The show will go great. Watch and see.
Right, well, I'll go up to Gem Pandas for a while. Fuck you, Demark. You dickhead.
Shut up. You don't even bring nothing.
Pete,
You're talking
there's
over
no
everybody.
name calling.
Yeah, be
no
nice.
I'm
name
talking over everybody all
calling,
time,
Pete.
Pete. Horizontal is what I asked Moyak. I block for the Globers, right? Stop doing it. So, Moyak, horizontally, which object can we see anything go 3 to 10 to 20 miles and not have dirt or water underneath it for 10 foot of a distance? I'm not talking space. I'm not talking crazy stuff you made up. 10, 20, 30, 40, 50 feet of no water or dirt horizontally. And I'll be a Glober with you tomorrow.
Your mom.
See how that works, guys? So the Globers can't leave the
Yeah,
planet
you got him.
horizontally. Well, do you have any footage, Jeremy?
Demark, you're not making any sense.
Leaving the
You
ball
got
doesn't
him,
make sense. I
Demlock.
know.
No, you don't understand how spheres work, all right? You just
Show me how a sphere stops. Show me where the sphere stops. Where's the dirt water sphere stop at? Where's space start horizontally on a ball?
What are you talking about? It starts horizontally as soon as it starts vertically. I mean, that's just because you have to.
You live on a ball? Demonstrate it. What do you mean? What am I talking about? I live on a flat plane where it never ends horizontally. You can't go to space horizontally.
Yeah,
It
you
would be
can.
impossible.
It's just it'd be the same thing as
I
just
would
going
never hit flat Earth.
diagonally.
Listen to me, Arma. Stop. Stop being goofy and saying, what am I talking about? That's your only sentence. You've said that for 8 years now.
8 years? What the
On
fuck?
a globe, the globe has a radius.
been
It
that
stops. The globe stops here, right? Where your curve is. Stuff goes down. That's where your globe stops. And space starts at that circumference of 24,939.59, right? From the center out.
Okay.
Right?
Yeah.
A flat earth doesn't. Now, you have to show me, right? Prove to you a flat earth is you can never leave horizontally and ever get off of it horizontally. Not 1 foot.
Yeah, you can, man. What are you
Not
talking
1
about?
foot. Show me. Show me the footage.
I don't even know if there's footage like that out there. I don't know.
So you're telling me there's no footage of you ever leaving the dirt 1 foot horizontally on a globe?
Bro, I don't even know what you're asking for. All right, you're just talking nonsense. All right.
So why are you talking if you don't know what I'm talking about? Why would you not just shut up and let
I
somebody
literally
do it?
said, "What are you talking about?" And you said, "What do you mean? What are you talking about?"
Dude, I've been saying the same thing for 8 years. If you don't know now, stop
8
asking stupid questions to me.
8
Go
years is
learn
a long
something.
time to be
Google what
doing
it
this.
means. Google horizontal, Google globe, Google horizontal line past 10 miles, globe gone. Do you understand? Google it. You Google it. You figure it out. You comprehend the globe? Show me how you comprehend the
I
globe.
understand
Show
how
me
the
how you comprehend you can disappear from the globe's dirt and water and leave it horizontally. Show me you comprehend that.
Get him, D-Mock.
Come on.
Show us your comprehension. Draw it for us. Draw how your plane can never leave this dirt horizontally, not 1 foot. Not a bullet, not a rocket, nothing, not a missile, nothing. Not a railgun, not 1 foot horizontally. No object ever. This is the nitty gritty. Forget horizon, forget all this garbage ass making up phenomena shit. Talking about somebody monologuing. Fuck that. We need to stay on target. Horizontal. 1, 10, 5 foot of anything leaving this planet horizontally will prove a ball.
That doesn't even make any sense. What are you talking about?
Yeah, it makes all the sense. You
No,
don't
it
make any
doesn't.
sense.
No, you don't make any
Your
sense.
IQ cannot be increased
Your,
by me.
your IQ is
You
negative,
understand?
man.
You have to increase your own
Wait, no, that's an
IQ,
insult.
Arma.
My bad. I have to take
That
that back.
means stop saying, what are you talking about? And go read. Go read
He
what a horizontal line
basically,
is that continues forever versus a globe that stops at 3 miles and 6 miles and 10 miles and bends away from you. I can't put
he's
comprehension
basically
in your head,
saying
buddy.
he's basically saying that yeah, if you go horizontally because the surface isn't a horizontal surface, it's a ball, then if you go horizontally, then the distance between you and the ground would increase. You would
Okay.
leave the earth that way. We have this idea that we can experience that actually being level is being level around the ball. The only way to leave the ball is to actually go up and then make an arc. A few times, by the way, to reach escape velocity, and then you can leave the earth.
Which it doesn't make any sense either, Elijah. I've asked all of them to do this too. Take a ball, put a little floating ball or a little ball with a little cord line. Put a little ball in the exact center of that, mount it in there. You know what I mean? Like in the center. Draw lines out from that ball, the center of your ball, outward. The 39.59 one, all going outward. As soon as all of them go 1 foot past the thing, one of those lines is horizontal because there's a trillion of them coming from the center, going everywhere, from all the way out the ball like pinhead, from the center of the imaginary center of a ball. Like if you have a basketball and you take all these needles and they're coming all the way out the ball from the center. These lines are horizontal and vertical to everyone. They're all, it's just like up and down to you and me. It's all relative. So their horizontal is vertical to the next guy on this portion of the globe in his orientation.
Yeah.
So,
Okay.
yeah.
I guess. I don't know.
No, there's no guessing. This is physics, buddy. There's no guessing.
You're not making any. Are you saying you want proof of this movie leaving the
I'm
ground?
saying, show me what a horizontal, show me the difference between a horizontal and a vertical line on a globe coming from the center of the globe out. Color
Why?
code.
Why do I need to do
Because you
that
don't know
for?
what that is. What do you mean? Because you supposedly understand what
No, I want to know
are.
what the argument is. What is the goal of his argument?
You
Otherwise,
don't know. Your globe
what?
doesn't know horizontal and vertical. They're
That's
both the same thing. You have to demonstrate you can do that.
so.
Just
What's
a
the goal of his?
sidebar: rockets do not fly horizontally. They cannot fly horizontally.
Welcome to Flat Earth. Welcome to no space. Welcome to no rockets going.
No, they
Thank
can't
you.
fly horizontally on a flat Earth either, retard.
I just asked you to color code. Color
Can
code.
fly.
This is simple, dude. Color code vertical versus horizontal and put all the lines on your ball from the center out. I'll wait, Moyak, smart guy. Blue for vertical, red for horizontal. I'll wait. From the center going out past the ball, like pinhead.
Well,
I'll wait.
I just heard Moyak say that rockets can't fly horizontal. That's true, but you know what can? Planes. Okay, so this should be a perfect example. A plane should be able to fly level horizontal with a plane and be able to end up in space. This is what DMOC is essentially saying. How come that's not
The plane
possible?
can't even see in space, bro. You can't
Planes
even put a
fly
camera
under
mounted diagonally forward on the tip of the plane, mounted 33 degrees in a diagonal line forward, right? Where it would see ahead of the plane at the ground all times. So it would be focused on the horizon downward, and you would be able to see on this camera on an airplane. Even if your airplane can't go that way forward, your camera can. See how this works? We don't have this view of anything 3 degrees below the horizon. As you go up on a ball, your eye level should drop below the horizon every foot. Every foot, every foot, every foot. More. Demonstrate your claims. Demonstrate I'm not right. Demonstrate how I'm wrong. When I get to stand on a ball and I go up and I should be able to see more 1 foot, 2 foot, 3 foot, 4, 5 foot, 6 foot, 7 foot more. Every time I go up on a ball, more of a degree
Galore.
forward. Yeah. Show me I'm wrong.
What are you talking about?
Demonstrate how I'm wrong.
How?
If you
What do you?
can't comprehend anything, will you please
How are you
stop
right? I
talking?
don't even know what you're talking
Please
about.
mute him. All he keeps saying is he doesn't know anything. He's like a broke parrot. Do you want a cracker?
No, I want to know what your argument goal is. I mean, you probably said it, but I mean, I really didn't understand it. Like, I'm really confused.
Here's all you do is repeat. You don't know anything, dude. What are we talking?
I don't
What are you
repeat.
talking
Get out of here. I've made
What
my
are you
own
talking
things.
about?
Can I
What are you
give him a
talking
What are you
shot?
talking about?
What are you talking about?
Yeah, can I give it a shot? They might.
Oh yeah.
They like to use the basketball example. So Arma, put yourself on top of the basketball.
Okay.
Look straight out. What do you
Okay.
see?
Okay, I see a horizon on the basketball.
No, you don't.
Yeah, I do.
Put yourself on the basketball.
Oh, like my human, okay, like the scale is.
Stand on top of the basketball. Yep. We're just gonna prove a point here.
Okay, if
What
I'm
do you see?
if I'm like 5'10" or whatever on a basketball, then I don't see anything. I just see whatever's in front of me.
Okay. Now put yourself on the earth the size you say it is. Put yourself on the ground level. What do you see? You see Earth?
I see a horizon that dips 0.04 degrees.
No, you don't. You're just
Yeah, I
making that
do. That's the
shit up.
math. That's the math. You shut
Yeah,
up.
but you don't see that. See, you're trolling. Why are you trolling?
Yeah, I do see that. What do you mean? I'm not trolling. I see that. This is the horizon that dips 0.04
You do
degrees.
not see that. You've
Yeah, what do
read
I see
that.
then? Tell me what I see, all right? I want to see what you think I see, because apparently you think you can see what I see, all right? Which you don't, because
Yep.
it's my eyes,
All
not
right.
yours.
There it is,
Get out of here.
guys. Yeah, get out of here, right?
No, you get out of here. What are you talking
You
about?
turned into a troll. You don't see 0.4. You see Earth. You see land. You see water. Now rise up to 30, 40, 50,000 feet. You shouldn't
Yeah,
see that land or Earth.
Yeah, you should. It dips. It just dips more. That's it.
And how far do you go where you don't see that?
I haven't done the math. I'm right now busy with something, but it doesn't dip much.
Wow, dude.
How far do you have
This
to
should be
go forward
embarrassed.
before? How many feet forward do you have to go? Just feet. Do you have to shoot your rocket before its camera can see with a diagonal tilted 33-degree forward? Put a camera on the rocket tilted forward, and when you shoot your rocket, when can this camera see no dirt and water ahead of it? That's all.
Oh, I think I'm starting to get that now. Okay, so it's gonna take a while, man. It depends on the angle and whatnot.
Take a while.
Yeah.
When your globe disappears at 6 miles, 3 miles, 10 miles.
Because you don't understand how spheres work, man. You're clearly showing me that.
Show us with a bottle rocket or a little plane on a ball with a camera on it, and we'll all understand. Get your little model.
No.
That's what I want you to do.
Oh, you mean like
All
with Blender?
Globers are allergic. Stop talking over me. You're allergic to a demonstration. That's what I'm waiting for. A little toy plane, which we have, little balls, which you can produce. You only need the top portion.
You could produce
And a
small,
little fucking
tiny
camera
balls or whatever
on
you just said.
And a little. Stop talking over me, can you please? You say nothing anyway. A toy airplane model that has a camera on it. We have these everywhere called drones. And a little
I have
ball.
a drone, yeah.
Yeah. So get a ball and put it on there and fly it around off of it, up higher and higher. And now take your measurements from a side view as a human in reality, from that and how many degrees you see and what you see live on your camera. Put a 360-degree camera on there so we can all work it for ourselves and see how the ball works. Every foot you exponentially go up, or every inch in this case.
It drops
Or
appropriately.
millimeter.
It drops appropriately. The
What?
math. Yeah, it drops appropriately.
Appropriately to what? What does that mean?
What?
Appropriately, what number is that?
According to the math.
What number is appropriately? What? How many feet?
I don't know. It depends on the height. I mean, give me a height, and then I would give. Maybe I'll give you a number or some shit. I don't fucking.
So why don't you go do this? Why don't you get your drone you say you have, and why don't you get a sphere that you claim exists, that you claim you're on, right? Get a little one and show us how it works and shut me up. Show me how I'm wrong on every point.
It won't shut you up, and you won't believe it. So why do we bother?
I'm waiting for you to do it. Quit talking ifs and buts, candies and nuts. We're all gonna
Well,
have
what
a
don't you
Merry
do,
Christmas if you just believe his words, guys.
Why don't
Don't
you
ever
do it
demonstrate any
yourself, Dennis?
science.
It's not like
Don't
it's
ever do
super
any
easy.
physics for yourself. Just talk over me the whole time. When I'm trying to demonstrate, you guys are
We're
allergic to
not
physical
demonstrating
touching
anything,
stuff.
We
and
ain't
we're just
allergic
running
to
through it.
Demonstrations or physical videos.
Get
I'm
out of
done.
here.
And you just talk a lot,
And
Demick.
Nate,
You don't demonstrate.
yeah,
You
and
don't
you
do
both
anything.
talked over me the whole time, and you
No,
have free
come
run.
on.
Thank you,
No one
Globe.
cares, Demick. No
Thank
one
you,
cares.
Glover Zone.
I could
Nobody
let
cares
out a
about the Globe
10-second
Zone.
fart, and it would be more intelligible than what you said, Demick.
Yeah,
Is that
your
what you're
demonstration
adding?
would be more
Why you little
intelligible
kid?
than any globe has ever said ever for the last 3,000 years. Your demonstration would say more shit words ever have.
Why don't you add something to the conversation besides that childish fart noise that
That was
Arma's
me. No,
laughing at?
I hold on. I added the childish fart noise. All right.
Yeah, I know, but he said that. He was talking about that. It's just childish.
No, but he said it, but I made the fart sound.
I
so
understand. That's what I just said.
Okay, I'm just double checking. All right. I want to take
Yeah,
credit
I
for
know
that
you're
part. That was
trolling.
mine.
I
all
know
right?
you've been. I know you've
Yeah,
been
that's
giving
fine.
him a bigger reign to come in here and troll more because
I'm not
you've
trolling.
seen. Yes, you are. You just
Democ,
acting
of
silly.
all people, Democ, how do you pronounce his name? I'm having a stroke just like thinking about the shit he said. All right, he's the one trolling here. He's always spewing shit. All right,
because it's
He's
called original
not
thinking.
trolling.
Yeah, he is.
Yeah, he's
No,
telling
you just
you
don't
you
understand.
fly
You
a
don't have
rocket
any
horizontally.
Say that with a
Unless
straight
it's
face,
you.
Rocky. All
Some
right.
shit, they get to burp online. They
Now,
get to burp
just
loud
said
over
it.
the mic. They get to chew,
Okay, but with a
eat,
straight face
talk,
though.
cuss people out, make fart noises, talk over me the whole
Yeah.
time.
Is
And
there a
Jeremy
mod
sits
here,
there and
by the
laughs
way?
about it and thinks
Yeah,
it's
that
funny
was
while
me.
his
I
cousin
burped.
Arma.
That
Jeremy,
was
don't
me.
be
My
like
bad.
cousin Arma, please.
Yeah, that was me. I
I know
burped. My
Jeremy
bad.
does.
I forgot my mic was open.
Oh,
Okay.
well, your cousin Arma's been burping with you, buddy. Get your cousin and rein him back, all right?
He's not my cousin. He's my niece.
You sound like
Hey, come
you
on!
guys sound like twin brothers. I can't tell you
Jeremy,
apart.
Leave her alone.
what are we talking about? The fucking.
Jeremy,
You
shut
gotta
up.
be fucking kidding me with this shit.
Jeremy, be quiet.
Jeremy,
Yeah,
Hey,
Jeremy,
Jeremy.
be quiet.
with my
No,
Jeremy Jr. now. What the fuck's going on here?
Yeah, you and
That's
Jeremy are
considered
the same.
doxing.
I can't tell you
That's
apart.
considered doxing. You can't do that, D-Mock. That's considered doxing.
I'm sorry, Jeremy Arma. I'm sorry. I won't do it no more,
Yeah,
Arma.
if you call Arma Jeremy as a joke, that's doxing. But when you say somebody's real name, that's iffy. That might not be doxing. Especially if you
Yeah,
said your own name before.
no one can say my name anymore. My name's Jeremy.
Army.
Definitely don't
You
call
need to call
Jeremy
him
Jeff.
Army.
That's
Army.
Democ.
So,
Let's see, what can I
Jeremy,
name you? Democ. Dumbass. There we go. No, I'm just kidding.
No, just name me demonstration you don't have.
I'm just kidding. Okay. What are you talking about? You don't understand
To go
spheres.
out horizontal Oh my God, this is what Denmark's trying to say. If you go out horizontal from the ball, there should be a point where vertically underneath you, there's no land. Right, Denmark? Is that what you were trying to say with a million words?
Yes, sir. Well,
I'll have
I've
to
said
show
it
it
for
to
the
you,
last 8 years in two, but Arma keeps saying, "What do I don't?" He don't get it. So how else
So
can I
yeah,
explain it to him?
there's nothing crazy about that. I mean, if you think about a rocket going up straight, like straight up, then on to the side of that rocket, yeah, there's no land under it. All right. I mean, it's the same thing with the diagonal fucking rocket. I mean, at some point, yeah, it's going to get to that point. But I mean, the person on that rocket is just going to, it's going to be like, if they're going straight
We
in a
only
way.
need that point. You're stuttering. You keep saying all your shit about up. We don't say up. Horizontal. Fuck up, man.
You're not making sense, man. All right.
No, you're not making sense.
You're not
I
making
said
sense.
horizontal, and you keep saying
No.
up. What is up on the ball? Go up to Australia. Is that going to work for you? Get in your rocket and go up to Australia.
You go up to Australia, man.
Wow. Arma, do
Where
you
is
really
up
not
on the ball?
understand this? Like, dude, this is really simple.
This
This
is
is like
really
literally like
simple.
second, third grade level, like ball, like spherical, like
He's
we're just talking
trolling.
about.
I'm
Yeah,
not
it's
trolling.
so
He's
simple, dude.
Dalmock just
No,
sounded.
dude, it's fucking simple. It's
Wait, hold
so
on.
simple.
No, it's not simple. All right. He thinks. Okay. He thinks that.
That's it.
I don't even know what he thinks. Honestly, I'm gonna be honest with you. He's something else.
I know there's no ball. There's no globe. And
Yeah,
horizontally,
Dalmock,
you can prove it by saying,
no, you
guess
can't.
what? Democ's challenge. You'll never do it.
That's not. You can't.
Challenge is prove a ball to Democ horizontally, and I'll be a glober. Real
How does
simple
that prove
stuff.
a ball?
What is
The ball.
talking doing for you? You should go shoot the fucking horizontal rocket out and shut me up.
I don't have a fucking rocket to shoot out.
You don't have a drone?
I
You
do,
just said
but
you had a drone.
so yeah.
Show
How
us
far?
where the dirt stops.
It doesn't stop because it.
Horizontally.
Oh, okay.
It
So
never
if,
stops.
okay, hold on. So horizontally, if I'm shooting it off horizontally, which is really stupid. I mean, on one side, yeah, obviously there is no land because it's facing the sky.
Arma, rookie mistake. You don't engage with Demo. He will never
No, you don't understand it.
Ever get protection out of him. He will not get it. He's trolling you. He does this.
No, I know. I get that. I get that. You know, I want
people
this.
with no comprehension and no video proving me.
I'm a masochist. All right, I want this. Trust me. All right,
Unless you have a video,
this is
you
intentional.
and the other guy with nothing and no IQ, you guys are talking about nothing. Show us what you're talking about. Show me how I'm wrong. I'll wait. Just quit talking about how I'm wrong and show me, demonstrate that there's no dirt and water horizontally somewhere.
Yeah, trust me, you're wrong, man.
Hey, in other news, Jeremy, did you ever figure out the Earth rotating?
I think he did.
I could possibly have been wrong, and the sun would freeze in the sky instantly. I'm not 100% on it. I'm not 100% on it, but most likely that might seem to be the case.
Whoever is 100% about anything, right, Jeremy?
Well, I'm 100% about a lot of stuff.
I'm 100% about my claim.
Well, that's your flaw. That's your flaw, D-Mock. All right.
Your flaw is you don't have any. You don't have a globe.
You're too cocky.
You can never get to the edge of your globe. You can never
Too
find
ballsy.
it. Your waterfall never ends horizontally. Your cliff.
Yeah, don't go chasing waterfalls, Armbar. Don't go chasing waterfalls.
Don't go chasing water cliffs, water globes. Stick to the flat rivers and lakes and oceans you're used to.
Yeah, I'm getting hungry. You guys talk so much shit. It's like I forgot to eat. You know, I've been on here just listening to shit.
I don't understand how it's so hard to stick a selfie stick off of a boat 20, 30, 40 feet once the boat's going down, and tilting and cocking itself, diagonally down to Australia to go around, down and up to Australia. Why doesn't it have the selfie
question
stick?
about the rocket. The rocket would be approximately 2,000 miles up. If you flew horizontally to get Democ's requirement, you'd have to go about 2,000 miles along that horizontal.
Oh, look at that, D-Mock.
The first 500 miles would be through the thickest part of the atmosphere, which would be really abusive to the rocket equation.
Wow.
So can you see the clouds?
You wouldn't be able to see anything at that point horizontally.
So there's no clouds horizontally.
There would be no clouds horizontally in that situation where the rocket flew straight along this magical straight line off into space horizontally, starting at the ground, and getting to about 2,000 miles. At about 2,000 miles, you no longer see anything below the 90-degree 0 point horizontal.
2,000 miles. How is that when your Earth is away from the dude standing there at 3 and 10?
He just did the math, man. How are you going to question it? You haven't even done it yourself.
You're telling me we have a 2,000 mile flat plane that you have to fly over before you can see no dirt.
The whole time, look at the picture. Look at the picture I posted. Actually, each one of those little lines, colors, is 100 miles.
So you're telling me that a rocket going horizontal easier, right? Can't leave the dirt at the same time or hit the clouds at the same rate as another rocket going away from the ball and the boat just leaving the. Show me the math on this real quick.
That's a little bit different of a question. You just changed that to being clouds now.
No, we got vertical and horizontal.
Yeah, moving the goal.
We have
How long
two rockets.
originally you said that you
It's
wanted to
real
know
simple.
how
It's
far,
called an L, bro.
how far would it have to go before you could no longer see clouds, dirt, or anything under the rocket? That's 2,000 miles. If you want to know, since that image that I posted for you is
okay, you got the number. You got your magical Narnia number that doesn't
image that I
exist.
posted for you, and that image that I posted for you is to scale. So if you count the little red lines and black lines, which I alternate, those are each 100 miles. You probably have to go about 500 miles until you're out of the atmosphere.
And how far does a vertical rocket have to go before it sees clouds? Just like
About 100 miles.
Oh, 100 miles before the clouds?
Well, no, before it's out of the atmosphere.
Clouds, man. The clouds. Stick with me here, Moya.
Clouds.
I'm trying to go slow, bro. Low and slow.
Shithead, shut up.
Clouds.
Let's go 30,000.
Possible.
Shut up,
We're talking
shithead.
possible.
All right, Jeremy, I'm not going to talk in this room. Have a good one.
Well, you keep saying weird shit and keep talking about up when I've said stop saying the word up and that's all you guys keep mentioning. Then you said horizontal and then you said 2,000 miles. That's all I needed to hear. Now, 2,000 miles is what you need to go forward off a ball that has less resistance forward than going vertical up, which is only the clouds at 5 miles. I don't reach the clouds, right? So now if I have two rockets and we're doing this equation, right? And we have two rockets, one's going, and they're both at the same spot. They're both right next to me. One goes vertical, one goes forward. Why in the fuck would the math be different and one be going and only take so long to get 5 miles and the other one had to go 2,000 miles? Show me this on a ball. Do the drawing.
Look at the image.
At the same time.
The image has all the answers to your questions. You have to do a little bit of like
rockets on there. So you got a fight resistance going up, and you get to 5 miles going up. Then you get to what? So it takes the other rocket gets to 2,000 miles at the same time. Gets to 5.
Did I say gets to the same place at the same time? No. Get 2,000 miles.
Clouds is where we want to be, and the vertical clouds. We want to meet them at the same time. How long does that take for both rockets?
Oh, that's an interesting question. Let's see. That was in the first 500 miles before you're out of the atmosphere. That'd probably be about, I think, probably about 200 to 300 miles. So you got to like say clouds at like 30,000 feet.
Right. So 200 to 300 miles is all your rocket should have to go horizontally and up.
So you got to go 5 miles straight up, or you have to go 300 miles
forward.
Is he saying like take
300
off
miles horizontally?
Is he saying like take off level and just fly straight horizontal? And then
he wants to break rockets and make them just do magic.
I know this is unheard of, guys. Physics.
Oh my God, D-Mark, that mouth of yours. I'm trying to pay attention. I'm really on your side. You'll hear you. Man, you are you're just obnoxious.
What are you talking about, dude?
You're just obnoxious. Stop talking.
Stop talking.
You really are, D-Mark. I really want to hear what you have. Today I'm in a different position where I'm actually wanting to listen to you, but man, your mouth is just getting you in trouble. Stop talking.
So do you understand what an L is? Give us the math.
Do I understand what an L is? So I jumped in late. I understand what you're trying to say. You're saying if I just took off horizontally, like over the ocean, and then we saw this drop beneath us, how long would it take us to get to the same level that these rockets get to when they go straight up and then start arcing to follow the curve? Is that what you're saying? Is that the question?
No, I said when they get to the clouds.
Yeah, the
Well, the
clouds.
rocket.
Yeah, you look at an airplane; it's about 250 miles to the horizon, essentially, from an airplane to the ground. So that's right there. Tells me that my math is pretty close.
Right.
And by math, I should say my model is very close.
It doesn't make any sense. How can it be 200 miles full, 5 miles up? Show me
Because
this.
the Earth turns away slowly. I
Because
did. Look at the image. Look at the image and count little red
That's the
lines.
tangent. That's the tangent. Hold on, D-Mock. That's the tangent. That's the tangent at which you look at some spot 250 miles away. That's
No, I'm not looking at spots. Listen to what I'm saying to you, man. Draw a little circle and then draw your L on the top
Why
of
do we
it.
even try to
And show me what you're
communicate with
talking
them? It's
about, because
ridiculous.
whatever you're talking about now is not what I'm getting into. Simply draw a circle. This is fucking, you don't need your numbers for this, not until a certain point. Draw the circle first. Draw an L on top of the circle, right? You got one portion of the L, which will be your vertical rocket. You got the bottom portion of the L, which is your horizontal rocket. The L, you make it the same size, right? Now, why would there be a different amount of mileage or timing or distance in these two when they're both the same? I don't comprehend.
I know you don't. I'm trying to explain it to you. 250 miles level, horizontal flight gets you to the clouds, right? Probably a little shorter than that, but gets you to the clouds. And then going straight up gets you out of the atmosphere. You're going faster because you less wind resistance, less air resistance. Then you arc over, but just getting to the clouds is straight up. You're only 30. You said it yourself. 5 miles. Boom. You're in the clouds.
Are you broke, Zanuck? Can you guys say any
5 miles is less.
one direction,
So
but
5 miles is less than
Stop saying
250
up,
miles.
please.
Is that a hard
Hey,
number?
hello?
Is that
Zanuck,
yeah? Hello.
I'm talking about horizontal, bro.
Is 5 miles less than 250 miles?
It's 5 miles forward, less than 250.
What does that even mean?
Horizontally.
Dude, you're going horizontally 250 miles
Yeah.
to get to the clouds.
No,
250
5
miles. Or it goes straight up.
Maybe can you draw a circle and an L so that you have, unless you've already done this, can you draw it out and show
Yeah,
them?
I've done it a million times, but I'll do it a million more. So I got you. I'll draw another one.
Well, it's simple. You know how the argument is fallacious when we try to talk about how much drop would be in 500 miles. Well, in this instance, since you're starting from zero and going strictly horizontally, then you would have to have that 8 inches per mile square drop, like over whatever distance. And so it's like, how long would it take to get to outer space going horizontally versus straight up? That's all he's asking.
Interesting. Are we defining space as 100 miles up?
I'm not saying space though, Elijah. Give them all the way to space. Because they're gonna argue all kinds of dumb shit. I just want to go to the clouds. Fuck space.
Oh, to the clouds. Oh, okay. Then never mind. That's. Oh well, then yeah. That's still. I think that's still 8 inches per mile squared. Just until you hit like whatever the how high up are clouds, like 30,000.
Well, why don't we have 2 GoPros doing this live? How come no military or Department of Defense or National Geographics or Geodesy or Geo Excavating or any fucking company of it for that sort hasn't done this? Why haven't they done this?
Clouds are as low as 2,000 feet. So we can why don't we just do 2,000 feet? It's easier to measure and figure out.
You know it's crazy. I just thought about the fact that like as an observer on the ground, like the horizon is 3 miles away, but the clouds are supposedly. I don't even know how far the furthest cloud I'm looking at is, but that's definitely well beyond that geometric limit. I don't know how I'm seeing what I'm seeing. With that being,
because Elijah,
I'm looking
clouds
into,
can be 2,000 feet off the ground, or they can be 30,000 feet off the ground.
Yeah, but the clouds I'm looking at have to be in space. Like,
why is that?
From my perspective.
What do you mean from your perspective? What do you mean?
The ground is curved away from me, so the
Right.
clouds that I'm looking at aren't flat. So they're like to some extent like beyond the horizon.
Yeah, they are. They are behind.
The
Yes,
clouds
good.
are bigger
We're
than the
making
globe.
progress beyond.
They're a
They're
ring,
beyond the
a halo.
horizon. Correct. Yes, they are beyond the horizon.
Yeah. But we can't experience that though. We just have to imagine it. It's hard to imagine. That's all.
The sun didn't clue you in on this. The sun and the clouds, anything that is blocked by the horizon.
You know, it's interesting when you look at like the horizon. Hawaii is a great place to do this because you have really clear nights, night after night after night. Very little refraction because all the temperatures are very close to the same, the water and the air, and you can see the sun. And you have islands that are 50 to 100 miles away, some even 200 miles away. We can see the sun setting between them, and you can see cloud that they pass through clouds before the sun sets in a very clear
What
path.
passes through clouds?
The sun, you'll see it hit a cloud way in the distance, 100 miles away, like between Maui and Oahu. It'll hit the cloud. It'll kind of be obscured for a bit, and then it'll pop out underneath the cloud for like just maybe a fraction of a degree, and then it will set very clearly without any kind of distortion. And that's you can
Well,
now tell that
I'm looking at a
that cloud
I'm looking
that
at
in
a
front of
building.
is much further away than the horizon.
I'm looking at a building that's in front of the clouds, and the height of the building is higher than the clouds. And am I to expect that that's due to the fact that the cloud is curving because of Earth curvature, or is that a perspective thing?
The cloud is curving?
Well, I mean, because you're saying that you can see the sun in the distance and then it goes below the cloud. And I'm like, okay, so there's an object that goes below another object. Well, here are two objects, the cloud
Well,
and the
you can
building.
call
And
your
in this
friend in
case,
Oahu and say,
and
"Hey, this cloud."
in this case, it's the cloud instead of the
Well,
sun.
yeah.
It's
So
the cloud that
I've
appears.
kind of done this ad
Stop,
hocly,
Zenick.
but
Stop, Zenick. Stop,
Elijah.
Zenick. Because you can talk when I'm done, right? It's not a
Yeah.
big deal, right?
No, not at all.
Okay. So, like in your example, the sun, instead of that, I see a cloud that in the distance is lower than the building that I'm looking at in the foreground. Like, so what?
Well, you can call your buddy in Oahu while you're in Maui and say, "Hey, I just noticed the sunset, and it seems like the cloud is like right above Oahu." And they'll say, "No, that the sunset around Oahu, right?
So
You're a
stupid.
big band."
Ask him if he can see the cloud
Yeah,
that
and
your
he'll say, "Yeah,
fan is
we have,
blocking.
I'm
Yeah, he
looking. I'm
can't see the
looking at it.
cloud.
I'm
Yeah,
looking."
Because
Just let
the
me finish.
cloud.
Hey, Elijah, can you tell me to shut up a second? So he looked at
Unbelievable. You're
the clouds
unbelievable
look like
saying this, man.
they look like they're over Oahu, but when you call your buddy in Oahu and say, "Are there any clouds?" No, it's a clear day, but I do see some clouds like 50 miles away. Those could be the clouds you're seeing. You can go and you can look on a weather chart. There's actually radar weather charts in Hawaii and where you live too. See if those clouds are there.
Can't be serious.
You gotta substitute chemistry teachers.
Maybe the clouds are closer to you, so the sun is further away, so it appears that it's lower than the clouds that are closer to you because of the angle.
You were not paying attention,
You think
Rakia.
maybe? So you understood what I said, Rakia, and yeah, Zanuck is just even though you're unbelievable. What I'm saying, he's saying that you don't understand.
But he
Even though
doesn't,
you're
though.
repeating my sentence,
What Rakia just said about
nobody
the sun
understood
being
it.
farther is therefore lower, and then that doesn't make any sense.
Yeah, it doesn't.
Wow!
Oh, really?
Wow!
You don't think
yes,
the really?
things that are further.
You didn't hear anything I said.
Visually, it can
things that
appear
are
lower,
further.
but it's not going to actually cast any light
That's
under
what
the
we're
clouds.
talking about. That's
okay. Just
the casting the light has nothing to do with that.
all right. Just making sure we're getting that clear.
I'm
All
just
right.
making sure you're adding something that has nothing to do with what we're
All right.
talking
My
about.
bad. My bad.
Yeah, just trolling again, right?
I'm not
Just trolling.
trolling. I misunderstood.
Biggest troll of the world. How do you
He
go to
just
sleep
admitted.
at
He
night?
did just admit. He said, "My bad." Let's go.
You go to sleep to porn at night?
Elijah, most clouds are like 7 miles up, man. If you see clouds at the horizon, they're still 7 miles
Yeah.
up.
Okay, right. I know the clouds are 7 miles up, but this building appears higher in my field of view than the clouds. I'm not going to be saying that's because of Earth curve, like Zanuck is attempting to insinuate.
Why
Hello.
wouldn't you though? Because the clouds, if they are in
Oh,
fact
now
7
why
miles up,
wouldn't I?
and you're on a flat plane, then why would the building ever look like it's blocking clouds 7 miles up?
Exactly.
I'm not going to dignify that
No,
with a
you're just not
response
thinking
after
it
I just
through,
explained.
Elijah.
Yo,
I
Zanuck,
understand.
actually,
You're
I
just
didn't
really not
ask you to
thinking it through.
interrupt. I didn't ask you to interrupt. I didn't interrupt you at all. Let's not
No, you
start the
didn't.
day
But
like this.
Rakia did.
So let's not start the day like this. So everybody already knows what I'm talking about with something being in the foreground and something being in the background. How you know something in the background could be literally smaller or shorter, but appear,
Smart.
or did I say that backwards? Appear taller. Something in
Yes.
the foreground can appear taller than something in the background, even though it's actually shorter. Like, and so that's all I'm describing with these clouds.
Well, I want to if it's the only way
Obviously
I can
this
fix it. So
building,
you send me the
obviously this
drivers for
building,
the Intel chips,
obviously this
and
build.
I loaded them
Oh
last
God,
night and
yo,
installed them,
stop,
and it
Zanuck,
Xanax,
seems to
We're
Xanax,
talking
but
about
it's
work
fuck's
still
stuff
sake.
over. We're
it
talking
worked.
about
Yeah,
work
like right now
stuff.
I'm moving it around
Work
and
stuff. Hello,
it does
hello.
and there we go.
Work stuff
It
on
moves
the
for a while,
live.
then it
We don't
hangs,
want you
and then I
getting
got
in
to put the
trouble,
external
Zanuck.
mouse under.
Hello. Somebody mute him. Jesus Christ. I was almost equipped with a weapon to undo him, but good men
Whoa.
don't do that.
And back it up, and
Anyway.
then
Calm down now. Yeah,
is that what you're
Yeah,
saying?
I know that's only
But
what
Zanuck, hold on.
So I haven't
only
done
what the
anything.
globe
He's
Earth
still.
is do.
Take everything up
Hold
on
on,
you.
Elijah. He's still talking
It
after
works.
I
Should I
muted
send it?
him like 6 times. Zanuck, can you fucking hear anybody speaking?
No. No, he's busy. He
Oh,
probably
I think
has
he
his
heard
earpiece
that.
out his ear. Maybe.
Oh, he probably took a call. Yeah, and
So
it's
So
so
why did you
anyway,
unmute
so
yourself if he's taking a call? But yeah, I drew the picture in there. Sorry.
so back to what I was saying. Like, obviously the building in front of me isn't fucking 7,100 feet tall. It's a perspective thing. I'm sure everyone can agree, but it's the exact same effect that we see with the sun. So all I'm saying is, since it's the same effect, and there's no way to differentiate between what you're saying it is versus how we experience things with this effect, all I'm saying is, how can you attribute that to the clouds, following the curve of the Earth?
if you're in a plane. If you're in
Therefore,
a plane,
the sun appearing like it's below the clouds. That's the argument.
yeah,
I saw the sun below the clouds, and I'm like, wow, profound. Maybe because it was far enough away that it appeared that way,
yeah,
just like the building I just described.
yeah. See, that works. Yeah, that works if you're on the ground. But if you're in a plane where you're above the clouds, then that would never happen. The sun would never be below the clouds because of perspective.
Yeah, well,
And that
guess what? Dave Weiss well, I don't know about all that. I don't know about all that. You can
There's a
make
lot of
that claim. You can make that claim. I know the horizon doesn't rise to eye level, and so just because things appear lower than eye level doesn't mean it's because the Earth is curved. But all of those effects that a lot of flat earthers just I guess they deny. I'm saying I know that happens. I just know it's not Earth curve. So back to the whole scenario with the cloud sun situation. You guys you like to have these arguments where it's like, oh, look, the clouds look like they're lit from the bottom. Not generally, not when I'm looking at a sunset, but I have seen that video or that picture where it appears like the clouds are lit from the bottom. And then guess what? Dave Weiss did a video where he had a light source above his table, and he moves the light source away, and voila, the bottom of the table is illuminated with some of that light, even though it's above the table. So I'm like, well, that settles that. But on top of that, if I was actually turning away from the sun, at some point I would begin to see the bottom of the clouds lit. That just never happened. It's always lit from the top. all the way until the sun is gone, well after the sun is gone, but I'm still getting the ambient light. The same thing is the case. They're never lit from the bottom.
They are lit. What are you talking about, Elijah? It's just you can see tons of pictures of clouds illuminated from the bottom because the sunlight makes a path, an angled path that intersects clouds from below because the Earth's
You didn't
surface
hear
is.
the first thing I said?
I did hear the first thing you said. Well, you're wrong about
Okay,
it.
so you say I'm wrong, I say I'm right. Guess what? Everybody at sunset, just before sunset, maybe an hour before sunset, yeah, hour or two before sunset, go ahead and get a video of your clouds. I'll do the same thing because you know the popcorn clouds that are lower,
Yeah.
and typically like the rain clouds and stuff. Like you typically see it shadowed at the bottom. Obviously, the brighter portion is at the top. I'm saying that nothing changes about that, no matter how long the sun has set. The sun could
So
have
here's
set
a
20
really cool
minutes.
experiment.
The sun could have set 20 minutes. The sun could have set 30 minutes. So if I'm wrong about that specifically, then all we have to all go do, so that it's not like some trickery or some one-off, we can all just go out and take a video of the clouds and see if eventually, because the sun is always, the earth is always turning away from the sun from our perspective here on earth. So every night we should be able to get a shot of the sun appearing to light the bottom of the cloud versus the top. Like I can see it right now lighting the top of the cloud versus the bottom. Like we
Yeah,
should all do that, right?
Exactly, and have a shadow from the top up and down should be illuminated, and the top should be a shadow, just like they say when you one side of something and it's lit up bright, and then the other side is shadowed. Here's a funny thing too about all these distances. No one can ever point out what 93 million miles is. So if I see the sun to my left and the moon to my far right, is that 93 million miles? Or during an eclipse, is that 93 million miles between them? Or when one looks like it's set and one looks like it's still up at high noon, is that 93 million? Or the inch between the two when they're just like right by each other? Where do I see this 93 million mile air like amount in distance when we can triangulate and like compare to all the other, orientations that it has? There's no 93 million mile high altitude footage that you can see a gap between these. And if the sun and moon are 400 times further, but different, different size, then how are they both setting at 6 miles? How
All
are they
right,
both
so
setting at 10 miles?
Elijah, you can do a really easy-ish now with today's technology experiment to show that light can illuminate clouds from beneath. You can have a camera set up at a location, pointed up at the sky, and on a cloudy day, you can go 20 miles east of wherever you set that camera up. And you can look at the camera and you will notice that as the sun sets from the camera's point of view, the clouds above it will be illuminated from below. And you can physically go look in the direction west of where your camera is set up, and you will notice the clouds do not look like they are illuminated from the bottom up because from your position, the sun isn't setting. Easy experiment.
The Earth should not be spinning, just like the moon. When the moon's in orbit and we see
Can
one
I
face,
respond to that specifically?
the
Because you
Earth
sound
should
like
be
you're
tidal
saying
locked with the
something
sun.
else.
Jesus Christ. I was speaking to Elijah.
Yeah, my observation included before, during, and after sunset, though. So
Right,
it's
but it's only from
likely.
one location. I'm saying you can take two
Yeah,
location
for
points
what?
and you can see it easily demonstratable.
I don't get what you're trying to. I don't get what you're trying to suggest. I don't get it.
If you set a camera up
Like,
looking straight up at clouds and you go away from it, like in the opposite direction of the sun setting, you can go 10 miles,
okay,
20 miles. The further, the more time, obviously, it'll take for you to notice the effect. But you go away from that spot, but you can still see the same clouds that your camera setup can see. When the sun sets,
right.
from the camera's point of view, you can notice that the clouds are illuminated from below. But if you, at
From
your
the
position,
camera's point of view,
yeah, from the
at
camera's point
night.
of view,
Hold on, hold
and
on.
then you,
The
the
cameras,
sun is
the
still
cameras in
almost
the cameras. No, stop. I'm confused. Okay, so the camera's point of view is still in daytime with the cloud. You're
it's
moving away from
sunset.
the sun, so you're moving closer. No, you're moving closer. Okay, fine. So the camera's there during sunset, and you're moving into nighttime. So we're just imagining that you're standing in nighttime, and your camera is somewhere at sunset, looking at the clouds. Right?
Other way
Is that
around.
the scenario?
Your camera has sunset first. The sun is still at dusk for you. Your camera will experience the sunset first, and you will notice the clouds illuminated from bottom up. And if you turn around and look towards the direction
Can you
of
show me
the
this?
sunset where your camera is, you can notice that the clouds aren't illuminated from the bottom up because it's still daytime for you.
My
And the
premise is
further
that my
away from
premise.
the camera you are, the greater the disparity is, the easier it is to notice the difference.
Yeah, my premise in the first place is that from your position, you'll never be able to see the clouds lit from the bottom to the top. So if you were to leave your camera somewhere as if you were just standing there, you're basically telling me, well, the camera will show. The camera, you can get on camera the clouds being lit from the bottom as the sun is setting. I'm literally saying that the sun doesn't light clouds from the bottom as I'm standing there during and after a sunrise. You don't see how these two things. So basically, I'm not arguing with you. Just give me a video because because
And
obviously
someone,
what we're saying is conflicting. You're saying that what I'm saying is wrong.
yeah, it is. But hey, someone unmute Zanuck. He's got pictures for you. I gotta go.
Of course, Zanuck needed a good distraction from those dumbasses. Did anybody get his retort to me, or am I just flat Earth biased?
They are willing to say anything and then go feed the dog. It's ridiculous.
No, that's
Like,
not true.
what the hell? If you have a camera, like, mind you, that's unnecessary because what we want is the camera's view. Like, I can just stand there myself, like I have, and I'm saying everyone tonight or during dusk, you can take out your, or just before that, take out your camera because you're going to need that to show us and show us what you're looking at. So I'm saying you're going to observe the opposite of what he's saying the camera is going to observe. I don't even know why you had to add that additional story of another person
Elijah,
moving
can you
into
look in the
dusk.
chat real quick or no?
Not right
Because
now while I'm fucking talking.
okay,
And
well,
yes,
there's
I
a
am just.
picture of the sun well below the clouds, and you can see the sun actually under the clouds. Nothing above the clouds
Yeah,
except
that's
sky, but below the clouds, looking level down, is the sun
right.
below the clouds.
Right.
So that
No one
that's
ever
exact.
argued that
Or
that doesn't look like that.
can you
Nobody's
see it real
arguing
quick?
that.
Can you take a quick glance at it?
I can
Yeah.
already say that no
How
one's
far are
Does
the
anyone
arguing with
clouds?
that.
disagree? Does anyone disagree that the sun is not below the clouds?
How far is the clouds away from you?
Well, you're in the
Doesn't
clouds, and
matter.
as far as the eye can see.
How far is the sun away from you?
Doesn't matter. That's not how perspective works.
Yeah.
If you're
So it's
above the
just a
clouds and the sun is supposed to be above the clouds, then the sun should be still above the clouds, even in the
No,
distance.
no way. That's
Yes,
He
yes,
said.
yes.
Remember, everything
So
in
he said
perspective
that's
If you
stays at
time
understand
eye
out.
level.
perspective,
Slow
you'd
down,
understand
Zanuck.
that. All right.
Zanuck,
Yeah,
Zanuck,
you're being
Zanuck, Zanuck.
dishonest.
We heard you. We heard you. He's fucking up your argument. Like, so I'm gonna respond to him, and I'm gonna need you not to jump in. So my response to him is like, yeah, sure, perspective works. Oh, you like mean how this building right here appears higher than the clouds that are 2,000 or so feet above me. Just like that, right?
What?
Right.
That
Like,
works. That
because
works
you're
if you're below
saying
the
that,
thing. If you're below
because
the
you're,
thing, it works. But if you're above the thing, right? If something is taller than the thing you're above, then it will never. It would never set below that thing. All right. If you're below it, that's fine. But if you're above it, that doesn't work like that. You understand that, right?
Look at
The
the
simple.
picture I have in there right now. Look at the new one, Arma. Check this one out. Because this actually has a flash upward on the cloud that's probably the same level this plane's flying,
Oh wow.
and the clouds and setting below it.
Yeah, that's beautiful.
So
Look at that.
yeah, that's a great shot too. So we know that the sun and perspective is always being used, but somehow they miss the point that, like you said, it always anything at your eye level, anything will always stay at eye level as it goes away from you. It won't go down or up. It'll stay there. If you don't get that particular point, then we have no discussion to have here.
Yeah. You
Maybe
could
that's well. What if I were to say the sky is a dome, which I don't believe, but then the parent sun
even
would
that
be
wouldn't
going lower,
change
wouldn't it?
perspective.
If it's a
Yes, it
dome,
would.
then that means
No. Then it means the same thing, that the sun is going
No, because
down.
the clouds aren't on the dome.
Yeah, hold on. Are you
No,
evoking?
of course not. Of course not. But the light that's being projected onto the dome that we see as the sun is.
Oh, so sky magic then, right? Because it's a personal
Maybe.
dome everyone has.
I don't know.
It would have to be a
Maybe.
personal dome because obviously we have time zones.
No,
and
not the personal dome.
It would have to be. I mean, if the sun sets one place, we'd have to set everywhere. If this is a dome that's over us, you know what I'm saying? Like, I don't understand how you could logically get this to work where, time zones exist and this dome.
Yeah, I mean, if it's a dome, here's what that's so stupid. I like it. And I don't mean you're stupid. You're not stupid, but you're.
Well, it's a very slight.
Here's
It's
why.
a very
At some
slight
point
curve in the dome. That's
that
why.
sun will have to be
So you can
touching
barely
the
see.
ground, right? If it's on a dome,
Very
and the
slight.
sun is setting, that sun would have to be on the ground. So someone in that distance
It's a
without-
dome on top
hold
of a
on,
cylinder.
remember you told me not to
So
talk
it
over
works.
you? You notice
It
when I
touches
raise my
down
voice
like a
because you're
cylinder.
talking over me.
So
You're such a hypocrite. Just shut up for a second, Elijah.
It's like a cylinder.
Just
on
shut up
top
for a
of-
second,
on-
Elijah. It's
with
my
the-
turn, and
with a
you'll have a
little,
turn.
like a
Yeah.
clock
Elijah.
face, like a clock glass on top.
Elijah, you made your point. Okay, he's clarifying. He's specifically clarifying what you're trying to say. Zanuck, go.
Thank you. So we have a dome in your world, your this, and if it is a dome, then this particular object would be at the horizon on this flat Earth. That means somewhere in that distance, however far the sun is away, they're going to have the sun on top of them, near the ground, because that's what the dome is. You can't have it both ways. You can't have perspective and then have a dome. It doesn't work that way, Elijah.
Yeah, but it's a
personal dome?
I'm not
We all have
saying
personal
it's a personal
domes?
dome.
Let
I'm
Elijah respond.
I'm saying it's like the glass of a watch, and then the sides are something cylindrical like. Yeah,
It's
like a
kinda
petri
like-
dish.
You're just making shit
I
up now,
got you, Elijah. It's like a cup.
Sure,
it's like
sure,
a jar of
sure.
liquid looking one way. A jar
You're
of
a
liquid
grown
one
ass
way.
man and you're just
and
making shit up.
and
Come
it's
on.
Dude, shut the fuck
Y'all
up.
make shit up all the time. I'm having
No,
fun.
I'm not
I don't
making
even
shit up.
care.
I do this all the time. I put a little glowing
Not you.
ball behind. No, I know.
Then don't give a
Behind-
shit then,
I know,
Elijah. All right?
behind a glass of liquid water, right? I get a jar of liquid. It's a glass. It's cylindrical. It goes up all the way. I take the ball and I move it from the right to the left behind it. You know what I see? The object coming from the other direction. Okay? So when I move a ball behind my cup of water, my glass of water, it's shaped like a cylindrical glass, like rounded at the edges. When I move it from the right to the left, it appears in my image that I'm through that it's coming from the left to right. So that's pretty wicked. Then if you get a flat aquarium and you do the same thing, it comes from the right direction. You see the right way. Now, if you put the object directly in the water, and you know what I mean, then you can also get a weird skewed vision. But that's usually only in the rounded glass, not in the flat aquarium. So like the beveled portion of atmosphere will be magnified. That's why you see the sun bigger as it's further. And when it gets closer, it's more focused and above you, because that's the flat portion, right? And then in front of you is like the blurred portion, the magnifier. And that's why the atmosphere is a magnet and a magnifier. That's exactly what it is in all counts. Are you talking right now, Elijah? And
So the magnet MAG and magnifier MAN, they're not spelled the same. So are they the same word?
I didn't say the same number. I didn't say the same letter. I said they're the same things. They magnify. They magnify an effect.
Magnets magnify, and magnifiers magnify. So why
Yeah.
would you have the word
So,
magnet
like,
when
air.
magnifier could just be the use of that word?
Well, you're like a conductor. You're like a piece of copper.
I'm
You
a
are
piece of
kind of.
copper. I'm like a
Yep.
copper.
And the air is like a magnet.
And
And
the
you
air is the
together,
magnet.
you work
Okay.
together, and that's
The
electricity, baby.
magnet and the copper, and me,
Yep.
the copper, and the air is the magnet. We
Yep.
work
It's
together.
electricity.
We all work
It's
together.
an electrical magnet.
One big happy
Air
family.
is electricity.
Air is electricity. I thought it was a magnet.
That's what a magnet is. It's
Magnet's
electrical
electricity. So magnet's
You know what a
electricity.
lodestone
I'm
is?
copper,
You have
and
a
the air is a
nail or a
magnet.
stone.
You're making more sense with
Guys,
every word.
stop.
Keep on going.
Shut the fuck up. Will you guys talk like normal fucking humans, please?
He's not talking like a normal human, though. You know
Yeah,
that, right?
because you keep stepping on every fucking thing he's saying.
Yeah, but to be fair, they're both stepping on each
Oh, I know
other.
they are, but Xanax started it in this case.
I'm not
I get
trying
it.
to step on
Yeah,
him at
okay,
all.
Rocky.
I know you're trying to
you're just
get out
saying
what you're
words now.
saying, and Xanax keeps stepping on you to make his point. I get
I'm
it.
not stepping. I'm asking him questions along the way. It's all nonsense. You know that. Come on. I'm not a magnet.
So what
The
is
air's
a
not a magnet. I'm
lodestone
not
taking
copper.
on?
Xanax, was it you earlier that said, oh, okay, so sky magic, right?
No, I was
If that's
Sky
an
Magic.
explanation for the dome.
I
Okay,
would
cool.
never say
So,
sky.
if you can explain the amount of sky magic that the globe claims is unreal. It's the same.
First off, it's not
we
sky
don't know
magic. It's actually it's been studied. All right, we know about refraction. All right.
Yo,
So
shut up,
get
shut
this
up,
shit
shut
out of
up,
here.
shut up, Neil deGrasse Tyson. Turns out there's a magic speed. Yeah, there's a lot of magical
Okay, I
shit
will admit
going
that was a
on.
good impression. I will give you that.
Yeah. Shut up.
I just complimented you. Come on.
What about this
That was a
distance?
good impression.
At what point in time can we see left to right 93 million miles or forward 93 million miles that we supposedly see a sun 93 million
Every
miles
day.
away?
Every day.
No, listen to what I'm saying. I never get done with my sentence and you keep answering something nobody's talking about. The distance between the moon and the sun, and there's supposed to be 93 million miles between the earth and the sun. 238,000 between the sun, the earth and the moon. So when the moon drops at 3 miles, shouldn't the sun be dropping at 93 million minus 3? So where can you see a side view? Look up anywhere with any ISS or any high altitude footage. Get the and see that there's 93 million mile distance. So when I look up in the air and I say, okay, this bird just flew away from this tree, at what point in time, how many feet and my actual vision is the bird away from the tree before I can declare that 93 million miles? Now, me and Jeremy were talking about perspective in the distance, right? When you look in the horizon, and we were trying to determine how many miles you could see from left to right. Now, how many miles is 93 million left to right? How far, like in your view, when you turn, you see the moon to your left up in the air, and then the sun to your right up in the air. Where is 93 million miles distance at?
Anywhere, really. I mean, technically, you could, depending on how you look at the. Oh, during the eclipse, my bad. Okay.
Yeah, when they're both supposed to be touching and they appear to be touching to us because they're 400 times further apart. Now, somewhere on this planet or somewhere up in the sky or high altitude footage, you should be able to see. There's the moon. Now, look, there's in between the moon. Look, the moon's not touching the sun at all. It's nowhere near it. It's 93 million miles away. Where's that gap?
So again, the clouds, it's crazy. The clouds, that shadowy part, because I see that during the sunset, and it's not because the sun is shining on the bottom of the clouds. We're looking at shadows because the clouds in the background are blocking the clouds in the foreground. That's why that effect is happening. Now, looking at the sun, it's not above, it's not below, the sun is not below the horizon and below the clouds in this picture. Like that's an artificial horizon that all of that stuff is under. That's not, and on top of that, the plane flies a couple of degrees above horizontal. You're not looking at the sun below clouds.
So how do clouds cast shadows upwards then?
Why is the sun?
What do you mean? It's not upwards. It's like when you ask about anti-percussion. It's like when you ask about anti-percussion. Whoa. crepuscular ray.
Anti-crepuscular.
But it
There you go.
Crepuscular.
anti-crepuscular. But it's just that it's just it's a trick of
We
your
need to go over
mind. It's
crepuscular
not.
rays too. How come
So
you
what
It's a
about
trick.
like you
that
have no
line
It's a
understanding of
logic
trick
that
of
anything?
your
we see?
mind.
The sun makes a
Huh?
straight diagonal
Planes do
line.
not fly 3
Why is it not
degrees
curving?
up. They have the nose 3 degrees above level, but they don't fly 3 degrees above level.
Why is that
It's
sun making a
curved.
perspective line a straight path from point A where you see it to? Why is that sun making a perfectly straight line, guys?
I don't know what you're looking at.
The picture in the back.
Sorry, I can't see it driving.
It's got like 15 suns lined up, and they're all perfectly in a straight line, like the edge of a pyramid. You understand? From the top down, they're in a perfect line, diagonal. Now, how in the fuck does that work on a ball? If everything's in a circular motion, in a circular orbit, moving in a circular path, how are you making a straight fucking line with the sun and the moon spinning, or the sun and the Earth? I'm sorry, and they're both circular, spinning it at a certain angle towards you. Like, there's no way in hell you're making that straight line. And see, there's no demonstration on a ball. You guys don't have the cameras on it spinning somewhere with like an object on the wall set, or a ball on a string, or a ball on a string above it doing it while you got the camera on the sun and the moon, little. So we can get the perspective of how we're actually supposed to see it. But you guys don't want to do that. You guys want to just keep going to a flat,
Explain what we're.
of a flat
Explain
picture
how we're supposed to
that
do it again.
doesn't show anything. You work for the Department of Defense, right? You work for the military, but yet you can't even get a video. That's just, I mean, it's sad.
Why do you always have to go to what I do for a living? Is it? Does your life
Because
suck
it's
that
pretty
much that you
fucking
have to?
sad that a person in the military can't even get footage. Regular civilian, public people to have fucking footage or proof of something that the
Footage of
military is
what?
supposed to have for 3,000 years, and
Footage of
umpteen
what?
billions of different footages of side views
DMOC.
of everything. No
You're-
side view, not one from the military.
Stop
You're
getting
going to show us
triggered,
still
DMOC.
pictures, cartoons that a third grader could
I
show us
don't.
and say that's evidence for a ball. You don't have
Stop
anything
getting
more
triggered,
convincing than a third
DMOC.
grade cartoon that you look at it for. Get real.
Okay, stop getting triggered. Stop getting triggered. Just relax. Just relax, okay? What are you asking for? What kind of picture are you asking for?
A side view of the distance between the moon and the sun, the 93 million mile gap.
A side
Especially
view.
during an
Listen,
eclipse.
listen to what you're
And
asking
why do you
for.
keep
A
acting like you
side
don't
view
understand what I'm saying when I
of
ask you the question the
wait,
third grader gets? I don't
wait,
comprehend
hold on.
this.
Shut up for a second. You're asking for a side view of the distance between the sun and the moon?
Right. Another claim that's impossible
Yeah.
to carry out for
No, it's
verification.
impossible. Well, yeah, it's
Yeah.
impossible because of the
How
distance you'd
exactly
have to
would you?
be.
Right. It's an unfalsifiable claim. Exactly.
Okay,
It
Okay,
could be
what
Narnia
exact?
for
I
all
don't
we know.
understand. it's
How
just
Yeah,
weird
far
to
you
is
ask for
understand.
something
That's why
like
you're
that.
93
laughing.
miles up in the
What
air?
would that even
Where's
do
your
for you?
air scale?
What would
Your
that
air
do
scale.
for you though? If
No,
someone was to
it's the
do that,
point
They're
that it's
93 million miles
it's the
apart.
point. It's the point that it's actually literally impossible
okay,
because
Elijah, give me a picture of
even if you had
the dome.
even if you had a field view, like still prospectively the object would be too small to resolve for any like it's literally a claim that's literally unfalsifiable. Now
okay,
You shouldn't see the
you
sun.
can be
That's so stupid.
you can be comfortable with that if you like.
a
No.
That's
side
fine.
view.
Because guess
I'm
what?
just trying to.
Guess what? A
God,
93 million mile away sun doesn't necessitate any explanation or reasoning why we need to breathe, given that they lie about a vacuum, is something quite easy to understand. It's not a vacuum.
okay.
It's
You said
contained,
they,
like
you
every
said we
system ever.
lie. Hold on. You said we lie about a vacuum. Does the pressure of the atmosphere not go down as you go up?
No,
Yeah, so
there is
what?
no
It doesn't.
pressure to begin with.
Say it
I
does, so
mean,
what?
How do you
Say
weigh
it
the
does, so what?
so
atmosphere?
any
What scale?
vacuum is lower pressure, right?
No.
We know that is,
No,
you
that's
know,
what you claim. That's your claim.
anytime you have anything less than atmospheric pressure is technically a vacuum.
No,
Okay, but
that's your claim.
we would
Action and
have to
reaction is what
what
you're making the claim of. We're not claiming the action and reaction. You are.
Okay.
You're claiming the
Okay.
word vacuum, but you can't demonstrate vacuum.
Yeah,
right.
but people have already demonstrated it, though.
That's another unfalsifiable claim. Let me tell you why. Because it's not like you can see or experience a vacuum that doesn't have boundaries. Like, period. Like,
So
but
now
that's
you're
what
saying
we're
you're
supposed to believe. But that's what we're
now you're
supposed to believe.
Well, let's stay
Versus,
on the
now
93
you're
million.
versus.
saying
Let's not get off the 93
hold
million.
on. Now you're saying that
Hold on,
there's
man.
a
Well,
I
vacuum
well,
want this
and we
it's
have
hard.
to
It's
be.
hard.
You're
It's
in the
hard without
military, dog.
moderation because it's
God.
like I have
Guys,
two key statements. Two key statements more often than not. Specifically because everybody else talks so much, and it's hard to answer for all the illogic there is. Like, why can't y'all just stop until you know the person is done talking?
Okay, you're saying that we have a vacuum because therefore we should have some sort of container. So in order for that to be true, we would
No,
be
I'm
able to
not. No,
detect
I'm
this.
not. No, I'm not. I'm
Okay,
stopping
go
you
ahead.
because no, I'm not saying that. That's why I'm stopping you. Not because I can't say you're wrong, but your premise is wrong because you're tying it to something that I said that I didn't say. Can't do that.
Okay. Okay.
so Elijah, clarify that point then.
He was talking
What
about
I'm saying,
pressure in the
what I'm
vacuum of
No,
saying
air.
is there's no such.
Elijah.
What I'm saying is there's no such thing as a vacuum. I've never interfaced with a vacuum. I don't. The only
So
vacuums I know about are vacuums that. You see what I'm saying? You see what I'm saying? This is why you don't understand. So the only vacuums
okay.
that I do know. So.
No, go ahead.
Is
My
he
bad. Go
okay?
ahead. Go ahead.
Okay, so he said okay. Okay, go for it.
So the
Let
only
me just go ahead.
vacuum. I don't know. If someone is for, I'm not going to show the truth because my point is not going to
So
matter because you're just waiting to. Like, what does it matter? What
No,
difference
he
does it make?
was he was he was trying to say
Just don't
sorry. No,
address me.
look.
No,
I'll
I'm
go
saying
on mute.
if you're
So
not going to
you got
listen,
what you
if you're not
want
going
to
to
say.
listen to
Go
the
ahead.
entire thing, you
he
can't
said
address
he
me.
said he's going on mute. He said he's going on mute to listen. So there's no it's the delay. He thinks there's a go for it, Elijah. Go.
In my vernacular, there's no need for a vacuum. There's no need to discuss a vacuum at all. Just like in my vernacular, when I see something in the distance, all I have to do is say that I see something in the distance. You're the one that has to explain that we have gas pressure adjacent to a vacuum that doesn't have any parameters. You're the one that has to
Parameters?
explain that and explain why that's the case. Yeah,
Just because.
because if we actually made a vacuum, then it would obviously have to be contained to take
No,
the
it
thing out of it. So all I'm saying
wouldn't. Well,
is,
you're wrong.
all I'm saying is, I'm making zero claims. Actually,
You just made a claim. You said if you have.
the people that have to explain why the air pressure is less and less the higher we go up is specifically to explain the idea of gravity and all this and all that. I have no use for an empty sky that gets more empty the higher I go up. So I don't have a claim. I'm just
Okay,
saying
real quick. So
the claim that the higher up you go, the more nothingness there is, and so there's absolutely no. The
why
edge of
would
that
that?
nothingness
Hold
is
on.
our expanding
Let him
reality.
finish.
That's the thing that I don't believe. Like, that's not me making any claims at all.
You done, Elijah?
Yes, I am. Thank you.
All right. I'm gonna let him go. So
Yeah, I mean, that was a
Okay,
long-winded answer,
so
too.
why?
Well, I hope you don't
Why
straw
would
man
that
me then. You heard the
necessitate?
whole thing.
Never mind.
But why would that necessitate us needing a sort of between where we see suddenly
You're breaking
drops
up real bad.
to nearly nothing, Sorry.
Heard nothing there. Let me jump in real quick because I was trying to get a word into Elijah. Vacuum just means a differential pressure. If something's lower pressure than something else, that's considered a vacuum. How much is everything in the world? We have
I know
measured
what a vacuum is.
Okay, we measured a vacuum. There's no containment. There's no container. There's no physical container. Yet we know there's a there's a law of hydrostatics, and we know that things pile up. And you can do this demonstration yourself anywhere in your home and certain other types of controlled tests. So we know that the air has weight, and the air has weight would logically give it hydrostatic qualities, which we see as pressure goes down as exponentially as you go up. Nearly linear, but somewhat exponentially as you go up. And there's
Where
no
did you
containment.
measure a vacuum? Sorry.
Right above your head. A vacuum
You
on
measured
top of
the
your head.
vacuum right above
A vacuum on top of your head is a vacuum compared with the pressure at the bottom of your feet.
You realize what you sound like right now, like that. That's
like someone that actually took physics and understands what pressure and vacuum.
That's a vacuum. So there's just because any amount of lower pressure than something else equals
is
a vacuum
yes.
compared to the other thing.
Yeah, well, I have a vacuum chamber and it's 3 psi. It's a vacuum. It's a very strong vacuum chamber. Hold on, guys. There's no need to talk over anybody. I'll try to be respectful too.
It was an echo. You were echoing yourself. No one was talking on you.
Okay, so we have a vacuum. Anytime there's a lower pressure than another pressure, it's relative. So we have a vacuum chamber, 3 psi. Outside is 14.7. That's a pretty strong vacuum. That's a pretty heavy-duty vacuum chamber. You have 3 psi in a vacuum chamber.
So,
but it's still 3 psi.
All right. So the differential between the sea level, right, 14.7, and let's say somewhere between here and Jupiter, would you say that's a vast differential?
Vast differential? It would be you'd be removing this 14.7 and having 0.
Right. But so how do you have air pressure that's just sitting there?
How do you have air pressure just sitting there? Well, because air has weight, as I mentioned earlier.
Right next to it, you just said it would. We all know the gas would fill the available space.
No, we don't know that. Whoa! Hold on. We don't know that.
Really?
Yes. If I have an aerodynamic surface and I run it through a medium, either a liquid or any kind of fluid, I will get a differential pressure, and that differential pressure will stay there, and a vacuum will stay there, which is relative to the pressure, for as long as the force is applied. So all you need is a force. You don't need a physical container to contain a vacuum or to contain air pressure. That's why we have air pressure above us. That is lower than below your feet. Hold on, let me finish real quick.
No, but he's talking about real physics and systems.
Yeah, real physics. This is
that inside, and he's talking about what you can experience.
Yes.
Inducing. Shut up, please. So he's talking about what you can induce in a setting that includes a container.
Well, we can use containers all day. In fact, a lot of things like gas law, you need a container to actually calculate some of the values.
Right.
In using
Everything that has to do with pressure, ice has to be in a container.
No.
You cannot escape from that. Show it.
Yeah, that's what
demonstrated it without a container. Show any pressure without it.
Not to interrupt him, and we kind of did, but again, Zanuck, this is the important part. The physics you're talking about, right, and the chemistry that you're talking about, it's known because it was tested in a setup that included containers to create the environment.
Correct.
Wait, silent. You don't need to validate him. Let me respond. You did cut me off.
Okay, he was.
So that being the case,
Are you done, Elijah?
I don't. No, I'm not. That being the case, I don't see how that turns into no container at all, just wait. Because these things that you're talking about are on the level stationary plane. And they're doing these experiments on this plane. And then you have a plane that apparently a portion of inside this setup you would consider a vacuum because there's a differential in pressure. But that's on a plane in a closed environment. Now you want me to believe that that's how up there works, but without the container?
Yeah.
No.
Let me know when you're done.
Thank you. I am done.
Yeah, you said that being the case, and that's not the case,
Yeah.
Elijah. Just so you know.
Yeah. So we know there's a differential pressure. We can measure it. We can actually take a cube, a container, if you will, but in the container there's a differential pressure. So we don't need. One thing we all do know when you study physics is that those Gaussian collisions with each other, the molecules with each other, or with a container, are no different. They're said to be inelastic.
Nothing you said is in contention.
They're said to be elastic impacts. There's no loss of. See, why do when you talk we let you have the floor?
Why is Zanuck? Why are you reading from a script right now?
I'm not reading from any script. I'm just telling you what I know. What everyone knows.
He's right. He's right. He is right to be.
Elijah, you're talking all over me. I let you talk. You said you were done. Now you're interrupting me. Just bite your tongue for a second.
Guys, let Zanuck finish. Let Zanuck finish.
Thank you.
He's reading a script.
I'm not reading any script.
Yes, you are. I can hear it in your voice.
No, I'm not. You're lying.
The thing is up on you.
Stop it. Let me finish what I was saying. Everyone told you. Let me finish. So these Gaussian collisions are no different.
A script, Sammy.
I would just let him read the
Sorry
script.
if it's the common knowledge of physics. So maybe I'll use words that aren't what I learned. But
let him read his script. Go ahead, Zanuck.
The point is, all you need is a force to contain air, contain a differential pressure. If we have higher pressure at the ground level than up at 30,000 feet, which is 3 psi or 4 psi or 5 psi, whatever it is, at some mountaintop, that's a huge differential pressure. It doesn't expand into that void. It doesn't, because air has weight, and that weight is a force no different than a physical container that you need in physics class to do some of these tests of gas law. If I increase the volume, what does the pressure do? What does the temperature do? All that uses containers. That is extrapolated out into the atmosphere. Those forces are no different. And if you think they are, you're wrong. Period.
I have a question when it's my turn.
In the created environment.
He's just gonna like hand wave it, start blabbing about something.
You have these in the created environment that you just talked about, right? We have all of these forces that are only possible, like you can only create a micro version of it inside of a container. You saying that that's how the atmosphere works is begging the question. You do know that, right?
It's measurable.
It's not.
You can measure, observe it, test it, validate.
You can measure what?
Well, hold on. The measuring the differential. Listen. Measuring the differential wasn't in question. Physics and chemistry wasn't in question. All I said was, well, in the classroom, well, obviously you're roboting whoever this is.
How?
Is that Nidhug?
No,
Fuzzy.
Can't
sometimes you can't take yourself off of mute like it. The robot.
I know. It's like he could have stopped like literally 30 seconds ago, and it's still going.
Well, even when you press exit, it doesn't take you out sometimes.
But yeah, the idea that all of these forces are in play isn't in question, because when you induce the effects here, all those forces are in play. Let's just say in a contained environment. You can't use that to bolster your claim already is that the atmosphere is in of itself contained because of the weight of the molecules. Like it's already that.
Perfect.
You're not proving that. Right, but you're not proving that by using an example of something with a container here on Earth.
No,
you don't need a container.
We just add a force to it. Force is a force, of course, right? Like the horse. A force. We add a force to something, whether it be from a container or we add acceleration to it, like we put air in a cup.
Well, how do you add weight?
Hold on, Elijah, you're doing it again.
How do you add weight?
Elijah, you're doing it again.
Can you manipulate the weight of
air?
Gases?
Yeah, we can change the mass of the air and see that it increases.
Oh my God, this sounds familiar, but okay. My
So
bad, guys.
Well, here we go again.
Don't be offended.
I'll do a quick synopsis of my my rant from many years ago. We put air in a container, we weigh it, and we put more air in the container, it weighs more. And it weighs more because the velocity going down is greater than any other direction. That's the vector that's due to
so you don't even do anything, you just add stuff.
I would propose
That's
that the pressure changes the state of the air to more of a liquid state, and it becomes.
No, we know that.
Yeah, it doesn't change states to liquid.
Make sure that we know that air does not change into a liquid at 500
Do you think
psi.
air doesn't change into a liquid? But can I ask my question real quick? Because
it doesn't change into a liquid
up.
until it condenses into a liquid.
Yeah.
It's a change of
Yeah,
state. Hold on,
causes
Rakia.
that?
Changing a state has many principles and characteristics, i.e., latent heat energy changes and
pressure
volume will change. God damn it, Rakia, you are the problem. You know that.
Dude, I just asked a simple question.
No, you clip people and do all this shit that you whine about other people doing, and you do it worse than anybody.
Dude,
So
I've
shut up for a
opened my
second.
mic
Let me
just
finish the
once. I
sentence.
just asked you a question.
Hey,
Rakia,
Rakia, you can't speak over him. You got to let him finish what he's saying. All right. Even
It
if
was
you have a
within the
valid point,
conversation.
Rakia, you got to at least let Zanuck finish his thought, even though it might be a little long-winded. Zanuck be a little bit more poignant
Well, I would have
on
been
what
if
you're
it had been
saying. I know, I get it. Just don't talk over each other, guys.
Yeah, good idea. And let's try to do that, Rakia. And I will as well. I was being very brief. I said in one sentence that air has weight. We can add more air to a bottle, increase its pressure, and increase its mass, and it will weigh more. And you're saying that certainly the state of the matter does not matter inside of a container. We know that the velocity of the air molecules are greatest going downward due to the air having weight, due to having this attraction, which we can call hydrostatics if you like, or electrostatics, as Witzel would call it. We don't care what causes it. We know it's a real thing. And that force can be added to any gas or any mass that is sitting on a scale.
Hey guys!
Wait. I'm not going to be told to hold on and then go on mute and then have someone jump in. So, Zanuck, does pressure have anything to do with that? As you add more air to your container, which you say is not necessary, but you seem to insert a container every time.
Pressure does not change weight.
But you're adding pressure, right?
We're adding mass.
But the pressure goes up, right, in the container?
Correct.
And the weight goes up?
Yes, because we added more mass.
But the pressure went up also, right? As the weight
I can have a smaller container with less mass with greater pressure and have it weigh less. So that's the wrong answer.
Pressure goes up in all directions anyway, except there's more pressure down than there is up.
Okay, let me ask my original question and I'll be done. I promise I'll go on mute because I don't believe much of what they say anyway.
It's okay, Rakia.
Just calm down. You don't have to go there. You don't have to clip me and then tell me I don't understand. So Zanuck, the pressure is higher at your feet than at your head, correct? You stated that?
Yes.
Would that create airflow? High pressure to low pressure?
If air didn't have weight, there would be an airflow, but there's no airflow because of that.
Well, because of the air weighing, it doesn't flow because of the pressure change?
It doesn't flow because of the pressure change because the air has weight. Yes, it's at equilibrium. That's what hydrostatics is all about, equilibrium.
Mm-hmm.
Yeah, I get that.
Way asking.
Yeah,
you're talking yourself in circles with these questions.
Little follow up. What pressure change does create airflow? Like how much do you need to overcome the weight?
You hit it on the target. You hit the target right in the bullseye. Whatever exceeds that pressure or that weight will be the direction of the flow. So if you exceed the force, if you can exceed the force that the pressure is innately given to that body of mass, a body of air, then it will move. But if it isn't, it'll be in equilibrium and it won't move. And it'll be a hydrostatic stacking of the air molecules where the most of the force is at the bottom and least force per square inch is at the top.
Gotcha. Would you say 14.7 to 10 to the minus 7 would create airflow?
No. Why would it?
I'm just asking. So you're saying it would?
It depends on the distances involved.
If you have enough mass, if you have enough mass, enough weight, then that will counteract that pressure differential. Because it'll be in other words, it'll be. Oh, I'm still talking. It will be in that equilibrium. So up at 100,000 feet, when there's almost zero pressure, 0.015, and the psi, and when you have 14.7, Air doesn't go upward because it's at equilibrium because of the weight of the air over that distance is, and that amount of mass allows for that pressure differential to be in equilibrium. Now, once it's disrupted, once you add more forces or add more air somewhere, it will start to flow. Like you put that pressure up at 0, where would that air go? It'll start traveling downward.
Like several points at once. You answered the question right off. You could have stopped, but so you're saying that the 14.7 to almost 0 is not going to create airflow because of the distance and the weight of the air involved. The mass.
Perfect. Couldn't have said it better myself.
That's what you're saying. So a vacuum, like a Hoover vacuum, creates a lot of differential in a short distance.
No,
I thought it was 72.
Very little differential.
Right
Maybe 1 or 2.
Well, high to low pressure in a short distance.
Only produces a 1 or 2 psi difference.
Are you talking about 1 Hudson, 75?
That short distance is what creates the sucking motion, the air movement, right?
Well, you've created a differential. By definition, that's why you flow. In our atmosphere, there's no differential, so there's no movement.
No differential from 14.7 to
No
0
differential
because
forces because of the weight. The weight is balanced.
For someone who complains about it just
no, I was trying to help
5 minutes ago said, let's not talk over each other. And you clip me almost every time I've opened my mic, dude. So anyway, all right, cool.
I was just trying to answer the question.
So,
coming out clearly.
But Zanik, so you're saying that there's no. Okay, so the distance between here and Jupiter, right? The space, that distance, nothing. So creating air from nothing is going to create airflow when there's that much distance.
How are you? Who's creating air from nothing?
Well, no, but I guess my point is that the reason it's not creating airflow is because gravity is affecting the gas.
Yeah, gravity gives air weight. Now, that gravity can be caused by electrostatics. I'm not going to say it's this magical, mystical bending of space-time. I don't even want to go there. Some force, whoever knows where it comes from, I don't know, you might know, or not know, is causing air to have weight. The fact that it has weight is the fundamental foundation of hydrostatics.
But again, you can't demonstrate that without. You can't demonstrate that beyond a logical fallacy. In this case of the Earth needing some sort of containment, or like you can't demonstrate that claim except in this one case where it applies to Earth, and you have to trust it.
Who said it requires containment?
All you need to do is give that air an acceleration, which gravity gives it, this attraction gives it, and you will create air having weight. For example, if I put air in a container and I accelerate it at, 100 meters per second, that air will have weight against the back of the container. Pressure will increase. It'll be a differential, just like it is on the Earth. We can actually show very clearly that this is what's happening. Hold on. We can show. Well, we can show that's what's happening. All you need is air to have weight.
Just like it is on Earth. Sorry to step on it, but you just said just like it is on Earth. But no, Earth
force.
is not a container. No,
I know.
But you can't demonstrate gas. But gas inherently is not affected by. It goes off in all directions.
So if we have this container, real quick, if we have this container, we should be able to detect this container, right?
You missed the point about the force, Fuzzy. I said there's a force. We can give a force. We can give a force which gives rise to an acceleration to air and see the pressure rise. Just like on Earth, yes, we have the force, which is its weight. Forces they don't know each other. All forces are just forces. They can give it mass and acceleration. Right? So we know that these forces, but whether it's caused by a container or not, we don't matter. We're just saying that the force is there, and that can cause containment. That can cause.
But if there were some sort of container, we would be able to detect it.
No, so you said the force. The force in this case is gravity. You're talking.
You might hear me,
right? That's the force you're talking about.
No, the force is
specifically ignoring you.
The force is the weight. Force is the weight caused by gravity.
The force
straight.
That's called resistance. There's only resistance.
I can cause a force by the container, and I can cause a force by acceleration. I can cause a force by gravity. It's caused by something. Something causes the force. Regardless of how it's caused, that will cause hydrostatics.
Are you saying that weight is gravity manifest?
I'm saying, I said it very clearly. Weight is caused by gravity. This force is weight is caused by gravity. It can also be caused by by moving something, accelerating something. It doesn't have to be gravity. It could be something else too.
Right. Okay. But I guess this is the.
And you don't need a container, by the way. I can have a wing.
But I guess container.
But
to do it with gas, you absolutely need a container.
No, I can fly a wing through a medium
Earth
and
is
get
not
it
a,
and
Earth
get
is
it.
not a wing.
Xanac,
Earth
you
is
keep
not a
saying a
wing.
No,
medium. A medium.
the Earth has
Hold
a
on.
surface, doesn't
A
it? Hold
medium
on.
would.
The Earth
Is it
has
a
a surface,
wing?
Fuzzy. You're talking in circles, and you're talking over.
Is Earth a wing?
No, the Earth isn't a wing. I'm saying you can develop forces many different
how
ways.
can you demonstrate it on a sphere
Yes.
of some sort?
Surface of the Earth. The surface of the Earth
Yes.
Or
is
and
creating the
actually,
force.
you could throw a
You
ball
guys
in the
say
air,
it's
and that would
riding
form
on
a
the
pressure gradient
vacuum.
around it because the air is
Well,
moving around the ball.
You're saying it's riding on the vacuum of space, and that's not possible. We're
Okay,
trying to tell
DMOC,
you
now's
the
not the
air is
time.
not
Go back and
riding
play with
on
your
no
toys.
resistance. You keep talking about the word resistance,
Go back in the
Xanac.
corner and play with your
Resistance
GI
builds
Joes.
the word force. Without resistance or differential from one thing to another, you don't have force. So now, if there's no resistance of space, there's no resistance. Where are you getting the resistance from?
Did you just pull a Pete, Democ? You started with a false
Where are you
premise and
getting
then
the
kept going,
resistance
building
from?
more
It
premises.
sure sounded like it.
Yeah, well, it's called resistance. You just named 100 things, and it's no different resistance. Now, space is what? No resistance. So how do you have pressure with no resistance? Demonstrate.
Force and pressure are different than the word resistance. You can equate the two, but you're doing it wrong, Democ.
No, if you don't have resistance in your equation, you're doing it wrong, Duford Mock.
Good job.
I still don't understand how we wouldn't create airflow from 14 psi to negative whatever it is between
Not
here and
negative.
Jupiter.
I know
Whatever.
you don't. And I'm trying to explain why.
Yeah, but no, but but here's the thing, right? So the further the air gets out, the further apart they get from each other because the sphere gets bigger, right?
What?
It's not because the sphere gets bigger.
The sphere of atmosphere gets bigger.
The volume gets more.
That's not the reason that they're separating.
Well, but as they
that's
go
one
out
reason.
further, they're separating from each other in all directions outwardly, right?
They're mostly
The
they have a vector
separation,
down.
the separation does not come from the size of the shell around the surface of the Earth. The separation comes from balance of pressure versus weight. That's the reason. Pressure versus weight. That's the only
You
relationship
don't
you
have
need
any
to
of that.
acknowledge.
Gravity zeroes everything out. Gravity is in the chewy gobstopper center of your gobstopper. It's already centered out.
You need
What
a
do you mean?
gobstopper. Go ahead. You need that
Well,
gobstopper. Go
for
chew on it. Go in the
gravity,
corner and play with your toys.
gravity in the center of itself would zero itself out automatically, would it not? Hello?
Look, Fuzzy had a real question, and we're trying to help him answer it.
No,
You
no,
jump
no.
in.
I got a real question that's
No,
original.
it's
You
his
just want to.
turn. He doesn't
Listen,
understand
I'm
how
asking you
this.
how gravity is in the
Yeah,
center, but not zeroing itself out. Hello? So you don't comprehend gravity.
No one wants to talk to you when you act like
Center
this,
finds
D-Mock.
everything to the center. You understand, right?
Fuzzy, you want your question answered or not?
Well, I don't know. The moment you said like that, that there wouldn't be any kind of airflow of a vacuum difference between
No,
here in the
of course
middle of
not.
space is just I don't understand. I don't know.
Because air
Well, a
has
weather
weight.
balloon can go up there and measure that there's a vacuum up there. Of course,
Really?
then we have to acknowledge that the fact the vacuum is definitely there because it can be measured.
What device do you use to measure that?
A barometer sent up on a weather balloon.
A barometer is not a vacuum.
No,
What are you measuring?
no one sent a weather balloon halfway between here and Jupiter.
It's the same
No,
pressure.
but they got as far as they've got as far as to measure less than 0.1 psi. There's a vacuum up there. It's been measured.
So that means 10 to the negative 17 torque. Is that what one
Shut up,
psi
D-Mock.
is?
Why are you doing this?
So one
Just
negative
diarrhea.
13 to the negative 7, negative
is 10
17
to the
torr
negative
negative.
17. So what is 10 to the negative 17 torque? What is it? How many volts? How much does that weigh?
Many volts. Oh my God, Democ.
How many volts?
Huh?
D-Mock,
What?
just give us a break, man.
What
You're giving me a
temperature is
headache.
10 to the
Seriously,
negative
man.
17 torque?
D-Mock,
Oh, for
you
fuck's
realize
sake.
everything you say
So
makes
you
no
don't know?
sense. And it's just
You don't know
funny
any of
for like a
this.
minute,
A
but now it's
vacuum
getting
has a
old.
temperature. What temperature is your 10 to the negative 17 vacuum? You say
Fuzzy,
you're
this guy's on
Literally
your
by
side, by the
definition, a
way.
You
vacuum
say
doesn't have
you're
a temperature.
measuring a vacuum with a barometer, which is
Fuzzy, when
supposed to
he's done, let
measure
me know when you want to answer.
resistance. right? Everything you guys have is only measuring that resistance. This, and this. And you keep making up phenomena after phenomena, which makes no damn sense. And it's just electrical resistance from something trying to find its equilibrium.
Yeah, right. A barometer's made up. Thanks, Demok. Way to go.
No, I think the problem is that a barometer's not made up, but that no one took a barometer to a made-up area very far away in between here and Jupiter.
Why do you keep
Okay.
on saying
It doesn't
Jupiter?
have
To go that far, as I mentioned, a weather balloon can go as far as to measure less than 0.1 psi atmosphere up there to measure the fact that there definitely is a vacuum up there.
Surely there are probes that have them though, huh?
Yeah, near zero. I mean, very close to zero. We don't ever get zero. Even between here and Jupiter, we don't get to zero.
Yes,
We
no,
get
that's
very,
the thing. So
very
what is
close
it?
to zero.
How much does
Right.
a
How
My
much
God,
is it
Demog,
between?
what is
Yeah,
with
Demok.
you?
Yeah. How much is it between here and Jupiter? How much air exists between here and Jupiter? Like, in a, I don't know. How would you even
Generally,
quantify that?
10 volts.
10 volts. Yeah, listen, it's generally accepted that in space, the pressure is
Well, no,
roughly
generally
around.
accepted. I'm so sorry. We're not worried about what's generally it's generally accepted that the
Well, the
tooth fairy
value
is
is
real.
10 point. They've measured, and it's a statistical measurement too, because there's so far a distance between air molecules that never touch. So actually, you have absolute zero between tests. So you test it, and you'll say, "Oh, it's absolute zero." And then there'll be a collision, and I've measured 10 to the minus 17. Statistically, is what they measure to be space.
Right.
Negative
We
10.
get into the realm of fractions of an atom per cubic meter by that point.
Okay, and you still don't
On
think
average.
that airflow would happen?
Why would
Like,
it happen if you have it
well,
forced?
because again,
This
so
guy
the,
has
the
wait,
further
Fuzzy.
the
Let me
further
ask you a
you
question.
get
It
out,
was my
the further
turn.
away
Fuzzy,
you
it was
Zach,
get
my
from
turn.
the
able
Honey,
to interrupt every conversation
no, it was
that
my turn.
everybody has
So
repeatedly for the last 10
He
minutes.
asked me a question. I was answering
No,
it. Yeah.
stop it.
Nothing.
Just where
no,
is the mod here?
yeah. So here we go, Zanuck. Right, the Earth right now, right at like.
Yes.
Right, all right, and the further you go out, halfway between here and Jupiter, that sphere gets bigger of air, correct? But also
No.
thinner at the same time.
No.
Thinner. The molecules
No.
are thinner
It gets to a point
Interrupting again, Zanuck. Interrupting
I
right
He
in
did
the
kept
say
on
middle of
right.
the
asking a
I
sentence.
did say right.
question. He said
I
right,
did say
right.
right.
I said no.
I did say right.
Right.
Rocky, you're not the fucking policeman here. Shut
Jesus,
up.
fuck. Shut up and answer the goddamn question.
Right. The size of the whatever shell size that you have, the amount that it has spread out is not the reason why the atmosphere itself is spreading out. The reason why it's spreading out, as I mentioned earlier, because you're asking it again for some strange reason, the reason it's spreading out is the balance of weight to pressure. That relationship is the thing that you need to acknowledge. It's not spreading out because the sphere is getting spread out. That's not the reason.
Well,
Seriously,
the
so
reason,
but the molecules have to cover the same amount. Like, what do you mean? The
yes, the
further they
Right.
get
volume's
out,
That's not the
increasing.
the
relationship
thinner
that's
the air
occurring.
is going to be because they have to travel for. Like, what do you mean?
Right. That's not the relationship that's occurring there. The relationship is that the weight and the pressure are in balance.
With pressure of what?
Oh, I see. He doesn't want to use volume because he doesn't want to invoke a container. So
Exactly.
volume, as it goes out, doesn't matter. It's not in the relationship of PSI, pounds
Right.
per
It's not
square
about
inch.
what you want to do, Rocky.
Yeah,
Thank you for involving yourself for no fucking
yeah.
reason.
Yeah,
So
no problem.
no.
Because as the
Actually,
volume increases, of course, the pressure would get lower if the same amount of air is in the volume. If you
Yeah,
increase the
that's
volume,
not
the
the
pressure would go
relationship that
down.
we measure,
As you
Rocky.
interrupt
Thank you.
me, as
yeah.
you tell me you don't want me in the conversation.
Right, because you're not doing anything here. Because I
No.
just
He
You mean
actually
talked to you
besides
earlier.
pointing
both
out
of
as
you
the
guys. Both of
volume
you guys.
gets
Nothing
All right,
to
bigger,
do
the
all right,
with
both
pressure
the
of
will
you
go
guys.
volume.
down?
The
Stop.
relationship between the
Doofus,
two is
stop.
actually about the pressure and the weight, has nothing to do with the volume.
No, actually, it does. So I said
Volume would have.
the sphere around me,
No,
right
actually it
at
does.
Earth, on Earth of air. That you're saying that the volume of air that is encompassed, if I take that and enhance that sphere to the size of here to Jupiter, You're saying that the volume of places where air can go is not increased?
No, that's not what I'm saying. What I'm
That's what
saying
I'm
is that's
saying.
not
That's
the
what I'm
relationship.
asking, though.
No, you asked me a question, and now it's my turn to answer. That's
I'm
not the relationship
clarifying the
that's
question.
being. You go ahead and keep talking, but it's going to get unbearable. It's going to get fucking unbearable if you want to keep talking over me.
I'm pretty sure
All
I
right.
am a mod,
Let's
right?
go
And
ahead
I'm
and
clarifying the
finish
question
answering the
for
question
you.
that you asked me. So
No,
here we go.
You asked
Because
me
it's
earlier
not
why I'm
about,
asking it
because
again.
oh my
This
god,
is
dude,
why. I'm
God,
trying to
here we
clarify.
go. Let's make it unbearable. All right. It's not about the volume increasing. That relationship is not what's followed. If you look in the chat, the relationship has to do with the pressure and the weight of the air. We know this because as you look at the altitude on the left side of those graphs, the volume is not what's being, that's not what's the relationship that's being followed. The logarithmic scale on the bottom of the left graph tells you this.
Fuzzy, can you hear me? I'm going to say something really quietly and really calmly. Can you hear me okay? Fuzzy?
Okay, I'm still.
It's a yes or no question. Can you hear me?
I was trying to answer. What did I didn't even hear what you said because I was talking.
I'm going to say something really quietly and calmly about this whole topic. If we had a box and all the way out to Jupiter, and if there was no Earth, all of a sudden, boom, it evaporated, and all this air under 14.7 psi under pressure, and the Earth was suddenly removed. It means the forces on that gases were removed. All that air would then traverse the solar system out to, or this box that includes out to Jupiter, and it would evenly spread out, completely evenly. And the pressure would go down exactly proportional to this increased volume. Okay? So there you'd be right. But we don't have the Earth evaporated and missing. It is there. And it does induce a force in mass, and that is called weight. And that's why the molecules of air are hugged around the Earth, because the air has weight due to this mass attracting mass for whatever reason. Could be electrostatics. All right. So that's the reason why it doesn't spread out everywhere. I think that's the simplest way I can.
For whatever reason.
I'm almost done. That's the simplest way. Let me just give me closure. The simplest way I can explain it to you. Now, do you understand that? Because we understand gas law.
Yeah, gas law. Yeah, you need. Okay, so we're making a box. You want to take Earth, put a box around it, and put the air in that box. Right now, I want to make a ginormous fucking box.
And Jupiter's in there too, way far away, right?
Way far away. And now I take that same amount of air that's in that one box, and now I remove the one box, and now it all fills into that other box.
Right.
And the volume increases. Correct?
If the Earth was removed. See, right now we have a box around. You saying we have a box around the Earth? I mean, you're taking the analogy too far, but you're saying there's a small box around the Earth?
Yeah.
Okay, the small box around the Earth.
That would be 14 psi, like, right? And then we remove that box.
Well, not always.
Right, we take that
it's 14 psi at the surface, and then near the end of the edge. Let's say it's a box, or can we have it?
Right. Okay.
Hold on, Fuzzy. We can do.
Hold on. This is my example.
I know we can do it, man. I know we can do this. Let's try to help each other.
I'm trying to clarify it so we're not talking over each other about what we're not talking about. Okay. Earth is a ball, and any ball, right? And we put a box around it, small, and we have that air there, and that's staying there. Okay, great. And now I take a much bigger box and put it around that. Now I remove the box that's around Earth. What's going to happen to all the air that's around it?
Nothing.
Nothing. It's just going to sit there.
Yeah, well, because the air is. Remember at the edge of that box, at the edges of this box, we know it's zero pressure, and the air is not moving there. It's not going and equalizing anywhere, which is part of gas law. Gas law says if you put pressure in a box, add pressure, it should be even everywhere, biting no other forces. But there are forces, and we can't
change the box.
We can't even hold on. Let me just finish. And we can't even do that on Earth. We can't even get a box of air without seeing a gradient in it. Why? Because air has weight. Same thing happened on the Earth box. You said we moved the box. The edges were zero pressure anyway, so the gas doesn't care that you made the box bigger. And now you made it all the way out to Jupiter. It doesn't care. But if the Earth was removed, instantly, bam, yes, gas would scatter in all directions and equalize in all directions.
So,
well,
so
actually, now
if I
it
increase, so
actually go
if
to
I
Jupiter.
give
It actually all
gas
go to
more
Jupiter.
space to roam, if I give gas a bigger box, it won't fill the box.
There's no other forces acting on it, and that could be all sorts of different forces, by the way.
Right, and forces by you saying whatever which you can't actually describe, articulate, or show.
I can. I did. I said air has weight.
You said mass attracting mass, or whatever.
No, I didn't say whatever. I said if air has mass,
or whatever
it has
is causing gravity. Because you guys don't
gravity
know.
causes air to have weight. So
but you don't know what causes gravity. So this is all just like
Let's say it's a flat plane, and the flat plane was accelerating through the universe, creating this hydrostatic pressure as well. Same situation. Of course, we have to have this box moving, accelerating constantly, but the same thing would happen in your world, or the Flat Earth Society world, right? It's accelerating 9.8 meters per second in one direction, and it would hydrostatically stack up all that air on that plane, and you have this box around the plane. Same thing would happen. It wouldn't go anywhere. It made the box bigger. Same thing would happen. Air wouldn't go anywhere. It'd stay right where it was around the plane. So you're just not understanding the basic concepts. We're trying so hard to explain them to you. And by the way, we're doing this not to be dicks. We're actually doing it out of the goodness of our hearts. We see this wrong, and we're trying to help.
You're trying to help by explaining what you don't. Oh, you said mass attracting mass or whatever is exactly what you said. You're right?
Hey, if mass attracted mass and comets have a trail behind them, why doesn't the atmosphere stay around the comet instead of having a trail?
You know what that trail is?
Do you?
I do. Do you know how it can actually lead the comet? It leads the comet sometimes. You know that?
Is that relevant to his question, though, Zanuck?
His question was relevant to our discussion.
It's dealing with gas law. So is gravity accounted for in gas law, by the way? When Fuzzy Swan is talking about increasing the volume, isn't volume one of the things in ideal gas law equation, right? So if you're increasing the volume, won't that affect things?
Yep. You have Gay-Lussac's law. You have Boole's law. Yeah, you have laws that are related to containers. And if you increase the volume, what does the pressure do? What is the temperature? If you keep the container the same and you increase the mass, what happens?
Yeah.
We know all that.
All right. So within
this isn't
I gotcha. So within all of those laws, which one of them accounts for gravity? Which one takes gravity into account within the gas laws? Okay, thanks.
You got me. You got me there, huh?
What is a molecule?
Do the laws say that the pressure would equalize?
So what's causing the weight of the air then? If you don't know what gravity is doing, how you can account for it?
Newton
how
says
is it
the pressure
causing it?
Pardon me. What was that?
That's what I was asking. What is the air?
T-Mod, quiet, please. Fuzzy, what'd you say?
Shut up, Zanuck. No, nothing.
Let me go after Zanuck. Don't tell people to shut up. I'm after Zanuck. Go ahead, Zanuck.
So what did you say, Fuzzy? You asked a question. I didn't hear you because D-Mod was talking over you.
Well, I just don't understand because you're very adamant that gravity is what's causing.
Gravity causes air to have weight.
But you don't know what gravity is.
We don't need to. I said it could be electrostatics. I don't care what it is. Never have cared what it is, actually.
Okay, does the gas law, are you done, Fuzzy?
Go for it.
Okay, do the gas laws say that the air is going to equalize and it'll be the same pressure all over the place?
No, Newton says that.
Where?
A equals F over M.
What about when Newton says you have to have sorry, go for it. Sorry.
So the gas laws don't say anything about the gas equalizing. So I don't know why you invoked that when we were talking about the gas law.
Because he was talking about volumes changing.
Yeah, the volume changes. The gas laws say it's going to be a different pressure. You said, no, it's not going to be a different pressure.
because we didn't have accountability for that force with gas law.
According to gas law, according to gas law, it is going to be a different pressure, though, right?
No, only if there's no other forces involved. Yes, only if there's no other forces involved. I'll put.
What force is involved? Gravity
Air
is
has
not a
weight.
force. There's
Air
no
has weight.
resistance.
You hear me?
Weight from where to where?
Who's ever asking that
The
question?
Earth
That
is
Demon?
supporting the weight of the air, right? So
I'll
if
put him
the
in
air
chat.
has weight, what does a molecule of air weigh? Just one.
Well, a cubic meter of air will weigh 1.2 kilograms.
No, I said one molecule, Zanik.
Force.
Can you hear me?
Kilogram force, rather. Kilogram force. Notice I didn't say kilograms because that's mass. 1.2 kilograms. Can you see
You're telling me right now there's 14 pounds of pressure on every square inch of my body?
Correct. Absolutely.
Wow.
If you didn't have it there, you would blow up like a balloon.
Would you not feel 14 pounds?
Not when there's equal pressure on both sides of your cell walls. Everything's under 14.7. Except when you fart. Then
And you wouldn't feel that.
Yeah, why don't I hear, why does my arm in all directions feel? What do you mean? Gravity's going down. I should have more weight on the top of my head and shoulders as opposed to my arms going left and right.
No.
How many pounds of pressure?
Pressure is a scalar. Pressure is a scalar value, and forces have vectors. So it is in all directions for pressure. Weight is has a vector.
All right, how many pounds of pressure do I have to press on you before you can feel it on a square inch?
Measure a couple extra, probably, I don't know, maybe 5 or 10.
10 of what?
But you're saying there's 14.
Air, but you guys remember that the air is supposedly made up of so many different, 14 different things. So when they say the weight of a cubic meter of air, do they mean the nitrogen amount, the oxygen, the hydrogen, the helium, the argon, which amount of which gas?
Well, mostly oxygen and nitrogen. That's 100. That's almost 99% of the air makeup. But when you answer your question, if you're down in a pool or even in an airplane, when you have a 3 or 4 psi difference, your ears pop. That's how you can tell whether you got more pressure acting on you or not. Jeremy.
So I can't feel it on my skin. I can only feel pressure on my body when my ears pop.
Right.
That doesn't. I don't know. I feel like I could press on your skin with my finger.
That's a force. You're confusing a force with scalar. Pressure is not a force.
You're telling me there's pressure, 14.7 pounds of pressure on every square inch of my body.
It's a force per unit area.
Is it pressure? Is it pressure?
Pressure is a force over an area. It's a scalar value. It has no direction.
Okay, so there's 14 pounds of pressure pressing on my skin right now on every square inch, right?
Right.
Okay, and if I take my little finger and press even 1 pound on your skin, you're going to feel it, right?
Yeah, so you'd have to double the pressure to feel anything. Because that's what you feel in water. If you go down 30 feet, you feel it hard to breathe. You can't expand your lungs against it. You feel the pressure on your body. It's constricting your body a little bit. That you can feel. That's about double the atmospheric pressure. Not much.
I'm gonna disagree a little bit on that, Zanik. You feel the pressure differential. So like the air that's in your lungs is 1 atmosphere less. When when you're down at level and you take in air into your from your aqua lung or whatever, you don't feel any pressure at that point, except for maybe in your ears, which haven't equalized yet. So basically, when you have the pressure it has an equally opposing force inside of your body as well. It's in all directions.
Right, but he said he just increased the pressure. So I was taking it to be like you have air in your lungs and you have pressure acting. Can you tell? But yeah, if you equalize everything, you'll never tell. You could keep on adding more and more pressure, and you could live at the bottom of the ocean, thousands of psi greater than you are now, as long as everything's equalized. It's all about different. Remember we talked about ISS and other things. It's all about differential pressure. All of it. Got to be different.
I think Jeremy was hung up on pressure being a force. It's a measure of a force, Jeremy.
Hey.
It's a resistance.
Look at the chat. I have the three major gas laws that are understand, and also their mathematical representations. You have Charles' law, which is the pressure and the amount of gas is constant. Then if volume increase, temperature goes up. If volume smaller, temperature goes down. So Charles' law is about the volume changing in the temperature. Bool's law is temperature and the mass is constant, and the pressure varies with volume. That's what Fuzzy's talking about. If the temp and the mass and the gas is constant, the pressure varies when the volume changes. That's what he's talking about. And then Gay Lassik's law is the one I like the best because it's most relevant for most of our discussions. Constant volume and pressure is proportional to the temperature.
Constant voltage, you mean? So there's a differential in voltage and a differential in amount of resistance as you go up, right, Zanik? So you keep saying all these laws, wait, but are you really just describing voltage and the amount of resistance? Like the currency, right? Placed by resistance onto the spring? No?
No.
So you're not putting any pressure on the spring? No electrical force? No kinetic energy?
Yeah,
so when does air do that? When does air put its electrical force scale? This PSI. Like where does that show up on, like when I put a scale out and I like, why does it say 0?
Because you zeroed the scale.
No, I didn't do it. I just turned it on. Why does it say 0 and not 14?
And then it came zeroed.
Why does it not say 14? The pounds of pressure you say is on us.
Because it came factory at 0.
So when do you weigh the air? When can we weigh it?
It's included in the net weight of 0.
So what is it before 0?
14.7.
Can you demonstrate that?
Yeah.
Or are you just making up claims? Demonstrate from start to finish how the scale is made and how the scale reads 14.0 somewhere.
I mean, you can do it. Air has a pressure and a weight. This is easy to tell. You can put a piece of paper on a table and put a ruler under it, and when you smack the ruler like you're launching a catapult, you'll break the ruler off because the pressure of the air is greater than the force applied at the lever.
The resistance of the air is greater than.
No, it isn't. You're just fucking wrong, Demick, like always.
What the fuck are you talking about? There's no resistance there with that paper?
Resistance is, you're not using resistance.
Your hand is resisting one side and the paper's resisting the next. And when you put the paper, it exponentially exerts its own fucking resistance to the medium of air that you're trying to put it through. When you smack the ruler, that's resistance on one side, and there's already resistance on the other side. There's your differential right there. Nothing's pulling from the top down. Your hand is hitting an object, right? The object is sitting on the ground. Everything is exerted that way. Everything is from the ground going up, resisting from the bottom down.
We're just talking about different forces, but when you talk about electricity and you talk about resistance, resistance is the opposition to the flow of an electric current. They have multiple definitions. You're using the wrong definition when you're describing the scenario.
What's an electric current? What's
flow
that?
Flow of electrons. Why are we being sidebarred by this asshole?
Because I'm getting down to the scale. What's an electric current?
Go look it up then. I'm not your teacher. I'm not your teacher.
Yeah, we don't call them teachers, sir.
I already told you.
We can mod ourselves.
They were having a conversation until you jumped in.
I told you the flow of electrons. Yeah. If you don't believe me, then go educate yourself.
Flow of electrons from where? What does that mean?
Go look it up. I'm not your teacher.
The soda bottle on the scale, where the electrons flow at? Is that electron?
Again, I'm not your teacher. If you don't understand
then go away. Then what the fuck are you here for if you're not here to help? Shut the fuck up then.
I'm not here to help. I'm not here to teach.
Hey, NASA Shield, go on mute. Let's pay NASA Shield's trip.
I'm sorry. I'm just here to point out the idiocracies in
every. In the wrong context, that's not my problem.
No, D-Mod, your thoughts are welcome here, sir. If he don't want to explain it or to give his knowledge, then he can go on mute. Someone else can.
Definitely. But when you use resistance in the wrong context, I can most assuredly point it out to you. And if you don't like that, it's not my problem.
You can't just say it, though. You have to explain it to him how he's using it in the wrong context.
So when am I
tell him to go look it up?
in the wrong context. When you go up, it's an increase in voltage. So you have an increase or decrease in pressure or resistance, right? So that's the reading you get no matter whether it's a salt scale on the electrical continuity in the chemical that you have. Chemical electrolysis, that's how that works. That's electricity. You're putting electricity, which is resistance, which is kinetic energy, on the scale. You're giving it a resistance. So if you put a 1 pound soda on there, you're putting energy into the middle of that scale. You're putting energy into it, potential. You see what I'm saying? So basically all you're measuring is potential of something. Really, you're not ever measuring weight. You're measuring the electrical differential that you took it from, right? From the equilibrium that it resided in. And when you take it and place it on the scale, now the scale is a differential with the spring, right? And now the spring can take the energy that you were putting in the ground and give you a reading. And it's just an energy like voltage or currency, right? Like pressure or temperature is all the fucking same. No matter how you want to divide it and say it's different. When you rise up, the voltage increases. Now, how are you going to differentiate your claim versus voltage?
Yeah, it's simple. There's a force. The force of gravity causes weight. We measure the weight as the amount of pressure over an area. There's formulas that very accurately describe this. What you just said, bunch of nonsense. It absolutely, in no way, shape, or form comports with reality. You've taken a bunch of science words, thrown them together in a mixing bowl, and then just spat them out. Absolutely no idea what you're talking about.
Okay, so there's no voltage increase as you go up exponentially. There's no voltage increase. Is that what you're telling me? Can you demonstrate that?
I don't need to demonstrate it.
So you keep spewing nonsense, but you don't need to demonstrate your Lucky Charms model.
No, I don't need to demonstrate. I don't need to demonstrate you claiming that there's a voltage increase.
Lucky Charms physics is what I'm claiming that you have that you can't demonstrate.
I don't need to demonstrate you saying that there's a voltage increase. No, I don't. If you would like to demonstrate the voltage increase like you are claiming happens, then by all means. But no, I don't need to reify your fairy tale.
I'm asking how you reify yours. How do you know what you're measuring?
Experimentation. Your turn.
What? You can't experiment with gravity.
Sure you can.
You can experiment with gravity, make an apple levitate right now.
Sure, we'll go on a parabolic flight and the apple will levitate. Next.
Is it going to rotate around you?
Off of a wait, hold on. If I take a beach ball and I force it under the water, I attach a string to it to a spring to measure its upward acceleration, and I call that, I could call that whatever force I wanted to.
You could call it buoyancy because that's what it is.
But you're saying your buoyancy is, you're going to say gravity, because you're saying that something's automatically pulling it down. But we're not looking at what's pulling it down. We're looking at, it's not going down though. That's the problem. We observe it going up, accelerating, in fact.
Yeah, it's called buoyancy. It needs gravity in order to be a thing. There's an equation for it.
Does it though?
Yes, it does. There's an equation for it. It accurately describes it in every scenario. So yes.
But it accurately describes it in every scenario. Okay.
Yeah.
But so if I create a unicorn theory about the sun coming up in the east, it's accurate every time, right? And by equation, it's going to be there, right?
Show it to us. I don't know, maybe.
You want me to make up a fake equation about unicorns to prove to you that equation will equal it coming up in the sun every day in the east?
Yes,
you don't think I can put something together to make that happen?
I don't think you can, and I don't think you can experiment on it and show for a fact that it's the cause.
Great. So you can okay. Now, when you say you're experimenting with gravity by putting it in something that's the parabolic flight, how is that experimenting with gravity? What's the experiment like? All you're doing is falling with the same thing that you've brought up there.
That's what a parabolic flight is.
Right, but you brought it up.
You remove the downward acceleration from the equation, and then things are in free fall.
But what downward acceleration?
That's what we call gravity. You should really keep up.
What downward acceleration? The only thing I see accelerating, the only thing I see accelerating downwards are the things I pick up or I can see be brought up high and then let go.
All right. Well, that's not my problem, is it?
No, but every time I see upward acceleration in the pool, is that reverse gravity? Well, I mean, what?
We call that buoyancy. I already explained that.
But I want to call it reverse
slow,
gravity.
dude? Are you slow right now?
I think you're the slow one if you're not seeing the example or how to.
I saw the
I'm trying to
example.
make
I gave you the exact word that example is defined as buoyancy.
But you're missing the point. If you just said by seeing the height, the parabolic flight, we're observing something falling down, right? Right. Now, in my reverse parabolic beach ball flight upwards, we're observing something going upwards, correct?
Not the same thing. Nope, not at all.
How is it? No, we're observing it go up. So when we see the parabolic flight, we're just observing it going downwards. We're not seeing the flight go taking off from the ground and going up in the air. We're just looking at it from up in the air down, correct?
You don't know what a parabolic flight is, apparently.
So is that what we're observing? What part of the flight are we observing? The part where it goes up or the part where it drops down?
The parabolic curve downwards, yes.
And
so we're not. So we're ignoring any and all energy.
Yeah, you're ignoring the gravity part. Yes, you are. In fact,
we're
ignoring the gravity part.
Yeah, we're ignoring all the energy that we're putting into whatever it is we're dropping by bringing it up into the air.
Yeah, you're ignoring the gravity part, and you notice that things don't interact the way you think they should when you remove gravity from the equation.
Resistance.
What are you talking about? Like, all I'm saying is
maybe you should go read up on what I'm talking about because you clearly don't understand.
And what you said was that we're looking only at an object falling down from up in the air downwards, correct? That's when we're starting our acceleration, is watching it go from up in the air, which we've given force to bit up there. And all of a sudden now we're removing any amount of force, keeping it there, and we're watching it go down. And you're calling that a force of nature called gravity, correct?
I didn't use any of those words. Maybe you should stop trying to put words in my mouth and listen to what I said.
Am I correct in that assumption, in that explanation?
Maybe, I don't know.
So you weren't even paying attention.
Well, I heard things like force of nature and things we put up there and a whole bunch of nonsense that wasn't at all what I said.
So if you're not going to pay attention or help people talk, why would I even continue to let you stop talking? Like, what are you doing here if you're not paying attention or helping?
Because I say things like that's buoyancy, and you go, you mean reverse gravity, and I say no, that's buoyancy. So who's got shit in their ears?
That's what we're trying to. Because I'm trying. Are you saying that I didn't pay attention in all of my years of school?
Yes. I am saying you paid zero attention.
All you're doing is repeating what I already know. We already know.
Here's an exercise. Here's an exercise for you. Can you say buoyancy?
Buoyancy.
Hey, do you know what buoyancy is?
You already explained how it assumes gravity, correct?
It does not assume gravity. Gravity is in the equation to calculate buoyancy.
Oh, so what's gravity then?
Gravity is the acceleration we feel here on Earth. There's local gravity and there's universal gravity.
Acceleration where?
Towards the center of the Earth.
Okay, but okay, great. So reverse gravity is something accelerating away from the center of Earth, correct?
No, I don't know what reverse gravity is.
Reverse of gravity is not, even if I'm making it up, you can't imagine what reverse gravity is? Are you out of your fucking mind?
I mean, why aren't you a little bit more clear? No, I don't know what reverse gravity is.
Well, if gravity is one vector, what would be the reverse?
If you have 9.82 meters per second going in one direction and another 9.2 meters per second going in the other direction, you have zero net energy and zero net vector. You're standing still.
Gravity is zero.
Okay. Hey. Gravity. Your observation. Gravity is the observation of something falling down to the center of Earth, right? That's what you said. Your observation of that acceleration. What I'm telling you is I can show you an acceleration of the exact opposite vector.
Okay. Where is that?
In a swimming pool.
That's not the exact opposite vector. If it is, then show it to me.
If I bring a basketball up in the air and it goes down from gravity, and if I put it in the pool and I bring it down and I force it down and it goes back up to the surface away from the center, that's the reverse of what it was doing before. Correct?
No, it's not the reverse of what it's doing. It's no more the reverse than when you
Travels in a different
It's no
direction.
more the reverse than when you jump in the air. You temporarily defy gravity, but you still come right
No.
back down. What's
I
your
just
point?
hold it there. I can't just hold the ball there.
Sure.
No, but all we're observing is the moment I let go of the ball to go up, or in your case, the whatever object in the flight going down. You're ignoring all the force it takes to bring the thing up into the air, or all the force it requires to bring the ball under the water, which is hard to do.
The buoyant
you
force,
are.
the density of the fluid it's in, the acceleration of gravity, and the volume of the fluid.
Oh my God.
Oh my God, I gave you formulas that prove you wrong.
Formulas. Jesus Christ. How does it? Okay. So all right. What's the Oh Jesus! I don't even know where to start.
What's the formula? What's the formula for gravity? What's the formula for buoyancy?
Letters prove you wrong, he said. Saying A, B, C, D, Q, F squared.
All these things you supposedly learned in school that you just said you graduated from.
I guess you guys just don't understand.
Did tests on and did lab experiments on to prove that they exist. All those formulas, yes. The things that you supposedly.
Why don't you know what causes gravity then?
Where's the film?
If you can experiment with it.
No one knows what causes gravity. Who cares?
Who cares?
It's still something we can measure and use. So what?
No, you're making up what you measure. You see an action or reaction and you just keep making shit up.
That's your opinion, Demick, and your opinion's worth very little.
That's a fact.
Why would
That's a
you not?
guaranteed fact. Everything you said just was the word resistance over and over again. How does something not be buoyant?
Maybe you
It's
have
called resistance. You put it in the water and it resists the water like an air bubble. The electromagnetic equilibrium, right? That it tries to reach.
Does the other guy want to talk, or you just going to keep spouting nonsense?
Well, how'd you disprove resistance yet? Nonsense. Where's your equation? Disprove resistance, and why doesn't it have it in there? Because everything in the world experiences resistance from the ground up, not the other way around. The ground is what holds stuff. The ground holds everything, not the air, not up.
You've got your computer standing on the floor, then.
Demonstrate the Lagrange point. Hello? Go get two masses or two mountains, put a little lead ball in between them and watch it just levitate. We'll wait.
Your mom is two masses.
Find that sweet spot, that sweet gravity spot, a Lagrange point here on Earth somewhere. So you guys can only calculate imaginated stuff, right? You can't calculate or do anything like physically here in the lab. It's just weird.
Nobody can calculate the ether.
I know you can't calculate anything. You need direct measurement to do stuff. You're not supposed to calculate what your favorite color is. You know what I mean? You're not supposed to calculate certain things that are just a given. Like the tree in my backyard. I'm not supposed to calculate. I can measure.
All right, show me measurements of the ether, please.
Ed, you got some really bad mic issues, Ed. I don't know. It's really hard to hear you.
I'm sorry.
Also, in a parabolic flight, don't you start free falling? Planes going up? Aren't you experiencing this zero-G weightlessness as the plane goes up, or what? Is it just when it goes down? Can you guys hear me? Yo. Hello?
Yo. That's good.
Yeah, so in a zero-G flight, the parabolic flight, you experience the zero gravity as the plane's going up, or is it just down?
All along the path of the geodesic.
You'll experience weightlessness.
Yeah. So is it when the plane is going up or going down?
It could be both, as long as it's following the path of it's geodesic, right?
So the plane goes up and it goes down in a parabolic flight, right?
Like I said, Jeremy, it could be both. Going up and going down doesn't matter.
No, there's no way a plane is
What
being
matters is whether or not
zero
it's
G going up.
following the geodesic.
So if you don't know and you say it could be both, maybe it's neither of them. If you don't know, why are you even answering? It's fine if you don't know. I'm asking someone that knows.
All right, whatever, man. But what I'm telling you
Well, I need
is,
to know.
it doesn't matter whether it's going up or going down.
It matters because
As long
someone
as
just
it's
said.
along. Who said it matters?
I said it matters.
No one in the
You
history of
said it
anything
matters?
has gotten zero G's in a plane going up.
Why does it matter to you? Whether
It
it's going
matters
up or
because somebody just said when you fall at free fall speeds in the parabolic flight that this thing happens because you're falling at the same time getting rid of the 9.8 meters per second squared. So now I'm trying to figure out when the zero G part starts if it happens as you're going up too. Do you know or no?
I'm telling you, bro, whether it's going up or down doesn't matter.
It does matter because the other guy said that we get this zero G effect because we're falling with, and you guys use this all the time. You say we're falling with the thing. We got rid of the 9.8 meters per second because we're falling with this stuff, right? You guys say that all the time.
I don't understand what you were saying, Jim. Remember, when it comes to gravity, falling is just something following a curved path through space-time. And that curved path can go up or down.
So we can fall going up. You're saying we can fall going up.
You can go up and be, have no forces working on you, be weightless. Yeah.
Okay, but we're definitely not falling when we're going up, right?
Yeah.
It's crazy.
It depends now. If you're looking at it from a classical, mechanical perspective, yeah, falling is when the force of gravity is working on you. So when gravity is seen as a force, so that would be when you're falling down. But if you're looking at it from the general relativistic perspective, which best describes what's happening when a plane is, taking a parabolic path and you feel weightlessness, then falling is when there is no force acting upon you and you are following or traveling along a geodesic.
Do you think this parabolic flight? You think this parabolic flight is following a space-time bending geodesic path?
It's following a geodesic, yes. Just look at the diagram I posted just now in Livestream. So you will see there's a part where the thing's going up. Do you see the diagram I just posted in the text chat?
No, I can't look at your diagram, no.
Okay, but in the diagram, for anyone else that can see it, you can see there's a part at the beginning when the plane is still ascending, going up, and you already feel weightless.
No, it's not going. It's slowing down, and your momentum is carrying you forward as the plane changes. It's more like inertia at that point. But
okay, so
you could see it that way, but
I'm glad you figured it out. So we're experiencing
going up.
So we're
the plane is going
experiencing
up,
the weightless
away from Earth.
No, the plane
so
is
we're
going
experiencing.
Not upward. Sorry, John.
All right, Fuzzy. Go ahead, Fuzzy.
No, I just that I saw the diagram that he's talking about.
All right. Okay, we don't need his diagram. I just need to know. See, all of a sudden he knows now we are experiencing weightlessness when the plane goes up. Cool.
Yeah.
So not falling. It's not falling. It's going up, right?
When it
starts
to curve.
Like I said, Jeremy, it depends which perspective you're looking at it from. But this whole scenario is best described within general relativity. If you try to look at it from a classical mechanical perspective, I don't think it would be that well explained, you know? That's
Well,
just me
we know what
Explaining,
falling
Jeremy, is the
We know what.
differential of resistance that he's controlling.
Oh
Right?
my God! Shut up, dude. Just stop, man. Resistance, action, reaction, voltage.
Oh,
Shut
come
Because
on.
up.
I'm talking
Don't
But he's right.
silence it.
Guys,
Mark's
Jeremy.
trying to
he's
help
right.
you,
The
Jeremy. Come
You
on.
control the
plane is the thing.
resistance amount when you put the
But Mark's
airplane
trying to
around
help.
your body. Do not say shut the fuck up unless you can disprove what I'm saying. What you said was ignorant just now. Don't say shut the fuck up when
All
I'm
right,
the only one making a relevant point.
Okay, you've been rambling for like an hour now, and I haven't said anything.
That's
It's
your
my
opinion.
turn. Okay, I can
You're
wait till
wrong.
you're done. I waited till everyone was done to go. Okay, if you guys are still going, go ahead. I'll wait longer.
You just cut me off. That
I'll
was
wait
cool.
longer. Go
Guys,
ahead.
hold on. Both, please.
You love cutting me off.
He's
I know. All you
Demek.
guys do.
I know.
That's how it
Demek, I
works.
get it.
And we've changed
Right.
the topic from where I was way long ago from seeing a
I know.
93 million mile distance to all this dumb shit.
Right, but that is an unfalsifiable claim, and Demek, we get it. I understand what you're saying, and Jeremy, what he's saying is correct, because the thing that's
Did
the
Fuzzy
thing
cut out?
that's changing, the thing that's changing is the plane. The plane is starting to make the turn. That's what's causing you to feel weightlessness, because it's literally moving out from underneath your seat. The seat is moving out from within you, right?
But just
That's
wait.
why
I'm
you.
gonna wait till
But you're
you
not
guys. I'm
even
gonna wait
in
till
your
you guys
seat.
are done.
You're floating
I'll
in
be
the
back.
middle of the plane. What seat are you talking about, Fuzzy?
Okay, if you're on the plane, say the floor, you're sitting on the floor of the plane. The plane starting to go to do that arc that you're talking about, where it starts that thing, is because
Then
the
you start
plane,
floating, right?
yes,
When the arc
because
starts, don't you float?
wait. The only reason you think you're floating is because the
What do you mean you
box
think you're
in,
floating?
because the box you're in now has been taken out from under you.
Yeah, but what do you
And
mean
you're
you
falling.
think you're floating? Have you not seen the videos of the people actually floating? Like, did
you're
they
not
just
floating.
think I'm floating and
They're falling.
you're not floating?
They're not floating. They're falling in a box. The only reason it
Okay,
looks like
cool.
they're floating is because you can see the background, and it looks like they're just floating.
You're right. They're falling, but they're not attached to any seats. There's no seat moving out from underneath them. You know. So this whole seat idea you have,
the floor from they're standing there.
Fuzzy.
And that's
What
they're
you're
not
saying
floating.
really makes no sense, man.
The
No,
plane
they're
is the
standing there.
seat.
Yes, the whole
We
floor of
literally
the
see
plane.
them in midair in the plane. Like the seats have nothing to do with any of this.
Okay. So take all the seats.
I waited till you
Yeah,
guys
go,
were
Jeremy.
done.
Go.
Fuzzy, you just went
Yeah,
on
go
and
ahead, Jeremy.
on. Democ went on and
Go ahead,
on. I
Jeremy.
waited
I'm
till you
sorry.
guys
Yeah,
were
Fuzzy
done.
and
Trying to
Democ
show you a
derailed.
picture. What he's saying makes sense, but you have to see the picture for it to make sense for what you're talking about.
I don't need to see his picture.
All right, go
I don't
for
need
it.
to see his picture.
Go for it.
Thank you, though. Thank you. So the parabolic flight starts as you're going up. Nate?
No,
remember
not
when
as
you
you
didn't know
start.
before? Remember 5 minutes ago when you didn't know if the free fall effect started as you were going up or not? Now we know it is happening when you're going up.
What do you mean I didn't know? What I said is whether it's going up or down doesn't matter, Jeremy. It'll happen going up and going down, depending on whether or not you are on your geodesic along the parabolic flight relative to the center of the Earth. Going up and down
What
doesn't
happens
matter.
is you're going
That's
up
not
and down.
important. It could happen going up and down. It could. But going up and down doesn't matter, Jeremy.
It could or it does.
Sometimes it does. Sometimes it doesn't. It just depends whether or not you are on that parabolic flight along your geodesic relative to the center of the Earth. Up and down doesn't matter.
Okay.
Why do you feel
say
up
that
and down?
Because they say that we're getting rid of the 9.8 meters per second because we're falling.
Yeah, like I said, I personally wouldn't use 9.8 meters per second and Newtonian, gravity and classical mechanics to really explain the situation. I wouldn't do
sure.
that.
Yeah, I know.
Whoever
but it's still
did that,
It's
Yeah,
still
whoever
9.8
did
meters
that
per
should
second,
come onto the
regardless.
mic and explain themselves.
So we're still using 9.8 meters per second, whether we're talking about Einstein or Newton, right? Or does Einstein stuff not fall at 9.8 meters per second squared?
We're only talking about free fall and aerodynamics. Once you put the airplane out of it, you knock the aerodynamics out of it slightly, and now the plane is your resistance. When you take the thing out from underneath you either way, you can experience it because you're experiencing less resistance on your body.
All right, I'll be back. I'll be back.
Jeremy, take a look at the diagram because it starts. It's not at the beginning of when the plane is going up, and it's not when the plane is still going up when you hear it. Like the arrow, the first arrow that's pointing at where you start to feel weightlessness is the very moment that the plane starts not going up anymore and starts its curve. Was where you start to feel like you're floating as the plane drops from underneath you as you were sitting on the floor or a seat or whatever you was carrying you up in the plane. The moment the plane starts, instead of going up, it goes down now. That's
Okay, so
when
the free fall effect only happens when when the plane's going down.
When it's starting to go down.
When the plane's starting to go down. Oh, okay. Not up. I don't know. Nate was telling me it could happen when we're going up.
Because he's saying it's up, but really it's when it's the start of the curve to go downwards the other way, is when you're just going to start to lift off.
Okay, so not up. All right. Nate gave me bad information. Thank you, Fuzzy.
Yes.
Glad we got that out there.
What I want to know,
Jeremy,
is what part
I'm gonna tag you with something that you can read when you get home and you have the time.
I'm not gonna read it.
Why not? Why?
I never have
won't you
time.
read it?
Did it make sense?
I'm not gonna have time.
All right, I'm gonna DM it to you.
I'm still not gonna have time.
What do you mean? But like when you at home having like your 10% juice or a glass of cold milk, just read it.
Did it make sense what I just explained, guys? Did it make sense? Clarity. What's your name?
Nate. His name's Nate.
Nate.
Yeah, well, you can call me Kyrell.
Did it make sense?
What you said makes no sense whatsoever, Fuzz.
Okay. So, if I'm going up in a roller coaster, right? It goes up the ramp, right? And at a very certain point, you start to feel like, whoa, as you go down the roller coaster, correct? The moment that if you weren't strapped into the roller coaster, you would just float away in relation to the roller coaster. But in reality, you're just falling off of the top of the roller coaster tower. But you happen to be strapped into something, so you don't. Right? The moment the roller coaster starts its turn and it's not going up anymore, and it's starting its curve the other way, is when you start to feel like you're not going up anymore. You're starting to float. You're starting to change. So if you had that on an airplane, it's the same thing.
So does the free fall effect start as you're going up or going down in elevation?
As you're starting to go down is when you first start.
That's not what
to
Nate
feel
told
free
me.
fall.
Nate told me it could happen. Nate just told me it can happen when you go up.
I know. He said that what I said doesn't make sense. I'm trying to show it to him.
It doesn't matter, ball or flat. It's still up and down. We know what up and down is. We know what a higher and lower elevation.
No.
Irrelevant.
That matters.
It's irrelevant. Doesn't matter. Doesn't matter. It's irrelevant.
Jeremy, I'm sorry you don't comprehend. It matters 1,000,000%. Whether you're over just a horizontal plane that never goes down and curves around to the other side, or whether it does 100%. Because what Nate thinks is you can fall from pushing this fucking ball upward back to the other. So don't tell me it doesn't make sense what I'm saying. Every time you speak, you make me feel like you're like talking third grade level, dude. Come on now.
Yeah,
use your brain and imagine something, could you? You can't imagine shit, right?
Yeah, if you saw Jeremy in the street, you would slap him. What are you, Demar?
Guys, this is not, guys. Okay, for real. All right.
Nate,
does it really? Nate, does it not make sense that when you were standing on something and that thing dropped out
more
from
than
under
I
you?
agree with Fuzzy and Jeremy. That's all I'll say.
As far as up or down matters, doesn't matter if it's a ball or not or whatever. It's you're changing elevation. You're either going up or going down. It's The same thing on either model. Totally irrelevant. Everything that just got said.
What I really want to know is why, when they say buoyancy is part of density, like if I'm trying to do my from before, right? If I put something under the water and it accelerates up, what part of the equation, like what is it about gravity that is required in that equation? Like,
so I'll be back. I'll be back later. It's fine.
You're roboting, at least for me, really bad.
I got all night.
Here's a question related to this topic, but also related to another topic from the other day. The cause of the density, the density tower, the density, the different densities or whatever. Somebody said that, static is the cause of that, or the, whatever you call it, the static dielectric or whatever. Why is it that you have a density tower in a parabolic flight, it seems like the density kind of goes away, like they don't separate. If it's static, wouldn't that be constant no matter what? You guys get what I'm asking? Did I completely mess up the question? Or can you even hear what I'm saying?
Yo, could you repeat the question?
Okay, the other day.
Tower.
Yeah, in a density tower, I asked the other day, like, what's the cause in the density gradient? I guess it's a better way to say it. Like in a density tower, or even the density, the lesser, air pressures you get up, the air gets less dense. So, and I know the heliocentric model explanation, but if it's the static charge or whatever that's causing the density gradient, why is it that in the parabolic flight, it seems like that density gradient kind of disappears? Because I've seen people have like.
I heard you.
Okay.
I've seen it.
So,
I've seen it. I hear what you're saying. Yes. So I can answer it. So density tower. Oh, go ahead. You're not done. Go ahead. I can answer. I heard you the first time, but go ahead.
No, go ahead. Yeah, if you got an answer, go ahead.
Yeah. So when you move the density tower, right, you can shake it up. You can get in a car crash. You can roll it down some steps, and it gets messed up. And then when it's still again, back to the density tower.
The gradient. Back to the gradient.
Back to the density tower as it should be when it's static with everything properly aligned.
Yeah, when it has to be in equilibrium for those things to align. When something is falling out of the sky,
well, you can't.
It's not at equilibrium.
It's moving.
Yeah, I know. I agree with
You're
you.
moving
No,
it.
Jeremy, you're right. Whatever the density tower is, whatever it is, has to be stationary and at equilibrium for those things to separate. If something's falling out of the sky, it's definitely not at equilibrium.
Okay, but I mean, but the thing is,
stationary.
Okay, so it's only the stationary thing, so it doesn't matter. Well, I mean, if static is the cause of the density gradient, like as I asked the question the other day, shouldn't, since the static or whatever is still in the air, shouldn't the density gradient still be in play?
No, because
it's still there, but I mean, they said it's still there, yes, but they say it's a very weak force, right? You're equivocating it to gravity, so no matter what, when you shake a density tower up or move it or something, it's gonna knock it out of whack a little bit, and then you set it down on the table or keep it stationary, and it's back to business as usual.
Okay, so really what you're saying is you don't really, it doesn't really, the static is still there. It's just that because it's moving. But so I guess it would just have to say that some kind of acceleration is causing the density gradient. Now the question is it static? Is it static or is it the bendy spacetime? So we're back to that again.
I don't know. You move a density tower, it gets jumbled up. You can do it in your hands. You can do it on a zero-G plane. You could probably do it in a, you could roll it downstairs or a hill or something, or you could, there's all kinds of stuff where you can move it and knock it out of whack.
Well, I know my point is it just seems like there's some kind of acceleration that's causing it.
No,
So
it's
the
the
question
mediums.
is,
The mediums are what causing the gradient. The mediums themselves, whatever it is that's in the gradient, is what's causing the gradient, because that's just what the natural material would do when at rest. If you shake it
well,
out,
the
yeah, it's never going to be at rest. Yeah.
well, what the thing is in the parabolic flight, you're kind of neutralizing the acceleration. Because that's why the density gradient, you can shake it up and it will not go back to the gradients. It'll stay mixed up until you stop or get back on the ground or you level off the flight, and then it'll come back up because the parabolic flight.
Yeah.
Why do you think that happens?
It? Yeah. Why would you
That's what I'm
expect it
asking.
though? No. Why would you expect it to stay together while it's falling in air? Raindrops don't all fall at once.
No, but I mean, this is a really good question. How come in parabolic flight this density gradient doesn't stay uniform?
Because
because
it's not at rest. It's
that's
not
a
in
great
equilibrium.
What do you mean it's not at rest? If I have a density gradient in the wind,
out of a plane.
it's not gonna, all of a sudden go all weird.
No, why? If you threw something out of, if I take a I don't know, a can of Coke, and I open it up and I drop it out of an airplane, your question is why does all the liquid not stay inside of the can or bottle?
No, but listen, when the plane is flying straight, or if it's flying, straight up, that density gradient stays normal. But all of a sudden, I'm still talking. Please don't interrupt me in the middle of a sentence. That's just ridiculous, right? So if it's landing, or if it's ascending,
Shut up.
The density gradient. What do you mean? Shut up! I'm talking.
No, not you. Who's ever talking in the background? Man, let him.
Yeah, stop interrupting him. What are you guys doing?
What?
Nate, go ahead.
No,
Nate,
go
finish.
ahead.
Oh, it was Nate. It was other people were interrupting you.
Zanuck, shut up.
Yeah, so if let's say you have a plane and it's landing, right? That plane isn't at rest. But if you had a density like a density gradient in a column next to you, the liquids in that column are going to stay in their fixed positions, even though the plane isn't at rest. But the moment the plane starts going in parabolic flight, the liquids get all mixed up.
Yeah, so you could be on a you could have it on a train. You could have it on a train. You could have this density tower on a train, right? And it'll be fine. It'll keep its the whole gradient as it's supposed to.
Yeah, but the train,
and then the train
is not
gets in a car crash. Bro, why are you interrupting me in the middle of a sentence? It's rude, bro.
All right, my bad. I'm sorry.
So you could have it on a train, where it's moving, density gradient still at rest, and then you get a train wreck, right? And is it going to stay at rest though?
But when the train is moving, it's already not at rest, Jeremy. The train doesn't need to get in a train wreck to all of a sudden not be at rest. This train was accelerating. It was taking turns. It was slowing down. It wasn't at rest. But the liquids in the column maintained.
And neither was the plane wasn't at rest either.
The airplane.
Yeah, I just gave you an example where the plane is landing, and the density column stays, uniform and fine. But the moment the plane goes in this parabolic path, all of the liquids gets mixed up. I've given you two situations where the plane is not at rest, but it's only one situation where the liquids get mixed up. What's going on there?
Yeah, this is where flat Earth messes up. This is where flat Earth messes up. They try to go down swinging with the density only thing. I just don't. I'll never.
I wasn't. That's not what I was doing.
Because it makes no sense.
I was doing at all.
No, there is someone in
I was actually promoting your electrostatic.
I know that. I'm not talking to you though. I'm talking about the other guy in here, and I'm saying they have a valid point here. So the flat earthers should, don't just if you say it's just because it's moving. He just pointed out it can be moving in other ways, and it doesn't do that. So rebut that.
I pointed that out too.
Yeah, no, Jeremy's also saying the same thing. I'm just saying this is one of the things that makes flat Earth look bad.
No, but moving in one
first of all,
direction
terms
is
are
different than
important.
free fall. Free
First of
fall
all, the
is
terms are
different
important.
than
Acceleration is not movement. I mean, it's type of movement, but is it changing that movement? So you can have something moving, and all bets are off. What
Yeah, well, I'm sorry,
Nate was
well, there
talking
goes
about? I was in the middle of a sentence. Really? Is that your time to jump in? Fuck.
yeah, but you
Just let me
fucking
finish
look
the
like you
sentence. I've
stopped
said nothing for an
talking.
hour. I've said nothing for an hour. Do you jump all over me when I say?
Have I talked for
I'm
like
trying to
fucking
bite
3
your
hours
tongue,
already?
Debo.
Everyone needs to calm down and everyone needs to be concise and not interrupt each other, man. You're adults.
Yeah, so what we're talking about is
I've been trying to get in here since
would
Nate
you
talked,
stop
and
it?
then
You're
you
doing it
fucking
again
start
now.
talking.
Just shut up.
I've been waiting.
Just shut up for a second. Fuck, what's wrong with you?
Elbow,
So we
you're
have
next.
something we're talking about acceleration. It could be a turn, or it could be the parabolic flight. Matching the acceleration that we see. Now, whether it's caused by electrostatics or gravity, we don't care. The fact that it is there, things have weight, and that acceleration is something that we know and value to. So we can drop something and neutralize that acceleration until it has terminal velocity, then of course accelerating more. When anything's going constant speed, it's not accelerating. It's still moving, but not accelerating. That's a key point to make out.
Flight, show that.
Okay, go ahead, Elbow. Or whoever was trying to get in there, I think it was Elbow.
That goes a step against gravity because accelerating downwards, it shouldn't have stayed in the gradient. Because if you're telling me that accelerating down is going all making it all go jumble bumble, it is in the fucking acceleration. There is no acceleration towards the ground.
That is exactly why there is. You're backward. The acceleration that we measure, we can actually manifest itself as weight when it's not moving. It has weight. When it is moving, it doesn't have weight. So when the acceleration is actually happening, there is no weight, and that's why things jumbo. But once it stops accelerating, then everything. Hold on. Are you fucking? It's really amazing.
Zanuck, you take long pauses.
Fucking pause. Zanuck, you took a goddamn pause. Shut up.
Yeah, you take long pauses.
No, that was not a pause
Anyways,
at all.
let him finish. Let him finish.
And go back and replay it.
Go ahead. You.
It was a long pause. Let him finish,
all right.
and then
So when
you can go next, Fuzzy.
So when things are falling, there is a matched acceleration because it does have weight. When it starts falling, it manifests itself in everything mixing up. When it stops, you'll start having a density gradient because everything for the given mass will have a different weight per unit volume. That's called density. And that's why things gradient out when there's no acceleration. Pretty simple.
Okay. Are you done? Bro, you can't take long pauses like that and then expect.
Yeah.
I said thank you.
So can I jump back in? Because I think that at least we have to acknowledge there's an acceleration, whether through electrostatics or the bending space-time. So how would you prove either one?
Electrostatics is provable and literally everywhere and testable and detectable, and you can manipulate it.
Hold on a second, though.
Zanuck,
But here, if it's hold on a second. If it's the proof of the density gradient, then electrostatics, you should be able to neutralize electrostatics, and the density gradient should disappear.
How can you neutralize what's always there?
Well, then you can't. If it's always there and you can't manipulate the cause, which means turn it off, then you're back to square one, just like the bendy space time.
Manipulate the cause doesn't mean turn it off.
That's what the fuzzies say about gravity.
Well, turn it on and off, or turn it up and down, whatever you want to do. Then manipulate it, showing that the density gradient will go away when you with statics. Then do it.
Okay, yeah, you can. It's called a Van de Graaff generator, and when you manipulate it, you can make something go up.
I'm talking to make the density. Okay, the question is on the table: is the density gradient is caused by electrostatic? So your phenomenon is the density gradient. So you should be able to manipulate the electrostatics to cause the change in the density gradient. So there you go.
So this is simple. I don't know why people don't get this, but so like the buoyant force.
Oh, you're breaking up for me.
The buoyant force is stronger than the electrostatic force. So it's not an either or thing, right? Like the density of the mediums are obviously, like the density gradient, it has different mediums there. So that's obviously a variable too. But the question is, like, what sets the up and down? That's the question.
Which
Yes,
I think Paul's
That's
asking.
why.
I think Paul's asking. Can you mix up the gradient and the density tower using electrostatic? Is that what you were asking?
Well, then here's the thing. Then the other thing is true. Then you should be able to reverse the density gradient if it's determining up and down by manipulating electrostatic. So you can reverse it.
Yeah, you can do that. Again,
stir it up.
You can make things go up, right? But what people don't understand is electrostatics is super weak. Okay, so you can't just go grab whatever you want. Like you know how much electrostatics you would have to use to reverse something with any significant density, because it's so weak, right? And so that's the point that no one ever addresses. It's like, oh yeah, well, if that's true, then make the egg change whenever I put the egg in there with salt. It's like, do you know how much electrostatics it would take to make that egg move? Like, it's just the fact that it's there. That's what sets the up and down. Now we can move things that are lighter. So could we, in theory, could we do this in a way where the density tower is much less dense and it's much smaller, and then we'd still have to introduce a ton of electrostatics to it and try to find a way to do it safely? Yeah, we in theory definitely could, right? So that we do it on a smaller scale.
Can I ask a question? So is electrostatic caused by the object itself, the mass of the object itself? You said static bond or activity.
It's the relationship of the electrostatic field in the medium and the electrostatics of the object. Okay. So just like
the object has electrostatics and the field has electrostatics. I'm just trying to walk myself through logic here.
Yeah.
And the reason why we can't make the egg move electrostatics, but it possesses electrostatics. We can't match it unless we have another mass. Maybe it has the same electrostatics. Like, say, another egg. So adding another egg, does that change anything with the egg? If I put the egg on top of it?
No. Only your fairy tale claims that it's proportionate to mass. Okay, electrostatics is not proportionate to mass. No, you can claim to prove it, but that's not the same thing. But the point is that with the eggs, did you not hear what I said when I said that it would be so much electrostatics needed? Electrostatics is very weak.
I know, but you said the egg has electrostatics. If it has electrostatics, putting it near the other egg, is one positive to a negative or something? It doesn't work.
That's not what's causing it to move. The cause
it's what
of
sets
the
density
gradient. Yeah.
What makes it go up and down? Where is
the
it? Why
electrostatic
resistance?
Okay, as I understand
the mediums themselves determine how they're going to orient themselves.
I think Witzik can speak for himself. He doesn't need you white knight. So you're saying that the density the electrostatic gradient, where you get all this so many volts per meter above the surface, that's what's causing the up and down. Is that correct?
Yeah, that's what sets up and down. That's correct.
Okay, and then the object itself has electrostatic forces or qualities.
Yeah,
and that reacts with this differential voltage.
Yes. So, but this is the thing. Again, it's
but
very
wouldn't it weigh
weak.
less? Hold on. I'm just walking through. I want to understand your. So we have the egg at sea level, or surface, and as we go up, the voltage is changing. Right? It's getting less. Why isn't the object weighing less?
As we go up, the voltage increases. So it increases. It increases. This is just provable and objective.
No, I'm not arguing with you. I'm just trying to understand.
Okay, so on the Earth, we have an increase of 100 volts per meter.
Right.
So what's called positive charge, which actually just means an excess charge. And then we have what's called negative charge beneath our feet, which is actually just a lack of charge, a deficiency of charge, basically.
Okay.
So this creates the up and down because every system is constantly seeking equilibrium, and we have the positive charge building up. But the thing about it is that people don't understand, this is an important part. Whenever things go up and down, what sets the up and down is the electrostatics. But the buoyant force resultant of the relationships of density is much stronger than the electrostatic force. Okay? It's much, much stronger.
And what would you say causes the buoyant force?
The intrinsic electrostatics of the object relative to the medium, and then the density relationship is what gives you the buoyant force.
Density relationship of the object versus the density of the air around it, the medium?
Well, it's the same thing as gravity. It's the same.
I just want to make sure that if he's saying the same thing, I want to know. And then Because I have a point that I want to make after that. Agree on
You were
what
done
density
talking,
is.
and I went to respond, and now you're just over talking me. I don't know why.
I really wasn't. I was trying to talk to.
It's the same thing. It's the same thing as your gravity. Relative density sets where things are going to set, and your gravity model. Same thing with its electrostatic thing. You guys, whenever we argue relative density, it's always
is that
Y
true?
down.
What's it?
Yeah, the only difference is I can
He
actually
just told
prove
you.
what I'm saying.
He ain't even listening, bro.
No, I
He ain't
wanted to
even
hear
listening.
Winston say it. That's why I asked Winston, not you, Jeremy.
He
just told you that.
The
Okay,
difference is
so
it's
now we
not
have.
proportionate
Okay,
to
great.
mass.
Okay, great. So now we have this buoyancy force, which is based on the density of the object versus medium. We have the voltage gradient, which is the electrostatic gradient that goes up as you go higher voltage as you go higher away from the Earth. And then we also have the electrostatics of the actual object. Is that object's electrostatics different than the electrostatics in the medium? Is one like positive or negative or what?
Yes. So that's what you don't
What the
understand.
difference
And
is.
especially if, normally it'll have like a negative charge. Like,
Don't
for
say I don't
example, we
understand.
have.
I'm trying to ask you. I'm asking
Look,
you.
like,
Don't
so
tell
when
me
we
I don't
have.
understand.
Dude, can you chill, man?
No, but
So
you
we
keep on
have.
saying I'm doing things I'm not.
Oh
I'm
my
trying to ask
God.
you.
We have bumblebees, right? We have bees. What they do is they determine which flower they go to get the pollen from based on its charge. And they actually proved this because they did an experiment where they would add sweet sugar water to some of the flowers, and then they put electrostatic charge on it, and the bees always go to that plant. Once they removed the electrostatic charge, they didn't just go to those flowers. They went to all of them, even the ones with the bitter fluid. And so, long story short, they also do something called non-contact electrostatic pollen detachment. And so they're able to the flowers got a negative charge connected to the earth, and then as the bee flies in the air with a positive charge that increases in the air, it has positive charge flying, and so when it goes over a flower, the pollen will actually levitate up and attach to the bee.
Got it.
Yeah.
So that's a great example. So the question is, and don't say I don't understand because I'm asking you because I don't understand. Admittingly, I don't understand. So if you have this egg, it's floating in water, and you said it has a different charge than the medium around it. Yes.
Yes.
Okay. So if we put another egg next to that egg, they're not going to have any effect on each other because of the same charge.
Well, this is what I keep explaining to you, that the buoyant force is much stronger. If you put it in water, if you put an egg in water, that density relationship that gives you a buoyant force is way stronger than electrostatics.
Or gravity.
So, yeah, I mean,
if you have a light
gravity's just a
object.
fairy tale.
So you
What's the cost of
Like a balloon or
theory
something.
is
I know he's going to act like he didn't hear me talking. I know.
I didn't actually. What would you say, Jeremy? Asking me.
You have something light like a balloon or something, right? You can get some electrostatic charge to it and stick it to the wall, and now it will have an effect.
Yeah, or you can take a balloon, rub it on your head, and then put some pepper on the table, and when you put the balloon over it, it'll levitate up to it and attach to the balloon. Or you can take like a really light piece of like a certain type of like foil paper, and you can take a rod, get a charge, and you can literally hold it under this. You can throw the paper up in the air and you can levitate it. You can just move the stick around and levitate the paper up. So this is the point. This is what creates the up and down. Now, this doesn't work in the globe paradigm, though, because they need something way stronger than that that's proportionate to mass, and it can then explain like planetary movement, and electrostatics would not be strong enough to do that. So,
wow, not only that though, we can actually neutralize acceleration, showing that we know that F equals A or A equals m. Know that objects that have a force applied to them will accelerate. So when we match that acceleration simply as one independent variable, we can then determine that if it is matched, then the force has been neutralized. When it isn't accelerating or not moving, we know there has to be a force there. We call that its weight. So we can actually validate.
Okay.
You're not able to because your excuse is, oh, it's so slight and it's already intrinsic to the atmosphere.
What?
Hold on. Can I
finish?
No. I let you finish. Maybe you might not disagree, but let me finish. But you say something so slight we can't show it because the electrostatics is such a small, weak force that we can't show this differential between the electrostatics in the atmosphere, 100 volts per meter, versus object, which is an oppositely charged object. And we can't simulate that with any tool, any instrument we have, any generation of we have, which is only 100 volts per meter, by the way. We can't show that and disprove it. So you're making it sound like it's unfalsifiable. Am I wrong?
No. Yeah, you're wrong. So we
Why am I
can
wrong?
prove it, and it's not just 100 volts per meter. It goes up 100 volts each meter. It's equipotential.
That's what 100 volts per meter means, by the way.
It goes up. It's
I know that.
And this is the point. I said that if you have
that's a non sequitur.
Fucking bro, Xanax, shut up.
You're spiraling.
No, you're interrupting me.
Shut up, Xanax.
So I said when the density relationship creates a buoyant force, that force is much stronger than electrostatics. Okay, so you need to be able to neutralize that or keep it on a smaller scale so you can introduce enough electrostatics to it to create a difference. Like when you use a Van de Graaff generator and you make a little paint chip float up, that paint chip is equivalent to like the size of Mount Everest.
I know you said that a million times.
Well, then listen to it and actually understand it for once. You're saying that it's not unfalsifiable. You can literally make things float with it. We see it in nature. I just explained what the bees do. So this is the point, though. We can manipulate electrostatics and make things go up and down. You cannot manipulate gravity.
No, that yes, you can very easily. But we've already gone over that. But I'm talking. I'm asking you.
Bending of space time.
I'm talking, Jeremy. You just clipped me. I'm asking you about. I'm asking you about this voltage differential, and you said now it's buoyancy is due to the differential. Well, you're saying it's 100 meter, and I said per meter clearly. That means it goes up as obviously wrongly accused me of something. And this buoyancy force you can't simulate because it's so weak. If you levitate a paint chip, it has the mass equivalent of Mount Everest. So it all doesn't make a lot of sense to me. I'm trying to ask you to help me better understand it so I can put the together, because right now it's still sounding like gibberish.
Hold on, real quick. When you said real quick, you said we can manipulate electrostatics. You said you can do the same thing with gravity. You can't bend space time. You don't even know if that shit is real or not.
That's not what I said.
You said you can manipulate gravity.
I said gravity. I can change the gravitational strength easily by just changing my altitude.
So it's a non sequitur because we can manipulate the cause of it, and you can't manipulate the cause of yours. You don't even know if your cause is real or not.
Do an experiment.
Oh, wait, think about what he just said. He said he can change it with altitude. And the point is that the electrostatic field changes with altitude. The only difference is we can actually prove that.
How?
We measure the electrostatic field on the Earth. It increases 100 volts per meter.
So okay, great. So now we're getting somewhere. Now do that same experiment with your paint chip and see if it changes at altitude in a vacuum. So you can't. You won't. You'll say there's another reason. Show me the test. Make the test at sea level where we have this 100 volts at a meter, and see the strength and the speed at which you can accelerate a piece of chip. And then do that at 30,000.
Okay.
And then see if you're talking over me again. So you're doing exactly like you said I was doing.
Lost.
I'm not. I think. Does anyone disagree that this is a logical way to do science about this claim? Do it at sea level, and I said you could do it by altitude. I said you could too. Then show me the paint chip acting differently. Really? Can I just finish the sentence? Can you show me that you do the paint chip test at 30,000 feet, or even at a mountaintop near you, 1,000 feet or something, high mountain? Show me that paint test. Oh my God! Show me the paint test.
You pause and then you.
No, I'm trying to finish the sentence. Everyone knows I'm trying to say something. I'm sure they can probably finish it by now.
You said the same
but I'm going
thing
to finish
5
it anyway.
times.
Show me the paint chip experiment that shows the acceleration of that paint chip acts differently at 12,000 feet. God, is that hard?
How can you have acceleration on the way down, Xanax? When gravity's supposed to pull everything
now everybody
down,
can just talk over each other. Go ahead.
Will you shut up, Xanax? Gravity is supposed to nullify the resistance of going down towards the center of Earth, correct? So if I'm a human and I jump out of a plane, how can I have a fucking resistance equal to terminal velocity or escape velocity falling down when gravity is supposed to be pulling me down? How do I have resistance going down at all, Xanax?
Dude, just fucking stop, man. Just stop.
Jeremy, shut up with your incoherent nonsense. No, down. How do you fall down with?
Can I come back in? Because I got a question.
Well, can Witsit respond to that, please? It's hard enough dealing with the Globers.
Okay.
So measuring the acceleration Okay, let me just say real fast, and you can measuring the acceleration, right? There's only certain ways that we have to do that. Like we use like gravimeters and stuff like that. It barely changes at all with altitude. It's a very small change. Okay. So if you're asking, I just explained that the amount of voltage introduced to make that little paint chip go up is a ton. Okay. And it's like that paint chip's equivalent to Mount Everest. So you going up there and trying to move it, it's going to be a very, very slight change. But yes, there is a change with altitude, and there is a proportionate relationship to the equipotential increase of electrostatics. So that's the actual variable that we can test, we can prove, and we can show that it has an effect on vector. This is just objective.
Does the equipotential go up with the square of the altitude or linearly? How does it go? You said it's 100 volts per meter, right?
Yeah, it just goes up 100 volts each meter.
So it's a linear relationship.
Yes.
Yet air pressure goes up exponentially.
Air pressure goes up exponentially.
Yes.
Up exponentially?
Not linearly. Close to linearly
So
in the first few thousand feet. Oh, is it time for DMOX show again?
So there's more air pressure the higher you go up, and there's less on the ground.
There's less air pressure, goes down exponentially. Yep.
So at the ground level, we've got less air pressure.
No, I just said it goes down as you go higher. Eventually.
Oh, because that's not what you said. I was just clarifying.
I know. I said if I said up,
you made a mistake.
No, I didn't.
I'm just clarifying.
I misspoke.
I'm just clarifying.
Yeah.
I'm not trying to have a go.
Everyone knows the air pressure goes down as you go. If I misspoke, I'm sorry. So it goes down exponentially.
Yeah, let him go, I guess.
But yet the voltage is only going up. The voltage is going up linearly. So do you find that a little bit odd? Support your claim?
No, I don't find it. I don't.
As you chuckle?
Just
really?
I'm making my drink.
What kind of drink?
Just sweet tea.
But before we get off into drinks, can I come back in because it's related? Yeah. Okay. Different forces can be generated by different things. We obviously would agree. Like my vehicle creates a force, an acceleration. Magnets can create an acceleration. But what if the only problem I have with everything that's been described by Whitsitt is your static could be overcoming the source of another force, which means it's not necessarily it might be neutralizing it, but it's overcoming it, which may be stronger than the force that's causing the other thing. So I don't know if just because you can manipulate it, that's true, you can manipulate it, but you're actually maybe overcoming the other one, but not showing that that's the cause of the other one.
Wait, what other one?
Okay, this acceleration downward, and you cause this paint chip to go up. The electrostatics in the paint chip might be overcoming the other cause of the paint chip going down, but it may not be necessarily showing the cause of the paint chip going down. You're just overcoming it. So it's not. I don't know if that experiment is sufficient to say that statics is the cause of things going down.
It's what sets the up and down. Things don't just go down. All right. So the object being more.
Listen to what I said. You're saying it sets it, but you don't like your experiment is that's your proof. The experiment you set up, the paint chip. Yeah. What only thing you can be showing is that you're overcoming the other force. You're not saying that's the cause of the other force.
When you keep saying the other force, and I asked you what other force?
The force of weight.
Okay, so you can't have weight without electrostatics because everything's
that's your claim. That's your claim, but your experiment does not prove that. That's my point.
Well, actually, I'm about to explain it. So everything that exists is intrinsically electrostatic, and everything on the Earth is electrostatic, and the air is electrostatic, and every medium is electrostatic. So if we manipulate the electrostatics, we can change something's weight. You can't have density or weight without electrostatics. Intrinsically, you can't have any matter held together without it. So, what are you claiming is the cause of the weight? You keep saying another force, then what's the force that's the cause of the weight if it's not electrostatic? So
I don't know. At this point, I don't know. I'm just trying to analyze what's being said on both sides, analyzing your experiment, thinking about all the things I do know about how forces are generated. And I'm saying is I'm not sure if your example is sufficient. Yes, you may be true that the electrostatics is there. Just because it's everywhere doesn't mean it may be the cause of everything.
Okay,
and that's
my point. Well, science is, of course, you're gonna look at what you can test, right? And so we're gonna try to figure out what is the cause of weight. So we're gonna look at all the variables that we can, and we're gonna figure out which one of these variables contribute to the phenomena that we call weight. Okay, and so electrostatics is always there. If we manipulate that variable, it changes something's weight. So what we've done in science so far is prove. Now, could there in theory be something else that we haven't discovered? Sure, that's always true. But the point is that electrostatics is intrinsic in the phenomena, and it does alter the phenomena. It alters the naturally occurring phenomena, weight. So that's what we know, right? I mean, that's the point. Like bending of space-time, we can't do that at all. And so there is nothing else on the table as of now.
Well, here's the thing. Let me give you an example. I can pick the paint chip up off the ground and hold it and cause it to levitate in my fingers. In one sense, I just overcame gravity. And honestly, it would not weigh anything on the scale because I could pick it up just enough where it would reduce the weight. And is it the electrostatics that's causing the weight reduction, or is it my fingers?
Well, you've introduced an additional variable, right? You have introduced a different force. That's right, but this is not the same.
My point.
That's not doesn't
make the thing. You're saying the cause of the thing is the source of the thing, and you're saying you're manipulating the thing. But that's pretty much what they're saying. So at this point, I don't know if I'm convinced yet. Still.
Okay. Well, my point is that all matter is intrinsically electrostatic, so you can't have weight without electrostatics. This is just objective. You can have weight without you picking it up, though. So, like, it's intrinsically there. That's the point that keeps getting skated past. So if it's a variable we know is there, then the step of science is say, okay, we observe this naturally occurring phenomena. Things have weight. Now we want to know what causes weight, right? We were all told that it's something called gravity, which they never proved that, though. Well, we can manipulate a variable we know is there in all matter that has weight, and we can change its weight. So one thing we know for sure is electrostatic cause weight is a cause of weight, right? And now you're basically saying, well, how do we know it's the cause? Well, good question. You can ask that about everything in science, in my opinion. Everything we determine in science is we can quote unquote prove a cause and effect relationship, but only relative to the variables known at the time. There could always be something that you don't know about, sure, but we're talking about what we can demonstrate to be true.
It's called evidence, not really proof. Yeah, there might be other evidence on the road, but right now the evidence shows that we have this force that gives this effect that gives things weight, and that force gravity by bending, attracting. Else you want
Is he breaking up just for me?
Or? All right, whatever. Doesn't really matter what causes it.
Yeah, your mic's clipping, Zanuck. Zanuck, your mic's clipping, and you have no evidence that space-time is bending, causing mass to attract mass.
GPS is one example. Also, laser communications, but telecommunications field has known this for a while.
Wait, watch this, Zanuck. What do you have to say about? Have you ever heard of Walter Lewin, a very famous professor at MIT? I'm not appealing to his authority. I'm just saying that within your paradigm, he explains that everything observed on the Earth, all phenomena, everything that's held together, what causes all the phenomena we see on the Earth, including things going down, is electric. And this is the case for up to thousands of kilometers. And it's only until you get out into space on the planetary scale that gravity is the cause of what we see.
Yeah. Right.
Yeah.
So gravity is invoked when you can't verify it for yourself.
Exactly. Which is why it's crazy flat earthers wouldn't have already put this in the arsenal, because it's like a freaking death blow.
But I mean, I don't even think that, like, because you have to say it even like a very basic level. If all matter is electrostatic and all intermolecular bonds are electrostatic and all the rest, then whatever gravity is, even in their paradigm, it is affecting stuff that is electrostatic. So it's like you can't even get past it, even in their paradigm.
Yeah, exactly, and that's what Walter Lewin's explaining. I'll drop some lectures. You know, like when the Globers like to talk about, you need to go to school. Like, well, actually, it's 2022. You can just go watch a lecture on YouTube. I'll drop. You know, it's occasionally math heavy, but you can skip through the math if you want. But anyway, he explains the principles pretty well. And like you said, even within their paradigm, basically what they say is that gravity just gets much stronger because it's scalar. So on the big scale, it's going to overtake the electric nature of everything and then become the cause because it wouldn't be strong enough.
Gravity isn't scalar, by the way.
Okay. What is it?
Vector.
Really?
Yes, because the scalar has no direction, only magnitude. Vectors have a direction and a magnitude.
Okay. Do you agree that everything on the Earth is electric and that it's not until you get out into space that it would be gravity that causes it?
No, I don't believe any of that. And I don't believe the context where you say everything is electric. I mean by everything. You say that quite often.
Zanuck, I think you're using a different version of the word scalar to what Witz it was using.
Oh, is he using it can scale? How it scales? Maybe?
Yeah,
Scalar
that's
is a
how I...
physics term. Could be saying it that way. I mean, I look for context and I kind of
the way I thought that, the way I interpreted what he said is that at that scale, it then becomes more dominant.
Yeah.
Oh,
Not
yeah,
that
that's so. Yeah, yeah, I agree. I took it at. I kind of took it at that, but as is.
But to be fair, yeah, I mean, there is like a physics attribution to the word of having only magnitude and not direction. So, but so anyway, do you understand? Like when you say, what do you mean when you say everything's electric? I mean, yeah, it's a pretty simple statement. Can you name anything that isn't?
No, we know these electrostatic forces exist between atoms. Everyone in physics. So I guess everything in that sense would be electrostatic. Now, is it electric? What do you mean by electric?
Well, that's what I'm talking about. Yeah.
Electrostatics is not.
Technically, it would be dielectric.
Dielectric is an insulator.
That's what you think, right? So I don't want to go into like how you have aphasia because you were brainwashed by mainstream.
No, I've used that word in definitions successfully, professionally, and it's never failed me. When I get it. Or I've used a capacitor, it's worked exactly.
I don't want to talk about this with you, dude. I've already talked about it with you.
I know, I get it.
Okay. So the point is very simple, though. Everything, we'll say electrostatic for intents and purposes, right? So like everything, dude, everything that exists, like you can't name anything. Like everything has like an intrinsic electric nature, like even a neutron.
We all agree there's electrostatics involved in atoms, and molecules, in Coulombic bonds, and all this.
Or even neutrons. In your paradigm, even neutrons. They just don't have a net charge.
You can't, that's a stretch to say because everything together with electrostatics, that electrostatics is the reason that everything does what it does. That's kind of
I never said that.
It's an unfalsifiable and fallacious logic.
But it's okay to say it about gravity, though, right?
No, never okay to say it about gravity. Because we understand gravity doesn't work.
You know, it's funny.
How that works? We acknowledge it. We know its limitations, but you don't think it has limitations, which is fallacious.
What? I'm saying everything's intrinsically electrostatic, bro.
It doesn't mean it's the force that causes things to move.
Okay, well, we know that is a... Sorry, go ahead.
Sorry, go on. I was going to say, but you can use electricity to move things, so it doesn't matter.
He's not talking about electricity, he's talking about electricity.
You can do both.
Do you not see how they're linked?
I know how they're linked, but they're not the same.
But you can do it with both.
Who said they were the same?
Well, electricity can flow. Well, create a magnetic field. Magnetic field can then create a force. That's a whole different. That's a big stretch saying that just because we have electricity doesn't mean it does anything. Okay.
I know that you're not this obtuse, Zanuck, so I feel like you're actually being obstructive deliberately.
No,
well, yeah, because this makes someone uncomfortable.
Just because electrostatics exist doesn't mean.
But I just answered that like 30 seconds ago, man. Come on.
No, I'm
Your
really.
conclusion, the fact that something has electrostatics doesn't mean that electrostatics is the cause of all attraction.
I didn't
Correct.
say that.
Zanuck
I
said that. When Zanuck said that, I answered it, and you didn't hear the answer either. Seriously, what's
I
going
heard
on?
it, but I keep on hearing that everything's electrostatic, and then maybe I don't understand why you keep saying that.
Well, because you should probably listen, maybe, right? And just for all for the true earthers, like this is how you know that you're talking about something that they're scared of. They will interrupt you and intentionally strawman what you're saying repeatedly. So I did not say that because everything's electrostatic. That proves that's what causes directionality. What I said was the first step is acknowledging all things are electrostatic. Now, in science, what we're going to do is we're going to try to manipulate the presumed cause, okay, in this case, direction, right? And we're going to manipulate. We're going to manipulate.
Wait, hold on. What's it? Direction's the cause?
I didn't say that.
You said we're going to manipulate the presumed cause, direction.
The presumed cause of the effect, and in this case, that's direction.
So direction's the presumed cause of the effect. Direction.
He said it again.
Am I hearing him incorrectly?
Yeah, you are. You're actually hearing him incorrectly. That's not what he's saying.
Direction is the presumed cause of the effect. That shit don't even make sense.
That's what he
Yeah,
said.
he's not saying. No, he's not. No, he's not saying it.
Paul,
I'm not on his side. He said, okay. He said you're manipulating the presumed cause of direction, which is electrostatics.
Oh, okay.
He didn't say that. That's what he was implying.
Jeremy didn't hear it either. I didn't hear that either.
Well,
I did hear it. I was mocking you.
Yeah, I heard it. I heard it fine again.
Yeah, again, this is how you know that you have a good argument, is when the Globers have to do this.
Electrostatics. Okay, got it.
Yeah.
I don't have a
okay.
problem hearing any of this stuff. I don't get it. Other people do.
It's tough to hear enough. It's bad enough. Sometimes when people phrase things,
I said it very clearly. I said in science, what we do is we test the
I'm not trying to be disruptive. I'm really trying to.
Is that why you're interrupting every time? So we're gonna test the presumed cause to see if it's the cause of the effect, which in this case, the effect is direction. Okay. So we're going to manipulate that variable that we know is everywhere in all things that exist, electrostatics. So we're going to manipulate that variable and see if it is a cause of the effect of what direction something goes. And when we do this and we manipulate that independent variable of electrostatics, we make things go in different directions. We can make it go up, we can make it go down, we can make it go down faster, right? We can manipulate the weight of an object detected by a scale, because that's intrinsically tied to direction.
I mean, can't you essentially do a Cavendish with it if you had like two balloons or the balloon in the wall or something and see the attraction between them?
Yeah, of course you could.
Jeremy, let him go for a second.
Side to side.
By the way.
Yeah, I was just pointing that out. Go ahead. Go ahead with it. My bad.
Okay, so what we've done objectively is verify that the independent variable of electrostatics is a cause of the effect of what direction something goes. This is just subjective.
Can we stop? Can you take a break for a second before you go on? I see huge flaws in the scientific method and in your conclusion and in your logic. Would you like to hear why?
Not particularly, but you can go ahead.
You did a test, and you varied electrostatics, saw that you could move up, down, and over, etc. That is not logical to say that. Therefore, it becomes the cause of all weight, all accelerations of objects. That is not how you do science. It's not how you do physics. Because you could do that with compressed air. I compressed air on this, it moved. I could compress air there, it moved. So therefore, compressed air is the cause of direction. It can cause all these things can cause objects to change direction, to have weight, or to create a force. It doesn't mean that they are the cause. That would be your hypothesis.
Okay, well that's a non sequitur, though.
Hold on, it's done.
Well, that destroys gravity as well, then.
What causes all objects to have weight? You're saying it's electrostatics, and then your proof is this contraption that can generate electrostatics and make things move at a very small scale. Don't you see how flawed that logic is?
Good one.
Do you want to know how I define space-time, Zanuck?
Wait. Let him finish it, because I know you have a different...
He hasn't started, so it's my turn to speak. Yeah, I define space-time by putting some compressed air under a balloon. So now we don't have space-time.
Crypto.
Make an opposing force.
All you're doing, you're white knighting him because he knows.
What?
My guy. I don't need to white knight with it. He can white knight himself perfectly well. I'm trying to have a discussion with you about the flaw in your criticism.
Okay. What's the flaw?
Yeah. The compressed air is a nonsense argument.
It added a force, object, and made it change direction.
Yeah, so does
all
that
things
debunk
have air? All things are in air. Maybe air is the cause of direction then.
So if I put compressed air under a balloon, does that debunk space-time?
According to Witz's logic, yeah.
No, that's what you just said.
No, I'm saying that's because it doesn't. I know compressed air.
Then why did you say it?
It's because it is one cause. Like electrostatics is one cause. It's not the cause. You can show that by truthfully, honestly going through the scientific method and doing experimentation. You're not. He's not doing it.
Zanuck, I saw a video.
He says pepper chips and paint chips can be elevated. That's not. That doesn't count. The gravity is a cause of a force in objects, mass.
Yeah, he doesn't get it. That's fine.
Yeah. So
I'd like to chime in for 1 second. I've seen a video of a guy. It's like a 1950s video of a Cavendish where he sets it up and he shows how electrostatics can affect the Cavendish. So he puts in a Faraday cage in order to limit it. Now, what I think is interesting about that is that he charges a Lexon rod, and he puts it next to it, and the Cavendish goes wacky. It just starts moving all over the place. But then he gets rid of the charge on by putting in the Faraday cage, and now the object no longer moves until he puts a big, massive weight in front of it.
Okay. Did he get rid of the? Oh my God!
Why is that not eliminating the argument that it's electrostatic that's causing it?
Yeah, you can't eliminate it. And so when you ground something, then it's connected to the earth and it has a negative charge, and then the air around it has a positive charge. Well, we know what positive and negative does, don't we? Yeah, super difficult, man. It did.
I hate to say this. I hate to say this, though. You know, there is the other side, like, you know, space-time. Like, can you manipulate time? Well, no. But it's always there, and it's something we can do. Something like we can stop it by stopwatch. When you're saying it's always there, but you can't truly manipulate, I mean, you're like saying it's in everything. It's the cause of these forces. But you truly, well, I mean, I'm just trying to make a point. I'm listening to the argument. I'm focusing mainly on the argument. I'm not thinking about anything else. But I mean, I have to agree that at this point, with everything that's been argued, I still ain't convinced that you've manipulated electrostatics to show that it's the cause of acceleration downward. Because if it's in everything, you can't get rid of it. Hold on a second. You can't get rid of it. So that means you can't truly manipulate it because you have to be able to control it to make it happen. It's not sufficient. Sorry.
Paul, think about this. Think about what you're saying, dude. QE's heat water boiling experiment. You can't get rid of heat. Just because you can't get rid of it doesn't mean you can't manipulate it, bro. It's crazy. Go tell QE to that when he brings up boiling water again.
Yeah, you said that I said it's everywhere but can't manipulate it. I didn't say that. I literally said you can.
You can't get rid of it.
I know. I'm talking.
Can't get rid of it.
Jeremy, I wasn't talking to you. He said that I claimed that it's everywhere, but it can't be manipulated. I literally didn't get rid of it.
Well, I'm actually just trying to say get rid of it. So, like, so you're saying is even in the Cavendish, electrostatics is the cause.
Yeah,
not math, because you can't get rid of it. So it's the cause of everything. So that's what I'm saying. It's you get to that point, it becomes the cause of everything. It's like time. Time is the cause of everything. It's the same kind of argument. That's the point I'm trying to make.
It's not the same kind of argument, though, because you can physically manipulate it, and you cannot do that with time.
Well, okay. Well, he can manipulate space by moving an object away. That would be his argument, and you can.
That's not manipulating space. That's just manipulating the object in space. Well,
you're manipulating the space between the object.
No, you're
between the object. You're not manipulating the space. You're not increasing and decreasing the space between the objects.
Okay, but you're not manipulating the space. You're just moving an object.
All right, but you're manipulating the distance as part of their argument.
Okay, but their argument doesn't follow, though, because they're claiming that two concepts are being physically manipulated, but not directly, indirectly, with the begging the question fallacy and then changing mass.
Paul, I don't know if you've ever done. Have you ever done any programming in your life?
Back when I was in high school years ago, which were a long time ago, but no, not to the point where you're asking. No.
All right, I want to go after crypto.
So the way that I see this, and maybe I'm wrong, I don't know, but the way I see it is that you have a programming language, say C++, and then you have programs within that language, right? So the way space is conceptualized, it's actually the room within, or say the rules of the game. So C++ in this case is the rules, right? You have to be able to type a certain thing in order to get a certain manifestation within C++ or Java or Python or whatever, right? If you change the program Python, within Python, for instance, and in your example, you're moving the object, Python itself doesn't change. You've just changed the program. Does that make sense?
No, I mean, not really. I mean, that's because I'm a visual person, and programming has no visual cues to me. But I mean, I can take an object like in space, and I can visualize that. And I've seen static, so I can visualize that. So,
how about, have you seen the Matrix films? Have you ever seen the Matrix films?
Yeah.
Okay, so if you were to go into the Matrix, you understand that the Matrix in the films is a program, right?
Yeah.
So you can change, say, an agent or a person or the woman in the red dress or whatever, but the Matrix itself hasn't changed.
Okay, well, I mean, if that's what you are going to get that to a point, I think I get the idea of what you're saying. But even in that, go ahead.
I'm trying to what's the word? I'm trying to tell you what Witzit's argument was and why I think you two are understanding each other, right? Okay. I'm not even saying this is my argument. I'm just trying to what's the word? Translate.
Well, I mean, and I kind of hear the argument, and that's fine. I mean, hold on, Jeremy, I don't respond. I kind of get the idea of the argument. I mean, but again, it's like I mean, I have to say, I think Xanix's illustration was trying to make my point. I mean, just because you can use another force to overcome another force doesn't necessarily mean the thing you're using to overcome the force is the cause of the other force. That doesn't logically follow. That doesn't logically follow.
What I was talking about was with regards to the idea that you manipulate something in space, therefore you manipulated the space itself, right? I think that these are fundamentally different, and I think that was where your discussion was getting lost in that crack.
I mean,
when the Globers, go ahead, Paul. My bad.
No, go ahead, Jeremy. Go ahead.
I was going to say, when the Globers say time is their independent variable and they can manipulate it, they're not talking about time. Right? You can't manipulate and vary time. They're talking about the duration of time. Something totally different. And as far as, hold on. I just want to say one more thing and I'll be done. I wasn't done. So you can saying a lot of flat earthers go around saying, oh, you can't get rid of it completely, so therefore it can't be your independent variable or whatever. That's crazy. That's crazy, bro. We got to stop saying that. That's not how it works.
That's fine.
You can manipulate shit even if you...
That's fine then. But even my argument, then let's focus on the logic. Okay, that's true. Okay, we'll say that. But my argument is still valid. If you're saying...
you have a good point.
Okay, so it's like you're using another force to overcome another force, like the air pressure. I can levitate. I mean, that's actually, there's a little science thing here in town, and they have those little air things that can cause a ping pong ball to levitate. Well, that force of air is overcoming the other force of the acceleration downward. And I'm not saying what it is. We call it gravity for convention's sake, whether it's caused by electrostatics or the bending of space-time, but you've got another force overcoming at the other force. You can't say because you're using that force to overcome it it's the same thing. You can't do that.
I already rebutted this.
The logic is flawed.
No,
The logic
you
is still
just
flawed.
breezed right past my rebuttal, which was that, first of all, not everything is compressed of some compressed air or anything like that. That's just the point is that electrostatics is everywhere, and we can manipulate that variable to prove it is a cause of the effect. And when you say just because you use it to one force to overcome the other force that's there, you're just saying the other force. And then I said, what is it? You said, oh, I don't know. You're just assuming that there is another one. That's not how science works, okay? And so first of all, acceleration isn't a force. That's a product of force, okay? So the axiom is that you need force for acceleration. We have electrostatic force. It causes acceleration. Manipulation of that goes up and down. Every object that goes down is electrostatic. The air is electrostatic. So there's a relationship between an electrostatic field on the Earth and every object that goes up or down. So we can manipulate that variable and prove that that is there and that is a cause of things going up and down. If you want to claim there's something else there or just vaguely appeal to the idea that maybe there is, then cool story, until you can also step to the table and provide some type of empirical scientific evidence that you've manipulated another variable and proven that it is a cause of that effect, then it's just hearsay. It doesn't mean anything.
I mean, Paul, would you agree that this is real science? We can have a cause and effect relationship. We can experimentally prove it with this electrostatic thing.
Okay, well, here's the thing. Okay. You have shown in his example that electrostatics can cause things to levitate, but you haven't proved that that's the cause of the acceleration downward.
Okay, but this is what I'm saying to you. So the object is if something accelerates downward, that's our natural occurring phenomena. Okay, something accelerating downward. We observe it in nature. So we're going to figure out why the pine cone fall from the tree. Okay, so that pine cone is electrostatic. There's an electrostatic field on the Earth, and we have a downward current. We have a downward current.
You're saying the same thing over and over and over again. I hear you. I've heard it 1,000 times today, or not 1,000 times, several times today in the last 20 minutes. I get what you're saying. The more you say it, and the more you say it in different ways, is not convincing me.
I don't care about convincing you. That's fucking irrelevant to me, bro. I'm getting frustrated because this is why flat earthers look so stupid, because they don't ever offer anything to the table. They don't say, oh, well, here's what I think it is. Here's another test we can do. They just think that they have some intellectual high ground to sit back and say, nuh-uh. What I'm saying is we can prove this. There's a downward current on the Earth. There's a downward current towards the Earth. There is a downward electric current towards the Earth. Things accelerate downward, and it's in that downward electric current on the Earth. So therefore, we've definitively demonstrated and proven that there is an effect being caused by electrostatics. If you think there's something else, you have to come provide evidence for it. Just saying nuh-uh doesn't mean anything.
Well, you know what? We have light constantly, either during the day or during the night, from the stars or from the sun. That's constantly going downward. Why isn't light the cause?
Why isn't light the cause?
I'm just asking.
Can you manipulate light? Can you manipulate light and make things go up and down?
I'm just saying your logic. I'm just saying, using the logic you just said, you connected something that's constantly flowing of its electric current down towards the Earth is the cause of things going downward. That's what your argument was.
Well, first of all, my actual argument, I've said 12 times, is it's a cause, because I've actually stated that science. You can never claim that science definitively proves the sole cause of anything, because there could always be a variable that you don't know about. But you can prove a cause and effect relationship. And if we have a downward current on the Earth, and we can prove that with the manipulation of...
Now you're saying current.
Yeah, we do.
You're saying current. You were saying there was a voltage of 100 volts per meter. Now you're saying there's a current going too?
Yeah, you can easily you get a current out of the air. You can easily get a current out of the air.
Lightning bolt?
No, like you can just
use
there's
a... Dude, Witsit, you took him and Rumpus to school on this one night. Do you not remember, Zanuck? I was there. I heard it. There's a downward current. Yeah, don't act surprised, bro. You and Rumpus went through this with Witsit one night.
Flowing downward?
Not very much at all. That doesn't matter. The amount doesn't matter.
Funny that
the amount doesn't matter. Yes, I can put things with light up, down, and left and right.
Really?
Pretty sure they use lasers as a
for some spacecraft or some
Well,
spacecraft.
by the way, the light is electric, buddy.
Electromagnetic.
Okay, what's electromagnetic made of? So they claim that light is electromagnetic radiation with an oscillating magnetic field and an oscillating electric field. Oh, okay. So if you prove that light moves something anyway, you're just supporting my point more.
Hold on, real quick, Paul. Paul, you still
There's
there?
a reason that the light, when it hits the target.
Paul, you still there? Zane, could you hear me?
Yeah, I'm here. I was waiting for Zanuck to stop so you can hear me.
Do you agree that this is actual science? I asked you just a minute ago. I don't know if you heard me or not. Do you agree that this is actual science? It's electrostatic cause and effect relationship?
I mean, I said that. I said you've proven that electrostatics can cause things to go upward and maybe even change their weight. I did agree with that, but I'm still not necessarily convinced because the thing is, I can do the same thing. Like I said a minute ago, I can manipulate something on a scale with my fingers. I can increase its weight. I can decrease its weight. I can make it have no weight on the scale. And the only thing different is my fingers.
Did you not hear my rebuttal to that, though? That not all objects intrinsically have your fingers in them, so it's not the same.
What's the difference between this electrostatic thing and the relative density thing?
Well, and I asked the question, so he's back to that. I mean, I did ask the question earlier. And see, again, it's from what I heard earlier, the cause of relative density is back to electrostatic. So back where what causes things to be more condensed is electrostatics again. So the cause of everything, the density tower, the downward vector, is electrostatics as far as I understood.
No, the experiment that Riley did with the egg. What's the difference between that experiment where he made the egg go up and down and this one where you can make the paint chip or whatever?
He manipulated in Riley's experiment, as far as I understand it, he manipulated the density of the liquid and caused it to move up and down. And I don't disagree with that. I think density is a factor. Density is a factor.
Well, none of us disagree with that either. You know, like
I'm not fully. Okay, so the electrostatic. The only thing I would say about that is, I don't necessarily see electrostatics everywhere. Okay, like when I see it as a phenomenon. Now I see phenomenons that are electrostatic, like with a balloon. I do see that. But I'm changing the charge by rubbing, because I did this with I play with balloons every day with our kids, and I showed them how to rub the balloon on your head, change the charge of on the surface of the balloon. That's what's happening, and it caused it to stick to your hand. And we played with that. Yes, I can see that. But to say that that's the cause of things being attracted and the pulling of all molecules together and causing all, I'm like, I don't know if I see that.
But do you think it could? I know, but do you think it could be just relative density?
Okay, but that's back to what I said earlier. Now let's go back. Hold on. Let's go back to, then this goes back to what I said earlier. Like the question I had, because in the density tower in the aircraft, right? When you get on that parabolic flight, the relative density seems to go away, and the liquids and fluids start to mix together. So that starts to.
Okay, so you don't think it's just. Okay, so you don't think it's. So you don't think it's just relative density either? Then you don't think it's just relative density.
I'm just trying to. I don't know at this point. I'm acting like I don't know nothing.
And that's what's frustrating, because when we provide empirical verifiable evidence of something, instead of being like, okay, well, we've demonstrated that, you're just saying it doesn't convince you, but you don't know anything. So what's the value of that?
Well, here's the thing though, Witsit. Okay, which is the better, saying I know everything and I know I have a solution, or constantly be asking questions? Okay, I don't have a solution. I don't know. Though. Well, you claim you know what the everything about what's the cause of gravity or cause of weight or directionality.
I said that we can prove a cause and effect relationship between something's weight and its electrostatic nature. That's what I said.
So you're changing the charge. So what you're saying is you're changing the charge on the outside. When you say electrostatic, you're changing the charge on the outside of the atom or outside of this object, which you're changing the polarity or changing whatever you want to call it. And because of that, it's attracted to something of an opposite charge.
Yeah, or like even just within the air itself. It's the same. Like with the density, what we did was we manipulated the medium, right? So we've altered the density relationship of the object and the medium it's encompassed in. It's the same thing with electrostatics. If you manipulate the medium around the object, you can make things go up or down. It's not like this crazy strong force. It's not like this crazy strong force pulling objects down to the earth from dozens of miles above it. That's not what it is. There is just a downward electric pressure on the earth, which is provable.
Okay.
And it sets the up and down. And the buoyant force that comes from the density relationship is much stronger than that. That's why things can go up and down.
Okay, let me ask you that. Okay, about your experiment. You just brought up a good point.
But wait.
Okay, hold on a second, Zanuck. Zanuck, hold on, Zanuck. Okay, so you're saying in the Van der Graaf generator, when you cause that paint chip to accelerate, you're saying you change the medium of air's charge, and you change the paint chip's charge.
Well, yeah, so you change the medium's charge, and then it transfers charge and reacts to the object. That's what happens.
So it's the charge. So you're saying, no, your argument then is, in this experiment, you're just changing the charge of the molecules in the air and in the paint chip, causing it to go towards a different charged plate.
Yeah, you charge the relationship of or you change the relationship of electrostatics, and it changes the direction something goes. We demonstrated 1,000 ways.
This is honestly no different than the relative density thing. Every object is going to have a relative density to the medium that it's in. Every object's going to have electrostatics.
But you're claiming that the force on the medium and the object that causes the density gradient or the differential density great buoyancy is caused by electrostatics. Yet this went back to what I said earlier. You were talking about a very small force, had a flawed logic and flawed experimentation concept to show that because we can get a change, that therefore is the cause. And that's fallacious.
Think about how.
Hold on. And then lastly, God, stop interrupting me. I can finish a thought here. God. You got this force that is caused by electrostatics, and you're not able to apply it or change it to show that it is the soul. By the way, you said pressure was a downward pressure. Pressure is scalar again. And I know you're using pressure in the correct way, but I'm interpreting it. No, pressure cannot cause a directionality. This pressure is scalar.
Okay, so here's the deal. Think about how disingenuous pretty much everyone in here is being, but specifically right here is Zanuck, right? Not everyone, but that's contending this. So he's like, oh, it's just so weak, so it's not really scientifically valid. Dude, it's 10 to the 36 power stronger than gravity even claims to be. So it's too weak, so we can't invoke it. It's not scientifically valid, but we can invoke gravity. We can invoke gravity, even though electrostatics is 10 to the 36 power stronger than that.
But it's I agree. Remember we talked about it at the very small level, small scale. Did it work? Chips, salt and pepper, or pepper flakes, and gravity is so much weaker than electrostatics. Yet we can manipulate gravity. Can't with electrostatics, which is obviously now suddenly it becomes more stronger. So you're talking out both sides of your mouth. It's logic. Logic is very flawed. I'm just giving my opinion.
And it's
logic
stupid.
is flawed. I've tried to understand, and so far you have not convinced me that there's any coherency in your theory.
Did you hear what he just said? He said, so, yeah, gravity's so much weaker than electrostatics, but we can manipulate gravity, and we can't manipulate electrostatics. When that is...
can't manipulate gravity.
Exactly.
I don't know
it's the
why
exact opposite of that. Like, we
exactly
can manipulate electrostatics. Zanuck, shut up, dude.
Oh.
Shut up.
Zanuck, stop. You had your turn.
We can manipulate electrostatics. We can literally do that and change something's direction and its weight. It's 10 to the 36 power stronger than gravity even claims to be. We cannot manipulate the bending and warping of space-time. The quote-unquote proof of it is that we manipulate the mass of something, we presuppose the bending and warping of space-time, then reify it. So one is 1,000 times more scientifically valid.
Absolutely. You don't even know if the bending of space-time is a real thing or not, let alone manipulate it.
Yeah.
How are you going to manipulate something you don't know if it's even real?
Would you be able to, with your electrostatic idea, develop a mathematical formula to explain why everything accelerates at 9.8 meters per second squared?
Sure, it's super easy. So for one, everything doesn't do that. It's just an agreed upon average. There is no like constant. Shut up, dude. So it's an agreed upon average, 9.8 meters per second squared. Everything doesn't literally fall at exactly that. It's an agreed upon average. And when the mathematical formula that you have, little g is just that number. That's all it is. So you're literally just putting that number in there. So there's no difference here at all. No, the question is what causes that number. Okay? And
No. My question is, and I'll state it again, right? So yes, we'll put an asterisk. Not everything falls at exactly the same rate, but we'll use the agreed upon 9.8. My question is, how can you calculate that 9.8 with your electrostatic idea?
You can calculate that without either one of them. You can calculate that without either one of them.
It's a
measurement.
measurement.
I'm asking you, how can you calculate that, right? Like, how can you calculate that with your electrostatics? Because what you're saying, right, is that electrostatics is the reason why things are able to change their vertical position in space, right? Either they go up or they go down because of a difference in charge. Am I understanding that correctly?
Relatively close. I mean,
right.
Yeah, things change their direction relative to the electrostatic nature of the object relative to the medium it's in.
Right. So when you are building things, right, you'd be able to say, well, if I'm going to experience this much electric charge and I want to go this or vertical, I need to offset it by this much, right? And that's where the idea of 9.8 comes into play. And I understand that we can measure it several different ways, but I'm asking you is when you're using your electrostatic charge, how do you calculate the force you have to overcome to move vertical?
Yeah, we could just use Coulomb's law. And Coulomb's law, all they did was take they replaced the charge with mass. And so to calculate it within your paradigm, you have to just assume the center of mass of a globe 4,000 miles away, and you throw it in there. So yeah, you could easily do it.
But we're not talking about mine. We're not talking about the mass.
I just answered you, dude. I just answered you.
No, you answered me by saying what I do in my.
No, that's not what I did. I told you what you could use.
So Coulomb's law, can you go into this more? Because I'm not familiar with it.
Well, maybe you should look it up.
Why can't you explain it to me? This is your idea to debunk globism and prove that gravity is actually electrostatic. So you should be pretty able to express your idea to its completeness.
Hold on. When you say debunk, do you mean disprove? Because there's a little uncertainty on that word.
Coulomb's law is about how the force is relative to the magnitude of charge, the distance between the two bodies, and then the dielectric coefficient.
Well, shouldn't you be able to then, using that, you should be able to come up with the amount of charge and actually come up with how much lifting or gravitational effect it would have. It could show that happens in the environment to cause gravity, because we call it.
Once again, within your paradigm, you can't do anything of the sort other than just using little g with the agreed upon average.
Oh no, we can do Cavendish, which actually helps you determine little g. And I was talking about that earlier with the experiment with the Faraday cage, and we got sidetracked on that for about an hour.
So you said you should be able to do something with an equation to prove it. Then I pointed out you can't do that either. And then say, Cavendish.
Mass. I can do that with the amount of mass. I can check the charge. I can see how much charge there is on it. I can vary the charge. I can block much of the charge with the Faraday cage. And I'm not able to get any kind of a serious reaction out of those objects based upon the charge you can see.
Yeah, see, the ether's breaking you up.
Now.
Yeah, but see, the truth is you can't get much of an effect, period. So if we were to believe that gravity is real, and we were to believe that Cavendish is proof of that or whatever, there's barely any effect at all. Barely any. And so gravity is claimed to be way weaker than electrostatics. So
But
if
I
we
think
can't...
as a continuation on that electric charge, the example with this guy, he took the Lexon rod, he charged it up, I'd say probably approximated 50,000 volts by rubbing it in sheep's wool, and he was able to get a reaction out of the object at a distance. And then he put the shield up and eliminated that charge via the shield as much as possible, and the object no longer moved. But now he takes a piece of steel that does not have a huge charge on it, definitely less than the Lexan, and he puts that next to it, and it does move. So it sounds like it's distinctly different from the electric charge causing it. Because I had 50,000 volts there, unable to move it, and then a chunk of steel there that is able to move it with less charge.
Okay. So you actually expect me to believe that I can't move something with 50,000 volts of charge?
Not through the Faraday cage, in this case.
Okay, when you put the other object in there, right, it has an electrostatic relationship with the medium around it, okay? And then so does the other object, objectively. Now, no matter how small it is, it's significantly stronger than gravity.
Really?
So
why,
my Lexon ball had the 50,000 volt charge. And now the steel ball does not have a 50,000 volt charge. In fact, it's an unmeasurably low charge. And that one is able to move it, but Lexon ball is not able to move it with a tremendous charge.
Yeah, you're really missing something with it, because think about an electrode and a cathode, having a 30,000 volt, 50,000 volt differential between the two. Is there an attraction between those two cathodes and anodes?
I didn't hear you.
There's a 50,000 volt differential between the anode and the cathode. 50,000 volt potential, like you said. Is there any kind of attraction between that anode and cathode?
Yeah.
No.
Yes.
Why aren't spark plugs bending then?
Because it's very weak.
The tips of spark plugs bending.
It's really weak.
I don't. What's it? They're never gonna.
But you said it's 30,000 volts, 50,000 volts.
It's still really weak.
How is it weak if it's 50,000 volts?
Can I ask?
You guys are just lost.
You said
man.
you could pick up something with 30,000. You said you could. Hold on, before you go, Hank, or whoever's trying to get in. You said, remember, because it's not just the voltage that does that's just a potential. If you have to have the current flow, and you have to have some type of particular type of flow to create a magnetic field, which will move things, but voltage on itself does not move things.
Okay, so I just explained to you that bees fly in the air and they get positive charge. The flower is connected to the earth. It has a negative charge. When the bee flies over to the flower, the pollen will be attracted to the bee. Do you understand that?
I do. And is that a magnetic or is that electromagnetic?
It's electrostatic.
Right.
Zanuck, why don't you let Smooth take a shot? You had your time with it. Let Smooth take a shot.
So, quick question. Thank you, Jeremy. I'm all for this. So let's say we build a Faraday cage, right? And we get a ball of wood, right? Or, we can get a dog toy, like one of those Kongs. How much force, right? And we have all the electrical equipment we want. How much force do we need, right, to make that material be weightless?
Be weightless? You could,
yeah,
dude, a ton, an insane amount. I don't know the exact amount, but it would be insane. Well, it's super weak.
The reason why I'm bringing this up, right, is because in your idea, right, how do you reconcile the fact that conductive materials and non-conductive materials experience the same acceleration?
Because when the experience acceleration is just that it's going down. Once something goes down, we just have an agreed upon average for how fast it goes down, right? So it's just the main thing is if it goes up or down. And so what sets the up and down? Well,
right.
Yeah. It's we know what it is. There's an electrostatic field. There's an electric gradient on the Earth. There's downward electric pressure, and so things go up and down relative to that. It doesn't really change much. It does change some, though. It isn't actually always 9.8 meters per second squared. So
maybe, and I could be
Wait a
wrong
minute.
here, but
He said downward. He said a downward pressure again.
electric pressure,
Listen,
yeah.
pressure is not a direction. It does not have a vector. Pressure is scalar. You keep on saying that, and it
There's
really
a downward
weakens your
electric
argument.
pressure on the Earth.
Yes, and there's no such thing as a downward pressure. Pressure is scalar.
No, there's a downward electric pressure.
so
Pressure
correct
is
me if
scalar.
I'm wrong,
Just keep
but
saying it. I don't care.
does electrostatics affect material differently?
Yeah.
Right? Okay.
Okay.
How differently?
Not
Like,
not
what's
much because
not
it's
much?
so weak. It's so weak. So like, yeah, if you have rubber, it's an insulator, right? It's not the same as like a piece of metal. Okay, but
Call him out on the pressure thing. So downward pressure is a force. Would you agree?
Just
Listen, we gotta
blast
stop.
away,
It's got a fundamental
Anytime
problem
you're
with
ready, buddy, just
foundation of
blast
his argument. He's got a downward pressure, which is a force, right? What's it? So how does this electrostatic differential cause a force? Because that's what a downward pressure is.
electrostatic is a force.
Electrostatic is a force.
You didn't know that?
I'm just reflecting on what you're saying. So we have a force created by this differential voltage. Now, is the voltage a force?
Well, technically, it's intrinsically electrostatic, and so electrostatics is a
No,
force.
you said what we know. All we can measure right now, you agreed, is a 100 volt per differential voltage, an increasing voltage. Every 200 meters, every meter we have a 100 volt change, right? 100 volt per meter.
100 volt per meter increase, yeah.
Is that differential per meter? Is that a force?
No, voltage isn't a force.
Of course not.
A volt isn't a force. That's not the point, though. The point is that there's a resultant electrostatic force, and we're wondering what it is that causes or sets up and down.
Okay, so how do you get a differential? How do you get an electrostatic force from
Okay, again, so there's positive increase of charge going higher and higher up. There's negative charge on the surface of the Earth.
Okay.
What does positive and negative do, Zenik? Zenik, what does something that's positive next to something that's negative do?
It will attract each other.
Okay, and so do things always seek their equilibrium?
That was a field answer, not the voltage. Positive next to a negative. If there is a potential between them, current will flow. No force will be generated. So if there's a potential difference and there is a resistance, there will be current flow because V over IR is still a law. Ohm's law still is I squared R law is also a law. So we need a resistance, which is the air. You have a voltage, which is you said magically appears at 1 meter above the surface, and every meter afterward, 100 volt difference. Then why isn't the current flowing? Because the resistance is too high, or there's infinite resistance. We know it's not infinite resistance. We know the resistance every meter. So why isn't current flowing?
There is a current. There's a downward current on the Earth.
It is flowing like a river.
How do you understand it?
I can give you the resistance value of air over 1 meter is the current comporting with Ohm's law that voltage is 100 volts, and that 1 meter distance, do we have that amount of current flowing through that resistance?
Yes.
Current flowing, yes. When you bring it up river, up current, and let it go, where does it go in a river of water? It goes down current, just like in the air. You lift something up in the air, up current, and let it go. Guess where it's going? Hello?
Yeah, it's just not even complicated. And like even within your own paradigm, gravity is
works for general descriptions of electricity, but not for the.
I just now cited Walter Lewin from MIT telling you that everything that's observed, including downward acceleration and the way that everything is held together up to thousands of kilometers, is all electric, and that within your paradigm, gravity doesn't come into play. Gravity doesn't come into play until you get on the planetary scale.
Rakia and Witsit. So now you agree that current is flowing, and if current does flow through that resistance, then heat will be generated. I squared R losses, right? Whatever the resistance is, current squared times that resistance wattage power that has been
Heat is generated.
Are you gonna see? You start looking at these.
There's energy and heat release. Yes.
None of this makes too much sense.
Wow.
Wow.
Go talk to Walter Lewin then.
What the frick just happened?
Here, I'll drop you some lectures, Zanuck, and you should watch them. Seriously, you should watch them.
What is giving the energy to this 1 meter high?
You ever heard of a dynamic system?
Okay, I do. You don't even know what a volt is, Rakia. You're hardly one to talk.
I'm smart enough to understand this, there, genius.
No, you don't. And I'm trying to ask.
Yes, I do. I promise you.
So you win. You know
no,
what?
I'm just saying. There is a current. There is energy release. There is.
Really?
Whenever you have
energy
movement,
released in what? Is it lighting up the sky? Is it heating up the air?
Yes.
What is it doing?
Yes, static.
Why do we ever have a?
All the energy that's in our dynamic system that's in a cycle is being released in different forms. Growth, mixture of chemicals, the flow, the energy it takes to make cycles. Cycle? You ever heard of a cycle in electrical currents? You're talking about resistance and energy release. You're making our points for this argument.
It's made up about 5 things that have nothing.
I haven't made up anything. It takes energy to run things.
Energy's released, dude. Energy can be transferred in a multitude of ways.
Yeah,
How
dude.
is it released in the air, which has resistance, and give me the number that corresponds.
You want me to quantify it and put it in a paper and run my Nobel Prize?
None of this makes sense because you don't know what you're talking about.
It definitely makes sense. It's clear as day, clear as the sky is blue. And I use the water analogy just so people can see the flow, right? You say that energy in electrical form in a conduit isn't moving. It's just giving off the information one to the next. But that's still flow.
Yeah, if you're talking about the electron flow, current flow in a wire, yeah, that's the analogy.
It's all the same. Flow, current, resistance,
it's senseless
energy
to argue
release.
about this. You don't even know what it is, first of all. Talk with Whitsitt about this, how we have an attractive force, a force that is downward due to this voltage differential and supposed current flow out power being
positive and negative.
None of this stuff makes any sense at all.
Okay, Zanuck, you're right. You're right.
Physics person
you win, Zanuck.
Agree with you.
Yep.
You win, buddy. Everybody believes you.
Yeah. Like I just explained objectively that within your paradigm, everything that we observe on the Earth is electric and it's much stronger, 10 to the 36 power stronger than gravity claims to be, and that gravity isn't the cause of that effect or any effect like that until we get on the planetary scale. If you want to just keep on monologuing non sequiturs and whistling past it, no one cares.
Can you restate that sentence?
This is his catchphrase. He does this on the megaphone too, by the way. 10 to the 36 times.
Wasn't you, Zanuck. Had no reason for Zanuck to talk there. That guy asked a question.
Yeah, so I can cite you some lectures from MIT professor Walter Lewin. He explained it pretty well. But so gravity electrostatics is 10 to the 36 power stronger than gravity even claims to be. And everything that we observe on the Earth is a byproduct of the electrics of the Earth. And gravity doesn't come into play as the cause until we get out on the planetary scale.
Yeah, I'll have to see that lecture because that sounds like a load of horse shit to me. But
okay.
Is there any way we could close out the Cavendish thing that I was talking about earlier? Because the point that I was trying to make was the Lexon ball with lots of charge cannot make movement happen in the Cavendish when it's got the Faraday cage. The lead ball, the same size with low charge, can make it move. Why is that?
I wasn't listening to you. What did you say?
Okay. In the Cavendish thing that I was talking about earlier, I keep, Zanuck stepped all over my ass, motherfucker. The Lexon ball has a huge charge on it and is not able to induce movement once the Faraday cage is introduced. But this lead ball is able to introduce movement. Why does the highly charged Lexon ball not create movement and the steel ball with low charge create movement?
I'd have to see the specifics of the whole entire thing, like exactly what the other ball is, the distance, exactly what the charge is of the other object, what's the charge within the system, et cetera, et cetera.
Well, you can agree that a Lexon ball, when you rub it in sheep's wool, gets a really big charge. I mean, it can be anywhere from 5,000 to 50,000 volts.
Okay, yeah.
Whereas
and I highly
a
doubt
steel
it didn't
ball,
move at all. That's not true. So if you want to drop the actual test, I'll look at it.
okay, it moves less than the steel ball with lower charge.
Oh, it moves less.
Yeah, that was easy.
Yeah.
Okay, no, that may be easy, but it's still, there's more effect by the steel one with almost no charge, and lots of effect by the one with charge, and the one with charge with a Faraday cage in between, and the ball with the Faraday cage in between.
I'd have to see the test because it barely moves at all. Any successful Cavendish barely moves at all. So
yeah, post it, bro.
Yeah.
Anything like that is cool, but it doesn't. I don't think anything is going to be proven by that one particular test. I'm just thinking in general terms, like what we see out in reality. We understand the static charge that's generated by things moving back and forth, or like a rotary blade or something like that. We see all the energy in the sky. We can feel it, right? So we know it's there. It's got to be affecting things around it, right? That's all I'm talking about.
My point, though, is that, and I'd have to provide the information better, but the steel ball with low charge, and we can all kind of agree that steel ball probably has lower charge. And just the nature of steel, you can't put a huge static charge on it easily.
I would say it depends on what it is. It's going to hold less potential maybe as a steel ball than, like, everything even on the periodic scale has a different charge potential, right? They call it potential or magnetic charge or whatever they call it.
Right, but
so depending on what it's made out of, it's going to have, that different potential.
But I was able to eliminate or severely minimize the amount of movement I got with the Lexan ball, which was charged. And the steel one,
I get it.
Yeah, it's just I don't get how you can even conclude that electric is the cause when the less electric thing caused more movement.
Yeah.
Yeah, so I would have to look at all the details specifically. I actually plan on doing something to that effect myself, but what I happen to know is that electrostatics is 10 to the 36th power stronger than gravity even claims to be, and it gives you that effect. And you would need to know the actual system's charge, the other object's charge, the actual distance. What's the actual difference? Is it consistent? Does it change at all? Does it happen exactly the same every single time? You just want to make vague bullshit statements.
How could all that be proven?
You see the 10 to 36 thing a lot.
So how could all that be proven? Is it just a theory?
How could all what be proven?
What you just said, Whitson.
Yeah, it can be proven that everything in the world's electrostatic. You can literally
how do you
transfer
prove that it's
charge to
stronger
everything.
than gravity?
Gravity is not real. So the point is that we can see how strong it is, and then they make a claim about gravity, and then they beg the question, and then you can compare the strength of what they claim exists, called gravity, to what we know exists, called electrostatics.
So you're saying gravity doesn't exist, so therefore it's stronger.
What I said is, well, I said it very specifically. I said electrostatics is 10 to the 36th power stronger than gravity. Even claims.
How can you prove that, though?
You see what I'm saying? You fucking interrupted me again.
Yeah, because I'm sitting here, you're saying all that, but how could that be proven?
Well, maybe if you'll shut up and listen to what I say, then you'll understand. I
Just imagine I was the one who was muted for like 2 hours.
I said electrostatics is 10 to the 36th power stronger than gravity even claims to be. I said it that way for a reason.
Why did you leave out the at the micro scale?
No, I just now dropped Walter Lewin explaining everywhere on the Earth on the terrestrial scale. The atomic scale, everything on the Earth. Yeah, thanks for playing. I just dropped 3 lectures.
That all sounds like bullshit to me, man, to be honest.
Wow, very profound input.
That's a great one. I think what they're calling gravity could be what, like it could be similar in many ways. Like, I don't think they're too far off. I think you're just stuck on what gravity is and what electrostatics could be. The potential of both could be very, very similar.
Yeah, I don't understand why is this dude over here saying that? Like, we can prove electrostatics and we can manipulate it and we can show that something's weight will change. We can show that something will fall faster, that we can make things go up. We can prove that everything is electrostatic. And so objectively, it's a variable of things going up and or down.
But you prove that it's stronger than the gravity is what I was saying.
I said the gravity's not real, okay? But the point is that we can measure electrostatics. And so even if in their own paradigm, it's 10 to the 36 power stronger than gravity even claims to be. That's why I say it like that, claims to be, because it isn't real. It isn't proven. My point is when they say, oh, look, we grounded this, that way we know it's not electrostatics. That's stupid because even within their own paradigm, electrostatics is way stronger, even on the smallest scale, even when it's the weakest and the smallest, it's still way stronger. So it doesn't matter if you ground something. There's still a way stronger force there. You can't claim that you somehow found something called gravity and just beg the question when it's, well, for one, not even a real thing. And two, even if we pretended it was real, in your own paradigm, it's significantly weaker. That's the point.
Even like moving something through water or moving water past something creates a current. Like in boats, you have to ground and you have to like use lead, lead inserts in your engines to keep the water from oxidizing and doing all kind of things because the water movement. Like we have to run grounds everywhere to keep our parts from just rusting away because we're moving in water is creating a current through the hull. Like there's just the movement alone is creating that charge.
So it's 802. I just dropped the whole playlist.
So in your opinion, what do you think? If gravity doesn't exist, what's the force that's like acting keeping us down, basically?
Yeah, so there's an electrostatic force.
In your opinion,
there's an electrostatic force. So we have equipotential increase of electricity on the Earth. It goes up 100 volts per meter. So we have positive charge increasing above us. We have negative charge on the ground beneath our feet and below the Earth. So we have the natural up and down set with the electric nature of the Earth. Electrostatic field.
So how can you prove that force is strong enough to keep us down?
How can you prove gravity, dude?
Well, that's a fair question though. Let him.
Yeah, so okay, it doesn't keep everything down anyway. Sometimes things go up because the buoyant force resultant of a density relationship is much stronger than electrostatics is. It just sets the up and down. It's not like we would just be floating away. Dude, electrostatics sets the up and down. If something's more dense than air, it goes down. If it's less dense than air, it goes up. That buoyant force is way stronger than what sets the up and down.
Actually, it's because of what sets the up and down. That's what makes you'll have to displace an amount of the material, and you'll get a one-for-one relationship between how much is displaced.
That is true.
In the air,
it is true that the buoyant force would be relative to what sets the up and down intrinsically. You couldn't have density, weight, or buoyancy without.
You're displacing the medium. Whichever medium the object is in is what it's displacing.
But the root of the cause, though, or the root cause, at least at that level, is whatever sets the up and down. Without the up and down, you don't get buoyancy.
Yeah, that's.
I agree with that too. But you have more resistance in different mediums. Also, it's all linked together. Like you can't just take one thing. You have to look at it as a whole.
Yeah, the permittivity of the medium. So, whatever.
And from a globe earther point of view, if I believe it's a globe and it's a planet, so gravity is effectively just things being attracted towards the center of the Earth. It is gravity, therefore, is actually quite a weak force. Because if there's a whole planet pulling you down, I can lift my arm up right now, quite easily, So there's a whole planet.
Did you miss the part of gravity being proportional to the mass? So the bigger the mass, the bigger the gravity. So it's not really a weak sense that it's proportional to the mass. So a big planet has big force.
He just explained that big of a planet, he can still move his arm up really easily.
It's proportional to the force, proportional to the mass.
Yeah.
That's his point. That's his point.
Why. That's remember that physicist that blew that question about the butterfly. Oh, it's buoyancy. No, it has to do with the fact that mass dictates the force. Little mass, little force. So you have little arm, little force. You have big muscle arm, a little more force to move them because it's a little heavier. And a big planet, huge force.
So if you
get it?
so if
Come
you
on,
were
guys.
born on Jupiter,
You guys are smarter than
right,
that.
which is a bigger planet with a bigger gravitational pull, if you were born on Jupiter, you would, naturally grow to, be strong enough to lift your arm up on Jupiter. So yeah, it's proportional.
But
yes.
I don't think you know what that word proportional means.
Hold on. A planet that's bigger than another, but let's say one's made out of gas, and then there's another one that's just more like dense, not gas, or can't the denser one have more gravitational force? Even though the other one might be bigger?
Not big. Mass determines. Get it? I said it 4 times already. Mass determines gravitational force to be proportional to the mass.
Prove it.
If it's a gas planet, it means it's less dense. For the same size, it'll be
less mass, right?
Prove
it straight, guys.
This is just the same story being repeated. Like, everyone's heard this story, bro. It's like if I was to say to you that the Ultramarines exist, and then you give me a bunch of rebuttals, and then I just tell you the story of the Ultramarines for like the 12th time. Like, it doesn't matter how many times you recite the story, it doesn't make it true.
Exactly. It's annoying.
Well, that would go for the electric argument.
Crypto, are you in the 40?
Yeah, but we can actually show evidence for the mass having strength.
Prove it.
So what's that experiment where they put like a big weight and then they put like a string?
I heard you talking about it earlier. The little g came from the Cavendish.
Little g is just downward acceleration.
Who let Zanuck off mute? He just comes in and starts blasting away again over talking. Conversation got chill.
Jumping in things you criticize me on.
Dude, we were just having a conversation so chill without you. It was beautiful.
In the moment of quiet we got here again, I got to ask one. When you're doing your test, you said you want to do some tests with charge on a Cavendish-like device, I think.
Yeah.
What I would recommend is that you put the charge the same on your Lexon ball, then double it, vary it up and down to see whether you can get more movement out of something that has more mass. I think we kind of agree that mass is a thing.
Right? Yeah, but I don't agree that what's going on is proportionate to mass, though.
Right, but that's what actually seems evident. The charge varies kind of wildly in this world, but the mass seems to be what always shows the same answer.
Well, first of all, it's not always exactly the same answer, right? Like 9.8 meters per second squared is just an agreed upon average. It's not literally always exactly that. And the slight fluctuation you get is because electrostatics is so weak. So you would have to have a huge fluctuation to change it drastically.
No, it changes because of the spot on the Earth would have a little less attraction because the mass concentration there. But the
I know your story. You're doing the same thing Crypto just said. Like, you act like we don't know your religion.
Did you keep on describing it incorrectly?
But don't they find things using gravimeters? Like, you go around with it, and you go and you look and say, oh, you know what? There's really a high density object below us. And then they dig down and they say, hey, you know what? That's what we expected to see.
Actually, it doesn't work a lot. A lot of the times they don't get what they expect, though. So why do you leave that part up?
Definitely not perfect. But it is a tool that is used to positive ends. And it can be tested on a small scale where you can test it on essentially the bench. Move a 500-pound weight underneath your gravimeter. You'll be lead weight. You'll see a displacement on that scale.
Okay. So would you see a displacement relative to just mass alone, or would you see a displacement based on charge?
The amount of mass. The charge can vary. The charge you can vary, and you won't get much of a change at all.
You're saying that, but I've actually looked into it, and that's not true. And the gravimeter, I know what the gravimeter is. Interferometry, it drops a little little metal ball, and then it measures it over and over. And the changes that they get are very, 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 very slight. And when they go out and they do, these are like 20 to 30 grand, like usually just grants. As universities will do different readings, and they find out all the time that it's inconsistent with the elemental composition and the density and the mass. Like it's not consistent. Like there are times where you go up to the mountain and it doesn't work. Like even there's more mass, it doesn't really change proportionately like it's supposed to. There are all kinds of discrepancies with the current gravitational model.
Yeah. I don't know about
Right.
now. I'd have to ask somebody else about it, but I have not heard that the gravimeter was something that involved dropping a ball or whatever.
Yeah, gravimeter. Yeah, it uses interferometry, and it drops this little like metal ball, this little bitty like BB, and it measures how fast it falls with lasers. It's a little vacuum chamber box, and it uses interferometry.
That may be one kind of gravimeter. I'm not sure. Like, is that the one that they were going out in the field with and
Yes.
measuring? Okay.
Yeah, and I also read into like these giant PDFs about them as well. Like they have a lot of things kind of baked into them. Because, like sometimes they actually get readings that are way off, like freaking like 6 meters a second or something. So
I'll look that up. I guess gotta see it for myself.
And also it can be affected by the ambient atmospheric pressure. Even in the
that
vacuum
shouldn't
chamber.
be true.
I know that's what's crazy. It's even in a vacuum chamber. That's what I'm saying. Like there's a bunch of things. Admittedly, there's like a bunch of things that aren't understood even within your own paradigm when it comes to the gravimeter results. I can drop some links here. I actually got to work on this.
If you got gravimeter handy, it'd be easier than me going taking around looking for it.
Yeah, I'll try and find some.
Hello, dog.
Can I ask a question? Like genuine question. Like talking about vacuum chambers and like the rate of things falling and that Poland laser thing. I remember seeing a program with Brian Cox, where he went to like that, like it was like a massive vacuum chamber, and they dropped a bowling ball and feathers like at the same time.
Oh, that was awesome.
Yeah, it was incredible to watch, and I mean, I still don't really understand how that works. And you know, I call myself a globe earth or whatever.
Really simple. Just look at a pendulum.
Say again, Nick, sorry.
Why are you talking in the middle of his sentence though?
Well, he doesn't seem to be upset with it.
Yeah, but he's just respectful, and then Xanax going to take advantage of him and then keep doing it.
Here's a quick blab. You know, you guys want if you're confused about how gravimeter is complicated, simple. A simple pendulum is to estimate the vibration of beauty.
I'm going to drop some links for you, though. Just go ahead.
Yeah, I was just interested in, you know, in a vacuum, obviously the bowling ball and the feathers fall at the same rate, and yeah, I mean that blew my mind, you know, and I think is it like an Einstein like equation or theory that it isn't that the bowling ball and the feathers aren't falling to the earth, rather like the earth is moving up to them or something. I don't know. I'm asking the question.
Because they all have the same charge, I guess.
Yeah. So and I don't understand that bit, like like a static charge or something. Sorry, you don't have to re-explain. I know it's boring for
it's electrostatic field.
Why don't you talk about the ISGN, IG?
By the way, just for all the Globers in here, I'm dropping all these anomalies they have with the gravimeter readings. When you guys pretend it's all perfect and all this shit, no, it's not.
Did somebody ask me about the ISS? Then?
What's varying? The gravitational
So the actual readings of downward acceleration do not vary relative to the amounts of mass like they're supposed to.
Well, that's not exactly true.
I had just dropped the freaking proof it is true, though. So you're just saying things, and it gets really annoying.
I'm not just saying things.
I just dropped it. I just dropped
dropping
it.
a little steel ball, and that's one way they can do it. Accelerate. But a lot of them are a little more complicated, more simple, like just having a spring scale with a mass on the end of it, seeing the length of that spring. That'll determine the gravitational strength.
These are 100 times more precise than that could ever be. Okay, and these are showing the problems. They're called gravitational anomalies. There's many different types of them, and they don't.
What do they attribute it to? The inaccuracy of the structure of the meter?
They're trying to figure out what it is. Look at these are the maps showing you them not working. The predictions not working.
It's not a matter of not working.
The predictions are incorrect.
They don't know what is in the Earth to that accuracy.
That's not what this is about.
Read it and see.
Yeah, so shut up and stop talking about stuff you don't know, man.
Make correct conclusions when you think.
You get annoying, man. I'm just saying, you're annoying, bro.
Dude. If anybody's annoying, it's you.
Well, I'm dropping actual evidence, and you're just saying nuh-uh. Without even knowing what the evidence is.
You've made up stuff that nobody in this world, except for you, those physicists. I mean, millions of people are idiots. You're the smart one. Don't you think?
I never said that, though. So.
Have you ever looked in the mirror and say, you know what? Maybe I don't understand what I'm talking about.
Have you ever done that?
Have you thought about that for a second? Is that ever entered your mind?
I know that I don't know everything. You think you do know everything, but
you know more than all physicists.
No, I didn't say that.
Well, you're saying that they're all wrong and it's electrostatics, and it's not.
No, it's not that they're all wrong. I have a paper right here of someone saying that he thinks that all terrestrial gravity is actually electrostatic attraction.
Well, just because you get some guy like...
Oh, so now it's not all of them. Oh.
Well, there are physicists. There is scientists, and I get to consider...
Zanuck, just take the L.
There's no loss. I can take Ken Wheeler as being one of the scientists. Crackpot scientist. He's not credited.
Even
he doesn't
your
have any
microphone
knowledge,
doesn't
but he
want
is
to
a
hear you
scientist.
speak. It keeps cutting in and out. Are you aware of that?
He's wrong.
My friend's trying to help him out.
All right. Well, gravimeters. It seems a little bit more complicated than you say. There are spring gravimeters, and there are the ball gravimeters. So I'm not sure what the sensitivity is on the best spring one versus the best one, stuff like that.
The most precise is the little bitty BB that we drop, and we use cross patterns of lasers, interferometry, scanning that BB as it drops, and then it picks it up and drops it, picks it up and drops it.
Right, but if you can get a reasonable reading, I don't necessarily have to go to one of the highfalutin, high-tech ones. If I can just get if I can get a big enough effect to show up on a spring.
So what you're saying is like, if the ones that are really, really precise show us that our predictions are wrong, we don't have to really look at those. We can just look at the ones that aren't nearly as precise that'll be closer to my prediction.
Oh, the ones that drop mirrors are more from other masses. They're not dropping BB. They're dropping mirrors.
Yeah. Let's see. What is this one? This is the one I saw before. I thought this was spring-loaded.
What's so crazy is like what science is. It's like when you can actually, it's like science itself is actually really cool, right? Like it's not this weirdo thing that people make it out to be. Like science is where you can go out in the world and you can do stuff like, and you can learn the phenomenon, you can see it and mess with it and vary it and try and figure out what's going on. So like the science is actually pretty dope. And when it comes to this downward acceleration thing, like we can do a lot of science with it. We can do all kinds of little demonstrations with electrostatics, all kinds of stuff, and show it and vary it. And we can go look out in nature because like natural science is like trying to put the pieces together of the secrets of the natural world. That's the whole idea.
Yeah, well said. Yeah, science is dope.
I challenge you. You didn't even read the gravitational anomalies in Ireland. Did you read what it said there? I don't think you read the thing.
I just went over to my notes and started dropping all the ones I've already had in here. So
well, let's read the first paragraph about this. About you saying it's due to the instrument. No, it says the variations in gravitational strength occur from place to place according to the density distribution of the rocks beneath the surface. Such gravity anomalies have been mapped across Britain Isle and the adjacent areas, and they reveal aspects of these islands' geological structure. Negative anomalies. Negative gravity anomalies are associated with local deficiencies in mass due to volumes of rock which are less dense than the average. Typically, the anomalies, only 1% by the way, are associated with granite plutons and sedimentary basins. Gravity anomaly maps of the British Isles are interpreted as indicating the presence of granite plutons in the following areas, and there's a whole list. So it doesn't have anything to do with the instrument.
What?
You don't have to clip me. I'm talking quickly, so I'm taking less time.
You're straw manning me.
I'm going to finish right now. So you said, I'm not straw manning. You said there are examples of anomalies. I said what they were due to. You said, no, it's not the density of the Earth. It's the instrument that is not accurate. And you said, oh my God, did anyone not ever hear that?
What I said was, I didn't say it was the instrument. The instrument's what's measuring.
Problems on it.
The instrument's what's measuring it. I said that it's not. It doesn't match the predictions of mass.
Yes, it does. That's exactly what they're saying.
Dude, just read all of it, dude. Read all of it, and it'll show you. They, like, for example, they have data in these stuff I'm dropping where they go to mountains, and it isn't in any way measured to be what it's predicted to be, and they're trying to speculate as to. And by the way, I'm still talking. By the way, what you'll find out with actually looking at the data is that it has a lot to do with what type of element it is, not just the density and not just the mass. And so it has a lot to do with the conductivity of the element, which seems interesting, doesn't it?
No, that's not what they say. They say it has to do with the estimates of the thickness of sedimentary rock, and the sequences in the basin, and the models of the structure of the basin, part of their interpretation. And that gravity abnormality were different because they've actually detected that they were incorrect in associating their guesses and the predictions with reality, which is the instrument, which is very accurate. So you made you made an assessment of this paper saying that they predicted something. It should have matched the prediction, so therefore their tool is inaccurate. It's the opposite.
I never said that.
Oh my God, we all heard you say it.
No, I literally didn't say the tool is inaccurate.
Are you hearing voices?
Yes,
I said the tool is incredibly precise.
Then why is there even a discussion about this? It measures the abnormalities.
You're just lost.
It's so precise that it measures the abnormalities of what predicted in mountains.
That's the point.
Is that true?
So the mass predicts a certain thing within the geoid model, and then when we go use the very precise tool of the gravimeter, it shows a ton of anomalies, and they're trying to theorize different models to explain the anomalies.
No,
so
that's
I only
not
this got invoked because you guys were acting like it works perfect, and I'm like, no, actually it doesn't. Okay, so I'm gonna not talk to Zanuck anymore. He is the most annoying person I think I've ever engaged with.
But you're getting it wrong even now. Not what they're doing. They predicted what the
Why don't you just start your own live stream and talk to yourself?
Based on the graph. Okay, I'm done with you two. You're annoying.
Dude, that's such a good idea. Zanuck, why don't you get your own server and go somewhere else and talk about your gravity?
Zanuck can talk for a whole country, man. He can talk to himself in 3 different ways, 5 different ways. Specialist pain in the neck.
Breaking up, dude. Nobody can hear.
Someone's breaking up.
Apocryphon, reconnect. Give him a second to reconnect. See if he can come back clean.
I mean, clearly, what we were talking about instruments, the whole basis for bringing it up was not that accurate.
I thought you were done, dude.
I mean, I was just talking, and it was totally silent, and he got talking.
Man, you can't help yourself. Go and set up your own stream. Apocryphon, try again.
I was in the middle of a very calm sentence. Let me finish the sentence, and you say something. Go back to my other mode of being quiet.
Yeah, come on, guys. Don't interrupt, please. I know it's Zanuck, but let's let him finish.
Brought this up with the saying that the instruments have problems that are not inaccurate, found areas. The predicted mass of them didn't match the measurement. And then they cobbled together some excuse of why this case. In actuality, the actual measurements are very accurate, and they measured predictions of the mass to be inaccurate because they were able to accurately measure it with the instrument. See the difference there?
That's what I said. Literally what I said was that they have predictions with the model. And then when we use the gravimeter, it shows us that those predictions are not correct. And that when you claim that the gravity distribution is perfect with your theory and your model, you are incorrect. and I am citing all kinds of things
Great, you're saying it again, so
showing the measured discrepancies and how they're trying to figure out new theories. I just dropped one from Harvard that says the isostatic gravity anomaly used for misleading, explaining how the theory they came up with to try to explain the isostatic gravity anomaly actually just makes a whole bunch of base assumptions that are incorrect. So I'm not here to argue with you about whether or not you think your theory.
I think I've exposed.
I'm not here to argue with you about whether or not you think the theory that they ad hoc postulated was correct or not. I brought this up because the Globers pretend. Xanax, shut up, man. The Globers pretend that their model and their gravity claim it works perfectly, and that is objectively not the case.
Now I'm going to have to disagree with you there. First off, when we say perfectly, it means within a tolerance. It's not, you're not going to find a 9 point or a 9 gravity on Earth, 9 meter per second, or a 13 meter per second on Earth. It's within a tolerance. All measurements, every single measurement, no matter what measurement you mention, is within a tolerance. So nothing is perfect, as you state. When you state that we say it's perfect, no. Nobody says it's perfect.
Well, you guys are basically critiquing the electrostatic postulation with all this like, oh, it needs to be so perfect because it has to explain it to be exactly like this. So what's implicit in that is that you have one that is, and you're wrong.
No. You don't have anything. Like you don't like that video that you posted with them with the soda can and the rod.
I didn't post that.
That wasn't yours, I thought. But okay, there's a video that showed a soda can on a table. And they take one of these, like a plastic rod that they charged up, and they're moving that soda can back and forth. Now, you can tell two things about that. You can tell how much force that rod is generating, and you can tell the voltage. So you can now do a correlation between the charge and the amount of force. And now you can go and validate that relationship between charge and force actually exists in the environment. So when you see your comb under the water and you're able to bend water, that little stream of water at your sink, you can see how much it bends. That's a force that can be measured and how much it would take to make it move, deflect a quarter inch, a half inch, 2 inches. That soda can to get it to accelerate from stationary to 1 foot per second is a force that can be determined. And that if you change the charge on that stick by 50%, that force will change in a correlating amount. I mean, I don't know if it'd be an inverse, a logarithmic change or whatever, but it will change based upon that voltage and a predictable amount. So if I put 25,000 volts, it'll move the can this fast. If I put 10,000 volts, it'll move the can this fast. Now you have to show in the environment that same kind of effect, not perfectly, but a correlation, a reasonable correlation.
Yeah, there's electrostatic field in the Earth. We have equipotential increase going up from the surface. We have negative charge on and below the surface. This sets the up and down. We have an agreed upon average of 9.8 meters per second squared. It is not perfect. It is not constant. It is not completely consistent, but it is close enough for intents and purposes. And it goes up and down relative to the density relationship after that. And the buoyant force being much stronger sorts the rest out. These are all the provable and testable variables. It would make perfect sense that it doesn't change much from 9.8 meters per second squared because electrostatics is very, very, very weak. In order to get a drastic change in acceleration, you would have to have a drastic change in the amount of electrostatics introduced because it is so weak. But although very weak, it's 10 to the 36 power stronger than gravity claims to be. And it doesn't even come into play in your paradigm when accurately represented until the planetary scale. So I'm not going to keep repeating it. I dropped all kinds. No, it's not one person.
One small sliver of the scientific community that you've chosen to select as your priest that is this guy is not associated with Thunderbolts or something like that.
No, dude, this is just a famous MIT professor, man.
And he says that there's no effective or no appreciable effect of gravity at the ground level. I don't believe that.
I didn't say what he says is that everything that we observe is due to the electric nature, and that we could never isolate gravity here because it's up to thousands of kilometers. It's all electric, which is much stronger. It's not until you get out on the planetary scale that what you observe is a byproduct of gravity.
That sounds very
so I posted
I posted that video that you're talking about, and it's showing how do these crazy things, and it's real science going on. You can manipulate it, you can, change it. It's something that we always argue about, how when you talk about gravity, you can't manipulate it the same way because it's not real, because it's something that's it's a theory. But when we talk about electrostatics or electromagnetism, that's something that we can fuck with. That's something that we can demonstrate and show you the charge that is actually going, that can be manipulated when the water bends and all that other stuff. But I did want to bring up something. What about like the how they're studying how animals can how do they know from the sky?
Robot, dude.
The robot did.
Robot, and we didn't
Very hard.
got to animals.
Yeah, I just wanted to mention something. Oh, sorry, go on, Andy.
No, go for it, Crypto.
I just wanted to mention Mark Mann's no true Scotsman fallacy when he tried to remove some MIT professors as fringe because they don't conform to his worldview.
No, I mean, I just don't know. I have not read them. I'm still going through Witset's stuff, but they sound very fringe, and they I would say that they probably don't have fully worked out theories.
Well, go look at the lectures.
Well, this is just you making up a bunch of stuff. You've already said you haven't read them, so how could you possibly, like, you're just throwing out, oh, they're probably wrong in this way and this way, and you're literally like reaching for reasons not to like engage with this information. And I haven't read this, and I'm not making those same reaching accusations.
Right, but now
I just want to point out
you posted the electrostatic stuff with the water bending and the can moving.
Yes.
Now, do you
I
not?
posted it.
Now, if I put a 1 volt charge on that plastic rod, how much will that can move?
That's not the point.
Not at all.
That's not
It's
the
super
point.
weak for the 400th time.
It's
You're
because
missing the point.
no, it's not weak. It moved that can appreciably. It moved that can like it was fucking on a rubber band. So I mean,
But
it's
you're
not
missing
weak.
the point.
Electrostatics is objectively weak.
Now, you're suggesting that weight, whatever you want to call it, the effect of gravity is caused by this. Yet, with 50,000 volts, I'm only able to generate, let's say, 1 pound of force with this setup. Now, the gravity with 0 volts different, or next to 0 volts different, is able to generate 2 pounds because it's a kilogram item. Now, why is that tiny little voltage making this huge change when it's a weak force? When you're saying it's weak, and then on the flip side, conversely, this rod with only 50,000 volts is able to yank things around all over the place. How are you getting?
You see, I'll have to keep on like saying the same thing over and over. Where you're like, if you're saying it's weak, it's 10 to the 36 power stronger than gravity even claims to be.
At the micro scale, plus your side, the guy I haven't read yet.
Well, it's just well known, right? So like, I can overtake gravity easily by just rubbing a balloon on my head and sticking to the wall. I can
putting 50,000 volts on it.
I can like rub a balloon to my head, and I can make things levitate off my table. I can like take a rod and make something float by moving it underneath it. It'll float in the air. Like,
where is the 50,000 volts you're doing with this? That's the whole problem. Where is this 50,000 volts you're saying is responsible for me weighing 190 pounds? Where is that 50,000 volts that's keeping me smashed to the ground with 190 pounds of force?
Okay, so it's about the compactness of matter also, right? So the compactness of matter is a byproduct of electrostatics. That's what holds the matter together. So it's a variance of, or it's just a significant amount of variables, right?
Oh, so you're saying density, not charge. Density, not charge.
Well, what sets the up and down is the electrostatic field. That's what sets up and down. and then you have a certain amount of matter, a certain compactness of matter relative to the compactness of the matter in the medium, and then this is going to give you directionality. So once it goes down, then you're going to have a certain amount of downward pressure asserted over a certain area, and we call that weight.
Now you said you posted something. Which one was the lecture that you were talking about? What time was that?
I don't know. I dropped the whole playlist.
Was it mid physics, electricity, and magnetism?
Yeah, and it's like the first 4 or 5 of them are like really good. So I mean,
I'd
there's
really
some
like
math
to see
in
the one
there. I
where
mean,
he says that. I'd like to really see the one where he says that gravity, or that the effects of gravity on the surface of the Earth are
I think it's
not.
the first one.
Okay, mid physics 1.
Yeah.
Look at
802
lecture
1. Yeah.
Okay, yeah, got it. All right, thank you.
It's like another thing you can look. Like I think what I think is I think flat earthers, we've woken up to the spell that they make up a lot of stories. And so like the biggest thing is like, well, naturally occurring phenomena is a big step. And like I agree that's pretty important, right? Like, dude, we have clouds that are held together with electrostatics, and then they stay, suspended in the air. We have bumblebees that aren't aerodynamic, that can fly the crosswinds of 60 miles per hour. We have spider ballooning that whenever they use electrostatics, they propel themselves, even without the wind. We have beetles that use electrostatic resonance within their wings to be able to effectively fly. We have non-contact pollen detachment due to electrostatics, where a bumblebee will fly over a flower and the pollen will come up to them. We have experiments where we take the bees and we show that they actually determine what flower they go to get the pollen, right, based on the actual charge of that flower. And they tested it by again putting like a really sour liquid on some of the flowers, and then like bitter that they don't like, and then really like sweet sugar water liquid on the other ones that they love. And what they did was they put a bunch of electrostatic charge on the ones with the sugar water, and then like 85% of the bees went to those flowers. Like they mixed them all up, and they constantly moved them around so the bees couldn't like remember where the flowers were, and they kept finding the one with the sweet water. Then they took the electrostatic charge away, and then they evenly distributed going to all the flowers, even the ones with bitter. Like the bitter water, which means it goes to show, well, they actually can't just figure out based on the sweetness of the water or anything. They use the charge. And this is why like one bee won't go to a flower that another bee just went to get pollen from, because it still will have a different charge. And it normally takes about 100 to 120 seconds for that flower to build its charge back up. And it has a negative charge because it's connected, it's grounded effectively, right? It's connected to the earth. And then the bumblebee flies around, gets positive charge, and it goes over to the negative charge of the flower, and it detects this charge to know whether or not another bee's been there recently. And then when it hovers above it, pollen will just like levitate up and stick to the bumblebee. It'll be covered and coated in pollen because of this charge.
That's what I was gonna say with it. I was gonna say that how about in nature, the animals definitely react to this electromagnetic, field, and not only that, but birds fly for fucking thousands of miles based upon that energy in the sky that directs them, almost like highways for the birds knowing where to go. And they can even like fly all the way back based upon that chart. Like they get it. Like why in nature, how do they fly according to gravity? That's my question. No, it's not gravity. It's the electromagnetics of the we would, I guess, argue that's called ether. The ether is how they navigate through everything, not gravity. I think that's very, very very provable. So if you're going to deny it, well, then you're just, you're just the baller.
Yeah, it's been proven that birds navigate with the magnetic field.
I mean, this has as much validity as relative density, disequilibrium, whatever. I don't know why some people aren't
I would
acknowledging it and going with it, because obviously you need something more than relative density.
Right, I would say even more, because they claim that density is a force. Right.
Well, I mean, the disequilibrium causes a force, so to speak, right? Or maybe a pseudo force, you might say.
Yeah.
It causes
like
the stuff to move. I mean, stuff's moving because of the disequilibrium, right?
Yeah, but so like, okay, yes, exactly. So like Sleeping Warrior said, Newton said, whenever something moves, there's a force present. So therefore, since manipulation of density makes something move, density is a force. And
well,
no,
not
it's
the
like what
density
gives
itself.
something.
Not the density itself of just a single item. The relationship and the density of the medium and the object.
Well, what gives something its density? Like that's the question then, because like if there's
Just
a
how
driving
compact.
force. What?
It's just how compact the substance is.
Right, and
Density,
so
right?
what does that?
I mean, I don't know. You've been saying electrostatics.
Yeah, because you can't have matter held together without it.
What about a compact gas, Jeremy?
Compact what?
Good morning, good afternoon, good evening.
Gas, a compact gas like helium. Why, when you compact helium, does it become less dense than the air with the balloon as a whole? How does that work out? So, what is density exactly?
When you compact helium, doesn't it liquefy?
Tell me.
I don't know. Is a question. Does helium liquefy if you compact? If you put in those helium tanks, is it actual helium gas or is it liquid helium there? And when you release it, it comes out as gas. I don't know.
When you compact it, you're doing a lot more than just compacting it. You're doing a differential in temperature, resistance, like you're doing something with the whole medium itself to like get a reaction or action that you're getting, right? So it went from helium gas.
I don't
to a
think
liquid,
gases
a
follow
whole
the.
different thing now. React different as a liquid than a gas. I'm done.
So
Gas
it
follows the
did
density,
you say
relative density. What's up?
Yeah, I was gonna ask. What's you saying that density is caused by electrostatic?
Yeah, you can't have density without electrostatics.
So is there a way to undensify things? Like I guess they would have more space between them, or maybe they would. I don't know. Like how? Because I'm trying to. Like if you manipulate it, I just imagine a rock just falling apart rather than sticking together because of electrostatic.
Yeah,
Like
it would have to be a ton. Like you'd have to put so much in there, but yeah, in theory you could certainly disintegrate matter. I'm sure there's some type of test that's actually done this.
even a little piece of paper, if it just unbonded, if the paper fibers unbonded from each other or however, then to me that would be mind blown. But the sets the up and down thing, I don't know. I don't know about that.
Well,
But
what I don't know is
also
how
at the
someone could
same
ever
time, I
invoke
don't think that
density without that.
at the same time, relative density in clouds like are a problem for me. Like I've always considered there's
Yeah.
more to all of this than just saying, oh well, it's dense and this and that and the third. Like obviously there's a little more to it than that.
The clouds are clouds are electrostatic. Like even the mainstream says that. Like that's what holds the clouds
I told
together.
them that in GEMS like 2 years. They're like, "What do you think holds clouds together?" I was like, "Electrostatics," and they fucking laughed me out.
That's what I'm
They
saying.
laughed
Like
at me.
that's what I'm saying. So that means that it holds bodies of it holds the molecular structure of objects together. Right. So I would imagine manipulating this would make these things, what's the word, malleable?
Well,
Or
yeah,
like
the
it
government
would
does
make
that
it,
to manipulate weather and do cloud seeding. They utilize electrostatic charge.
That's always been a.
No, but I mean anything, literally any substance, since everything is
Yeah, you can do that
held
with acoustics.
electrostatically, then anything should be able to fall apart like sand. That's how I see it.
You can do similar stuff with acoustics.
But that's been a
You
question
can
since
do
I was.
Acoustics is electrostatics too.
Yeah, of
I mean,
course.
it can't
It's
be
linked. Yeah. Have you know the liquefaction that happens in those flood type things where it's the whole ground moves, stuff like that.
Oh, the different modality thing. Okay, so this is a different, because yeah, technically, like, what is sound? Well, it is still energy.
I think Lisa can speak on this more. I just thought I'd mention
like
that.
different versions of energy. Yeah,
Well,
it is interesting that
sounds of
if
vibration,
you
right?
hit a certain, if you hit a certain,
And
I got to think about it. I'm thinking real hard through this thing.
Sounds of vibration or oscillation, and it's technically a perturbation of what? Well, you have to have a medium to have sound, and we did talk about the air. Well, the air is a medium that's electrostatic, and if you have an object that has a sound, then that medium is also electrostatic, and so it's like the building block. And so then again, we have like a downward electric pressure on the Earth. We can test this. We can run a corona motor with the electric current down the Earth. We can prove that it has 100 volts per meter increase on the Earth. So, it seems wild to me. We know that density and buoyancy alone can't answer the question, because the question is, well, like, why up and down, or like how up and down, like what sets the up and down? And usually flat earthers say God or whatever, but God works through mechanisms, in the natural world. He set a natural order. And so, yeah, there's up and down. And again, we see this in nature. We see it in nature. And like, that's how a bee hovers over a flower and the pollen goes up to the bee without him touching the bee or touching the flower. The pollen goes up to the bee. So we do see things levitate in the natural world because of electrostatics. We literally watch it happen. So now we want to figure out, can we prove what it is that causes what we see in nature? And so what we would do is